Hi there, welcome to Data Analyst Full Course. Every day, organizations generate massive amounts of data, and the data analysts play a key role in turning that data into valuable insights that guide business strategies. A data analyst plays an important role turning raw data into meaningful information. By collecting, cleaning, analyzing, and visualizing data, analysts help business understand trends, measure performance, and identify opportunities for improvement. Today, data analyst is widely used across industries such as finance, marketing, healthcare, e-commerce, and technology. In this course, we will begin with the fundamentals of data analysis, including understanding different types of data and the basic data analytic mindset required to work with data efficiently. As we move forward, you'll also learn how to clean and prepare datasets, perform analysis using popular tools, and present insights through a clear and impactful visualization. You'll also explore key tools commonly used by data analysts, such as spreadsheets, databases, and visualization platforms. Most importantly, you will learn how to translate numbers into meaningful insights that help organizations make informed decisions. By the end of this course, you'll have a strong foundation in data analysis and the ability to work with data sets, identify trends and patterns, and communicate insights in a clear and structured way. Having said that, let's take a look at the agenda for this course. We will start off with Module 1, which is Introduction to Data Analysis. Module 2 is Understanding Data and Data Types. Module 3 is Data Collection and Data Sources. Module 4 is Excel for Data Analysis. Module 5 is Data Cleaning and Preparation. Module 6 is Exploratory Data Analysis. Module 7 will be SQL for Data Analysis. Module 8 is Data Visualization and Reporting. Module 9 is Introduction to Statistics for Data Analysis. Module 10 is Python for Data Analysis. Module 11 is your dashboard creation and data storytelling. Module 12 is Real-World Data Analysis Case Studies. And finally, Module 13 is Career Guidance and Interview Preparation. Hope I made myself clear with this agenda. That said, if these are the type of videos you'd like to watch, then hit that subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master business analytics skills, and land your dream job or even grow your career, then you must explore Simplilearn's cohort of various data science and business analytics programs. Simplilearn offers a variety of master's, certification, and postgraduate programs in collaboration with some of the world's leading universities. Through our courses, you will gain business and leadership knowledge along with work-ready expertise in skills like Python, Tableau, Power BI, Generative AI, and over a dozen others. That's not all. You'll also get an opportunity to work on multiple projects led by industry experts working in top-tier data and product companies. After completing these courses, thousands of learners have transitioned into data science or data analytics role as a fresher or even moved on to a higher-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find a business leadership and business analytics program that fits your experience and areas of interest. So let's get started with our data analytics full course with a small quiz. What is the main goal of data analytics? To store large amount of data, to analyze data and extract meaningful insights, to design website, or is it to build computer hardware? Please let us know your answers in the comment section below. Now over to our training experts.
Meet Sarah. Sarah is a young professional who recently graduated from college and landed her first job at a retail company. Her main responsibility is to understand which products are selling well and why. But with hundreds of products across multiple stores, she quickly becomes overwhelmed. Sarah has access to mountains of data, sales figures, customer reviews, and stock levels. But without knowing how to make sense of it all, she feels stuck. That's when her manager introduces her to the world of data analytics, a powerful tool that could help Sarah overcome her challenges. Let us first understand what data analytics is and what its various applications are. Data analytics is the process of examining, cleaning, and transforming raw data into valuable insights that businesses can act on. It helps professionals like Sarah understand customer behavior, track product performance, and make informed decisions about inventory and promotions. Widely used across industries such as healthcare, finance, marketing, and sports, data analytics aids in predicting trends, improving decision-making, and optimizing strategies, from potential patient outcomes to detecting fraud or enhancing sports performance. Let us now see how Sarah utilized data analytics to solve some of the key problems she faced. Her biggest challenge was that she couldn't figure out why certain products were performing better than others. While some items were flying off the shelves, others weren't moving at all, and Sarah didn't have a clear understanding of why this was happening. She needed to pinpoint the factors driving sales, whether it was pricing, seasonality, customer preferences, or promotions. Without knowing this, it was impossible for her to advise the company on what products to focus on or how to plan future promotions. Sarah realized that she needed a structured approach to analyze the data. Here's how she used data analytics to uncover the answers. 1. Data collection and integration. The first step Sarah took was to collect data from various sources. She gathered sales figures, customer feedback, and promotion records from the company's internal databases. She also included external data, such as market trends and competitors' pricing. Using Excel and SQL, she compiled all the data into a single, unified dataset. This step helped her see all the information in one place, setting the foundation for deeper analysis. 2. Data cleaning. Before diving into analysis, Sarah needed to ensure the data was clean and reliable. This meant dealing with missing values, removing duplicate entries, and correcting any errors in the dataset. Sarah used Python and Pandas, a powerful data analysis library, to automate the process. For instance, she filled in missing sales data and standardized customer feedback formats to make sure everything was consistent. By doing this, she ensured that her insights would be based on accurate data. 3. Descriptive analytics. Spotting trends. Sarah then used descriptive analytics to understand the current state of sales. Descriptive analytics is about looking at past data to understand what has happened and identify trends or patterns. She ran calculations to determine average sales per product, sales per store location, and sales performance over time. Using Excel pivot tables and Power BI, Sarah was able to create clear visualizations, graphs, and charts that highlighted which products were selling the most, at what times, and in which locations. By doing this, Sarah identified that some products performed well in certain stores, but not in others, and she also noticed sales spikes during specific promotions. 4. Predictive analytics. Understanding customer behavior. Next, Sarah wanted to predict future trends to better plan promotions and inventory. She used machine learning algorithms in Python to perform predictive analytics. Predictive analytics uses data and math to guess what might happen in the future. For example, using scikit-learn, which is a Python tool that helps build and test machine learning models easily, Sarah built a model that analyzed historical sales data, customer demographics, and external factors, such as seasonality, to forecast future product demand. This helped her anticipate which products would likely sell better during the upcoming holiday season. 5. A/B testing. Validating promotion strategies. Sarah's company often ran different promotions to boost sales, but she wanted to know which strategies were most effective. Using A/B testing, a technique that involves comparing two variations of a strategy, Sarah was able to analyze the impact of different discount levels on sales. She ran tests where one group of customers received a 10% discount, while another group received a 20% discount. By tracking the sales performance using Google Analytics and SQL, she discovered that a 15% discount yielded the highest sales without significantly cutting into profit margins. Through the use of data analytics, Sarah was able to pinpoint the factors driving product sales. Her analysis revealed that products that were marketed heavily during promotional periods, especially with a discount of around 15%, saw the highest sales. Additionally, she found that certain items sold better in specific regions, likely due to local preferences. With this insight, Sarah recommended the company focus their marketing efforts on high-performing regions and adjust their promotion strategies to maximize sales without eroding profit margins. By using data analytics tools like Excel, Python, and Power BI, Sarah not only overcame her initial challenge, but also transformed how her company made business decisions. Her ability to turn raw data into actionable insights helped the company improve inventory management, optimize promotional strategies, and ultimately drive higher profits.
Now let's get started. What is data analytics? Data analytics is a process of examining data to find useful information and patterns. It's like being a detective, but instead of solving crimes, you're solving business problems using numbers and facts. Think of it this way. A store has thousands of sales records, but analytics helps answer questions like what's our best-selling product or when do the most customers shop. By finding these answers, the store can make smarter decisions about what to stock and when to run sales. Data analytics involves four main steps. The first one is collection of data, which is gathering information from different sources. The second is cleaning of data, which is removing errors and organizing it properly. Then comes analyzing data, looking for patterns and trends. Finally is sharing insights, creating charts and reports to explain what you found. Businesses uses data analytics for almost everything, improving products, understanding customers, saving money, and staying ahead of competitors. And that's why data analytics skills are so valuable in today's job market. Now, what does a data analyst do? On huge data sets, data analysts gather, analyze, and run statistical studies to give insights and spot trends. They use various methods and tools to transform complicated data into useful insights. They therefore provide insightful data that enables business to make informed decisions, and this answers the questions of what data analysts do. The roles and responsibilities of a data analyst often consist of the following: creating and managing databases and data systems, fixing code mistakes and other data-related problems as necessary, using both primary and secondary sources of data mining, rearranging data in a way that both individuals and machines can understand, and then to create documentations that clarifies the data analysis process for stakeholders. Now, how to become a data analyst? Becoming a data analyst coming from different field can be challenging but achievable goal. It requires a combination of self-directed learning, skill development, networking, and strategic job searching. Here's a detailed guide with 7 steps on how to break into fields in data analysis from scratch. And the first step is to master the basics. Data analysts need a mix of technical and soft skills. Start by learning the basics of 4 different categories to focus on. We'll start with statistical and mathematics, and then move on to programming languages, data visualization, and SQL and databases. Let's get deep into each topics. In statistical and mathematics, the key topics covered should be descriptive statistics, which is learn the measure of central tendency, which is mean, median, mode, measure of variability, which is range, variance, standard deviation, etc., and data distribution, which is normal distribution, skewness, or even kurtosis. And next move on to inferential statistics, which is understand hypothesis testing, confidence intervals, p-value, and statistical significance. Next, we can go ahead with probability theory. Basic probability concepts such as conditional probabilities, Bayes theorem is included. And lastly, cover linear algebra and calculus, which is fundamental concepts that underpin many statistic algorithms. You guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our experts. Next, we'll move on to programming languages. There are 2 major programming languages you should know about. The first one is Python. You can start by learning the basic, which includes syntax, data types, and control structures such as loops and conditionals. Next, move on to libraries for data analysis. NumPy, Pandas, and Matplotlib for data manipulation and visualization. Next, continue with libraries for statistic analysis, which is SciPy and stats models for performing statistic tests and modeling. The second language you need to learn is R. Again, start with basic syntax, data types, and data structures. Move on with data manipulation. Then focus on statistical analysis, which is basics of R functions and packages like ggplot2 for data visualization. You guys can learn these topics from our Simplilearn's YouTube channel, where each of the topic is explained in depth by our experts. Next, moving on to data visualization and reporting. Under this, there are three major tools. The first one is Tableau. You can start by creating and customizing various chart types such as bar charts, line graphs, scatter plots. Then move on to building interactive dashboards and stories and connect to different data sources and data blending. The next tool is Power BI. Data modeling and creating relationship between dataset. Design reports with visual filters and slicers. Use DAX, which is data analysis expressions for advanced calculations. Next tool is Excel. Start with advanced formulas such as VLOOKUP, HLOOKUP, index, match, and array formulas. Next, move on to pivot tables such as summarizing analysis and visualizing data. Then come to data visualization, which is creating and formatting charts, sparklines, and even conditional formatting. You guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our experts, or you can just go through the official document websites. Next, we come across SQL and databases. Some of the key concept is basic SQL commands such as select, from, where, join, group by, having, order by. Next, move on to database design, understanding tables, relationships, and normalization. Move on to advanced SQL such as subqueries, window function, and even common tables expressions, which are CTEs. And finally, you can study about database management, connecting to databases, writing optimized queries, and understanding indexing. You guys can learn these topics from our Simplilearn's YouTube channel, where we have SQL playlist covering each topic that is explained in depth by experts. The second step that you have to concentrate on is work on personal projects. Applying your new skills to real-world problems is a great way to gain experience. Here are some of the project ideas you can get started with. The first one are personal projects. In that, you can start with public data analysis. Choose a public dataset that interests you and perform a comprehensive analysis. This could be anything from government data on health and education to social media data or even sports statistics. For example, you can analyze COVID-19 trends over time, predicting housing prices, or even study climatic change impacts. Next, we have Kaggle competition. Kaggle is a fantastic platform where you can participate in data science competition. These competitions provide real-world data and problems to solve, often with an opportunity to collaborate with others. For example, predicting customer churn, classify images, or even creating models to improve sales and forecasting. Next, you can build dashboards. Create an interactive dashboards using tools like Tableau or Power BI to visualize data insights. Choose a datasets you are passionate about and present your findings in an engaging and easy understandable format. For example, you can create a dashboard tracking global finance markets or visualize crime rates in different cities. The third step is to get certified. While certifications won't replace real-world experience, they can be a value addition to your resume. There are numerous data science certifications available online, such as Google Data Analytics Certificate. And next, we have the Data Analyst Master Program by Simplilearn. This data analytics course in collaboration with IBM will transform you into a data analyst expert. In this course, you will learn the latest analytics tools and techniques, how to work with SQL, the language of R and Python, the art of creating data visualization, and how to apply statistics and predictive analytics in a business environment. These certifications not only provide you with a solid foundation but also show potential employers your commitment to learning and growing in this field. The fourth step is to build a portfolio. One of the best ways to showcase your skill to potential employers is building a portfolio. This can include personal projects, data analysis on real-world datasets, or even Kaggle competition. The key here is to demonstrate your ability to apply what you have learned to real-world problems. Don't worry if you don't have access to any fancy datasets or tools. There are plenty of publicly available datasets on sites like Kaggle or even any government websites. Your portfolio should demonstrate your ability to extract meaningful insights from data and your proficiency with the tools and the techniques of data analysis. The next step is networking and mentorship. Connect with professionals in the field through LinkedIn, local meetups, or even professional associations. Look for a mentor who can provide guidance, feedback on your projects, and potentially help with a job referral. Networking can be invaluable in learning about unadvertised job openings or even internships. The next step is apply for an entry level position or even internships. Look for job titles like junior data analyst, data technicians, or even analytics assistants. Look for opportunities in your local community. Reach out to startups, nonprofits, or even consider offering your service for free initially. Even customer services or administrative roles that involve data entry or reporting can serve as a stepping stone, giving you practical experience with data. The final step is to prepare for your interviews. Be ready to discuss your projects, how you approach problems, and what you learned. You should also be prepared for technical interviews that may test your knowledge of statistics, programming, and data analysis techniques. You can refer to Simplilearn's video on data analyst interview question and answer on YouTube.
Better businesses and all those things, or home loans, right? So there's a business development in terms of this particular data set here. So that's how you create a fully functional and interactive dashboard in Excel. So that brings us an end of this session on Excel for data analytics tutorial for beginners. And you have learned data cleaning, data segregation, data organization, data validation, conditional formatting, dashboard, pivot tables, and a lot more. If you have any queries regarding any of the topics, then please feel free to let us know in the comments. Let's get started with chapter 1 or module 1. So our chapter 1 will be about a quick introduction to Power BI. Welcome to module 1 of our Power BI full course. In this first session, we are going to build a strong foundation. Before we even touch the tool, we need to understand why Power BI exists, what problem it solves, and why companies in the current and in the future simply cannot operate efficiently without a strong analytics capability. Let me start with a simple but yet powerful observation. Every organization today is drowning in data. We have data coming from websites, CRMs, ERPs, IoT sensors, social media, finance systems, HR tools, literally hundreds of touch points. But the value of data doesn't come from the volume. It comes how quickly and intelligently teams extract insights from it. This is where Power BI becomes essential. Think of Power BI as the modern equivalent of a digital microscope. You point it at a raw, unorganized, messy data, and suddenly patterns start to appear. Trends become visible, anomalies stand out, and performance issues are revealed. Just like successful learners who improve rapidly by analyzing their mistakes and strengths, companies go faster when they analyze their data systematically. Power BI is not just a charting tool, it is a decision engine. And by the end of this course, you will understand how it allows individuals and businesses to transform raw data into insights that drive strategy, innovation, and growth. Now, let's go with the section 2 of chapter 1. What is Power BI? So let's go deeper. What exactly is Power BI? At its core, Power BI is Microsoft's business analytics platform, but that simple definition doesn't fully capture its capabilities. Power BI performs 4 major functions. First one, data connection. It can connect hundreds of data sources like Excel, SQL Server, APIs, cloud storage, Azure, CRM systems, Google Analytics, SharePoint, and much more. Next, we have data transformation. It includes powerful engine called Power Query that can clean, merge, shape, and prepare data through a user-friendly interface. Next is data modeling. Power BI allows you to define relationships, create DAX or data analytics expression measures, build hierarchies, and design semantic models. Data visualization and insight sharing is our next point. Finally, it enables you to present the insights using interactive visuals, dashboards, and reports. Now, here's why it matters. In traditional workflows, people often work in silos. Marketing teams prepare Excel files, finance teams use SAP or Tally exports, operations teams work on CSVs or various tools. Everyone creates dashboards independently. This leads to confusion, conflicting numbers, and zero alignment. Power BI solves this fragmentation. It creates a single version of truth. Everyone from interns to CEOs sees the same numbers updated in real time using the same datasets. This eliminates the guesswork, the back and forth emails, and typical "who updated this file" chaos. Let me give you an analogy. Think of Power BI as a GPS for business decisions. Think of Power BI as the GPS for business decisions. You provide the destination, revenue growth, and cost reduction, customer retention, and Power BI gives you the perfect route. It adapts to real-time changes, helping you make informed decisions faster. This is why companies worldwide, from startups to Fortune 500 organizations, rely on Power BI for entire decision-making ecosystem. Now let's dive into the section 3 of module 1. Why Power BI matters in 2025, 2026 and beyond. Now let's take a forward-looking perspective. Why is Power BI even more important in 2026 than it was in a few years ago? Three major trends explain this. Trend number 1, rise of AI-driven analytics. Power BI today integrates directly with AI tools such as Microsoft Copilot, Azure Machine Learning, and AutoML. This means users don't have to manually write formulas or DAX expressions for advanced analysis. Power BI can do a lot of things. Let's discuss a few as mentioned below. First one is suggest visuals. Copilot analyzes your dataset structure and relationships, then recommends the most effective visual formats, bar graphs, line graphs, KPI cards, based on analytical best practices. This reduces guesswork and accelerates report generation. Next is summarize pages. It automatically reads all visuals on a report page and generates a narrative summary highlighting key patterns, anomalies, and correlations. This helps stakeholders grab insights without manually interpreting each chart. Then we have creating entire dashboards. By understanding your dataset and business context, Copilot can fully generate multi-page, fully formatted dashboards. It handles layouts, visuals, interactions, and defaults, making it ideal for rapid prototyping and stakeholder previews. Up next, we have explain trends. Copilot interprets real-time series data to identify rising or falling trends, seasonal patterns, and sudden spikes. It explains the why behind the changes using natural language insights grounded in statistical signals. Next ahead, we have generate DAX calculations. Instead of writing complex formulas manually, you can describe the logic in simple English, and Copilot converts it to optimized DAX expressions or measures. This is especially useful for advanced calculations like running totals, cohort analysis, and dynamic time intelligence. This shift automatically increases productivity. Non-technical users can now perform tasks that were previously the domain of data scientists. Now let's go into the trend 2. The trend 2 is all about shift to unified data architecture, which is Microsoft Fabric. So, Microsoft Fabric is becoming the core of modern analytics architecture. Power BI now integrates seamlessly with Fabric components like Lakehouse, and Power BI can directly connect to Lakehouse tables stored in one lake, enabling unified access to structured and unstructured data without complex ETL. This improves performance, governance, and cross-team collaboration. Next is data engineering. Data engineers can prepare, clean, and transform large datasets using Fabric notebooks and pipelines, and Power BI consumes these curated datasets instantly, ensuring analysts always work with high-quality, production-ready data. Followed by that, we have Data Factory with Fabric. Data Factory scheduled pipelines move data from multiple sources into centralized storage. Power BI then reads these refreshed datasets automatically, enabling consistent automated reporting without manual intervention. Now the next one is real-time analytics. Power BI dashboards can stream live data from Fabric real-time analytics, or also known as Custom Engine, supporting instant insights for IoT, transactions, monitoring systems, or operational dashboards where every second counts. After that, we have machine learning. Fabric's machine learning models can score data and write predictions back into tables, which Power BI reads in real time. This enables AI-driven dashboards such as churn prediction, demand forecasting, and anomaly detection without leaving the Fabric ecosystem. This means Power BI is no longer just a visualization tool. It's a part of an end-to-end data pipeline. Now comes the trend number 3, real-time decision making. Companies want insights as they happen, not after a month and a report. Power BI supports real-time streaming data. Power BI can ingest live event streams like IoT signal, transactions, or sensor logs and update visuals within seconds. This enables operational teams to monitor activity as it happens and respond almost instantly. Next, we have direct lake connectivity. Power BI reads data directly from Fabric's One Lake in its native format, and it can bypass imports and refresh cycles. It delivers near direct query freshness with import level performance for large scale analytics. Next is auto refresh dashboards. Power BI supports scheduled and automatic refreshes, ensuring dashboards always display the latest available data. This eliminates manual updates and maintains data consistency across teams and stakeholders. For example, a logistics company can monitor vehicle movement on live. A retail chain can adjust pricing based on real-time sales. A marketing team can track live performance of campaigns. Final thoughts? Power BI's importance in 2026 is not due to its charts. It's due to its speed and intelligence of insights. A business that operates with fast, consistent data insights outperforms competitors significantly. This is similar to how high-performance learners constantly analyze feedback and optimize their approach. Businesses that behave similarly using Power BI achieve superior outcomes. Now comes the section 4 of Module 1, Real-World Business Applications. Understanding theory is great, but what matters is real-world application. Let's look into how Power BI is used across industries, and I'll break it down by functional domains. The first one, marketing and sales analytics. Marketing teams rely heavily on Power BI for the following reasons. First one, lead generation funnel analysis, campaign return on investments, customer segmentation, revenue attribution, website and social media performance. Imagine you're running a YouTube ads campaign. Instead of manually downloading performance data, Power BI connects directly to YouTube Analytics or Google Analytics and creates a real-time dashboard showing the following visuals. So you will have a direct access to views, watch time, CTR, conversions, revenue. This allows marketing teams to optimize budgets immediately instead of losing money due to delays. The second one, finance. Finance departments use Power BI for P&L statements, expense forecasting, cash flow modeling, financial consolidation, aging analysis. The benefit is consistency. Instead of multiple Excel sheets floating around the organization, Power BI integrates everything into a single version of truth. Think of it like having an automated auditor that keeps all your numbers synchronized. Third one is HR analytics. HR uses Power BI for workforce planning, attrition dashboards, skill mapping, recruitment pipelines, diversity metrics. This helps HR leaders identify trends like which teams experience higher attrition or which skill gap can affect future growth. Now, the fourth one, operations and supply chain. For operations, Power BI acts as an operational command center. Companies track inventory analysis, manufacturing defects, supplier performance, order fulfillment times. This offers visibility from end to end, reducing bottlenecks and improving process efficiency. Now the fifth one, retail and e-commerce. In retail, Power BI is used to analyze daily sales, regional performance, product profitability, customer loyalty patterns, promotions impact, and Power BI helps these companies strategize inventory pricing and promotions. Conclusion: for this section, real-world value is what defines Power BI's credibility. Just like a learner becomes credible by consistently applying knowledge, Power BI becomes a credibility engine for organizations by delivering accurate, reliable, and timely insights. Now, the section 5 of Module 1, installing and setting up Power BI Desktop. Now let's walk through how to install and set up Power BI Desktop. Even though the process is simply straightforward, I want to explain each step, and it matters because understanding the environment makes learning advanced concepts easier later. Step 1, which is about downloading Power BI Desktop. Navigate to powerbi.microsoft.com, like the link I've shown on the web page. Go to the download section and you can download it. The second option, however, is the Microsoft Store itself. You can go to the Microsoft Store, go to the search bar, type Power BI, and then you'll get the app. You can download it from there and install in your local system. Both the steps are valid. The Microsoft Store version updates automatically, which is convenient for beginners. But if you are the person who is looking forward to continuing with the same version for a longer duration, then the first step would be better. Now, going into this step, second, installation. Choose the 64-bit version unless your system specifically requires otherwise. Once installed, launch Power BI Desktop and wait for the interface to load. Now comes the step number 3, understanding the interface. Power BI Desktop is divided into 3 major views. First view, report view. This is where you design dashboards. Second one is the data view. This is where you inspect raw data tables. And the last one is the model view, where you build relationships, define a data model. Each view plays a critical role. In the later modules, you will notice how frequently you shift between these views as you build complex solutions. Now comes the step 4, connecting to the data sources. Power BI supports over 160 plus data connectors, including Excel, CSV, SQL Server, SharePoint APIs, web data, cloud storage, Dataverse. Even IoT data can be streamed directly into Power BI. During the installation training, we typically load from a simple Excel file like financial sample or employee data or sales data to understand how columns and data types can be detected by Power BI. Now we go into step 5. The step 5 will be about configuring settings. Key configurations include regional settings, which is important for date formats, auto recovery settings, which is important for preview features like on object interaction. Next step is about enabling Copilot if available for your tenant. These small details significantly influence your user experience. Now, the conclusion. By the end of installation and setup, learners should be comfortable navigating Power BI Desktop. This foundation is essential because starting from the next module, we will dive deep into importing, Power Query, transformations, and data modeling. Now, that was the end of Module 1. Now, we will dive into Module 2, which is about understanding the Power BI workflow. Welcome to Module 2 of our Power BI Full Course. In Module 1, we got a complete understanding of Power BI as a tool, why it matters in 2026, and how organizations across industries depend on it. Today, now, we're going to dive deeper. This module is all about understanding the Power BI workflow, the exact step-by-step process that transforms raw, unstructured business data into meaningful dashboard that executives rely on decision making. Think of this workflow as the operating system behind the Power BI. Just as successful learners follow a structured learning path to reach mastery, successful analysts follow a structured BI workflow to create credible, reliable business insights. Now the section 1 of Module 2, Understanding the Power BI Workflow. Now the part 1. What is Power BI Workflow? Let's start by the core idea. A Power BI workflow is the complete life cycle of your data inside the Power BI ecosystem from the moment you import the data. Here's a sharper, insight-driven version of your end-to-end analytics workflow structure, like a value chain rather than a simple sequence. This keeps it analytical, avoids marketing fluff, and clearly highlights how each stage contributes to business decisions from raw data to decisions. The complete analytics lifecycle data import, you start by pulling information from multiple sources like CRM exports, SQL databases, API or cloud storage, ensuring the dataset represents the business data reality accurately. Next is the data cleaning. Next comes the eliminating noise step. Fixing missing values, correcting inconsistencies, normalizing formats, and validating data quality. Clean data increases reliability and reduces downstream errors. Data modeling is the next step. You then define the relationships, apply business logic, and structure the dataset into meaningful views or star schemas. This step shapes how metrics like revenue, retention, or conversion rate will behave. Visualization and insight generation is the next one. With a structured model, you build dashboards, KPIs, and trend analysis that highlight patterns, anomalies, and performance drivers. This is how you transform raw metrics into intelligence. Next, we have report deployment. Reports are then published into platforms like Power BI Service, Tableau Server, or cloud dashboards, ensuring role-based access, refresh schedules, and governance. Followed by that, we have decision enablement. Ultimately, these insights support strategic actions, optimizing campaigns, improving customer journeys, allocating budgets, and forecasting outcomes with data-driven clarity. Everything fits into workflow. This workflow is important because it ensures consistency, just like manufacturing industries follow a standard operation process. Data analytics team follow the Power BI workflow to maintain accuracy and speed across the reports. Now, the part 2. Why understanding the workflow is critical. Most beginners jump into visuals immediately. They drag a field, create a chart, and think that Power BI is just about visuals. But in real business scenarios, visuals represent only 20% of the work. The remaining 80% comes from data preparation. This is where raw inputs become analysis ready. It includes profiling data, handling missing values, correcting inconsistencies, standardizing formats, and shaping the data into usable structures. Good preparation reduces noise and ensures that upstream modeling remains stable. Modeling. The key goal here is to translate business logic into logical data structure. Fact and dimension tables are organized using schemas, hierarchies, calculated tables, and metric definitions mirror how the business measures revenue, performance, or customer behavior. A strong model determines the accuracy of every insight downstream. Followed by that, we have DAX. DAX is the analytical engine behind meaningful metrics. It enables time intelligence, filter, context manipulation, rolling calculations, and KPIs that behave dynamically. When models reflect structure, DAX inject intelligence, turning static data into performance-driven measures. Engineering proper relations is the next step. Correct relationship ensures context flows accurately across the tables. Cardinality, direction, and granularity must align with the business process. Proper relationship engineering prevents ambiguity, avoids circular dependencies, and ensures metrics aggregate exactly as intended. Understanding the workflow helps you avoid broken dashboards. A clear workflow ensures every step, data ingestion, transformation, modeling, and visualization follows a predictable structure. This minimizes mismatched fields, broken visuals, and errors that surface when datasets change. Next is all about understanding how filter contexts go through your model prevents inflated or deflated numbers. Proper modeling plus DAX discipline ensures totals, subtotals, and KPIs reflect real business logic instead of accidental aggregations. Next, we have an important step which is about fixing performance issues. A structured workflow highlights where bottlenecks originate, heavy queries, poor relationships, unnecessary calculated columns, or non-optimized DAX. It helps you diagnose and fix slow dashboards where they impact the users. Build scalable reports is our next step. When the workflow is consistent, your reports scale gracefully with new data sources, additional KPIs, or even larger datasets. A clean pipeline reduces redesign effort when businesses need to grow. Reduce refresh failures is our next step. Clear preparation and proper modeling reduce schema, mismatches, query timeouts, and dependency problems. Your data pipelines remain stable even as refresh volumes increase. Next, after that, we have create data that business teams can trust. A disciplined workflow results in consistent, predictable metrics. Team sees the same numbers everywhere, which strengthens confidence, supports decision making, and ensures your dashboard becomes the single source of truth. Basically, it helps you protect data credibility, which is the foundation of analytics. Now we enter the part 3 of module number 2, the 5 pillars of Power BI workflow. The first one, data collection. This is the starting point. Power BI connects to more than 120 plus data sources, including Excel, SQL, SharePoint, Web APIs, SAP, Oracle, Snowflake, and so on. Data usually comes in different formats. Flat files like .csv, operational databases, analytical warehouses, cloud platforms, streaming data sources, and a lot more. In real-world companies, data is scattered. One team keeps Excel files, another has SQL databases, marketing uses a CRM, sales uses a different system. Power BI becomes a centralized platform where all these data sources converge. Now, the second one, data transformation, Power Query. This stage is one of the most important one. Think of Power Query as the data cleaning refinery. Just like crude oil cannot be used directly, it needs to be refined. Raw business data needs cleaning before it is usable. Power Query handles many important stages like removing duplicates, fixing headers, splitting and merging columns, converting formats, handling null values, replacing errors, joining tables, cleaning inconsistency, category naming, creating calculated columns, and a lot more. This stage ensures the data is trustworthy, and without trust, no dashboard is valuable. Now comes the third pillar, data modeling. This stage is where Power BI becomes the most powerful. More than Excel, data modeling is the process of structuring your data for analysis. This is the blueprint that decides how Power BI calculates numbers. Key elements include fact tables. These hold numerical, event-based data such as sales, transactions, or clicks. They represent what happened in the business and typically contain high volumes of rows. Facts drive aggregation and they are the backbone of KPI calculations. Dimension tables are the next ones. Dimension tables describe the business context like customers, products, states, regions, or employees. They enrich fact tables with attributes that help slice, filter, and segment the insights. Dimensions make reports interactive and meaningful. Star schema. A star schema places a central fact table at its core connected to multiple dimension tables. This structure improves performance, simplifies DAGs, and ensures clean filter propagation. It is the recommended modeling standard in Power BI. Relationships. Relationships define how tables connect and how filters move between them. They determine the analytical behavior of visuals and calculations. Strong, properly configured relationships eliminate ambiguity and guarantee accurate results. Cardinality. Cardinality is described as the type of relationship. There are many types of relationships: one-to-one, one-to-many, many-to-many, and many-to-one are the basic examples. The correct cardinality ensures that data aggregates properly and prevents unexpected duplication or mismatches when calculating KPIs. Cardinality. Cardinality describes the type of relation. So the types of relation can be of different ones: one-to-many, many-to-one, one-to-one, and many-to-many. The correct cardinality ensures the data aggregates properly and prevents unexpected duplication and mismatches when calculating KPIs. Now let's go through cross-filter directions. Cross-filter directions determine how filters flow single direction, which is the most common one, or the bidirectional one. Single direction keeps the model stable, while bidirectional is used carefully for specific scenarios like many-to-many relationships. Now let's go through DAX measures. Measures convert raw data into meaningful business metrics such as revenue, retention, or year-on-year growth. DAX leverages filter content, time intelligence, and aggregates to produce accurate dynamic calculations across reports. A strong model ensures reports run faster, numbers aggregate correctly, filters work properly. You can slice and drill down insights. Companies heavily invest in modeling because it reduces conflicts such as wrong totals, duplicate counts, slow performance, and confusing visuals. Now let's deal with visualization and storytelling. Most people think dashboards are equal to visuals, but visuals without a narrative are incomplete. Visualizations include the following: building charts, choosing the right visual type, using slicers, adding filters, highlighting KPIs, and structuring pages. Good dashboards answer business questions such as what happened. This focuses on descriptive analytics. Dashboards summarize historical performance, sales, traffic, conversions, production output, or customer activity. The goal is to provide a clear, immediate snapshot of business performance without any ambiguity. Now, the next one is, why did it happen? This moves into diagnostic analytics. Power BI allows teams to drill down, segment data, compare cohorts, and analyze patterns that explain the drivers behind the results. It helps identify root causes, pricing changes, seasonal shifts, operational issues, or marketing impacts. Now, followed by this, we have what will happen next. This represents predictive analytics with features like forecasting, machine learning models, through fabric and trend analysis, Power BI helps anticipate future behavior, expected sales, customer churn, demand spikes, or risk exposure. What action should we take is the next question. This question supports the prescriptive analytics. Dashboards guide decision making by highlighting opportunities, risks, and required adjustments. Whether it is reallocating budgets, optimizing workflows, targeting profitable segments, or improving supply chain operations, insights translate directly into actions. Your goal as an analyst is to convert the data to insight and insight to action. Now comes the fifth point, publishing and sharing governance. Once the report is ready, it must be delivered to the right audience. So the right audience could be managers, sales leaders, finance heads, marketing teams, or operation teams. Power BI service enables cloud-based sharing, row-level security, data refresh scheduling, collaboration with teams, integrations with teams, Excel, SharePoint, etc. This final stage ensures business users get reliable, updated dashboards without manual effort. Now let's go to the section 2, which is about overview of Power BI Desktop, Service, and Mobile. So the part 1 in this is about Power BI Desktop. So Power BI Desktop is where 90% of the analytical work happens. This is your development environment, the workshop for building analytics. Now let's go with the key functions. The key functions are data import. This is the entry point of the Power BI workflow. You pull data from files, databases, cloud systems, APIs, or enterprise warehouses. The objective is to bring raw data into the environment efficiently while preserving the structure, precision, and metadata. Next is data transformation. Using Power Query, the raw inputs are cleaned, structured, and standardized. This stage fixes errors, handles missing values, merges tables, applies business rules, and reshapes datasets. Clean transformations reduce downstream complexity and ensure consistent analytics. Now, let's go with model design. Here, data is structured into logical schema, typically fact and dimension tables. Proper relationships, cardinality, IRR, and data granularity are engineered to support accurate slicing, filtering, and aggregation. A strong model is the backbone of reliable dashboards. Now, let's go with DAX calculations. DAX converts the model into intelligence. Measures define KPIs like revenue growth, conversion rates, year-on-year performance, and operational efficiency. Good DAX respects filter context, enables time intelligence, and enforces business logics across visuals. Report creation visuals are built to communicate insights clearly. Charts, maps, tables, KPIs, slicers, and storytelling elements. Reports aim to answer business questions, highlight performance trends, reveal drivers, and support decision-making through clean, intuitive design. It has a very structured interface. Now, let's go with that. The first one is the report view. This is the canvas where the insights come to life. You build visuals, arrange layouts, apply themes, and craft the storytelling layer of your dashboard. It's designed for rapid experimentation, letting you iterate on charts, KPIs, and interactions that answer business questions. Now, the second one, the data view. This view lets you inspect the transform table outputs row by row. It's used to validate common values, check data types, and verify the results of Power Query transformations. Analysts rely on it to ensure data quality before modeling and DAX creation. The last one is the model view. Here, you design the logical structure of your dataset. Tables, relationships, cardinality, filter directions are managed visually. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across dimensions. The model view ensures your schema reflects real business processes and that metrics aggregate predictably across all the dimensions. Now let's discuss about the visualization pane. This pane provides full library of charts, maps, KPIs, matrices, and custom visuals. Each visual has configurable properties, formatting, interactions, data roles, conditional formatting that help turn raw data numbers into strong analytical narratives. Now, let's go into the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. Now, let's go with the data fields pane. This lists all tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates reporting efficiency. Analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2, Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedding reports into websites, row-level security, and collaboration in Workspace. In 2026, Power BI Service is deeply integrated with Microsoft Fabric and Microsoft Copilot. Microsoft Fabric brings data engineering, data science, real-time analytics, warehouse workloads, and lakehouse architecture, all inside the same environment. This makes Power BI a front end for entire modern data stack. Now let's go through the part 3, Power BI Mobile. The third component is the Power BI Mobile. This is crucial for decision makers who are always on the go. Executives want quick snapshots, alerts, sales performance, market trends, and operational bottlenecks on the go. Power BI Mobile allows them to monitor business performance in real time. Many companies rely on mobile dashboards during morning sales stand-ups, weekly reviews, executive board meetings, and many more. Together, the desktop, service, and mobile form a complete ecosystem. Now, let's dive into the section 3, typical workflow, explained with some examples. So let's consider an example. Retail chain with 50 stores. Let's look at a practical example. You're a business analyst for a retail company that has 50 stores across the country. Now the management wants a dashboard showing daily sales, category-wise performance, store revenue, and top-selling products. Now let's walk step by step through how you build it. Step 1. Connect to data. You connect to Excel for daily sales, SQL Server for inventory, CSV export from POS. Power BI combines all these 3 data sources seamlessly. Step 2. Clean the data. In Power Query, you fix the category mismatches, remove duplicates, correct date formats, merge store metadata, handle missing values. You ensure that the data satisfies real-world business logic. Now comes the step 3. Build the data model. You create a star schema, fact sales, dimension product, dimension store, dimension date. You establish relationships. Then you write DAX measures like total sales, profit margin, average basket, size, year-on-year growth. Now, the model can answer the business questions almost instantly. Now comes the step 4. Build the report. Your dashboard includes a line chart for monthly sales, a bar chart showing category contribution, a geographical map showing store performance, KPIs highlighting revenue tables, listing top products, filter for store, category, and date. Users can now drill down from total sales to city to store to product. Now, let's dive into the step number 5. Publish the report. Power BI service is your option. You can publish the report, then you set frequency, define permissions, create dashboards, distribute to leadership teams. Now, the entire organization uses your dashboard. Now, with that, let's dive into the section 4. Key components of Power BI interface. The first one, ribbon. This includes home, insert, modeling, view, and help tabs. Each controls a different part of the workflow. The second one is the views pane. This includes report view, data view, and model view. Each view offers different angle of analysis. The third one is the fields pane. This shows tables and fields. A well-structured field pane improves efficiency. The fourth one is the visualization pane. This is where you select charts, customize visuals, change colors, enable analytics lines, and format your visuals. Now the fifth one is the filters pane. Filters allow control over what data appears on the report page or a visual. Then comes the sixth one, which is canvas area. This is where visuals come together and form a meaningful story. And with that, we have finished the module 2, and now we make a transition to the module 3, which is based on connecting to data sources. Next comes the filters pane. This pane controls all filters applied at visual, page, or report level. Proper filter usage ensures users see the right slice of data and that calculations reflect accurate context. It also helps fine-tune interactivity, comparisons, and scenario exploration. The data fields pane is the next one. This pane lists all the tables, columns, and measures in your model. It's the core workspace for dragging fields into visuals, building new measures, controlling hierarchies, and managing calculated fields. A well-organized fields pane accelerates report efficiency, and analysts spend most of their time here because this is where insights are engineered. Power BI Desktop is free. This makes it accessible to students, beginners, and companies of all sizes. Now comes the part 2. Power BI Service. Power BI Service is the cloud platform. Once reports are ready, they are pulled and published here. Its key features include creating dashboards, managing workspaces, scheduling data refresh, viewing reports online, organizing analytical assets using the Power BI app, embedded reports into websites, row-level security, collaboration in workspace. In 2026, databases, cloud services, real-time streaming systems, APIs, big data engines, enterprise solutions, Microsoft Fabric and Azure resources, and a lot more. Data connectivity is the backbone of every Power BI solution. And in this module, you'll understand not only how to import data, but also why certain methods are chosen in real-world business environments. Now, the section number 2 is about importing data from Excel. Let's begin with the most common and beginner-friendly data source, which is Excel. Excel is still one of the most used analytics tool in the world, making the perfect start point. How to import Excel data? You can open the Power BI dashboard, go to Home, Get Data. So browse and select your file. Power BI displays the Navigator window showing available sheets and tables. Don't worry, this is just a quick theoretical approach. Once this is done, we will be directly diving into the demonstration mode where we will practically explore all these. Now, once you see the available sheets and tables, select the required items and click Load or Transform Data based on your request. Repeat. And click on Load or Transform based on your requirement. Then comes the important concepts. If your Excel file uses names, tables, Power BI treats them as clean structured objects. If your Excel file uses plain ranges or messy layouts, Power BI still imports them, but you will need Power Query to clean them later. Now, business relevance. Excel is widely used for monthly sales reports, budget, financial transactions, campaign tracking, ad hoc department level reports. This means data analysts frequently integrate Excel with larger systems like SQL Server, CRM data, and a lot more. Now let's also discuss some common issues and best practices. Ensure the first row contains column names. Avoid merged cells. Power Query struggles with them. Keep date formats consistent. Try to use tables instead of raw ranges. Now let's go through an analogy. Think of Excel data as manually entered or department. Now let's go through an analogy. Think of Excel data as manually entered or department level data, like a student's personal note. They help with context, but they often require polishing before being shared. Now let's go through the section 3, which is about importing CSV data. CSV files are often another common data source, especially for exports from applications, websites, or tools. Now, how to import CSV? The same. Go to Home, Get Data, then you choose Text or CSV option. Select your CSV file. Power BI automatically detects column delimiters and data types. It also shows you a preview. Click on Load or Transform Data based on your requirement. Why CSV is important? CSV is a universal format used across marketing platforms like Facebook ads, Google ads, e-commerce reports, CRM systems, ERP exports, social media analytics, automation tools, payment gateway logs. CSV files are lightweight, system-friendly, and easy to automate. Now, let's go through some key differences between Excel and CSV. CSV does not support formulas, no formatting, no multiple sheets, faster for automation, and ETL pipelines. So basically, every CSV cannot be Excel, but Excel can be turned into a CSV. Now, let's go through some best practices. Treat CSV files as raw system output. They usually require data cleaning, but ensure more consistency because they don't contain any formatting errors. Now let's dive into section 4, which is about connecting to web sources. So next we explore one of the most powerful features, which is web data sources. Power BI can connect directly to websites or APIs and fetch structured data. Go to the Get Data option, enter the URL by choosing the web option. Power BI loads the HTML or JSON content. Select the required table or hierarchy. transform it, and load it. For example, extracting stock market data, or pulling cryptocurrency prices, or getting live COVID-19 data, weather statistics, reading product listings, import government datasets, and a lot more. You can also go with API-based data like YouTube Analytics or Google Maps data, and a lot more. Now let's also discuss a small use case. Imagine a company that wants daily currency conversion rates. Instead of manual downloads, Power BI can fetch real-time rates through a web API and keep dashboards always current. Now, a small keynote: when using APIs, authentication may be required. API keys, tokens, OAuth, etc. Now, let's also go through an analogy. Web data is like tapping into a live knowledge source. Similar to how learners use online platforms to stay updated instead of static files. You get dynamic, evolving information. Now let's go through the section 5, which is about connecting to databases. This section covers the enterprise grade side of Power BI, which is about connecting to databases. In professional environments, the most critical data lives in SQL servers, Azure, SQL, MySQL, Postgres Server, Oracle, Snowflake, Databricks, Azure Synapse, data warehouses, or lakehouses. Basically, anything which is a database online or on a data server. Power BI connects seamlessly to all of them. SQL Server connectivity steps are as follows. Same, you need to go to Home, select the Get Data option, and select SQL Server or any of the database where your data is existing. Enter the server name, database name, which is completely optional. Choose the Import Query option, Dual Mode, provide credentials, select the tables that you need on your Power BI window, and then, based on your requirement, either transform the data or load. SQL Server is extremely common for storing sales transactions, customer data payment, information, inventory, employees, employee data, ERP data, CRM data, and a lot more. Why it matters is the next question. Database connections allow you to integrate large, structured, professionally maintained datasets. This gives your report enterprise credibility, similar to how a researcher gains credibility by referencing authoritative resources. Now, Azure Cloud Database Connections, Azure SQL Database, fully cloud-hosted SQL database used by modern businesses for scalability and low maintenance. Azure Synapse Analytics. So Azure Synapse Analytics is an enterprise warehouse for big data and analytics. Azure Databricks for AI and ML and large-scale data processing. Azure Data Lake for massive unstructured and semi-structured data storage, business-relevant insight, cloud database support, real-time dashboards, large data volumes, global reporting, multi-department analytics, and a lot more. Companies adopting cloud architectures rely heavily on Power BI to interpret their cloud data ecosystem. Now we enter the section 6. Data load versus data import versus data query. This is one of the most important concepts in Power BI. How to load your data determines the performance of your report, the freshness of your insights, size of your dataset, the speed of processing. So now let's break down the 3 modes the Power BI offers. The first one, import mode, and how it works. Data is copied from the source into Power BI's internal storage, and it is through Vertipack engine. Fast performance, best for dashboards that don't require second-by-second updates. Now, where is this ideal? It is ideal for small to medium datasets, analytics dashboards, visualizations, monthly or weekly reporting, and it deals with Excel plus CSV plus SQL tables. Now let's also discuss the benefits. It is extremely fast in queries, full Power BI functionality, compression can be done up to 10 to 20 times, and there are also some limitations. Let's go through them. Data size is limited, not suitable for real-time systems, and let's also discuss some of the real-time examples. So one of them is monthly sales report where data refreshes every morning. Now the second type is direct query mode. Now let's discuss how it works. Data stays in a database. Power BI queries the source in real time. No data is stored in the Power BI itself. It is in the database. Now where it is ideal? It is ideal for real-time dashboards, very large databases, enterprise level systems like SAP, Oracle, or Synapse. Now let's also discuss the benefits. Always fresh data, no dataset size limitations, and apart from these, we have some disadvantages. Let's go through them. It is slower in performance. Many DAX features are unavailable. Load depends entirely on the database, and visuals refresh very slower. Let's also discuss one of the real-world examples. A logistic company monitoring real-time vehicle movement is a perfect example for this one. Now comes the third one, which is about the live connection. It is mainly used with analysis services, Azure Analysis Services, Power BI dashboards, Microsoft Fabric semantic models, and a lot more. It behaves similar to direct query but optimized for enterprise models. Now, what's the key decision rule here? Choose import mode unless you need real-time insights, your dataset is too large to import, your company mandates live connection for governance. This decision is strategic choice similar to selecting the right learning strategy. This decision is strategic choice similar to selecting the right learning strategy, which is like memorizing versus understanding versus applying. Each has strengths and constraints, and choosing the right method enhances efficiency. And with that, we have come to the end of module 3 and we transition into the module 4. So the module 4, which is all about data transformation with Power Query Editor. So welcome to module 4 of our Power BI course. In this module, we will explore Power BI's Power Query Editor and one of the most essential tools in Power BI for preparing and transforming data. Think of Power Query as the foundation of your analytics workflow. Without a strong foundation, even the best dashboards can give misleading insights. Cleaning and transforming data ensures that reports are accurate, reliable, and actionable. In this real world, most datasets are messy. They contain nulls, errors, duplicate rows, inconsistent formats, or unnecessary columns. Power Query gives you the tools to handle all of these in one go. Power Query helps you with repeatable automated way where you can once define these steps and Power Query will take care of them in the flow. Now, the section 1, Introduction to Power Query Interface. When you open Power Query, you will see a structured workspace designed to make transformation easy and intuitive. At the top, we have the ribbon. It contains tabs like Home, Transform, Add Column, and View. Each tab provides key commands for shaping your data. And on the left, you see the Queries pane, which lists all the tables and queries in your project. You can select Rename or Reference queries from here. The center of the screen shows the Data Preview grid, where you can see your data table and apply transformations. On the right side is the Applied Steps pane, where every change you make to your data is recorded as a step. And this step-by-step process is extremely powerful. It allows you to track, edit, or remove any transformation without starting over. Finally, at the top, there's a formula bar where the displays. Finally, at the top, there is a formula bar which displays the underlying M code for each transformation. Even if you never write the M code manually, understanding that it exists helps you appreciate how Power Query automates and records your steps. Now comes the section 2, Cleaning the data, removing nulls and handling errors. Data cleaning is often the most time-consuming part of any analytics project, but it is also most critical. Let's start by null values. Null values appear when the information is missing in a dataset. For example, a customer record might not have an email address, or a sales transaction may be a missing discount, or a lot more. In Power Query, you can choose to remove these null values. Replacing nulls is usually better than removing them completely, especially when the missing value has a business meaning. For example, a null discount might simply mean the product was sold for a full price. You can replace nulls with zero, average values, or even label them as unknown depending on the context. Next, we have handling errors. Errors occur when data is incorrectly formatted, calculations fail, or conversions don't work as expected. Power Query lets you remove errors, replace them, or investigate them. For instance, if 50 rows of date values fail to convert, you can check why. Perhaps the format was inconsistent or the data was entered incorrectly. Lastly, let's talk about the duplicates. Duplicates can inflate metrics and distort insights. Power Query allows you to remove duplicates either across entire rows or selected columns. But be careful. Sometimes repeated entries are legitimate, such as multiple orders from the same name or the same customer. Always analyze before removing any duplicates. Now with that, we enter the section number 3, which is about the column transformations. Once your data is clean, the next step is about transforming columns to prepare them for analysis. Changing data types. Every column has a data type, such as text, number, date, or boolean. The correct data type is critical because calculations and visuals rely on them. For example, if your sales column is text instead of a number, sums and average will fail. Splitting columns. Splitting columns is useful when a single column contains multiple pieces of information. For example, a full name. A full name column can be split into first name and last name. Similarly, a product code like PRD123USA, which can be split into category, ID, and country. Extracting values from Power BI allows you to extract specific parts of a column. First characters, last characters, ranges, or patterns. You can also extract years from dates, domains from emails, or UTM parameters from marketing URLs, conditional columns, or UTM parameters from marketing URLs. Next is conditional columns. Conditional columns let you create logic directly in Power BI query. For example, if revenue is greater than 50,000, mark the row as high value customer. This ensures that business logic is applied before the data reaches your visuals. Next is group by. Grouping helps you summarize granular data. You can calculate total sales by region, average orders value by product, or counts by the customer. This is particularly useful when preparing large datasets or dashboards. Now we enter the section for merging queries. Merging queries in Power BI is equivalent of SQL joins. You can combine multiple tables to enrich your dataset. For example, you might have a sales table and a customer table. By merging them on customer ID, you can add customer names, regions, and other attributes to the sales table. Types of joins include left join, right join, inner join, full outer join, and anti-joins. Merging is essential in real-world analytics because data often resides in different systems. By merging correctly, you can create a unified dataset that drives reliable insights. Now we enter section number 5, pivot columns. Pivoting converts row values into column headers. For example, if you have monthly sales in rows, pivoting months turns them into separate columns for easy comparison. Pivoting is often used when creating matrix-style dashboards. Unpivot columns. Unpivoting does the opposite. It converts columns into rows. This is particularly useful when you receive wide format data such as budgets or survey results because Power BI works best with long format tables. Now let's move into advanced splitting. Beyond simple splits, you can handle complex cases. Splitting product codes into multiple dimensions, extracting UTM parameters from URLs for marketing analysis, separating full names or addressing into components. Mastering pivot, unpivot, and splitting gives you full control over how data is structured, ensuring that your models are both clean and analysis ready. Now, the conclusion to the Module 4. To summarize Module 4, Power Query Editor is the backbone of Power BI. It allows you to clean, transform, and reshape the data in a repeatable and efficient way. By mastering these skills, cleaning nulls and errors, transforming columns, merging queries, and pivoting and unpivoting data, you ensure that the data feeding your reports is accurate, reliable, and structured for analysis. In the next section of this module, we will dive deeper into demonstration of data connections on Power Query, where we will use these clean and transformed datasets to build relationships, create measures, and enable advanced analytics. So now we are in the part B of Power Query. So part B of Power Query is all about importing data from multiple variety of sources. So your data can be in a cloud storage, in a database, in an Excel file, in some folders, in PDF, in WebPreet, which can be analyzed is your data for your Power BI. That's the source for you. So Power Query helps you with that. It can extract the data from any source you give to it, and it will make the data ready for exploration, insights, and analytics. Now we will be exploring that particular tool in our session for today. So let's go with the dataset that we are dealing with today. So in this particular demonstration, we will be using Excel files, folders, and we'll also using web scraping for our data set. And these are the wide variety of datasets that we will be dealing with today. And we'll also be performing some merging and joining operations as well. So let's get started with the simple dataset for now, for learning purposes. So this is our employee dataset. So we have the first column, which is name column. The second column is the gender column, the department column, salary location, and the start date as well. So in the first column, we have unique names, and in the second column, we have gender. So this particular dataset has some elements missing, right? You can see in the gender column, we have some blank cells as well. And in the department column, we have a lot of options: business development, training, engineering, research and development, product management, support, human resources, etc. But along with that, we also have few departments named as nulls, right? So remember this. In a few situations, you might recruit an employee, right? Here you can see this particular employee was recruited in the year of 2025. So maybe he's on bench period. So maybe he's an intern, or maybe the company just hired him based on his, or I mean, the company's requirement. He might be moved into a dedicated team. So there was a little misunderstanding or something going on in process to dedicatedly appoint that employee to a specific domain, right? And apart from that, if you see the salary section, you also tend to see some blank columns or blank rows or blank cells, right? So no blank columns, it's blank rows actually. So you can see another blank here. So these are a few inconsistencies that we have in our data set. And apart from that, if you see the location details, in the first row, you can see 3 Redmond Bay, Bellevue, and Washington, USA, right? So the problem is, let's say you wanted to extract the country, but you might feel we have this particular data in a comma separated, format. So you can quickly go to data validation and separate the columns based on delimiter. But is it the same? No. If you expand this particular cell, you can see this particular data is entered in a new line, but not comma separated. So that's the problem, right? And how would you apply split or delimiter based data validation here? That's difficult. But Power Query has a good tool for yourself. So the thing is, you can explain Power BI what your intention is. Like, let's say you just extracted the first or last few um, words of your particular location. Let's say, since this is USA, I want to extract the last 3 letters in this particular location. You can extract it. But down the line, if you have different countries, maybe Australia, then what it does is it will separate only the last 3 letters of Australia and the rest will be left out. So this is not the way you want to work with your data set, right? So for this, you might have to work in detail with your formula. You might have to struggle writing the formulas for that, but don't worry. If you're not so strong with the formulas and if you're facing tough time to recognize the text character based functions, you can just write few cells. It's like flash fill in Excel. You can explain your intent to your Power Query tool and it will understand what you're trying to extract, and based on that, it will extract the data for you. As simple as that. We will be also working on that. And lastly, we have the start date column. So this is the rough overview of our data set. Now let's go to Power Query. So for that, you might have to go to a new blank workbook. So we can continue with Excel here, but you can also continue with Power BI as well. Why Excel? Because the Power Query interface will be completely same compared to Excel as well as Power BI. So both are Microsoft products. So on Power BI as well as Excel, you will have the same interface for Power Query. So for learning purposes, let's also explore Power BI as well. Now let's create a blank report. And here you can see the get data option, same like Excel. So if you go to data, here you have the get data option, and you have a wide variety of sources you can choose from. Excel, you can choose from text or CSV, you can choose from XML, you can choose from JSON, you can choose from .pdf, or you can also provide a folder. So we'll also deal with the folder option. So in the future use case, we will be creating a sales dashboard where we will be having year-on-year data set. So we'll be having a data set from 2020, 2021, 2, 3, 4, 5, and 6. So you will have a wide variety of sales files, and that particular folder will be saving all these files. Let's say tomorrow you'll have 2026 data or 2027 data on future data sets. What you can do is just drag and drop the file in that particular folder, and Power Query and Power BI Desktop will automatically understand new data has been added to the file, and it will run all the steps we have made Power BI or Power Query to learn and get the data ready for analytics. So we'll also be exploring that. And apart from files, you also have a database. So here you can get connected to SQL Server database, Microsoft Access database, analysis services, SQL Server analysis, and apart from that, you have Azure. So we also have Azure, as we discussed in the part 1 of this particular module, the 4th module. We also can connect to Azure as well as Azure Data Explorer. So you need to have some credentials for that, but don't worry. So for the basic understanding purposes, we'll be dealing with the website data, we'll be web scraping the data, we'll be loading data from files and Excel documents, etc. And you also get some other sources as well. You can, as we discussed, the web and ODBC, OL, EDB from picture. You can also post a single picture just like AI does today. You just post a picture, it will build websites for you, it will extract the data for you. So the same feature is also integrated into Microsoft Power Query as well. You can combine queries where you can append the data or merge the data. Similar to SQL join operations, you can also Power Query editor, you can launch it, and a few more query options. Let's say you wanted to edit a particular step. Okay, when we dive into the Power Query editor, you will see the steps on the right hand side and the queries on the left hand side. So based on that, if you wanted to edit a particular step, you can also do that. So this was the option from Excel. Apart from this, if you go back to your Power BI window, you can see a similar interface. You can go to get data and you can also go to more here, and you have you have file, a database, Microsoft Fabric. So remember Microsoft Fabric, it's the new integration into Microsoft Power BI for data. So it's like a data lake, and you have Power Platform, Azure Online Services, others, right? So I think you already know the detailed differentiation between a data warehouse and a data lake. So roughly, a data lake is where you don't have organized rows and columns. It's like you'll have a wide variety of resources. You have images, multimedia, and all of those, and you can choose. This particular data lakes are very essential for machine learning purposes. You can choose what type of data you want to deal with, and you can directly access it. You don't have to modify and forcefully store the data in dedicated columns and rows. So those are data lakes. You can also explore that further in the data lakes tutorial on our channel. So apart from this, these are the data sources. You can also connect to a SQL Server, Access database, and a lot more. So let's go back to the basics. So we are on the new Excel spreadsheet here. Now all we need to do is quickly import the data from the Excel file. So I'll go with the Excel dataset, and the first dataset that we will be exploring is Excel workbook. So I'll be selecting the Excel workbook here. Now we need to navigate. Let's give it a little time to open the browser window. So my data is in downloads, so Power Query examples, datasets, and here is the employee dataset that we were discussing previously. So click on import, and it will take a little bit of time to load the data. It's establishing a connection. Now, any moment you can see a Power Query window. So there you go. So here you have just one file that's showing you the preview directly. In some situations where you have multiple files, just like we discussed before, sales data from 2020, 1, 2, 3, 4, 5, 6, and beyond. In those scenarios, you might just have one file available for you on the preview. But in case if you wanted to see all the files, you have a little option here, the checkbox, which says select multiple items. So if you just click on it, it will give you all the datasets available in that particular file. Now, I just have one, so you can just click on that particular data and you have a quick preview. So when you click on the dataset here, when you uncheck this, you cannot see the load options, right? But if you click on this, you can unlock or activate the load, transform data, and cancel options. So what these does is, let's say you're completely happy with the data you have. You know that your particular dataset is completely clean and ready for analytics. What you can do is you can directly load the dataset onto your analytics platform. But now it is Power BI, right? You can directly load the data into Power BI and get started with your analytics like building charts, graphs, even dashboards, interactivity. You can add filters, slices, etc. But in case your data is completely raw and you need to manually filter it, then you need to go to the transform data option. So now, since we know that our data set needs some cleaning, we will click on the option that says transform the data. So click on transform data, and soon you have a quick Power Query window. So as we discussed, the right hand side will be the steps, applied steps will be recorded, and on the left hand side, the queries that we are applying on our data set. So in case if you wanted to edit any query, you can quickly come to this section and choose to edit the options. And on the right hand side, you can see already Power Query window has took the liberty to make some changes to your dataset, right? So the first one is it chose the source, then it navigated the source, and it promoted the headers. So what has promoted the headers? If you go back to the dataset, here you can see the first row is name, gender, department, salary, location, and start date. So Power BI's Power Query or Excel's Power Query was intelligent enough to understand that the first row entry is the metadata or column header, or you can call it the name of the column in most layman's terms. So it understood that this is the row header, so I need to push this as the column header or the row header, and it took the liberty to do that. And apart from that, it also took the liberty to change the data type. So if you come back to the original data set, you can see it understood the format. So we have the dollar symbol, right? It automatically understood that this particular number should be a whole number because this is a salary number. And the location details are automatically set to character. You can see the ABC logo here, and you can see the 1.2 symbol, which means the whole number with decimal points. And you can also see the ABC character data type for department, gender, and name, right? So these are the few steps which Power BI took the liberty to help with us. And now let's go with the first requirement that we were talking about. In the original dataset, we had some errors, right? So we had some null entries. So we need to change that. So here you have the option. But before we begin with any operations, let's have a quick overview on the ribbons we have. So here you have the close and load option. This is the most important one. Whenever you apply all the steps you need and you're happy with the dataset transformations, then you come here and choose the option to close and load. What this basically does is it saves all the transformations that you apply to your dataset and saves them, and then loads the data to your Power BI platform or any platform you choose. So you have two options here: load, like close and load directly, or if you choose a different one, let's say you wanted to load to the Power BI platform, you can choose that. So the default close and load will load this particular data to the Excel because we're working currently on Excel. So that's how it works. And next comes the refresh preview option. Now, what is refresh preview option? As we discussed, in a file, there could be chances that you might add new data eventually. So whenever new data is added eventually, you just need to click on the refresh preview and Power BI will automatically understand there is new entry for the data, and what it does is magical. It takes its navigation directly to the applied steps. So here it changed or applied a few steps here. So it again changes the data type, it changes the promoted header step. It will remove the first row and it will automatically think this is the column header and it will promote it to the column header. And apart from that, if we are going to perform some operations here, like adding others to the gender column and changing the null value to engineering or any dedicated department, and then in salary section, if you remove the null values and then if you separate the country from this particular location column, it will record all those steps and it will automatically implement these new steps, these particular steps onto the new data. And you don't have to do this repeatedly. The most important aspect of using Power Query is automation. So the entire part of your data transformation will be automated. And whenever you load new data, you don't have to, worry about anything. Power Query will handle all the transformations and gets your data ready for your next step, which is data visualization. That's the magical part of Power Query. And apart from that, you have properties, manage, and choose columns. If you go to choose columns, let's say I just want the name and department here. Now what I can do is I can choose the columns and then it will give me a window. So let me go ahead with that. So it will give me a window where I have the liberty to choose whatever columns I want. Let's say I want to go with name and department. It will give me only name and department and any other things which we want to go ahead with. So that's the best one. And remove columns. So here you can see promoted to headers, right? But in case, if let's imagine that our data set had some misconceptions, like the first column or the first row was completely empty. In those scenarios, Power Query will consider that empty row or an empty column as a null value. and we don't want that null value. In those scenarios, you can choose to remove that particular column or that particular row completely. And you can see a similar option here, keep rows and remove rows. And the similar options like Excel, where you can sort the data in increasing order or decreasing order. And remember the column splitting that we spoke about, the data validation option that we used to have in regular Excel, where it identifies the delimiter and splits the data into columns, right? So that option is here, and you can also go ahead with group by options and use first row as headers. So this was the step I was talking about. Power Query automatically did that for you. Don't have to worry about it. And replace values, we'll be using this replace values. So the first place where we have to use these is replace the null values with a dedicated value you want to add in. And apart from that, you have merge queries option, append queries option, and manage parameters, data settings, and a few others. And here you have the transformation option where you can transpose the data, reverse the rows, count the number of rows, use first row headers. You can fill some data sets, and you have pivot and unpivot columns option here. We'll also be exploring that. And you have extract the data, parse the data, statistics, standard deviation, and scientific columns. And you also have a date option here because we have date column here, right? And you can also choose to add some customized columns as well. Remember the column I told about where you don't have to worry about the formula. You just have to explain Power Query what is your intention, and it will extract the data for you. That's the one here. So you can choose to have a custom column, or you can also choose this particular one. Our requirement is column from example. So you will add a new column. You will provide few examples from the location. You'll just write USA, and in the next one you'll write the next country, which is New Zealand, NZ, and so on. So based on your requirements, based on what you're applying, it will think like you. It will understand your thought process, and based on that, it will help you extract the countries. That's magical, right? So no worry, we'll also go through that in a moment. And the last one is conditional column, duplicate column, all those. And the last one is the view one here. So you have formula bar. Okay, remember the formula bar. For now, you have this particular formula bar. Let me highlight that, right? So I've done this a few times, so I have this particular column option available. So in few scenarios, if you're new to Power Query, in very rare scenarios, the formula bar is not visible. In such scenarios, what you can do is you can go back to the view option and enable the formula bar so that you can see this particular formula bar and see what is the operation being run on your particular data set. So this was the quick overview of your ribbons on Power Query window. Now let's go back to the home ribbon, and here the first operation, department. So we will be replacing the null values with some dedicated value that you are interested in adding, right? So yeah, I think we missed out the second column. This was the gender column. We need to work on this first. So you just need to select the column, and there are multiple ways to do this. You can, go to the add column or transform option and choose the replace values from here, or simply right click and then you have the option which says replace values, right? So for now, I think we have null, the empty value. So there are two meanings for it. If it is lowercase null, it means the columns or that particular cell is blank. But in case if it is capital null, then it means it is character data type and it was dedicatedly written as null, right? So you need to understand the basic difference between nulls. So this is the null value we're dealing with. And in place of any blank cell where the value is null, let's write it as others. So others will be the gender in place of a null value. And this will be your first transformation step. And take a look on the right hand side. So whenever I click OK, a new step will be registered. So that was the replaced value, and a new step has been successfully registered. So if we scroll down the data, we should be finding some others. So here you can see the others entry, and now the first column, or in our case, the first transformation is successful. Now comes the department part. Similarly, you can go ahead with the replace values option here. And in this particular option, we need to write down uppercase null. And let's imagine any new employee, let's say our requirement is in engineering. So any new employee which has been recruited will be provided to engineering department. So I'll write it as engineering, or it could be product management based on the requirement, right? And I will click OK. And the next replace value function is also successfully done. And this is simple, right? This is our imagination. But in case if it is a little complicated, let's say any employee that was recruited in the month of March 2025 should be for marketing, and any employee which was recruited in the month of May in 2024 should be for business development, right? You can also do that. You have the operation called add column based on a condition, and you can provide the conditional column and then move these employees to a dedicated team. And that's a lesson for the next session. Now we have another column, so let's quickly go ahead with that. In here, you have null values as well. So instead of just replacing these null values with some random data and making it complex, since it automatically took it to a float value, here you can see the fourth step, right? So let's not do that complication, but instead what you can do is just quickly apply a filter and unselect null, so that all the employee details which are no longer working with this particular organization are erased. Not erased totally, just filtered out basically. So now this was the thing. Apart from that, if you wanted to, yeah, the next operation is about extracting the country. So now the fun part. So go to add column, and here column from examples. Now here it will ask you two options, from all columns, and the second one from selection. So we want to go with the selected column. So we'll go with the second option, from selection. Now it's your duty to train Microsoft Power BI your thought process, the way you're thinking. So if I go into this particular cell and I write USA, it understands, okay, he's trying to extract the country USA. Automatically, wherever it finds USA, it has extracted USA. It's still in process. Now I come to the row number 3 and I'll write NZ for New Zealand. It understood NZ, and here you can see the highlighted row number 6. It has written some ELS, but ELS is not my expectation. So what I'll do is I'll quickly rewrite this as USA. It might take a few iterations, but not more than 6 or 7. It should, like, normally 2 to 3 iterations will make Power Query understand your requirement. So you can just eyeball everything, and once you're happy, I think we have about 1,000 entries here. So 1,000 entries are good enough, and all the entries have successfully extracted the country. And you can just click on OK, and your new column has been successfully added. You can also rename this particular column as country PRY. There you go. So your new country is successfully added. And in case if you don't want this, you can eliminate it. But in case if you want to continue having this address, you can keep it. So for me, I don't want it right now. I'll feel free to eliminate it. And you have a good amount of data. And in case if you wanted to go ahead with, the separated column for year, you can also do that. So you just need to go the first column, which is start date column. You can select the column, and here you have the date option. So what you can do is year. Select the year, and a new column which is dedicated for year has been successfully added for you. So your data is almost ready for analysis. So what you can do here is you can just go back to the home option, and here you can choose to close and load the data. So there you go. You have a completely filtered and purified data ready for analysis. In the same way, your data will be loaded to Power BI as well, and you can go ahead with visualizations part. So on the flow, in these next upcoming sections, we will also go to it, where we will load the data directly to Power BI, and we will start with explorations as well. And we will also create a wide variety of charts, column charts, bar graphs, pie charts, donut charts, and a lot of options which are available. And apart from that, we will also create a highly interactive dashboard. As discussed before, we will be having sales data sets, and we will be working on the first current 5 years of data sets. And then we will also add a new data set of the upcoming year or the current year, and then we will just refresh the dashboard, and automatically it recognizes the changes and it will load the data, and you'll have a fresh data set or dashboard which is completely interactive. So there are a lot of things which can be done. And here on the right hand side, you can see the query options. If you click on that, you can see you will be back on the Power Query window, and you can see all the steps that you have applied. And in case if you want to change anything or if you want to remove anything, you can feel free to just click on that cross icon there and it will remove that. So that's how it works. Now you can close this particular query settings and go back to the dataset. And in case if you have any connections with other datasets as well, you can establish that connection with your datasets and it will be good to go. And you can also include this particular data for creating a pivot table as well, which looks something like this. So let's select all the data, which is completely clean and ready for execution. You can go into the option which says pivot table, and here you can choose a new sheet. This is how it looks like. So you can choose to go with a new sheet, and you have a pivot panel ready for you. So what you can do is maybe drag and drop department into rows, and then you can also include the salary, and now you have how much salary are you paying to each department. And apart from that, if you wanted some a little more detail, you can also drag and drop the name row to values. So you have the count of employees in each department. So you can see product management has almost highest kind of number of employees, and you can also choose to kind of sort this just like you do in regular Excel. You can choose this particular table and then you can sort based on increasing or decreasing order as provided here. And apart from that, you can also choose to add a date or year here. So year to columns. So you have a side-by-side approach of 2024 data and 2025 data, and all the details of the employees and the salaries, everything, right? So this was the first approach, and we can name this as pivot table, right? So this was the first approach of loading data from an Excel file. Now let's go with the second approach where we wanted to get the data from a web page. So I'll close this Excel file. You can choose to save, and let's also save the previous one. This can also be saved as a reference file. I think I saved it previously already. Yeah, there you go. Now we have opened one of the web pages, and I think Power BI is also open. Not a problem. You can close this. Don't save anything. Yeah. So we can choose any of the open source datasets. So before you go ahead with web scraping, understand this fundamental rule. So there are many websites out there. It can be based on cryptocurrency websites. You can also know where the current value of a Bitcoin or any crypto coin, right? So such websites, they have some security concerns. That particular data is not available for open source, right? So most of the times when it comes to data analytics or business analytics perspective, web scraping is very rarely done. But from organizational level, web scraping can have a little bit of room for it. So there will be websites which have a dedicated log for them. So they don't open source their data for public users. And there are some websites which are open for everyone. So based on your choice or based on your requirement, you can go ahead with the web scraping option. So in my case, I'd like to go with some open source learning pages like Wikipedia, something like that. So I'll type Wikipedia, American population or Indian population demographics, such datasets. So let's go with this one. United States territories by population, or the first one, demographics of United States, right? So here we have some data tables. So here we have median males, females, total population, country, and yeah, this is year-wise data. And here we have rank, name, side-by-side approach. Yeah, this one is also good. Year-wise, average population, live births, deaths, and all those. So you can choose any of the web page that you feel comfortable to work with, or based on the requirement, if you if you receive any of the dedicated link, you can go ahead with that. So the approach is simple. So I think this particular data looks good. So here we have, state, and then census population, and largest cities, etc. So I'll go ahead with this particular web page. So I'll copy the URL. This is the first step, and go to Excel. Once you reach to Excel, you can create a new workbook, or you can choose to go with the reference workbook as well that we created previously. I chose to go with the new workbook, and here we go to the data option. So it is completely similar in Power BI as well. So we are doing this for learning purposes on Excel, and once we're comfortable, we can go to Power BI. So since Power Query has the same interface on both Excel and Power BI, it's comfortable to go with Excel as well. I think I closed Power BI. Yeah, so blank. And here you have the get data option. So here you can choose the option which says web. You just need to simply, okay, cancel. You just need to simply drop the URL and it will load the dataset for you. This is the one. You can simply place the URL and click on OK, and it will open the Power Query window for you. Similarly, while that happens, you can choose the get data option, and here you can provide from database, Azure, others. Here you have the web option from web. So if you are applying this for the first time, you might get a few options where you have to choose basic or advanced or based on the requirements. I've done this a couple of times. So it will just directly take the request and load the data for me from Power BI or Power Query window. So this is the one I was talking about. So access web content. So here is it asking for anonymous, Windows, or basic. So you can choose anything based on your requirement. If it is basic, you need to provide some credentials. If it is Windows, and you need to provide the current credentials of your Microsoft account, I would like to go with anonymous for learning purposes and connect. And slowly the Power Query will be starting for you. So meanwhile, let's also check on the Power BI platform. So here you have the preview. So it's completely similar on Excel as well as Microsoft Power BI. So you can just go to the view option. So this is the first table. So here we have columns and rows. So here you can see some values. So if you go back to the dataset on web page, here you can see some aggregations of, not aggregations, combination of the first two rows. So the first two rows were combined and named as state or territory. In the same way, here you can see the preview. Null value is placed in the first entry, right? And some naming conventions are gone wrong based on the web engine here. So here you can see some links, right? So some links are attached to this particular table. So what Power Query did is it considered this as the data entry, and this particular elements are also visible on the Power Query window. So you have the complete authority, and you have the complete options to rename the columns and eliminate the first row, right? You can do some changes on that. So let me close this here and go back to Excel. Let's see if that got loaded. Yeah. So here you have the select multiple items. So you can choose to select multiple tables you want to go ahead with, or if you want to go ahead with only one, like we discussed. So we can also go ahead with only one table. So you can quickly have a preview. So if this is the one you're looking for, since we had a lot of tables in the original web page, right? You have a table over here. You have furthermore, if you scroll down, you have one other table here, another population states table here, right? A lot of tables. So you can go through all the tables, preview, and select the one which you're looking for. So this is the one I'm looking for. So what I'll do is go to the transform option, and now it will open me the query window. So just like we had before, left hand side will be for queries and right hand side will be for applied steps. And similarly, it shows the liberty to do some changes for us. It promoted headers, changed data types. So I want to take the control for myself. So I'll remove the change data types and also promoted headers. So far so good, not a big problem with the headers, but we always have the option of renaming, right? So now let's rename this particular column header as census population _1, and this one as well. So we can go with rename. So this could be census population _2. Largest cities is good enough. Largest cities 2 is good enough. House seats B. Okay, why don't we name it as A? Or I think since house seats is good. Now this will be B by default. Let me remove this. There you go. You can also vote. So rename votes to population percent votes in 2020. And this can also be renamed. So this is simple, but we are doing it for multiple times so that you have a quick understanding. You have a grasp of how to continue when you're on your own. So here you have percentage of US in 2020, percentage of EC in 2020. And now so far so good. Now, remember the option that we were discussing about removing rows and columns? So here you can see some irregularities in the first column or first row, right? So here you can see largest cities. Okay, I think this can be named as city name, right? So rename it as city name and city population so that it is a lot more easy to understand, right? And seats could be good. Our seats percentage null, right? So far so good. So what you can do is choose the remove rows option and it will ask you the options, top rows and bottom rows. Based on your requirement, you can go ahead with that. So I'll go with the top rows, and what I will do is it will ask me how many number of top rows you want to delete. Let's say I have problem with the top 2 or 3 rows. I can directly specify the number as 2 or 3. But now I have only problem with the first row, so I'll provide the number as 1, and automatically the first row will be eliminated. Again, when dealing with such web extracted data or web scraped data, you need to be very careful about the steps you're applying, right? Now, for this scenario, we have changed some column names and all of those things, but tomorrow the columns might be rearranged. For example, here you can see state and territory. Next one is census populations, right? Instead of state and territory, you might have city name, right? The columns might be swapped, or maybe for the next time, the hyperlinking on the data table may not be done, right? And also there is a good chance where the dates, right, July 2024, April 2020, city names, city population, there might be slight changes to these, right? So this type of operations, when you're dealing with web scraping, you need to be at most careful with what are the steps you're applying. Mostly these are not preferred in real time in business perspective or data analytics perspective, but on the organizational level, very rarely this will be done, but it can be a long time consuming process. But make sure that you're applying all the steps that you are considering. Now, if I see all the data set ready for me. Now, what I want to do is I'd like to select few columns and run my analytics. So we have the choose columns option over here. So I'd like to choose the columns of city name, city population, and maybe population percentile of vote, and OK. So out of 3 million people, only 720 or 732,000 people chose to vote, or maybe some miscalculations in the voting terms, right? So let's go with the analysis part of it. I'd like to go with the population city. And if you're comfortable with the data set that you have, you can choose to close and load. There you go. So the queries, connections, extremely similar to what the process we made previously. And you have the option of forecasting, right? So in the current year, this is the population and what could be the future population. You can add a quick, forecast data for your data set. And apart from this, you can select this particular data set and you can choose to go ahead to Power Pivot, and here you can insert a pivot chart. So you can go ahead with any of the charts available, and you can have a demograph of all the charts. And that was part 2 of loading the datasets. You can quickly choose to save this file, and let me save it as reference 2. And now will be our next part. Now, so far we are done with the web import of data. Now let's go with another part. Cancel. We don't want to close Power BI yet. So the other part will be where we will be processing some appending and merging operations, which are completely similar to SQL joins. So this has been saved, so I'll close this. Save and close. I think we have a lot of states there. That's the reason bar chart was not showing any data. Not a big deal. So just for learning purposes of web scraping, we did that. So now I'll start a new workbook altogether for the third reference part. So the third part, initially we did Excel, then we did web scraping. Now we will be doing the appending and merging operations. So this is the fresh workbook. So again, we need to go back to the data option. So we will be loading the data from file, and again, cell workbook. So this workbook has multiple files in it. So that's the overall approach where we will be performing the appending operations. So we'll be in data sets, and this is the one, students and courses, right? We will load it. It might take a little time, but not to worry. Yes, there you go. So you remember the select multiple option we discussed before? That's the one. So we have courses, so we have years as well. So now we will be transforming the data. So now we are on the Power BI's or Power Queries window. Now, so this particular table is the courses table. So we have some random courses here, the respective teachers, lesson type is a practical theory or internship. Then we also have credit score like 1, 2, 3, so 4, so on. And we also have assessment type. Which type of assessment did they face? Was it a quiz type assessment, continuous assessment, return or project work, or was it oral assessment, right? Just something like that. And then we have year 11 and year 12. So these are the students in year 11 and these are the students in year 2. So what is the main purpose of this particular attempt? So in this particular attempt, as you can see, we have students, their gender, their course, and we also have courses. Now I want to know which particular student has taken what course and who was the dedicated professor or teacher, and what type of lesson are they receiving. Is it practical, theory, internship, anything like that? And then what are their scores when they write an exam or when they have an oral exam? Then what is the number of marks that they have achieved in what format? I want to know that. But here all I can find is student name, gender and course, their marks or the grades that they have received, what type of lesson did they receive, or what type of assessment did they face, who was the teacher. These details are not available in any of these tables. And again, we have two different tables here. One is year 11, another is year 12. Now how do we do that? That's the question, right? That's where the home ribbon has two options, merge and append functions come into the picture. So automatically it changed some data types. So here you can see only applied steps, and here as well it has changed a few things. And when it comes to courses, so credits, it took the changed data type, it automatically made it to a whole number. That's great. Now we need to combine both year 11 and 12. So for that, I'll choose year 11 and go to merge queries. And after that, I think we were supposed to go with append queries, not merge. Merge is the next step. So 2 tables. So you can choose 2 tables or more than 2 as well, 3 or more. For now we have just 2, so we'll go with the 2 tables option, which is default one. So here you can see we have year 11 as current. So that means we are currently in year 11 table. So I want to connect or append the data of year 11 with year 12. Then press OK. And now you have all the data of year 11 and year 12. But there is a small bottleneck. How do I identify which student belongs to which year? Okay, and also I think we missed out on the column headers. So in such scenarios can be reverted, not a big deal. So what you need to do is just click on the cross sign here to remove that function. And now what we will do is we will do some changes. So select the dataset and then click this particular option which says use first row as headers. So this is the fundamental thing which you need to remember. Always check the column headers. Once you're satisfied with the column headers, then you can go ahead with the rest of the process. Now this was step 1. Now what I want to do is add a dedicated column which says this particular column is data related to year 2012. So I'll add a custom column. I'll name this as year, and within I want to add a text based input here. So within the double quotes I'll add year 12 and press OK. So this is automatically, okay, we need to change the data type. You can change type to decimal, whole number, percentage, text. I want to keep it as text. So again, let's try that again. Okay, there you go. Now similar approach should be followed in this particular table as well. So we will go to a custom column. So the custom column will be named as year, and within the double quotes we should write year as year 11, so that now we have a quick identifier which student belongs to which year, right? And again we will change the data type from number to text. There you go. Everything is good to go. Now if we append, we can identify which student belongs to which year, right? Now we'll go back to home option and here choose the append queries. So append means we are attaching, here you can see the logo, you are attaching one dataset under the other dataset, right? So click that. You have 2 tables, so go with the default option. But in case if you have multiple, then you can go with 3 or more tables. So let's go with 2 here. So we are in current 11. So I want to append the 11 with 12. So click the option table 12 and now you have appended the data. So if you scroll down, you can see until row number 175, we have 11 years, and after that we have year 12, right? So far so good. Now the next task is map these with courses. So for that we might have to go to the option of merge queries option, right? So here we have course table. So if you go back here, you can see in year 11 and 12 each and every student has a course. So what is course? If you go back to SQL, there if you are merging or joining 2 tables, you will merge or join them based on one key, and it is called as primary key, right? So you need to have one common column or one common entry on both the tables based on which you can attach or join both tables. So in this particular scenario, course column acts as that one primary key for our merging option, right? So I want to merge year 11. So that's the one where we have all the data sets, right? So you can even rename it. So year 11. Okay, before we do this, it's better we rename this. So I'll rename this as, okay, before we rename, let's make a small confirmation. So we have both. Okay. Now we will rename this as students. Okay, we have students data table and courses data table. So again, go back to courses, use the merge queries option, and the table I want to merge with is students data table, and based on what parameter. So I would like to go with the course parameter or the course column as my primary key. So far so good, you can continue merging, but in case if you want to merge with referencing more than one column, that is also possible. So what you have to do is just hold control key and then click on the column which you want to refer. So here in case of this data set, I'm just randomly selecting gender and teacher, but for our data set, just one column is enough, which is course, and we have selected that successfully. Now, if you scroll a little lower, you have join kind, right? If you open the drop down, you have left out the join, which says all from first matching from second, and second one is right, all from second matching from first. Next, we have full outer join, all rows from both the tables. Inner join, only matching rows. Left anti-join is about only the first join. Right anti-join is about only the second one. So the best one to be safe side, right? Even if it is a replica, you can go with full outer join. But the default one chosen by Power Query is left outer join. So I want to go with the default option here. So the selection matches 19 out of 19 rows from the first table. So it's good to go. If there is any error, you could have found it over here. And you also have some option called fuzzy matching options. So if you know what is fuzzy match, you can also proceed with this one over here. But now we don't want to work with fuzzy match. We are good with left join. So you can simply click on OK and the data will be merged. But right now on your screen on Power Query window, what you can see is just table entry. So where are the rest of the entries, right? You don't have to worry here. So all you need to do is go to the top right corner where you can see two arrow marks, one going to the left and one going to the right. So that is kind of an option which says you need to expand this particular column. So if you click on that button, the data will be expanded. Okay, now you have the respective course, the teacher, the lesson they are giving, and what is the credit score or the number of marks they have achieved, what type of assessment did they give, and who is the student and their gender, the course they took, and which year do they belong to. Everything in one shot. Now you can go to the option which says close and load. So click on close and load. So yeah, there you go. It has established connections, queries, and everything in one shot. So now you have three different tables on the right. You can see courses, students, and year, right? So the latest merge option which we did is currently in courses. So click that particular one and you have everything in one shot. So you have the course they have taken, teacher, lesson type, credit score, assessment, and everything. So now let's consider a small use case. Let's say we want to award people who have taken practical lesson and have scored more than 2 or 3 credit scores. So for that, how do you do it? So we have a simple filter operation right here. So you just need to click on the filter operation. It is taking a moment. So you can go to home and apply a filter. There you go. Now you can click on the filter, close this. Or I'll do one thing. I'll create a fresh new sheet and then paste it over here. Courses. And here I'll be pasting it. There you go. Now we have a shortcut if you remember. Control Alt H O I. Undo that. Alt H O I. For adjusting the row width, and you have successfully adjusted the row width. Now these are your columns and rows. What you can do is quickly apply a filter and you can segregate your data. So I want to choose practical. The filters are not loading for some reason. But basically that's how you do it, right? So you quickly apply a filter. Okay, let me delete this. For some connections, I think it is unable to load properly. So let's try that again. If the filter is functional, I can see the filter getting loaded, but for some reason it is not staying on the screen. Yeah, so basically what you can do is, let's try to create a new sheet altogether without any data connections. Now we will do select all the columns, Alt H O I to adjust the width, apply a filter. I think this should help. Yeah. Yeah, basically what you can do is apply a quick filter, select the filter option, and in which you will select practical, and here you will apply a condition where filter condition will be credit score should be greater than or equal to 3 or 2, right? Based on that the data will be filtered. So for some reason I can see the filter, but it is not staying long enough on the screen so that we can apply it. Could be a small technical error, but that's how you basically do it. And that brings us to the end of module 4, where we have learned the basics of Power Query, how to clean the data, how to split into columns, and how to do some basic functionalities like creating an additional column which extracts the data from a logic based on your thought process. And we have also done web scraping. We have considered the Wikipedia open source data sets to do that. And now we have a comfortable understanding of Power Query in both Power BI and in Excel. Both the domains are one and the same. So in the upcoming modules, we will be learning data modeling, DAX calculations, data visualizations, and creating a completely interactive dashboard, which includes slicers, filters, and a lot more. Now let's proceed to the next module. Welcome to the module 5 of this Power BI full course. So module 5 will be about the data modeling in Power BI. So what exactly is data modeling? Imagine you had a store or some online website where you sell some products. So you have shipment data, product data, geographical data, and the sales team data. And apart from that, you might also have calendar data, which is really vital in business analytics. So all the tables are interconnected. So one, which is the shipments table, will be connected to the product table, also to the orders table, sales team table, and the calendar as well, and also to the geographical location, right? It's like the shipment data table is in the middle of all the other tables. It's forming a schema, it's forming a shape, right? So this is data modeling. It might be a little confusing, but don't worry. To have a better clarity, we will go to an Excel dataset so that we have some detailed understanding of what exactly I'm talking about. We'll also deal with the fact tables, dimension tables, relationship between all the tables, and how exactly a data schema is made. And then we will also do some sample visualizations using that particular data model. Now, let's go back to the Excel dataset. So now we are on Excel dataset. So we have a shipments table. So we have dimension data and also the calendar. Now, when we come into the shipment table, we have shipment ID, SPID, PID, GID, ship date, amount, the number of items, and order status. So we will look into each of these columns. So the shipment ID is a unique ID for each and every shipment that you made from your website or your inventory. And SPID is the sales team's ID on which this particular sale was made. Who was the person who was the one who is authorizing this particular sale and who took care of the rest of the process. Then we have PID, which is product ID, which product was sold, and the GID is about the geographical ID based on which geographical location was the order placed from or delivered to. Then we have ship date, based on which date was the shipment made, what's the amount and the number of units sold, and what's the status of the order. Is it delivered, or is it in transit, or is it shipped, right? Some details of that. Now, what are SPID, PID, GID, and ship date? How are they related to shipment data table? That's our next approach. So here we have the dimension data. So in dimension data, we have three tables. The first table is the product table. what products are in our inventory, what category they fall into, what is the cost per unit, and what is the PID. So basically this particular table, the entire table has to deal with one item, which is about the products item, right? Now here you can see the fourth column, which is stated as PID. Now PID is the primary key which can be used to connect the product table to the shipment table. There is one connection established successfully. Now let's go into the second table. So the second table is nothing but the geographical location table. So here we have a geographical location: India, US, Canada, New Zealand, Australia, and UK, and also the regions: APAC, Americans, APAC, Europe, etc. And here we have the third column which says GID. Now this particular GID acts as the primary key which combines the shipment data with the geographical data. So here we have the GID and the shipment ID. So this particular table deals with the geographical location. Now going forward, we have another table which says about the salesperson or the sales team, right? So here we have salesperson who is responsible for the sale, and here the team to which they belong to. And third column is the SPID, which combines the shipment data table with the salesperson data table. So this is the SPID we were talking about. Now, apart from these 3 or 4 tables, including the fact table, we have another table which is called as the calendar table. So this particular calendar table is nothing different to your regular calendar. It has all the dates, all the months, all the weekdays, and the year table, right? So this is like a calendar. So whenever there is an order or shipment made to that particular date, we will have a registry here. So that is how the calendar table works. Now, here in the shipment data, you have the ship date. So this particular ship date is connected to the calendar table here, right? Now we have all the 5 tables as per the discussion. Now we enter into the schema, the star schema, which is one of the most popular schema used in the current world of business analytics and data analytics. So here you can see this particular table is the fact table. Why is it called the fact table? Because rest are the dimension tables which deal about the people. So it might be the customer data or it might be the salesperson data. So basically any table which has the details related to customers or the salesperson is one dimension table. And the other table is the product table, which solely deals with the product details. And the other one is the calendar detail. So this particular table wholly deals with only the calendars. And the last one is the location table, which only deals with the location details. So all these people, product, calendar, and people data tables, which uniquely work on one single aspect, are connected to the fact table, which maintains the details of all these tables. Let's say I want to find out, if we go back to shipments table, I want to find out the details on this particular shipment ID, which is 058. So what is in 058? Who was the person who made this sale? What product was sold? To what particular location? And how many orders were placed? What is the status, right? All these details are not available here, but instead of that, we have the SPID. So if I explore the SPID, I will get this particular entry. So this person was responsible for that particular sale and he belongs to this team. And if I go back, here I see P01. So what is the product? If I enter P01, I have this particular product and this particular category, and this was the cost per unit, right? And again, if I go through the GID, this is geographical data. So GID 3 is Canada and the region was Americans, and this is the location where the shipment was sent. And now on what date? It was 28th of June 2024. So here I have that details as well, June 28th, right? And at last we have the total amount paid, the total units sold, and the status was delivered, right? So this is how each and every table is connected to one another, right? So shipment table falls in the center location, and all the rest of the details, which is calendar, people, product, geographical location, all are connected to the shipments table, which is the fact table, and rest of the tables which surround the shipment table are called as the dimension table. Now this might be a little confusing still, but don't worry. Now we will close this particular data set and head back to Power BI so that we have a comfortable understanding of what exactly I was talking about. So now we are on Power BI. Let's create a blank report and let's load the data from Excel. And here I have the sample sales data. So I'll open this. It might take a little while, but don't worry. So there you go. So this was the sheet 2 where we created the diagram. Don't worry about that. Now we need calendars table, locations table, people's table, products table, and the shipments table. So shipments is the fact table, calendar, locations, people, and products are the dimension tables. Now this particular data that we have is fine. We don't have to do any data cleaning. This was previously cleaned and processed data. So we can directly load the data from this stage. So let's click on the load button and it will take a little time to load all these data models to Power BI. So there you go. You can see calendar, locations, people, products, and shipments are loading. And you can also read creating connection in model. So data modeling is already happening. So detecting relations, 670 rows loaded successfully. So on the right hand side, you can see the data, right? If you scroll down, you can see calendar, you can see locations, people, products, and shipments, right? So these are the basic entries that we are having. Now, what are we talking about data model since so long? So here you can see the report view, data view, or the table view, and this is the model view. So if you click this, you will now understand why we made that diagram on Excel spreadsheet. So here, let me close this as well. So here you can see how the products table is related to shipments table and how locations table is also connected to shipments table and how the people's table is also connected to the shipments table, right? They create a star pattern, almost a star pattern, right? Now, you can see a star logo here, right? If I expand, and you can see one number here. So what this specifically means, this is many to one relationship, right? Many entries of shipments table are related to one element of this particular people's table, which is SPID. Remember the analogy we discussed? That's what it is. So here, many entries of shipment table are related to one entry of locations table, which is GID. Similarly, we have the many to one relationship here as well, where many entries of shipment table are related to one entry in products table, which is PID. Now, the only data which is not connected still is the calendar data, but not to worry, we can connect that as well. So here we have calendar date and here we have shipment date. All you need to do is click and drag this particular element to calendar date and you can establish a connection. Now, here you have a new relationship. So Power BI is showing you this kind of relationship can be established between the two tables. Now you need to cross verify of the elements you're choosing, ship date and calendar date. Once you're satisfied, you can proceed. And here you have by default many to one because Power BI's model was able to identify which kind of relationship can be established here. But in case if you're not satisfied, if you want a different approach, you can also move the cardinality from one to one to many, and many to many. By default, it is many to one. Let's keep it that way. And you can also go with cross filter direction, which can be single or both. For now, single is enough and single is the one recommended. So let's keep it that way and save this. And you'll have a relationship with this particular element as well. So multiple elements of shipments table is related to one entry, which is calendar date in this particular module. Now let me lesser the size. Let's zoom out and zoom in. So that's how the relationship looks like. Now, apart from this, you also have properties, which helps you understand what kind of relationship has been established between any two tables here, the cardinality, and you can also manage relationships here. So here the shipments GID has got many to one relationship with locations, and shipments has many to one relationship with PID, and shipment ship date has many to one relationship with calendar, and shipments SPID is collected to SPID in many to one format as well. Now you can close this, or you can also add a new relationship or edit an existing relationship or filter any of the relationships present here. Let's close this for now. And apart from this, you can also create a new calculated measure, new column, new table, calculation groups, and you can also manage the roles, view as, right? Basic functionalities. Now you also have the data details here, data model. So you can go and take a tour. Now let's close the model view and go to the report view where you can create sample charts. For example, I want to know the geographical location, or we can also go with the Q&A visuals. If you double click, the Q&A will start here and you can just simply type what are you looking for. I want to know category wise sales in region, geographical region. Category sales region, and the type of chart could be bar. Now you just wrote simple English language and the Q&A is trying to understand what are you looking for, and it will try to generate a visual for you. Or you can give it a moment and try to do it all by yourself. So I would like to go with bar graph, or you can go with the pie chart as well. And now what you can do is add geographical location. Since we're dealing with geo, why should we not go with map? You can also go with map, but that's not nothing to worry about. So what you can add is you can add this here, and you want values. So I want to go with the summation of amount, order status, monthly status, total sales. So I want to go with summation of amount and it will be added in values. So here we have a readily available visual. So we sold about 23% to UK. So you can also add tooltips. So I'll add geo to tooltips. And in India, we sold about 23% of the sale. And in USA, we had 17% sale. And in Australia, 17.47, something similar. And in New Zealand, we had 12% of sale. And in Canada, we had about 5% of sale, right? So apart from this, you have a wide variety of other visualizations as well, like slicers, funnel charts, cards, and a lot more, which we will be exploring in the upcoming modules. And with that, we have come to an end of this module on data modeling. In the upcoming modules, we will deal with DAX calculations, basic visualizations, and building an interactive dashboard. So now we enter our next module where we will learn the DAX expressions. So DAX stands for Data Analytics Expressions, but for some reason, instead of taking DAE, they took DAX. And simply, the same DAX is also as complicated as the naming convention. So we will have a lot of, let me cancel this. Yeah. So we will have a lot of naming conventions in DAX, and also we'll have one common misconception if you're a total beginner, or if you have transferred from Excel to Power BI or any other platform to Power BI, then obviously you'll definitely have a small misconception that DAX is all about some basic aggregate functions like sum, average, mean, median, standard deviation. But it is a part of that. Apart from just being an aggregate function, DAX has a lot of other things to deal with. So in simple terms, DAX provides you a lot of freedom when it comes to deep diving into data analytics. You can kind of write your own mathematical logic. If you understand your business requirement, to be honest, before you dive into DAX, you need to understand what is the business perspective of your business owner. If you are the business owner, or if you're working for an organization, then your organization's business perspective, you need to have a good stand on that. You need to be able to understand what your business owner or you as a business owner is expecting from your data, right? Once you have that particular clear vision, you need to extract the data and clean the data. Unless you have a clean and perfect data, writing DAX would always end up in miscalculations. Let's say for a simple example, if you wanted to divide a certain column with another one, if you had zeros in it or null values in it, obviously if you're directly dividing column A by column B using a slash, then definitely you'll end up into zero errors, right? The error that you get divide by zero, correct? If you change few things in the same division function, instead of writing a slash, if you write divide and the column main, comma, column 2, then you might not end up with that zero error, right? Divide by zero error. So few minute things you need to keep into consideration when you're dealing with DAX. That's one thing. And apart from the regular average or sum or aggregate functions, there is a lot to deep dive in measures and all the DAX functions. So with that basic understanding, let's dive into the DAX functions. Now let's create a blank report. And here we will be working with the same dataset that we worked on the previous section, that is the sales example dataset. So we will be having the calendar, location, people, products, and shipments. Let's give it a moment while the data loads. And apart from just the datasets, I would also highlight or some important things about the data modeling here. So when you're always working, whenever, just keep always this thing in your mind. When you're working with DAX, you need to have a good organization of your schema or the data model. Yes, previously we discussed that star schema is one of the most frequently used or one of the most important schemas out there when it comes to data analytics. But when you're especially working with DAX, then make sure that you are using star schema, but along with star schema, the arrangement of data sets or the data models is also important. It plays a very critical role. It kind of gives you a skeleton how the data is flowing and what it is happening in the background. So to understand this better, let's actually dive into the data model. So I've selected my tables, which is calendar, location, people, products, and shipments. So we want to go into transformation, or you can directly load. You don't have to worry about any kind of data errors in this. This is actually a cleaned data set. Since we are working with DAX, I made the cleaning and everything is good to go. So I'll directly press the load option here. And let's give it a moment while all the 5 tables load. So you can see creating a data connection in model and loading the data to model, relationships established, and all the rows are loaded successfully. Now, before we go into actual DAX, we should have a quick look on the model. So here, let me close data, let me close properties. So here you can see our fact table has been located in the center position. So let me reduce the screen size a little bit so that we have a quick overview. So whenever you're working with DAX, make sure your tables are arranged in this way. So for example, this is a dimension table, right? So dimension table should be all arranged in the top position. So we'll just give it a moment. So this is our calendars table and this is our products table. And this particular fact table will be arranged here, right? So now why did we do that? You will understand which of these data tables or data models is a fact table and which is a dimension table if you go ahead with this type of arrangement. So this type of arrangement, just by a visual glance, you can understand which table is what and which data model is meant for what purpose. So make some quick arrangements so that you'll have a quick overview of what exactly you're dealing with when you're working in real time. So here we don't have an established connection with the shipments fact table with calendar. That can be done in a moment. Just go to that one element which can relate to your calendar. So we should be having ship date. Yeah. So just like we did before, drag and drop ship date with the calendar date here. You'll be having the new relationship and Power BI will identify which are the columns which can be related here. So you can see it automatically selected ship date and the calendar date. And you can also see the cardinality. So let's go with the same cardinality by default provided by Power BI. So we have many to one, one to many, many to many, and one to many. So whichever cardinality suits best, you can choose that and go ahead with it. By default, Power BI has the caliber to select the best one for you. So I'd like to go with the Power BI's choice of cardinality here. And anyways, this is the one which we're looking for as well. So you can quickly save and you will have a well-established relationship between the calendar as well as the shipments table. So all the tables, let me expand this. So all the tables located up top are your dimension tables, and the table which is located here is your fact table. And here you can see the relationships processed. So here it is many to one, and all the other are also many to one. And if you expand this a little bit more, you can see the flow diagram here. It is flowing from the dimension table to the fact table. It means it acts like a filter. Let's say you wanted to filter out something from the locations table. So we have about 5 to 6 geographical locations and 5 to 6 geographical IDs. Let's say you wanted to know the information for a specific geolocation and you wanted to identify all the shipment track records for that particular location. So what this majorly does is it acts like a filter and it filters out the details for that particular geolocation. And similarly, the facts table will also change. It will only show the rows related to that particular geo ID only, not all. So similarly, here you have salesperson details. If you specifically provide a dedicated salesperson, the same filter applies and the data will be filtered. Let me drag this. So data will be filtered and accordingly the changes will be done on the fact table as well. Now that's how, or that's the reason why we need to arrange the data models in this particular module or this particular style, so that you can identify which table is a fact table and which table is a dimension table. So I hope you had a great understanding of that. Now let's go back to the report view here and you can get started with DAX. So there are multiple ways, since DAX is very critical and an important aspect of data visualization with Power BI. Microsoft has chosen to add multiple ways to select a DAX operation in Power BI. So here we have one option, which is DAX query view. You can directly access DAX from here as well, or you can choose to dive into modeling. And here also you have the calculations aspect or calculation style here. You can choose to create a new measure or create a quick measure. So nothing major difference between new measure and quick measure. So quick measure is the easiest way to create DAX or a measure which happens to be an aggregate. So if you wanted to create an aggregate function like sum of all the sales happened or the average of sales happened, you can choose those quick measures or quick aggregate measures through quick measure here. And if you wanted to dedicatedly write a DAX, then you can choose the new measure from here and write your dedicated DAX function. Apart from this, if you go back to home, you have another calculation tile right on the ribbon, right? You can choose to go ahead with new measure or the quick measure from here as well. Apart from this, there is a quick shortcut as well. If I go into shipments and wanted to write a measure, I can also do this from here by right clicking on amount, and you can see we have a new measure on new column option here as well. So which is also one of the options to create a DAX. So with that, we have a basic understanding of how exactly DAX works or how exactly you can navigate to DAX. Now, whenever you're dealing with DAX, you'd better, if you're new to DAX, then I'd recommend you better go with a table visual so that you'll have raw numbers and you can understand what exactly is happening on the go. Now, to understand DAX better, let's start with the picture which we already have in our mind. DAX is just aggregate purchase. So let's get started from there. So on the go, you will understand how it actually differs from our picture that we have in our mind. So if you're coming from an Excel background, then definitely you might think DAX is just another aggregate function, but it's not. So it's a lot bigger and different from that. So for having a comfortable understanding, let's anyway start from that particular aspect. So let's try to create a DAX here, which will be this one, and we will have a formula bar there. So to have a better visuality, I'll expand this particular thing. So you can just hold control and scroll up and down on your trackpad, or you can also use your mouse scroller to increase or decrease the size. So if you are proceeding with DAX, then you also need to understand the syntax of DAX. And by the way, on the flow, when you're already when you've already created some DAX for yourself, then those DAX will act as your primary asset. And when you're reusing that particular DAX, the syntax might change a little bit, not too much. But anyways, let's start with the fundamental syntax. So any DAX will have three particular parts. So the first part will be actual name of the DAX, which is total amount that we have added here. The second part is nothing but this particular small logo or symbol, which is equals to symbol. And the third part is nothing but the mathematical logic that we are about to write. So let's start with that simple aggregate function. I want to use sum of, I want to go with shipments table. So I have shipments. And here I have a shipment amount. So I want to go ahead with that particular point here. So you can either choose to write the entire name, or you can also use the tab operation on the keypad. So just click on tab and it will be selected for you. Make sure you close the last bracket and enter. So you have now successfully created a new measure. Now you might be asking me, why did I do this when I have the option of directly dragging and dropping this particular amount column from the data table? So let's also go ahead with that. Now let me add the product ID to the table. So we have added the ID rows and the total amount to this particular one. So there you go. Let me expand this. Yeah. So we have So we have the total amount here, and apart from that we have sum of amount, which we created using an aggregate function. Now if I drag and drop the total amount DAX which we created just now, we will have the total amount as well. Now you might be wondering, why did we even create this? Why did we even have DAX when we already have aggregate functions available on Power BI? So this is where the point comes into picture. DAX give us a lot of freedom rather than the aggregate functions give us, right? Now, if you see, there is no difference between sum of amount and total amount here. But if you look into this particular aspect, which says formatting option, so you can go ahead with formatting. So instead of general, you can go ahead with currency, and instead of the decimal values of auto size, you can just decrease the decimal values and choose I don't want any decimal values, and then the decimal values will be eliminated as well. So I want to remove the zeros here. And I can remove those. So now you can see a clear difference between the total amount which we got from the aggregate method and the total amount that we got from our DAX method. So clearly, when anyone sees this particular number, they will automatically feel that this is currency related or sales related or revenue related or anything which is basically related to business. So it gives you a clear business point of view if you're using DAX. Now, apart from that, you can also go ahead with a lot more functionality to this, just apart from creating a total measure. Let's inspect that as well. So let me resize it. So apart from looking at this particular DAX as a similar looking language like aggregate functions on Excel, there is a lot more differences. So you might think the same sum function is also available on Excel or any other data analytics platform that you have already been on. So the difference is, for the purpose of creating similarity between DAGs and the previous functions that you've already used, they are using the similar syntax, which is sum, bracket, and the shipment's table name and the amount column. But deep down, it is like alphabet, right? You might have the same alphabet on your language that you're using, but the way it is being used is a lot different. So it's like you're having the template of English language to write the terms of other language. Let's say you wanted to write something in a different language like Japanese, but you don't know the script of Japanese. So instead of writing the term in Japanese script, you're writing the same term using the words of the English language, which might sound same, but the script used is different. So that's the difference between the DAX and the aggregate functions that you've already used to from the other platforms like Excel and everything else. Now, you might wonder, let's now create a new DAX and see if that particular DAX is already available in Excel or not to have a clear picture. Now, let me create a new DAX function which says count of rows. Let me create a new measure and we will name it as count rows on OWS equals to, or you can also name it as shipment count to have a better picture. Equals to count rows was the function. Yeah. So if you select this particular function, now you will be a little confused. I have never used count of rows in any of the data analytics platforms like Google Sheets or Excel, right? This particular function or a few other functions, as you can see on the set drop down here, add missing items, all except, all, no blank row, right? These are a few additional functions that you were never used to work on Excel, or they were never available on Excel. But these are some additional functions or capabilities programmed into Power BI. So we are going to use one of those. So we will be now tracking shipments. So I'll drop down shipments, and this is the measure I want to add, and enter. Now we have a new measure, and this you can see. So the major difference between any of the dimensions and fact tables here and the DAX table is you can see a small calculator logo in front of the DAX that we have created, right? So whenever you find that logo right in front of one of the data models or the columns here or the data items present here, then you should be identifying that particular entry or that particular measure is a DAX measure. Now you also might be wondering if this particular DAX measure is available in the data model or not. So or the table or not. So if you go into a data model or the table view here, if you look at the shipment table that we just created, this particular shipment table, you have all the original values, the shipment ID, shipment as salesperson ID, PID, graph or geographical ID, ship date, amount, boxes, and order status. But the measures that we created right now, we created two new measures. One was total amount and the other was shipment count. So you cannot see those items here, right? You cannot see those two DAX columns here. So it's like an added layer on top of your existing table. This particular layer can twist and turn the data. It can, kind of stress your data to extract the insights, but it will never be a part of your data table. So that's the functionality of DAX. Now, let's go back to the visualization page or the report page, as you like to call it, and try to do some evaluations on this. Now, if I drag and drop the shipment count to the data column here, I can see what are the number of shipments made by each and every employee from a person level or a product level. I think we have added PID. So from a product level, so for better clarity, I'd like to also drag and drop the product name here. So I'll drop product name. So based on this product name, I have so many sales, right? If I directly click on this particular aspect, I can reorder, or we can sort this particular table. So you can see product 4 was one of the highest selling products. So we have highest selling shipment counts in this particular product. So this is the independence that gives you. Now, if I close all these things and reduce the size of my table, or here we have it. Let's try to make some space for a visualization. So you will clearly understand why DAX is so important for us and what's the freedom we are getting from using DAX. That's the one. Let us include one of the visualizations here. I'd like to go with bar graph or a column chart, whichever is functional. Let's go with this particular one, column chart, and I'll have this column chart on the okay, not this one. Let me unselect this and have an additional, yeah, this is the one. Now, if I select the geographical location and add it to x-axis and then add the shipment count to y-axis, you will have a visualization, right? Now, how is it different, or how is it making so much amount of difference? But let me uncheck this. So now you will have geographical location wise data for the total amount of sale done and the total amount of shipments done. But would you have, just imagine if you had used a regular aggregate functions, and if you wanted to find out the details for a specific product from a specific location, was that available for you? Unless you had a filter. Yeah, you might be telling me that if we add a filter, or if we had a slicer inserted into this particular visualization, maybe we could have done it. Yes, but could you hard code it to a slicer? No, right? Slicers doesn't work that way. You cannot hard code slicers to one particular aspect. It's like a switch on and switch off kind of a tool. If you click on one particular product from a slicer, it will show you the data related to that particular one. And if you automatically switch to a different one, you cannot keep that data anymore on your visualization. But in terms of DAX, you don't have to implement any type of slicers for your visualization. It is directly hard coded into your visualization. Let's imagine I wanted to find out the total sales happening for UK region. So if I just click on UK region, I have that particular sale value. And let's say I wanted to go ahead with a specific product. Let's say I wanted to go ahead with product 4, then automatically I'll have the details related to that particular fourth product ID and the sales happening in geolocation UK. So that's the power of using DAX in data visualizations in Power BI. Now, let's explore a few more DAX functionalities in Power BI. So this particular change, or this particular interactivity that you find in DAX is called as, or it can be termed as, evaluation context in technical terms. So the evaluation context here is the background process, what's happening when you're trying to filter out data without using any type of slicers or filters. Now, let's go with another type of DAX here. Let's say I want to calculate total boxes. So let's leave this page and create a new page so that we have a cleaner looking data. Now, what I'd like to do is I'd like to add a DAX function. So you can go ahead with adding new measure. So this is easier for me. You can also go ahead with clicking right click option here and writing a DAX function, whichever suits you better. So we have multiple options to create a new measure. So I'd like to go with this particular option, create new measure. And here, my new measure will be total boxes equals to, I'll use an aggregate function, sum of shipment table and shipment box. So here you already have the table and the column name. I'll just click on the tab button, close the function and enter. Now I have created a new measure which says total boxes. I think it went into the calendar table, but we don't want it to be here in this model. We want the total boxes model to be present in the shipments table. So let's collapse all these. And now I want a new measure to be created here. Create quick measure, create new measure, and the formula will be same. Total boxes equals to summation of shipments table, and the column will be boxes. Close the the column name will be boxes and close the ampersand. Hit enter, and your new measure has been successfully created, which is total boxes. Now, why did we create this particular measure of total boxes? We are trying to find out how many boxes did each product consume to pack. Sometimes you might be having a very big product, right? And for that very big product, you might have to, parcel it in terms of assembly, right? A part of the product in a box, a different part in a different box. Let's assume that you have a very big inventory, and in that very big inventory, you have one product which is bigger or the biggest of all. And to courier that particular product, you might need multiple boxes. Let's say our biggest product will need 3 to 4 boxes to courier it, right? And there is another product which is equally or a little bit smaller than that, but it is foldable, or it is in a way retractable, and it needs only one box. Now we are trying to identify that one particular product which is consuming a lot of your inventory just for packaging, right? In that particular aspect, if you find out that particular product, you might be looking for an alternate so that it saves you on packaging. So that's the business point that we are trying to deal with here. So for that, let's drag and drop, or let's create the same table vision for us. So we'll have a table here, and we will drag and drop product ID or product name into the table, and then the recently created DAX, which is total boxes. Now you can identify, you can see, or if you rearrange it, we can see product 4 is that one particular product which is consuming a lot of boxes to courier, right? And let's also see the total amount it is getting us. So let's have total amount here. Now you can see it is earning us about $33.2 million with such amount of boxes consumed. And let's rearrange this. So if you can see, we also have product 22, which has, okay, let me expand this a little so that we have a clear picture. So here you can see, earlier we shows product 4, which was giving us 32 or $3.2 million with using the highest number of boxes. But here, comparatively, 1/4 of total packaging, we have the most highest profit from product number 22. Now here, what we achieved is, we need to identify which is product 4, and we need to look for alternatives so that we can save a little bit of money on packaging and couriering the product, right? So this gives you a clear picture of business aspect that you must be looking into, right? DAX is the one which gives you this freedom or this level of freedom to identify and execute some business decisions. Now that we have understood the reason for this particular freedom, let's dive into the next aspect of today's DAX, which is DAX reusability. So this will take us back to the point 1 where we discussed about the syntax of DAX, right? So we initially thought the syntax would be different, right? So we will be having a DAX name, the second part will be equals, and the third part will be the table name and the column name. Now comes the part where we discuss the differences, right? There will be a little difference in this particular approach where we will be reusing the already built tags. Now, you can also go ahead with the standard procedure of using the table name and column name, but the reason for not going with the standard way is different. So this gives you an advantage, an edge to identify which is, so we have two types of functions. Basically, whenever you use an aggregate function or the function that Power BI provides you, that particular function is called as the implicit method, and the one you specifically write is called as the explicit method. So when you are using a calculated DAX for recreating a new DAX, then you will identify this particular method is already an existing DAX and it is a measure. And in case if you're using a table name, that means you're using a specific hard-coded table name. That helps you differentiate between these two approaches. That's the reason why we don't go ahead with the standard approach of using table name and column name when you're trying to reuse the existing DAX measures. For example, let's go ahead with identifying which box had more boxes per shipment. So here we had created right total boxes and total amount. So for identifying boxes per shipment, we will create a new DAX. So let me expand this. So let's create a new measure. And we will call this particular measure as boxes per shipment. So it's similar to the previous approach or previous calculation we did. So boxes per shipment can also be calculated by using total boxes. We created a total boxes thing here, right? You can drag and drop this particular thing here, or you can total boxes. So the key identifier that if you are reusing a DAX or if you are reusing or using a column name is this. If a formula starts with box bracket, then or square bracket, that means you're using a DAX. And if you are using the normal parenthesis, then it means that you're using an existing column. So total boxes divided by shipment count. So shipment count. So this is the one. Press tab to enter. Now you can close the parenthesis. I think we did not create a parenthesis in the end. Okay, that's fine. Press enter and your new DAX or the DAX which has been created by reusing the existing DAX is created here. Now what you can do is you can drag and drop boxes per shipment and identify maximum boxes per shipment. So if we rearrange this, just click on this particular aspect and you can reorder. Now you can see the product number 18 actually used a lot of boxes per shipment, right? And the initial aspect where we identified total number of boxes. So yeah, I think now we have a clear picture. Previously, we misunderstood that the total number of boxes used by product 4 were highest. But when the final packaging comes, there is a possibility where the exact number of boxes could be a little different, right? One huge box might have smaller boxes inside it, right? It's like an abstracting process where you package every minute item into a small box and all those small boxes will be packaged into a large box. Now this particular thing, what we have here, gives us a better advantage. Now you can see obviously 4,80,000 or 480,000 boxes were used to package product number 4, but at the final count, it is using 753, which is a lot closer or a lot similar to product number 18, right? So here you can see a minute difference between the two packaging. So that is the level of detail we can get into by using a little bit of DAX for business purposes. Now, if you proceed a little bit into details, then the next thing we can calculate is amount per box or amount per shipment. So let's create a new measure, and I want to identify amount that we are spending per every single shipment. So amount per shipment is equals to. Now remember the divide function we previously discussed about. If you might have, maybe there is a possibility that you might end up having 0 value in the second column, right? The column which goes under the denominator section. And if you divide such particular numbers, you might end up with divide by 0 errors. To avoid that, you can simply call a divide function here and mention the columns that you want to divide. So here we will send out 2 particular columns or DAX calculations. So total amount is the DAX calculation that we previously created. And the second value is people. So we'll be using people table here. or I can write down salesperson. We have a people table, right? So why am I not able to identify people of salesperson? Okay, let us try that differently. Anyways, we have the amount spent per packaging here, but we just wanted to explore a little bit of DAX reusability. Let's try to hard code that. So under people's column, we have PID salesperson. Okay, let me try this particular approach. Salesperson, still unable to identify. Let me create an parenthesis and type the table name. No news. But anyways, we have the shipment per box here. Let's close this. Let's deny this or cancel that particular DAX. But anyways, now we enter into one of the important functions of DAX. Now, this could be a game changer for you in perspective of business analytics. So that function is nothing but calculate. So let's create a new page and enter into the new page and try to create some functions, DAX functions using the calculate method. Now let's say I want to identify the amount of sale did or done by each person. So for that, I'll write a calculated or calculated field or new measure. So I'll go with this particular aspect. I'll create a new measure in the people's table, and the measure will be named as employee amount equals to calculate total amount, comma, people and salesperson. So previously we did not find this, but now Power BI was able to find salespersons. Some unexpected error, not a big deal. So apart from this, I want to find out for a specific person. So if we go into the tabular view, and here we have Emily Davis. Let's say I want to calculate the total sale done by Emily Davis. So rehearse that or copy this particular name and go back to report view. And where is our, this is the one. So we need to edit this particular DAX function, and salesperson is equals to, we copied, okay, I think we have everyone here. So let's erase all those. So I want to keep just Emily Davis here. So you can again come up with a new idea, or you can again come up with a new doubt where you can say, why use a filter in DAX if we already have a slicer, right? So you can do with this using a slicer, but as we discussed, when you use slicers, the slicers behave like an on and off switch. So when you switch from a different person, automatically the the control will also switch from an existing person to a different person. Now let's compare that side by side. Now this is my DAX and I'll enter, and we have the DAX. Now what we can do is we can drag and drop product. So let's create a new visualization. So we can drag and drop product and sales done by Emily Davis, and also we can have a salesperson as well. And if I drag and drop the amount once again. So here you can see the difference, right? In the first section, we selectively filter Emily Davis and the number is as is. And when it comes to the second filter, you don't have a filter here. You have all the data excluding Emily Davis and everything is normal, right? So this is the main difference that we are dealing with. So apart from this, if you wanted to identify the specific number of sales done by a dedicated employee, then you can create this calculate filter for a dedicated person in a many number of ways. Now, let's head into one last approach for DAX where let's say we have a target and every employee has some target and we want to find out if that particular employee has achieved the targets or not. So let's go and add a new measure and the measure will be named as sales target. And sales target is equals to, let's say, 1.5 million. So hit enter and we have sales target here. Now let's create a new measure. It's like an if condition. So if the sales target is achieved, then fine. If not, you mark it as not achieved or something like that. So we will create a new measure and we will write the measure as follows, as performance is equals to if condition total amount. So total amount is greater than sales target measure. We're reusing the measures again. Then you can write it as target achieved. Else not achieved. So this will be my DAX and hit enter. So I've created a new DAX here. Now what we will do is we will drag and drop, we'll create a new table and we will drag and drop salesperson onto the table and total amount that we have done. And we will also add that performance DAX calculation that we created. And now we have a clear picture how many number of employees have already achieved their target and how many did not. For example, here you can see Carter did not achieve his target and Ava Lewis did not achieve her target and so on. So the minimum bare number that we wanted to keep in order to find out if a target is given target is achieved or not was 1.5 million. So there are people who already kind of overachieved and there are a few people who did not achieve their target. So there are multiple ways that you can include and try to work on with using DAX. It gives you a lot of freedom than the basic implicit functions that you already get from Power BI, like the aggregate functions like sum, average, mean, and median, right? Now let's consider a small use case for you. Now let's also find out, consider this as your homework. Now, just like we had the target for salespersons, let's have target for product as well. Or you can just simply write the DAX commands that you're going to perform on your Power BI in the comment section below. So write down a DAX function to find out the product's target. Let's say the minimum product sale, the minimum sales for a product is about 500 and find me out the products which achieved their target and which did not, so that we can find out the performance of product visually and identify which products needs a little bit of marketing and which are the products which are highly performing and we can slightly increase the rates so that we can get a little bit of profit out of them. So this brings us to the end of module 7 on DAX basics. So let's continue with the next module where we will find out interactivity and drill downs, or basically creating a fully functional dashboard. So now we enter the next module where we will be understanding how to build charts and add slicers, filters, and basically create an interactive dashboard combining all the learnings that we have learned so far and create a completely business oriented dashboard for interactivity and insights. So let's go with the Excel files for this particular data set. Now we have this particular Excel file here. Before we get started with the dataset, let me bring back our learnings where I used to tell you once you use, like, let's go back to Power Query once, where I said you there is this particular feature in Power Query where you just provide the location of the file once, right? Whether it is on a database or a server or a cloud, or if it is just a file location on your local system or anywhere, we just provide the location of the source and create some queries or create some steps for data cleaning. And after that, if you load the data to the platform like Power BI, the modeling or the data visualization becomes easier for you. And whenever you add new data to it, Power Query will automatically learn or use the learnings from the previous transformations and changes to the data set, and it will implement all those for you, makes the data clean, and you can just focus on data visualization without wasting any time on data cleaning or data transformation part. So we will be bringing that back in this particular demo. So here on my screen, you can see I'm providing a file name as location prior learning. So this location will have 1 year's data, which is very old, 2021's data. Let's assume that we have a business statement here, and we are comparing year on year performance wise. And here, if we come out of the location, here we have sales data for 2022, 25, 24, and so on, 23, right? They are ordered a little different, but not a problem. What majorly our concern is we are having 5 years of data, right? So we'll start our process of data visualization with one particular file, and then we will build an entire dashboard with just one file. And the magic happens at the last stage where we add all the new data, all this new data, what I'm talking about is, let me highlight them, all this new data into this file location. And once we add it, the dashboard, what happens in the background is Power Query will check all the data sets that we have recently added into the location, and it will reanalyze, rerun all the numbers and update the dashboard on the fly within a couple of seconds. So that's our approach. Now, the data that we are dealing with is here. This is the data set. We have sales data, so it is order ID, order date, on which date was the order placed, the delivery date, right? What was the delivery date, order status, if it is delivered or not. We have customer ID, we have customer name and last name, the state in which that particular product was delivered. We have this region, is it east or west, north, south, and central regions of the location, and what was the product, and what product or what category does the product belong to, if there is any subcategory for that as well, and the number of quantity, and what was the initial traffic to the website, and how many number of traffics converted into leads, and how many of those leads converted into orders, and what was the quantity, right? And we have cost to company and also revenue and profit. So profit is nothing but the difference between the cost to company and the revenue, right? You might create a product for 10 rupees and sell it for 12 rupees. Then your profit is 2 rupees. That's how revenue and profit and cost to company matter. So this is the overall basic agenda for our dataset. And this particular dataset is already cleaned. So we have split customer, first name, last name. And to reduce the length of this particular demo section, we have used the clean data, and you already have a good understanding of data cleaning, modeling, and DAX functionality so far. So we will be directly ingesting this data into Power BI platform. So I hope you have a good understanding of what kind of data set are we dealing with. We are dealing with sales data. We have order details, customer details, location details, and the traffic, lead, orders, revenue, profit, and quantity details in all in one shot. You don't have to, kind of create joins or merges. We also dealt with joining data tables, merges, and how to append the data. And we don't have to work on all those complicated things. We can just understand basic functionality of how to create data visualization on Power BI platform, how to have a good background, a user interface. So coming back to user interface, let me show you one of the interfaces that I created. So this particular image that you're seeing is created for user interface purpose only, user experience purpose only. So when you directly go into Power BI, you don't have such a beautiful, if or a good, decent, if not beautiful, a decent background. All you get is a plain white background, but it doesn't end there. Power BI gives you an opportunity to add or customize your own background to elevate the user experience for business leaders. So the main, you need to understand what is the business purpose of your organization. So the purpose of this particular example is the business leaders wants to identify what is the traffic they are dealing with on monthly basis or year basis or provided date basis, and what are the leads. So here you can see we have state, year and month. We can drill down. So we'll also go through drill down and drill through options. So we can drill down the sales date into years, into months and dates as well. So here you can see month and year. So we can have that as well. So the business leaders wants to identify in a dedicated state, in a dedicated year, in a dedicated month, how was the traffic, how were the leads, how many number of orders did we receive, what was the revenue, and what is the quantity of orders did we receive. And if you scroll down a little bit, you can see region-wise sales, North region, South region, West region, East region, and Central region, and category-wise sales. What category of products sold most in what region, segment-wise sales. So if you go through this, you can see how detailed this particular approach is. You can find a product level data, you can find subcategory level data, you can find category level data. Apart from this, you can also find out location wise data, which state had particular product sales high or low, which region of that particular state had a dedicated product high or low, right? And also you can see geographical location here, which is the biggest box. So in this biggest box, we will have one of the visualizations, which is geographical visualization, or also called as map chart. And here at the last, you have month-wise sales performance. So one thing to remember, whenever you're dealing with date-related data, if you have one of the measures or one of the dimensions as date, then it is by default, you should be going with a line graph, because line graph is the one which shows you the performance, if it is growing, if it is spiking, or if it is dipping, right? That's the purpose of using a line graph whenever you have date. So remember that. And rest of the ones, when it comes to the first row, state, year, and month, you can go ahead with filter or slicer. We'll also be customizing slicer. So the best part of this section is you can see the minute details, how, the slicer level things, the background for a slicer, the color for a slicer, the drop down choice, right? For a slicer, you'll be having a vertical box. You can customize that to a drop down. You can also ingest a feature where you can have a search bar logo on that, so that when you click on search, you can simply type which date you're looking for and it pops out, filters out for you. And the same can be implemented for year and month. And you can also add KPIs, right? Cards are used for KPIs, key performance indicators, right? When to use cards, when to use a donut chart, when to use pie chart, when to use a bar graph, or when to use a column graph. Or apart from that, you'll also have a few more other alternatives like, a stacked bar graph, etc., and map chart. So you cannot use map chart for a bar graph, right? So the experience of using a dashboard matters a lot. So you can use, let's say, traffic by you can use a donut chart for indicating traffic. But will the purpose of indicating KPI be satisfied? No, right? So that's the basic sense you need to have. What kind of chart is created for what kind of indicator on a dashboard? When you're going ahead with KPIs, then cards are the best indicators. And when you're going with region wise state, like when you have less than 5 dimensions or measures, it's better to go with the pie chart or a donut chart, because it gives you the accurate amount of division of sales between the regions. So in regions, we have about 5. So we have north, south, east, west, and central. So this type of chart or this type of measure can be depicted using a pie chart, which has better visuals. And same goes with category. You have a couple of categories like 5 to 6, then you can go ahead with a donut chart and segment wise sales as well, right? You need to have that simple understanding of what kind of chart is best suitable for what kind of representation of data. So this comes to the user experience and interface section. So you're free to use any tool for creating better backgrounds. I've used PowerPoint for creating this particular picture. You can use Canva or any online tools. You can also write a prompt to your ChatGPT and share the data with it and share your business requests or the business owner's requirements so that it creates a good user experience or user visual for you, and you can download that and replace that with the background. So that's about it. So apart from this, we also have few other visuals. So here I have a social media dashboard. So you have follows, views, likes, shares, comments, right? If you're dealing with social media platforms, then you can go ahead with this one. So here we have buttons as well. X for Twitter, Meta for Facebook, Instagram, Snapchat, and YouTube. And you can also select the platform, state, region, resource. So we have this entire end-to-end tutorial on our channel. So you can also go through that. If you require this particularly, you can also comment us and we'll share the dashboard with you and the tutorial with you. So we have a lot of different varieties of approaches for building a dashboard. So this was the one which we will be using today. So this is also one of the dashboards for creating sales one, and this is the one which we will be using today. So now with that, let's go to the Power BI platform. So let's give it a moment to load. So there you go. And we will be using a blank report for this one. Let's open a blank report. And to get data, we have a lot of options. Let me cancel this out. So to get data in the Power Query section, we have understood what are the different variety of sources available to get the data from. So here, I will not use Excel directly. What I'll do is I'll go to more options. And from here, I will have an option which says folder, right? When you select folder, it will ask you for the location of the folder, for the path of the folder, right? So you can open on browse window. Then your data is in downloads. My data is in downloads. You might have a different location as well. So here, or what I can do is I can cancel this. I can directly go to the window where I have my data. So it's easier for me to navigate. So it's in PBI and in location. So just copy this location. This is my location. Go back to Power BI platform and just paste the location over here and press OK. Now, what happens is Power BI will automatically understand which data is supposed to be loaded. So here I have the data set. Click on it. So there has been a small error. So let's try that once again. I think it took 2 sections or 2 rows. Must be a smaller, don't worry. Let's give it another try. Yeah. There is a small error here. Let's try that. Yeah, we need to drill down. Just click on that expand button and it will expand the data for you. And now select the sheet. This is the preview that we were looking for. And I think everything is good to go as this data was considered the best one. I mean, it was already cleaned. So let's anyways have a quick preview. So we have order ID, order date, delivery date, order status, customer ID, customer name, and state, region, product, category, subcategory, quantity, traffic, leads, orders, cost to company, revenue, and profit. So as we discussed during the tags module, unless you have a clean data fully functional for analysis, you cannot proceed with analytics and it will not make any sense at the end of the dashboard. So I'm satisfied with my data. I want to click on OK for loading the data. So we have almost everything that we were looking for. So if we go back to data table view, I want to delete this particular one and go back to home. And I would quickly refresh the data. Now to the visualization train, and everything is now good to go. Now we will start with applying the canvas settings or canvas background. I would like to browse the picture that I created. So this was the one. Click open, and image fit will be fit, and transparency will be down so that we have a good visual. Discard the changes, and we are almost good to go. Now that we have a good background, we will start with making the visualizations. So first we will come from top to bottom. So the top section is about including a state level slicer. So what I'll do is I'll go to the visualization screen. So here we have a wide variety of charts. We have stacked bar chart, we have stacked column chart, we have clustered bar chart, we have clustered column chart, and then we have a 100% stack chart. This is the column chart again. So this is the line graph which I was talking about. This is the area chart and the stacked area chart. Next is 100% stacked area. This is a combination of both column chart as well as a line chart, and there is a different purpose for this as well. So each and every chart available here has a different purpose. So this is the ribbon chart. This is one of the waterfall chart which we most commonly use, and then here we have a funnel chart, then the scatter chart. So scatter chart is really helpful when you have the comparison performance, right? So if you have, let's say, employees performing date to date, then you can go ahead with scatter plot. So it shows you an indication of growth as well as a performance on a dedicated spot. So the performance is spread in dots in the graph. Yeah, so you can go ahead with that. And the pie chart, donor charts that we discussed before. And we also have a tree map chart, which is similar to not stack, similar to pie chart and the donor chart. But the only difference is the representation will be in the form of blocks. And here we have the map chart, the geographical locations, and we have the filled map chart as well. So both stand same, but if you use map, the fill will be indicated in terms of a dot. But if you go to the filled map, you'll have fully filled geographical locations. And you have Azure map, you have a gauge here, and these are the cards. And next is multi-row card. Then this is the KPI indicator, the slicer, the regular table that we use, and this is the one, the matrix chart. We have R script visual, Python script visual, and we have key influencers and decomposition tree, Q&A questions as well. You can include this in the dashboard, and you can try to ask questions. Like, let's say I want to find out which product sold best in provided state in a provided year. Then you can quickly get that particular visual. This acts like a chatbot for your dashboard. That's a very good feature in Power BI. And then we have narrative, which explains or which gives out the narratives on the performance of dashboard. Then we have metrics preview, and we have paginated report, then the card and new slicers and all the other things, which is AGIs maps for Power BI, Power Apps for Power BI, and this is Power Automate for Power BI. So Power Automate is a whole new segment of learning. So we have a completely dedicated tutorial on Power Automate. So you can drop us a message in the comment section below so that we can share you the Power Automate tutorial for Power BI. So, and apart from that, if you see here, we have drill through and cross report options here. Now, let's get back to the dashboard and try to add the slices that we were discussing about. So we will just click on the slicer, and we have a slicer option right here. And let me drag and drop somewhere else. Now here we will go into the visualizations format of this particular slicer. So let me drop the state location. So here we have now we have visuals. So we'll go into general, and I think we don't need a title for this one, so I'll keep it off. And we'll also go with the background. I don't want any background for this since we've already set it, and we don't want a visual border as well. And shadow, I think we don't need a shadow. Header icons, I don't need header icons. And background is also turned off. Transparency is 100% complete. Title is done. And properties, I think I'm almost satisfied with what I have. Now, apart from that, if we come into slicer visuals, I don't want the slicer header. And if we come into slicer settings, remember the drop down setting we spoke about? I don't want the vertical list. I want a quick drop down. So now I'll try to make it fit in the section where I, created the state. So this would be it. So I'll try to rearrange it to fit into this particular space. There you go. Now what I can do is I can also include the search icon. So whenever I click on the drop down, I have a search bar over there. Let's say I want to find out maybe Madhya Pradesh. I can just type down Madhya Pradesh and I'll get it. So now that the slicer is fit and done, now what I can do is to save time, I can just copy and paste it, right? I have a new slicer altogether. I'll just drag and drop this particular slicer to here. And similarly, I will copy this again and paste. Now I'll drag and drop this to let me select it to month. So the only thing that we will be changing for this particular slicer is, so instead of state, we will be selecting year. So we have order date hierarchy here. So if you open the hierarchy, you can select year in place of state. So we'll unselect state. Now we here have all the years. So for now, we just have 2021. So remember, we just selected one year per this particular visualization. So we will unselect state and we will open data hierarchy. So for date hierarchy, and then we will select month. So now we have all the states, all the years, just 2021 for now, but it will increase to 22, 3, 4, 5, and 6 later on. And we have all the months for the month section. Now the first slicer section is done. The next one is the cards. So what you can do is select a card, and this particular card will have the number of traffic. So you can see Power BI was able to calculate, the summation. So it automatically aggregated the total traffic happened. So now we will go into visuals for this one. So general, and we want header icons. We don't want effects, so background will be turned off. And apart from that, we don't want shadows and everything. So if you go into visuals, so here we will be having the category label. So we don't want category label because we already have a category labeled implemented into the dashboard itself. So we will drag and drop it somewhere here. And once you're happy with the location, the same thing what we did for slicer can be replicated here. So you can just copy and paste it. And now what you'll do is drag and drop to the leads section. You can also auto align that. And you can do the copy paste once again. And you can auto align to number of orders. Copy and paste for revenue. So you can auto align for revenue as well. And one last copy paste for quantity. So copy and paste, auto align, and you have the quantity. Now what changes is in leads, you need to unselect traffic and you need to select leads section. So here we have the summation of leads, and in the orders section, you need to unselect traffic and select the total automation, which is the aggregation for orders. Similarly, we can go to revenue, select the revenue summation and unselect traffic. And last is the quantity one. So you need to unselect traffic and go to total orders or total quantity of orders. So far so good. The first two rows are resolved. Now we have the region wise sales. Remember we discussed if we have 4 to 5 elements and not more than that, you can definitely go with a pie chart. So we'll go with a pie chart here. Okay, let me quickly undo that. Okay, now select or click anywhere on the dashboard and now click on the pie chart so that you have a fresh pie chart there. Now what you need to do is we have legends, right? So you need to add region data into legend and values of orders to values. So there you go. Now you can go to the visualization. I don't want legend. I don't want. You can have detailed labels, however. And when it comes to title, I don't want title for this. I don't want header icons and tooltips. You can include, or if you don't want, you can also remove them. But I want detailed labels and any effects, visuals, background, and yeah, everything looks good to me. You don't have any background. Now you can slightly increase the size of the dashboard and make sure to fit it into the dedicated location provided for this particular visual. There you go. Now comes the category wise sale. So click anywhere on the dashboard, use a donut chart, and for this particular one, category. So where do we have the category? We have subcategory and should be somewhere here. So we have the category here, and you can drop category to legends, and then you can order to values. There you have the category wise sales. Go to visuals, the same steps we did. We'll just have detailed labels and title. We don't want the title. We don't want tooltips. Now you can close this, and just like we did for the previous one, you need to fit it into the space provided for this particular visualization. Now we have segment wise sales. So for segment wise sales, we have a lot of segments. So when you have a lot of segments, it's better you go with column charts. So I'll go with this particular column chart, and we have a column chart there. And now we will have segment in the X axis somewhere here. Look for segment. Okay, subcategory. I think subcategory, yeah, we do have a subcategory. I think we don't have a segment, but we do have a product. So I think it's better we go with the product category wise, subcategory wise. So we have a lot of products, however. I think we missed out on the segment part. Or let's go to the table view quickly so that if we can find out we have any segments or not. This is the location, and here is the data customer. I think we don't have a segment, but that's okay, not a big deal. So in place of segment, we can include product, but we have a lot of products here. But anyways, in case if we apply a filter, let's say we apply a filter for a dedicated category, then we might drill down the products into a little bit. So let's have products there. Anyways, so drag and drop product to X axis and we will have orders in y-axis. It might be a little segregated, or it could be a little compact for this particular space. So we don't want header icons, don't want tooltips. We can keep tooltips, but for now it's okay. And yeah, everything is plot area background. So do we have a plot area background? No. So this is good to go. And same as before, we need to size this to the location provided. Yeah, similarly, we have a subcategory as well. So you can click anywhere on the dashboard and then go to visualizations. You can include a bar graph, and then what you can do is simply drag and drop subcategory to columns, and you can add orders, total orders to x-axis, and you'll identify how many number of orders were placed by how many number of products based on products. So you can click the visual, and just like we did before, we can make some general changes to it. We don't want title, we don't want header icons, and we don't want tooltips and visuals. So we don't want any plot area background. So far so good. So let's select all. Just like we did before, we need to fill in the area allocated for the subcategory. There you go. Now, grid lines, we don't want grid lines. Slicer. Just check for each and every aspect so that your slicer or your, visual stands out. And ribbons, data labels, all the plot area. So the overall intention of creating a better visual experience for your end user is having a good representation of all the insights or visuals you build. So unless you take care of all these things, then you might end up in just another dashboard which doesn't look or feel good for the end user. So that now you have everything sorted out in one place. Now comes the next visual. So click anywhere on the dashboard, and then you need to click on the map, field map, or any map that you want, and then you need to open the data, and we will add state to the legend. And then what we will do is total orders, so that we will identify how many number of orders are being bought or are being received from entire location. So if you want roads, you can keep the roads. And general settings, we don't want title. We have already given the geographical location and tooltips. There you go. Now, or what you can do is you can quickly fill in this particular area dedicated for the map region. There you go. Now the last one is the sales month on month. Remember, whenever we are dealing with date to date, year to date, month to month, or last date today, remember the time functions that we discussed in time intelligence section. That's the one. So whenever you have time related data, repeat. So whenever you have time related data, go with line graph. So click anywhere on the dashboard, then go with a line graph, and your line graph will be created. Now on the x-axis, you need to drag and drop month. Inside the date hierarchy, you have month, right? So drag and drop that to x-axis so that you have month on month. And now drag and drop orders value to the y-axis so that you can see month on month performance. Similarly, go to the visual section, and here check all the aspects, and general section. And here we don't want title, header icons, and tooltips. So everything will be provided by just one click. So just close this one as well. Now extend this particular graph to fill in the area dedicated to that, and here you have the tooltips. So I think we need the tooltips. So go to the visualization section, and here go to so if you add tooltips, then you'll have the values which are happening in that particular location, right? So now you have a completely interactive dashboard. Now is the best part. So let's say I want to identify for a dedicated location, right? So here I will select Delhi and I'll have the sales performance happening in Delhi right now. So we have about 17,000 traffic, and out of which we have 100, not 100, 1800 leads, 19 orders, and so much revenue. So we need to expand this a little so that we have an actual number. So we have about 647 revenue, which can be in millions or something like that. And this is the total number of orders we receive, 207. And provided if you want to drill down a little bit, you can provide the dedicated month. So in the August month, so many leads were there, but no orders. So depends on the seasonal value also as well, right? So if you have April, then you might have okay, when you go into some other month, maybe June, so maybe some due to some seasonality, like any festive seasonality, you have some orders. So based on that, you can achieve some orders as well. So apart from that, so if you unselect Delhi, and you'll have the overall countrywide sales, revenue, orders, leads, and quantity details. Now comes the best part. Now let's go to the data location once again. So I have my data in PBI, and this is the location. Now what I'll do is select all these data sets, and what I'll do is simply drag and drop inside the location. I did not do anything yet. Now I'll close this and go to the dashboard. Nothing changed as of now. What I simply do is refresh the data. Once I click on the refresh data, new data is being loaded. Just click on close. Now you have the data for all the years. So if I click on year, so you can see automatically we have 2021, 22, 23, 24, and 25. Initially, we just had 1 year, which was 2021. So all the data cleaning that we did, like a quick review of what the data is looking like, or what columns and rows we have, right? All that part has been done automatically or implicitly inside Power Query, and we have all the data ready for publishing or sharing with our business owners or your clients, basically. So now the next point is all about publishing this particular report or sharing this particular link to the business owner. And in the next section, we will be learning this. And that brings us to the end of this particular module on data visualization, charts, and adding interactivity, drill down, and all the aspects of a data analysis dashboard using Power BI. Welcome to module number 9. In this session, we will move beyond Power BI desktop and into the Power BI service, the cloud platform where you publish, manage, refresh, share, and embed reports at a scale. By the end of this module, you will be able to publish a .pbix file from Power BI desktop to the Power BI service and understand what is being published, which are reports, dataset, or model, etc. You can manage workspaces, roles, and the lifecycle of content and datasets. Configure dataset, which is refresh, including gateways, credentials, incremental refresh, and troubleshooting. You can also share reports and dashboards with users and teams effectively while maintaining security and governance. You can also embed reports into applications and web portals and understand the difference between embedded models and permissioning approaches. We will balance step by step, which is how-to instructions, with architectural reasons and governance best practices. So you know both what to click and why that choice matters in real business. So let's get started with part A of module 9. So the part A will be basically about how publishing works. So you need to navigate to desktop, then choose the service option. So let's start publishing. Publishing is the act of taking Power BI file, which is .pbix file you built in Power BI desktop, and uploading it into the Power BI service, which is app.powerbi.com, where it becomes a dataset, a report, and optionally a data flow or paginated report, depending upon how you build it and what you build, what you publish, when you publish from desktop, and how effectively you upload the three things: the report definition, the collection of page visuals, bookmarks, and layout; the dataset or semantic model, which is the second one, which is about the tables, relationships, DAX measures, metadata, and the connection strategy, which is basically how to import data query or a live connection. Then comes any query logic, the Power Query steps that you made, the produce data, the service stores, and the query logic in the dataset. So future refreshers can rerun the extract or transform steps carefully. Put simply, the report is the front end. The dataset is the engine, and the query logic is the recipe that builds the engine from source systems. How to publish step by step. So from Power BI desktop, you can either select the file to publish the Power BI option, or directly you can choose to click on the publish button from the home ribbon. You'll be asked to pick a workspace destination, select the workspace you own or have publish permissions to. The desktop app then uploads the .bbix file to the selected workspace. After a successful publish, you can open the report in the Power BI service and the dataset will appear under the workspace dataset section. Now, let's go through the key considerations when publishing. So firstly, the workspace choice matters. Don't publish into My Workspace, which is the default location for production reports. Use dedicated workspaces that you create for your teams, projects, or production apps. Workspaces map to content lifecycle and permission boundaries. A workspace should be the unit of collaboration and governance. We will dive into workspace roles shortly. So connection mode influences refresh and performance. If your dataset uses import mode, then Power BI stores a copy of the data and you must schedule refreshes. If it uses direct query or a live connection, the service queries at the source at runtime or caches limited resources or results, changing how refresh is handled and affecting concurrency and latency. So for this reason, it is better that you always choose the mode that matches your SLA and data size. Next is size limits and licensing. Large datasets and high refresh frequency may require premium or PPU capabilities. Check the organization's license and workspace capacity. If you run into file size limits, consider optimizing the model, where you can remove unused columns or use aggregations or move to a premium capacity. What to expect after publishing? Once published, your colleagues can view the report in the workspace if they have access, provided if they have access to it. The dataset can be refreshed on schedule and you can package the workspace content into an app to distribute to a larger audience. You can also download the report back as .bbix if permissions allow you. The service stores publication history and basic lineage. That's the publishing core. Next, we will look into workspace architecture and how to manage datasets after they are in the service. So let's go into the part B, which deals with workspace management. So roles, apps, and the best practices. Workspaces are the organized container in Power BI service. They hold reports, dashboards, datasets, data flows, and paginated reports. Workspaces are where teams collaborate, prepare apps, and manage lifecycle between development, test, and production. Now let's also take a look through types of workspaces. Microsoft has new modern workspaces which replace classic work pages. They provide better role control, governance features, and app publishing options. They create a workspace for each logical area or project rather than using a single workspace for everything. Now let's go with roles within a workspace. There are distinct roles you can assign to people and security groups. For example, we have admin. So admin has full control. He can manage workspace settings. He can add or remove members and delete workspaces as well. Then comes the member who has the permissions to edit content, publish reports, and create apps. Followed by that, we have contributor who has the right to publish and update the content but has limited management rights. Then we have the viewer who has only read-only access to the content inside the workspace. They can't edit or do anything with the report. Now, assign the least privileged role necessary. For production workspaces, use to publish apps, keep these sets of admins small, and use members or contributors for content authors. Viewer role is ideal for users who only need to consume reports without editing. Now, let's discuss the difference between apps versus the direct workspace consumption. An app is a packaged, curated distribution of selected workspace content intended for broader audience. It provides a stable URL, consistent navigation, and controlled access. Use apps when you want to distribute read-only content to a larger user base. Use workspace access when the audience needs collaborative editing or testing. Now let's discuss about the workspace lifecycle and governance best practices. So it comes from developer to QA, QA to production. Maintain separate workspaces for development, testing, and production. You need to encourage authors to publish to dev, QA, or validation, and then promote the production where you can republish or deploy the apps. Now let's go through the naming conventions. Name workspaces and datasets clearly. Include environment tag. For example, sales production, sales development, right? These are the tags you can use. And next comes the content endorsement. Use endorsement, for example, certified or promoted or trusted datasets to guide users to a single resources of truth. Certified datasets indicate governance vetting. Now let's go through metadata and documentation. Add descriptions to datasets and reports and keep a README page in Workspace with intended use. Data sources and owners contact as well. This will be helpful. Now let's go through monitor lineage and usage. Use Workspace and tenant usage metrics to track adoption and performance. Remove stale content and archive older versions. So let's go through an example. Imagine a company BI team supports sales reporting. You need to create 3 workspaces. First one, which is sales developer, which has only authors who build the reports. Next is sales QA, which has analysts to validate the report. And lastly, we have sales app, which is production app published to all sales managers in one go. Now, only a small set of admins and members exist in developer or QA teams. While the app is distributed to hundreds of viewers, proper workspace management reduces confusion, enforces governance, and controls cost, which is capacity of usage. Now, let's dive into the part C, data refresh. The concept, setup, and troubleshooting will be dealt here. One of the most important operations after publishing is keeping your dataset current. Dataset refresh is how Power BI updates the imported data in the cloud so reports show recent information. So now let's discuss the refresh modes and triggers. There are multiple refresh mechanisms. So the first one is scheduled refresh. The most common one is this one. You can configure frequency in the dataset settings, which is based on hourly, daily, or even weekly. Power BI will run the stored Power Query steps and reload data from import mode datasets. Next is on-demand or manual refresh. You can run a refresh immediately after the dataset UI. Useful for ad hoc updates. Now let's go through push and streaming datasets. It is used in real-time scenarios where external services push the data into the Power BI. Followed by that, we have Power Automate or API. So this is actually a trigger refresh which happens through automation flows or API calls for event-based updates. This is useful when data source systems signal the data changes. Now comes the gateways and on-premise data. If your data source are on-premise like SQL Server, analysis services, files on network share, etc., you need an on-premise data gateway, which is a lightweight service that securely facilitates connections between Power BI in the cloud and your internal data. Install the gateway on a reliable server, register it to your tenant, and assign it to the workspace or the dataset. The gateway supports clustered mode for high availability. Don't run the gateway on a laptop. Use a server class machine and put it behind appropriate monitoring. Next, let's discuss about the credentials and privacy levels. In the dataset settings, you will set the data source credentials. Make sure credentials are valid and use service accounts when possible rather than personal accounts. Review privacy levels if used for proper data handling of joint data. When credentials fail, your refreshes will error out. The refresh history gives you the failure message to diagnose. Now let's move into incremental refresh to scale large datasets. For large tables, use incremental refresh to avoid reloading entire tables every time. Incremental refresh allows you to partition time-based data, refreshing only recent partitions and keeping historical partitions static. A huge performance win. To use it, you typically define range start and range end parameters in Power Query and enable incremental policies on the dataset in the service. This feature is essential on large datasets and often paired with premium or PPU capabilities for higher limits. Now let's discuss the refresh limits and quotas. Be aware of refresh limits related to license type. Free workspaces have limited refresh options. Pro and PPU have larger quotas, and Premium provides the most frequent and larger model support. If you need many hourly refreshes across many datasets, premium capacity is usually required. Now, let's go through troubleshooting refresh failures, which is a practical flow. So, check refresh history. The dataset settings page contains the refresh history and no error messages. Note timestamps, error types, and affected tables. Next, we have verify credentials. Test data source connections in dataset settings, update passwords or service account tokens as needed. Then we have gateway status. Confirm the gateway is online and on the latest version. If the gateway is offline, refreshes will fail. Check gateway logs and network connectivity. Timeout and query issues. If refreshes timeout, look at query complexity, break down running transformations, or push transformations to the source. Consider aggregations or move heavy transformations upstream. Next ahead, we have concurrency and capacity. If many datasets refresh simultaneously, the queue can delay refreshes, stagger refresh schedules, or scale capacity. Use the Premium Capacity Metrics app to monitor the saturation. Followed by that, we have data schema changes. If the source changes column names or data types, our query steps can break. Maintain communication channels with data owners before source updates. Now let's go to some advanced options. Refresh templates and cascading refresh, which is from Fabric. So for complex pipelines with semantic models and data pipelines, you can orchestrate refresh templates or chain refreshes so upstream data flows refresh before downstream data sets. This gives more reliable end-to-end data refresh in advanced architectures. Now let's go through an example scenario. Let's imagine a retail company imports daily sales. They use the incremental refresh policy to update only the last 14 days each night and a smaller hourly refresh during business hours for the previous day's rolling window. The gateway connects to their on-premise POS database, and the admin monitors refresh failures via the refresh history and capacity metrics. The design reduces load, improves freshness, and keeps costs predictable. Now let's dive into the part D, which is about sharing reports and dashboards with teams and people. So publishing is one thing, sharing is where insights drive action. Power BI provides multiple sharing patterns. Choose the pattern that matches your audience, governance, and licensing. Now let's go through the sharing options overview. Workspace access. You can grant user roles inside a workspace based on viewer, contributor, or member, or even admin. Use this for collaboration where users may edit or test the content. Next is publish an app. Best for distributing polished, read-only content to many users in one go. Apps are versioned and provide a stable entry point for consumers. Next is the share option. The share button lets you send a direct link to the specific people or groups. This respects dataset RLS and requires recipients to have appropriate license or access. Use this for ad hoc distribution. Followed by that, we have embed in Teams. Add reports as tabs inside Teams, channels, or chats, so users access analytics where they work. Embedding in Teams keeps collaboration seamless and can include comment and chat integrations. Next, we have secured embed or public embed or publish to web options. Secure embed option is for internal portals with authentication. Publish to web produces an anonymous public link. Use with extreme caution. It is used rarely for internal data only. Secure embed respects permissions with row-level security. Public embed is not. Now, let's dive into embedding in Microsoft Teams. So let's go through the practical flow. To add a report to a team channel, open the channel, click the plus icon, select the Power BI tab, then pick the Power BI report or dashboard you want to embed. The Teams tab gives users direct access to the report without leaving Teams, and you can pin it for quick visibility. This is a strong pattern for operational teams that already use Teams for daily communications. Next comes the row-level security and sharing. When sharing, ensure RLS is configured if recipient should only view a subset of the data. RLS is defined on the dataset and enforced by the service. It travels with the dataset and applies to all sharing mechanisms, including apps and team tabs. Use RLS carefully and test via view as a rule to confirm behavior before wide distribution. Now, let's go through external sharing and B2B. You can share with external users via Azure AD B2B. Tenant admin must enable external guest settings. For customer-facing scenarios, consider Power BI Embedded, which is app owns data, to avoid provisioning licenses for external users. Always follow your organization's tenant settings policies and consult compliance teams for external data sharing. Now, let's go through best practices when sharing. Use apps for broad audiences, package reports and dashboards into apps with controlled permissions, and publish app updates rather than republishing workspace content. Next is document expectations. Every app report should include data refresh schedule, owner contacts, and intended use. Protect sensitive data. Use sensitivity labels and tenant settings to restrict export printing or sharing where needed. Training and adoption is the next step. Create short walkthroughs inside teams or pin documents so business users know how to navigate reports and filter correctly. Next comes an example. The HR analytics team publishes a headcount and attrition app. They deploy it to the HR app workspace, run RLS so managers see only their teams, and add the app as a tab in each manager's team channel with a pinned frequently asked questions tab. Managers receive an email when the app updates, and the HR team monitors usage metrics to iterate. Now, let's dive into the part E, where we will discuss about embedding reports, approaches, authentication, and permissions. Now, let's go into part E, where we have embedding reports, approaches, authentication, and permissions. Embedding is where Power BI becomes a part of product experience and workflows. There are two main embedding models, and each has different security and licensing implications. Embedding for your organization where users own the data. This is internal embedding where the end user needs to authenticate with their Power BI credentials. The report respects their permissions and row-level security. Now, let's go through some use cases. Intranet portals and internal web apps where only authenticated employees access the analytics. Authentication typically uses OAuth with delegated permissions only. Now let's go for another one, which is embed for your customers, where the app owns the data. This is an external model where the application authenticates using a service principal or master account and renders reports to the end users who don't have Power BI accounts. This is the recommended approach for ISVs and SaaS apps. It requires Azure setup, which is Power BI embedded capacity, and careful security design. Use the REST APIs with a service principal to acquire embedded tokens for the client app. Next comes authentication options for embedding. User authentication, which is delegated. Users sign in with Azure AD. The embed respects their direct permissions. Use this when users already have Power BI licenses. Next is service principal, where we have only the app. It is recommended for app owns data scenarios. You can create an Entra app, grant Power BI API permissions, and use the client ID plus secret to authenticate server to server. Generate embed tokens with the REST API and pass them to the front end. This approach lets you control which reports a user can see without giving them the Power BI account. Now, let's go through embedding methods and security trade-offs. So the first one, secure embed code or iframe. It is good for internal portals. It respects Power BI permission, but still requires users to sign in. It's the simplest path when you have basic embedding needs and internal authentication. Now, the next one is Power BI Embedded, which is dealing with Azure. It provides an Azure-based hosting capacity for external embedding with higher scale and performance guarantees. You manage capacity, scale units, and the costs at Azure level. This is the correct choice for commercial products. Now let's go through publish to web. This one creates a public anonymous embedded URL. You need to avoid this for internal or sensitive data. It is effectively public. Use only for fully public or non-sensitive visuals. Next is about permissions and row-level security in embedding. When using user owns data, RLS continues to work as usual. Each user sees the data according to their role. When app owns data, you often need to implement row-level filters at the embed token generation step to ensure each customer or tenant sees only their data. Use the REST API's embedded token generation and specify effective identities or RLS filters to restrict data. Test extensively. Now, let's go through practical architecture for ISV where app owns the data. Provision Power BI embedded capacity in Azure. Create a service principal in Microsoft Entra and grant it to the required Power BI API permissions. Use your backend server to call the Power BI REST API to authenticate, create or refresh datasets as needed, and generate embed tokens. Securely hand the embed token to the client browser for rendering via Power BI JavaScript software development kit. Rotate secrets and monitor usage and errors. Embedding example, secure internal portal. A company builds an internal vendor portal where each vendor can log in and view their performance dashboards. They choose secure embed with user authentication. Vendors authenticate via SSO and the portal uses an iframe or direct embed to render Power BI reports. RLS ensures each vendor sees only their data. The portal does not store embed tokens for long term. Now let's go through developer and security checklists for embedding. Use TLS and secure cookies. Rotate service principal secrets for every 90 days or use certificates. Log all token requests and embed activity for audit. Use throttling, retry patterns, and circuit breakers for REST API calls. Monitor capacity usage to prevent throttling or excessive cost. Embedding turns analytics into part of workflows and products. Choosing the right embedding model is a balance between user experience, cost, and security. And with that, we dive into part F, which is about permissions, governance, and tenant settings. Security and governance are the core. Power BI tenant settings and workspace roles provide guardrails. Tenant-level governance. Administrators can set tenant-wide policies such as allowing or blocking external sharing, enabling or disabling publish to web, managing who can create workspaces or use premium features, controlling which users can export data or reshare data reports, controlling which users can export data or reshare the reports. Work with the Office 365, Entra AD, and Power BI admin teams to create sensible defaults that align with corporate policy. Data sensitivity and protection is our next point. You can use Microsoft Purview sensitivity labels if available to tag datasets and reports. Labels travel with content and control export, print, or copy behavior. Pair sensitivity labels with tenant export controls to limit data exfiltration. For regulated data, consult data protection officers and legal counsel. Now, let's go through permission best practices. Let's start with least privilege. Only give the permissions that users need. Group-based access is the next one. Use Azure AD groups to manage workspace membership rather than assigning permissions to individuals. Next is service accounts. Use dedicated service accounts for schedule refreshes and APIs, not personal accounts. After that, we have audit and monitoring. Enable audit logs and review sharing patterns. Watch for unusual exports or public links. Now, let's discuss governance example. Finance publishes financial dashboard but restricts export and sharing. The tenant disables publish to web globally, and the finance workspace requires two admins and enforces certified datasets only. This ensures sensitive financial data is controlled and traceable. Now, let's have a quick closing summary and practical action plan. Let's summarize the core takeaways. Publishing moves your .bbix into Power BI service as a report, dataset, and query recipe. Choose the right workspace and connection mode before publishing. Workspaces are the primary collaboration and governance container. So use roles and developer to quality analyst to production patterns to manage content lifecycle. Dataset refreshes is critical for data freshness. Use gateways for on-premise resources, incremental refresh for large tables, and monitor refresh history for failures. Sharing should be intentional. Apps for broad audiences, workspace access for collaborators and team, embedding for everyday workflows, respect RLS and security. Embedding has two main models. User owns data, which is internal, and app owns data, which is external. Choose according to the licensing and business needs and secure via service principals and embed tokens for app owns data scenarios. So now let's discuss an action plan for learners. Publish a sample.pbix to a developer workspace, inspect the dataset, refresh it manually, and configure scheduled refresh options. Create a small workspace with member and viewer roles, publish an app, and install the app as an user. Now you can add a Power BI tab to the Teams channel and embed the report. Test the filter, add comments. If you have a developer background, you can generate an embed token using a service principal for test app. Work with your tenant admin to understand your organization's tenant settings and refresh quotas. Recommended reading and resources, publishing and uploading Microsoft Docs, workspace and role guidance, Power BI docs on new workspaces, schedule and manage dataset refresh, Power BI refresh docs, embed in Teams documentation and embedding Power BI and Microsoft Teams, embedding APS and service principal guidance, Power BI REST API docs. That wraps Module 9. In the next module, we will cover report optimization, large model strategy, and best practices for performance tuning in Power BI. Now we enter Module 9, which is about Power BI tips, tricks, and common mistakes. So, in this module, we are moving beyond the basics and intermediate skills. We are focusing on the advanced habits that make Power BI users truly efficient, reliable, and professional. If you think of everything we have covered so far, data loading, Power Query transformations, modeling, DAGs, visualizations, and publishing, these are the building blocks. Module 10 is where we refine these blocks into a professional analytics system that is fast, scalable, consistent, accurate, easy to maintain, easy to understand. This module is important because most Power BI performance problems, business confusion, or dashboard failures don't come from Power BI itself. They come from avoidable mistakes such as poor modeling, incorrect tags, unnecessary visuals, or inefficient refresh processes. So, in today's session, we will go deep into performance optimization tips, avoiding common DAX pitfalls, best practices for dashboard design, using Q&A visuals, and smart narratives for storytelling. By the end, you will have a complete mental toolkit that will help you build dashboards like an enterprise level BI engineer, not just a casual report creator. So, let's begin. The first section will be about performance optimization tips. Performance optimization is one of the most underrated skills in Power BI. Many users think performance issues only come from large datasets, but that's not entirely true. A poorly designed model with even moderate data can cause slow refresh, visual loading delays, memory overflows, frozen interactions, slow DAX measures, and many more. So, let's go step by step through the most important optimization techniques. So, the first one, reduce the model size. A lighter model loads faster, refreshes faster, and easier to maintain. So, here comes the tip one, remove unnecessary columns. Many datasets come with 100 plus columns, but typically only 20 to 30 are actually needed for reporting. So if you want to go through some examples of columns that you can remove, so some of the columns that you can remove are the columns which are only used for intermediate calculations. Audit fields like created by, updated by, columns with extremely high cardinality where you only need aggregates, pre-text comments, descriptions, or log columns that duplicate information like multiple versions of dates. Every unnecessary column increases refresh time. Removing even 10 such unused columns can significantly reduce model weight. Now, the next step, reduce data cardinality. Cardinality means the number of unique values in a column. High cardinality is equal to slow performance. For example, a column with 1 million unique customer IDs, a date time column with timestamps for every second, a text field where every value is unique. All this creates pressure on Vertipack engine. Now, let's go through the optimization techniques. You can convert the date time data type. Date minutes, seconds that are not needed. Reduce precision of numerical values. Group or bin data where possible. For example, if you have multiple ages, then you can segregate them into a group. From minimum age, that is 18 to 30, 30 to 60, and beyond. So you have three groups here. Avoid using GUIDs in visuals. Avoid using unique IDs in slices. Reducing cardinality improves compression and speeds up calculations. Now, the third tip, disable auto date time. Power BI has a feature called auto date time, which automatically generates hidden date tables. For small projects, it's fine, but professional BI models it should always be turned off. Why, you ask? Because it silently adds extra tables, which increases model size, relationship overhead, memory usage. Instead, always create your own date table marked as date table. Now, the fourth tip, use star schema for better performance. The most powerful optimization is correct modeling. A star schema ensures cleaner relationships, faster DAX evaluation, smaller models, predictable performance, and a lot more. In star schema, fact tables store numeric transactional data. Dimension tables store categories like product, region, or customer data. Many performance issues occur because users build flat tables or snowflake models with long chain. So, you need to consider one rule of thumb. One fact table connected to multiple dimensions is always faster than multiple flat tables. Now, the fifth tip, limit the number of visuals per page. Every visual is a query. Having too many visuals slows page Having too many visuals slows page load, increases memory usage, reduces responsiveness, increases dataset refresh time for direct query models. Recommended limits. Standard reports 6 to 12 visuals per page, executive dashboards 4 to 8 visuals, highly interactive pages 1 to 3 visuals plus slicers. If you need more, create drill down or drill through pages, bookmarks, or tooltips instead. Now, the sixth tip, avoid using too many slicers. Slicers may look simple, but they're expensive. Each slicer refreshes the entire page every time the selection changes. Replace slicers with drop downs, filter panes, drill through, filter report level, filters, buttons, or bookmark navigations. Only use slicers when user genuinely needs to make frequent selections. Now we have the tip number 7. Use measure tables. Professional Power BI reports separate measures from data tables. A measure table organizes calculations, improves model clarity, reduces accidental misuse of columns, enhances DAX performance because measures are calculated on demand. Never store measures inside fact tables. Now we have our next tip, which is about optimizing DAX. We will cover DAX mistakes in the next section, but performance optimization is deeply tied to DAX efficiency. A poorly written DAX formula can slow the entire model. For example, using SumX on large tables when sum is enough. Second example is using calculate unnecessarily. After that, we have using filter on entire tables instead of just few columns. Overusing all except, and remove filters is also one of the good examples. Great performance comes from minimal efficient formulas. Now, the ninth tip, avoid using many calculated columns. Calculated columns increase the model size, and these are computed at refresh time and are often found to be slow. These are usually replaceable by measures. You can reduce performance for composite models as well. Only choose to use the calculated columns if the logic cannot be handled by measures or a simple Power Query. 90% of calculated columns actually belong to the Power Query, not tags. Now, the 10th tip, use aggregation tables for large models. For very large datasets, millions to billions of rows, Power BI supports aggregation tables. Aggregated tables pre-calculate high-level summaries, reduce calculations, improve direct query performance, make dashboards more responsive. This is commonly used in finance, manufacturing, and IoT analytics. Now let's have a short recap of the section 1. In summary, performance optimization is not one thing. It's a combination of disciplined habits. Following these practices ensures smooth dashboards, reliable refresh cycles, and scalable models. Now, let's go to the section 2 of module 10, which is about avoiding common DAX pitfalls. This is one of the most important parts of today's module. Knowing DAX is one thing. Knowing how to avoid DAX mistakes is what makes you a true BI professional. So, the DAX issues almost always lead to incorrect numbers, confusing visuals, wrong totals, slow performance, incorrect filters, and a lot more. So, let's walk through the biggest pitfalls and how to avoid them. Now, the first one is misunderstanding row context versus filter context. This is the number one mistakes new users always make. Row context applies to each row in a table. Filter context, on the other hand, comes from slicers, filters, or calculate options. You must always remember a calculated column has row context, a measure does not. This is why formulas behave differently. Now let's go through some examples. Sum of sales of revenue. In a calculated column, this gives the same value on every row. In a measure, it changes based on visuals and filters. Misunderstanding this creates endless confusion. Now the second one, overusing calculated columns instead of measures. Many beginners use calculated columns for everything because they behave more like Excel formulas. This leads to bloated models, slow refresh rates, memory inefficiency, incorrect aggregations, and a lot more. Always ask, can this be done with a measure? If yes, then always prefer a measure. Now, let's go to the third one, using calculate even when not needed. Calculate is powerful, but many people use it unnecessarily. For example, calculate sum of sales of revenue. This is pointless because sum already respects filter context. Only use calculate when you want to change the filter context. Followed by that, we have using filter on the entire table. Example, let's consider a mistake where you added calculate function of sum of sales revenue and then you added a filter for sales region, which is equals to east. Instead of using this, you can simply write calculation method inside sum of sales revenue and sales region is equals to east. Now this filter adds row context, slow, and column filters are faster. Now let's go through the fifth one, misusing all method, removing filters and all except. These functions remove filters, but many users apply them blindly. Now let's consider an example mistake. So here total revenue is equals to calculate sum of sales revenue and all sales. This removes all filters, even date filters. This particular approach removes all filters, even date filters. Always think which filters should remain, which filters should reset. If you want only a specific filter to be removed, be precise. For example, all sales of region, not the whole table. Now, let's go through the sixth mistake. Improper time intelligence calculations. Tax time intelligence requires a continuous date table, no gaps, a mark date table. If your date table is incorrect, functions like same period last year, total year to year, which is total YTD for short, date add, these functions will return incorrect values. Now let's go through the seventh mistake. Using earlier instead of variables. Earlier is an outdated and confusing function. Instead, use variables. An example is VAR current value equals to sales revenue, return current value, previous value, etc. Variables improve readability, improve performance, prevent repeated calculations, reduce mistakes, and a lot more. Now let's go through the eighth one, not using divide function. Divide handles division by 0 gracefully. Now let's consider a bad usage. For example, sales of revenue divided by sales of quantity. So for a better approach, you can use divide method sales of revenue, comma, sales of quantity, comma, 0. Always use divide method to avoid errors. Now let's go through the ninth one, ignoring DAX query plans. Power BI has tools like DAX Studio, Vertipack Analyzer, Performance Analyzer, and a lot more. These reveal expensive measures, slow queries, heavy tables, and a lot more. Professional BI engineers always test performance before deploying large-scale dashboards. Now, let's have a quick recap of the section 2. DAX mistakes usually come from misunderstanding context. Once you master context, your formulas become faster, cleaner, and more reliable. Now, let's dive into the section 3, which is about best practices for dashboard design. In this section, we will shift from performance to design, the user experience portion of the Power BI. A dashboard is only as good as its design. Users should be able to look at your dashboard and instantly understand. The user should be able to understand what's the story, the trend, the insights, the action plan, and a lot more just by looking at your data dashboard. Now, let's look at some of the best practices that professional always follows. Now, the first one, apply the 5-second rule. A well-designed dashboard should make sense within 5 seconds. If the user needs to scroll, zoom, decode, guess, or mentally calculate, then the dashboard has already failed. Dashboards must deliver insights quickly and cleanly. Now, the second one is avoid chart overload. Not all charts are equal. Avoid some charts, for example, 3D charts, donut charts with more than 4 circles, pie charts comparing similar values, clustered bar charts with too many categories, maps with too many points, etc. Instead, you can prefer bar charts, line charts, matrices KPI cards, scatter plots for correlation, decomposition tree for root cause analysis, waterfall for financial analysis, and similarly, we have other options as well. Simplicity always wins. Now, let's go with the third one, maintain visual hierarchy. Visual hierarchy means guiding the viewer's eyes. Use large fonts for key KPIs, bold colors for important numbers, consistent placements, white spaces, grouping and alignment, and these things are to be considered. Use large fonts for key KPIs, bold colors for important numbers, consistent placement, white space, grouping, and alignment. A clean dashboard reduces cognitive load. Now, the fourth one, use consistent formatting. Consistency builds trust. Use the same number formats, colors, decimal points or decimal places, date formats, naming conventions, and etc. For example, if revenue is in millions, keep it in millions everywhere. Now, the fifth point, keep colors meaningful. Avoid random colors. Use consistent meanings. Let's consider green for good, red for bad, blue for neutral, and yellow for a warning. Avoid too many colors. Try to keep it within a limit of 3 to 5. Now, let's go with the sixth point. Use tooltips for depth, not overcrowding. Tooltips help keep dashboards clean. Instead of adding extra visuals, add details to tooltips. Use report page tooltips. Provide drill through options. This keeps the main dashboard. Provide drill through options. This keeps the main dashboard minimal but yet powerful. Now comes the seventh point. Use bookmarks for navigation. Bookmarks can create guided stories, step by step narratives, collapsible filter panels, interactive instructions, and a lot more. Bookmarks often elevate dashboards into apps. Now, the eighth one, hide the complexity from the user. Always design dashboards so that actions are intuitive, slices are minimal, visuals are self explanatory, navigation is almost effortless. The goal is to deliver insights, not complexity. Now we dive into the section 4, which is about Q&As, visuals, and smart narratives. This section focuses on Power BI's AI-driven storytelling. This section focuses on Power BI's AI-driven storytelling tools. These tools help users ask questions and generate insights automatically. Now the first one, Q&A visual. The Q&A visual allows users to type natural language questions like what are the total sales by region in 2024, what are the top 10 products by profit, monthly revenue trend for a specified country, etc. Now, Power BI interprets these questions and generates the chart automatically. Now let's go through the best practices. Use proper field names, create synonyms, build a glossary, train the Q&A engine, and use the suggested questions only. This makes dashboards conversational. Now, let's move into the second one, which is about smart narratives. Smart narratives automatically summarize the trends, outliners, key insights, differences, and anomalies. It generates text that explains what the charts show. For example, revenue is increased by 12% in Q4 and it is driven by strong performance in the electronics segment. This adds storytelling to dashboards. Now, let's go to the third point, narrative customization. You can customize smart narratives by adding your own text, highlighting key metrics, creating dynamic summaries, linking measures. This ensures that executives can read insights in plain language. Now, let's go to the next one, which is storytelling with Power BI. A great dashboard isn't just a collection of visuals. It tells a story. A story should answer what happened, why did it happen, why is it important, what should you do next. Smart narratives plus Q&A plus bookmarks plus drill through create powerful storytelling experiences. Now, the conclusion to this particular module. Module 10 wraps up all the advanced principles needed to build enterprise level Power BI dashboards. We covered optimization techniques for high performance, DAX mistakes and how to avoid them, best design practices, AI driven storytelling, and a lot more. These skills will significantly improve the speed, clarity, and impact of your dashboard. In the next module, we will conclude the course with advanced deployment and governance best practices. So, welcome to the final module of this Power BI full course for beginners. In this chapter, we are going to do three major things: recap everything you have learned across the 11 chapter journey, provide most reliable resources for going advanced, and third one, give you a complete roadmap to crack the PL300 Power BI Data Analyst certification. So, by the end of this module, you'll have clarity on how data flows through Power BI, how each module contributed to building your Power BI skill set, what you should practice for next, and exactly how to prepare for the industry recognized certification. So, let's begin with the detailed recap. Chapter wise summary recap starts now. Chapter 1 recap: Introduction to Power BI. In this chapter, we laid the foundation for your entire Power BI journey. We started by understanding what Power BI actually is, not just as a tool, but as a complete ecosystem for business intelligence. We discussed the importance in 2026 and beyond, especially as companies shift from manual reporting to automated data driven cultures. You learned that Power BI is composed of Power BI Desktop, where you build reports, and Power BI Service, where you publish and share the reports, Power BI Mobile, where the leaders consume the insights on the go. You also explore the real world use cases of Power BI: marketing team analyzing campaign performance, sales teams forecasting revenue pipelines, finance teams automating MIS and dashboards, HR teams monitoring employee performance and hiring metrics, operation teams optimizing supply chains and logistics. Finally, you installed and set up Power BI Desktop, preparing your environment for rest of the course. Now we dive into the chapter 2 recap. You have understood Power BI workflow here. This chapter explains Power BI's end-to-end workflow, which mirrors how organizations actually use the BI. It all starts from data, next to transform, next to model, then visualize, then publish and share, and lastly automate. We broke down each layer: data sources like Excel, CSV, SQL Server, cloud services, transformations using Power Query, where we did the cleaning operations, modeling, where we established relationships using star schema, visualizations, where we created interactive and insightful charts. Then comes the publishing, where we uploaded the dashboard to Power BI Service, sharing and governance using workspaces, permission, and apps. By understanding this workflow early on, you were better prepared for the practical steps that followed. Now we dive into the chapter 3's recap, which is about connecting to data sources. Chapter 3 was your introduction to real data ingestion. You learned how to import Excel and CSV files, pull data from the web, connect live to SQL Server, understand the difference between import mode and direct query, understand dual mode and when to use each. We discussed real life scenarios like import mode for faster dashboards, direct query for real time analytics, live connections for enterprise semantic models, etc. We also learned how businesses often deal with multiple systems, ERPs, CRMs, marketing systems, and how Power BI acts as a central reporting layer. Now, with that, we come into the chapter 4 recap, which is about data transformation with Power Query. This was the most important modules in the course because 80% of the data issues happen before the modeling stage. In chapter 4, we explored the following: Power Query interface, applied steps pane, query settings, data types, transformation, and add column ribbons. We also went through cleaning operations such as removing null spaces, null values, handling errors or replacing errors, filtering unnecessary rows, standardizing data formats, and a lot more. We also did some transformations where we merged queries, join operations, appending tables, splitting columns into multiple fields, pivot or unpivot operations for reshaping data, etc. We also covered why Power Query's M language is powerful for automation. Once you build a cleaning process, Power BI can rerun the same steps every time a new data arrives. Now, with that, we dive into Chapter 5's recap, which is about data modeling. Chapter 5 introduced to the heart of Power BI, the data model. You learned relationships, primary keys and foreign keys, one-to-many versus many-to-one cross-filter directions, schemas, and a lot more. We also dealt with schemas such as star schema for the best practice, snowflake schema and when to avoid it, lookup tables, how dimension tables helps you slice data, why fact tables contain measurable values, why hiding unnecessary columns improves the model, and finally, you learn how the model affects performance, DAX calculations, reports interactivity, and long-term scalability. This chapter gave you the structural backbone of your reports. And now we dive into chapter 6 recap, which is about introduction to DAX. This chapter was your first deep dive into data analysis expressions, the formula language behind the Power BI. You learn calculated columns versus measures. Columns are row by row measures that are aggregated at query time. Measures are recommended for calculations involving filters. We also went through some common DAX functions such as sum, calculate, filter, all, distinct, count, divide, and a lot more. We also went through time intelligence functions like year to date, month to date, same period last year, date, add, etc. We discussed practical business scenarios as well. For example, calculating year on year growth, computing conversion rates, creating running totals, generating customer cohorts, and a lot more. This chapter gave you the analytical depth required to turn raw data into insights. Now, we also discussed the recap of chapter 7, which is about visualizations in Power BI. This was your storytelling chapter. You learned core visuals, bar and column charts, line and area charts, maps, pie charts and donut charts, KPIs and cards, and a lot more. We also learned formatting skills like removing clutter, customizing colors and labels using themes, adding drill throughs and tooltips, and we also implemented filters, slicers, visual level filters, page level filters, report level filters, and a lot more. You also learned how professionals make dashboards intuitive, minimalistic, insight focused. Your dashboard started to look polished and business ready. Now, with that, we dive into the recap of chapter 8, and this was about time sales dashboard project. This chapter was the hands on real world project for you. You worked with a sample data set and performed data cleaning, data modeling, measure creation, visualization building, bookmarks, and UI design. You created sales KPIs, trend charts, region wise sales performance, category level insights, and a lot more. You designed an executive view, an interactive drill down, a modern UI layout. By the end, you had built a complete industry grade sales dashboard. Now, this brings us to chapter 9 recap, which is about Power BI service, publishing, and sharing. This was your introduction to Power BI and the cloud. You learned how to publish reports, how to create and manage workspaces, how to refresh datasets manually or automatically, how to share dashboards securely, how row-level security ensures data protection. You also explored embedding and permissions, which are essential for enterprise rollout. Now, this brings to the chapter 10 recap, which was majorly about tips, tricks, and common mistakes. In this chapter, you gained production level experience, performance optimization, avoiding large cardinality columns using star schemas, minimalizing visuals, disabling unnecessary interactions, and a lot more. We also learned about DAX pitfalls, misunderstanding row context versus filter context, using calculated columns when measures are better, relying too heavily on iterators, dashboard designs, best practices, consistent colors, proper visual hierarchy, fewer slicers, meaningful titles and tooltips, and a lot more. We also dealt with AI features like Q&A visuals, smart narratives, text-based summaries for executives, etc. This chapter helped you transition from a beginner to a professional level Power BI developer. And now you're ready for Power BI certification and professional growth. So now we will go through the section 2 about this particular model, which is based on the resource guide. So the first resource that you will be going through is the Microsoft Official Learning Resource. The Microsoft Learn Power BI collection from beginner to intermediate to advanced topics. This particular guide covers data modeling, DAX fundamentals, Power Query, Power BI service, row-level security, deployment pipelines, and a lot more. You can search this particular resource online. You can just type Microsoft Learn Power BI and you'll have the resource. The second one is Power BI official documentation, the most updated resource for Power BI visuals, DAX functions, data gateway configuration, Microsoft Fabric, and Enterprise BI. You can search online and you can type Power BI documentation from Microsoft and you'll get the resource. The third resource is Microsoft Power BI blog. This is perfect for staying updated on monthly feature releases, new visuals, performance improvements, and industry announcements. Now comes the resource number 4, which is about Microsoft Fabric plus Power BI integration guides. This helps you understand lakehouses, warehouses, one lake, AI-powered BI workflows, etc. Now, the last one, which is the Simplilearn learning resources. You can go through Simplilearn's Power BI tutorial, which is free. And to get this, you can search online. You can type down Simplilearn Power BI tutorial, and our videos break down complex topics in beginner-friendly formats. You can also go through Simplilearn's Power BI full course, which is available for free on YouTube. This particular resource is useful for revision, especially for tax basics, data modeling, and dashboard building. Apart from this, you have Power BI certification material by Simplilearn. To get this, you can go to a browser and search Simplilearn PL300 and you will have access to structured content mapped to exam topics. Now, let's go through the next section of this particular module. Which is about PL300 certification roadmap, a detailed step-by-step industry-recognized preparation blueprint. So firstly, what exactly is PL300? PL300 or Microsoft Power BI Data Analyst is one of the most in-demand BI certification in 2026. It validates your skills in data preparation, data modeling, data visualization, tax analysis deployment, and sharing. The exam focuses heavily on practical business-oriented BI scenarios. PL300 skills measure the first one, prepare the data 15 to 20%, get data from different sources, clean, profile, and transform data using Power Query. The second one is model the data, 30 to 35% weightage stays here. You need to design star schemas, create relationships, optimize the model, implement row-level security. The third stage is visualize and analyze the data. 25 to 30% weight stays here. So you need to build dashboards, create measures, add advanced analytics visuals, apply filters and interactions. Then comes the fourth stage where you deploy and maintain the assets. 20 to 25% weightage stays here. You need to publish report, set up workspaces, configure refreshes, manage permissions. You've already learned all these topics throughout this course. Now, let's go through the detailed study roadmap for 4 to 6 weeks. Let's start with the week 1. Power Query plus data preparation. Focus areas: import modes, merging, appending, pivot and unpivot, working with data types, removing errors. So you need to practice, and the practice is take 3 to 4 messy datasets from Kaggle. So you need to practice for this. The practice might include taking 3 to 4 messy datasets from Kaggle or public data, clean them entirely using Power Query. The goal is to build muscle memory in transformation logic. Now comes the week 2, data modeling, the most important week. The focus areas: star schema relationships, cardinality lookup tables, model optimization. The practice: build at least 3 models from scratch, identify fact versus dimension tables, create a semantic model report. The goal is you should be able to design a model on paper with confidence. Now comes the week 3, tax mastery. The focus areas: row context versus filter context, calculate all except iterators, sum x, and time intelligence. You need to practice, write at least 20 to 30 measures, calculate year to date, year on year, month on month, create KPIs, etc. The goal: you must be comfortable with calculate and context transitions. Now comes the week 4, visualizations plus Power BI service. The focus areas are building dashboards, drill through, bookmarks, tooltips, publishing reports, and workspace management. You also need to take care of dataset refresh and row-level security. For this, you need to practice. You need to practice creating a polished report, publish it, set up schedule refresh, add row level security. The goal, you should be able to present a full report end to end. Now comes the week number 5, revision week. Plus, you can also have some mock tests as well. So, you need to use Microsoft's Learn practice questions, Simplilearn's practice questions, Microsoft practice assessments. The focus areas here are rereading DAX functions, reviewing modeling diagrams, practicing service related flows. The goal, achieve 80% in mock tests. Now, let's go through some recommended learning approach. You can use Power BI Desktop daily. Try building dashboards from any dataset you see. Practice explaining your report. This helps for interviews. Follow Microsoft blogs monthly for new features. And now the wrap up and motivation you were looking for. You've completed one of the most comprehensive beginner to advanced Power BI journeys. You now understand data ingestion, data transformation, data modeling, data analytics, dashboard storytelling, cloud publishing, performance tuning, and a lot more. And now with the module 11, you know where to go from here. The best official resources, the certification roadmap, and the job ready skills that you must practice. Whether you're stepping into BI, upgrading your analytics career, or preparing for PL 300, you now have the foundation and clarity to move forward with confidence. So the module 1 will be about the introduction to SQL and database basics. So what is SQL is our first question, and why is it important? So today, SQL in simple terms, or let's expand as structured query language, is the standard language used to store, manage, and retrieve data from relational databases. In very simple terms, SQL acts as a communication layer between humans and databases. Instead of manually browsing data through files or spreadsheets, SQL allows us to ask precise questions to the large data systems and receive accurate answers almost instantly. You can think of SQL as the grammar of data, because just like grammar helps us form meaningful sentences, SQL helps us form meaningful data queries. So through SQL, we instruct databases to perform critical operations such as searching for specific information, updating existing records, inserting new data into the entries, deleting or removing outdated data, and organizing information using tables, views, and schemas. Without SQL, interacting with structured data at a scale would be slow, manual, and completely error-prone sometimes. Now, why is it important? SQL turns raw data storage into an intelligent, queryable system that businesses completely rely on. Now, you might be wondering why SQL still dominates in 2026 despite hundreds of new technologies and tools and frameworks emerging every single year. So the answer is SQL continues to dominate the data ecosystem in 2026 and in future, because this is not by accident. Because SQL solves a fundamental problem: reliable access to structured business data, universal adoption. Every major organization, whether it's Google, Amazon, Meta, banks, hospitals, or e-commerce platforms, they rely on SQL-powered databases at their core. Even modern cloud-native systems ultimately store their most critical data in relational databases using SQL, and they also query that data using SQL. Next is standardized language. SQL allows ANSI standards, which means once you learn SQL, the same knowledge applies to MySQL, PostgreSQL, SQL Server, Oracle, Snowflake, BigQuery, Redshift, and many others. This portability makes SQL a career-safe skill that remains relevant across tools and companies. Next is essential for analytics and AI pipelines. In analytics and AI workflows, SQL is often the very first step. Before any dashboard, machine learning model, or AI system is built, SQL is used to extract clean, structured, and reliable data. In many ways, SQL is the foundation layer for data-driven intelligence. After that, we have high performance with massive data. Modern SQL engines are highly optimized and can process millions or even billions of rows of data in just mere seconds. Features like indexing, query optimization, and parallel execution make SQL extremely efficient for large-scale data operations. Now, the next question is, where do you see SQL in real life? Although users rarely see SQL directly, it silently powers many everyday systems we interact with. Whether you book a flight, withdraw some cash from ATM, place an online order, or check your bank statement, SQL queries are running behind the scenes. SQL also supports food delivery applications, telecom recharge history, hospital records, and customer support systems. Each of these systems rely on fast, accurate retrieval of structured data, which SQL excels at. A useful real-life analogy is to think of SQL as a remote control for business data. Successful learners who master SQL gain the ability to instantly switch to exact channel of information they need, whether it's sales data, customer retention, or customer records or transactional history, without delay or dependency on others. So the next one is types of databases. So we have two types, relational databases or RDBMS and non-relational ones. Let's get started with RDBMS. A relational database stores data in tables made up of rows and columns, similar to Excel spreadsheets, but with far more structure, rules, and reliability. Each table represents a specific entity, and relationships between tables are clearly defined. Relational databases enforce consistency through constraints and relationships, ensuring that data remains accurate and reliable even as systems scale. They follow ACID, or popularly known as asset properties, which guarantee transaction safety, making them ideal for business critical operations. Since relational databases are SQL based, they allow precise querying and strong validation and predictable behavior. Most popular examples include MySQL, PostgreSQL, SQL Server, Oracle, and MariaDB, all of which are widely used in enterprise systems. Now let's discuss the second type, which is non-relational databases, or simply known as NoSQL. Non-relational databases, commonly known as NoSQL databases, store data in formats designed for flexibility, scalability, and speed rather than strict structure. Instead of fixed tables, they often use JSON documents, key value pairs, columns, or graphs. These databases are designed to handle large volumes of semi-structured or unstructured data and are commonly used in microservices, IoT platforms, real-time applications, and distributed systems. Some of the popular examples include MongoDB for document storage, Redis for key value access, Cassandra for column-based storage, and Neo4j for graph-based relationships. NoSQL systems trade strict consistency for flexibility and scalability in many use cases. Now, in the next stage, let's discuss the basic fundamental differences between relational and non-relational database systems. So, relational versus non-relational analytical comparison. Relational databases focus on structured data, predefined schemas, and strong consistency. They are ideal for transactional systems, reporting, and business logic where accuracy is critical. SQL serves as a powerful and standardized query language in this ecosystem. Non-relational databases, on the other hand, prioritize flexibility, horizontal scaling, and high-speed access. They allow schema changes without downtime and are better suited for rapidly evolving data models. A strong analogy is to think of RDBMS as a well-organized library where every book has a catalog number and fixed location. NoSQL is more like a creative studio where items can be placed freely based on immediate needs without any rigid structure. So, what is RDBMS? A relational database management system is specialized software designed to store structured data and manage relationships between different data entities. It acts as an engine that processes SQL commands and ensures data remains consistent and secure. An RDBMS is responsible for enforcing rules, managing user access, and handling backups, recovering from failures, and even ensuring that multiple users can work with the same data simultaneously without any conflicts. In short, the RDBMS is the backbone that makes SQL reliable, scalable, and safe for enterprise use. Tables represent real-world entities such as customers, products, or orders. Each table focuses on a single concept, keeping data organized and easy to manage. Next is columns. Columns define the attributes of an entity, such as name, email, or city. Each column has a specific data type and rule set that governs what value it can store. Rows. Rows represent individual records within the table. Each row captures a complete instance of an entity, such as a single customer or transaction. Next is the primary key. Primary key uniquely identifies each row in a table, ensuring no duplicates exist and enabling efficient data retrieval. Foreign keys create relationships between tables by linking related records, helping maintain consistency across the database. Next is indexes. Indexes function like a book index, allowing the database to locate data quickly without scanning every row. Followed by that, we have constraints. Constraints enforce data quality rules such as not null, unique, and check. These rules help preventing invalid data entry entering into the system. Now, the next stage is why RDBMS is the industry standard. RDBMS systems are highly reliable and trusted for business operations that cannot afford data errors. They enforce data integrity, support normalization, and handle complex transaction workflows efficiently. Because of these strengths, companies use RDBMS platforms for mission critical applications like billing systems, HRMS, ERP solutions, inventory management, and logistic platforms. When accuracy, consistency, and reliability matter, RDBMS remains the preferred choice. Now comes the next stage where we will learn the installation and setting up SQL environment. So now we have come to a stage where we will install MySQL into the system. Now it's really simple. All you need to do is just type down MySQL Workbench on your browser, and then you'll be redirected to this particular page. Use the first link, MySQL Workbench, or you can also go with the download option. And here you have the download now option, right? So you can click on this and your installation file or the setup file will be downloaded for you. And you just have to run that particular file. It's a simple installation procedure. But if you have any queries, don't worry. I'll also drop a link to this particular tutorial on how to install and run MySQL Workbench. For now, we have already installed MySQL. So let me run that. So this is my database, which is SLP database. So you can see on the right hand corner of my screen, we have an option that says the position of all the prompts and all the sections of this particular workbench. So I'll go with the first option where I can see all the databases I have and the tables I have, right? So right now we are in the table that we earlier created for interview questions and answers. So this will be down the line. So let's go to any of the databases. I would like to go with this particular one, sample dataset. So I'll be using the SLP database. So we can test our SQL database in this way. You can start by selecting any of the databases. Don't worry, in the upcoming section or the upcoming module, I'll explain you how to load the data, how to create table, how to insert the values into your table, and all those fundamental things. So first, for the beginning section, to test our SQL installation, we'll do this. So before you get into anything, you just need to select the database where you have the data. So you can do that by simple command which says use the database name. This is the font. So let's say use and database name. And you need to have a semicolon, right? So you can also see why I'm using specific format. I'm using, let me expand my screen. I'm using all caps for the keywords. In SQL, we have keywords and also the user-defined words, right? So the keywords are something which carry a functionality. So here, if you see, we have a select, from, where, not in, right? These are keywords. They have specific functionality. And whatever the things you see in a black color, which have case sensitivity in lowercase or sentence case, those are the ones which I define. So tomorrow, if my query gets a little more complex, so down the line, we will be learning subqueries and advanced querying functions where we should be at a stage where we should identify our own code. If you follow or some mixed kind of way to write your queries, then you might fall into a confusion understanding what is what. Is it a keyword, or is it a word that I define, or is it the name of the column, or anything, the name of the table which I define? So to avoid such confusions, we will follow this standard. If ever there is a keyword, just keep it in all caps. And if ever there is a column name or a table name, then you can keep it in mixed case or low case as per your requirements. So product ID, this particular name is a column name, so that I identify it as a column name, I'm using mixed case there. So it has a caps thing, and then the all small letters in that way. So basically, you need to select a database name, and explain MySQL workbench that I'm going to dive into this particular database, which is SLP. And you can see I have complete access here. So if I expand this particular section, you can see SQL gave me a green to go, and then I can also check what are the tables present in my database. So for that, you will be using show tables, control enter, and these are the tables which I have: bonus, book collection, book order, clone, consolidated student information, employee details, etc. So now, if I want to understand employee details, what I'll do is copy this row, copy field, and then I'll simply write down a select statement, right? We will also understand what exactly does select from, and every aspect, every syntax of the statements in the upcoming module. For now, we are just testing the condition of the installation that we have done. So for that, I'll be writing down select. So you can see when I type, you can see some auto suggestions, but don't take any auto suggestions. Follow a strict format for yourself. So select star, which means all the columns. So maybe I'll be having 5 columns, 6 columns in this particular data set or data table. When I indicate star, automatically MySQL Workbench will understand that user wants to query or extract all the columns from the table. If I dedicatedly provide, let's try that as well. So from, and remember the field that we copied, just paste it and remove the single quotes. And at the end, yeah, without semicolon, your query will run. But to follow a strict syntax, we need to enter semicolon. Now, let's hit enter to find out the entries in our data set. So we have 5 columns. You can see we have employee ID, employee name, age, department, and salary. So now, let's say I just want the employee name and their department. In that case, what I can do is quickly copy this and paste it somewhere here. And instead of star, I will write the dedicated column name, EMP name, comma. If your intention is to extract specific columns, then you need to specify them and separate them using a comma. Now I want employee name and department, so I'll write EMP name column, comma, separated, both are separated by comma, and department, right? So let me run this and I'll have, okay, there was some error. Copy field name and I'll paste it here. Yeah, I think that was a small spelling mistake, not to worry. Enter. There you go. So we have John Doe and all the other employees, Jane Smith and Michael Johnson, and their specific departments. Now let us understand something a little more detailed. Let's say the user wants to extract specific employees from IT department. How do we do that? We do that by adding a where clause. So these are clauses, don't worry. We're just testing it out. In the upcoming module, we will be going deep diving into each and every part of this. So where our department is IT. So since this is a character data type, it will be inside quotes. So IT, semicolon. Remove the semicolon and everything is good to go. Enter. And we will have the details of all the employees who are in IT department. So this is how a basic query on MySQL Workbench works. Now we have a briefing on the understandability and working functionalities of the MySQL Workbench. Proceeding ahead, we have the choice of SQL engine for learning purposes. So MySQL and PostgreSQL both are excellent choices. MySQL is known for simplicity and ease of use, making it ideal for beginners and web applications. On the other hand, PostgreSQL offers more advanced features and widely used in analytics and data engineering roles. Both databases are open sources, stable and production ready, making them perfect environments for learning SQL fundamentals. Now we have common installation issues and fixes. Beginners often face issues like port conflicts, authentication mismatches, or missing environment values. So these will be the common issues that you might be facing during the installation process. Don't worry, we will be linking the complete installation and setup video in the description box below. You can go through that and it will have all the mistakes and all the possibilities of creating mistakes and all the permutations and combinations of the problems that you might be facing in real-time installation. It's a completely detailed tutorial, so it might take a lot of time of this particular session. So for that purposes, we have created a dedicated tutorial for installation. So we will be linking that. Now, why these issues come? Because you might be having Jupyter Notebook or any other platform that deals with databases like MySQL as well. So you might have to dedicatedly create a port for their access. So if there is a port conflict or any kind of authentication mismatch, you might face these. So you have that all covered in that session. Understanding these errors early prevents frustration and builds troubleshooting confidence. Addressing problems such as 3306, which is a port number conflict, or PG admin setup, which is for PostgreSQL failures, helps learners become self-sufficient and comfortable with database tools. Now let's go through best practices for beginners. So some of the best practices are: you should learn always to create a dedicated practice database to avoid accidental data loss. Using meaningful table name and column names improve readability and long-term understanding. Backing up data before experiments and maintaining a personal SQL notes file helps reinforce learning and builds good habits from the start. And that brings us to the end of module 1, and next will be the module 2. So now we have entered module number 2. So this module number 2 gives us a brief introduction to the basic commands in SQL. So this is all about how to create a table, how to insert data into a table, and then when you start querying, how do you query, right? For a basic example, you have select. So select in SQL means you're trying to explain the SQL workbench that you want to select something from a table that you just created. So there might be many number of tables. For this sample execution, we're going to create 5 tables, and you must specify which table are you focusing on, right? So for that, you might have to give SQL table name along with the select statement. And then what do you want to select? You want to select a specific column or all the columns available. So there are again specific ways to select the columns again. If you want any particular column from the table, you need to specify the column name. Or if you want to extract all the tables, then you don't have to write all the column names. You just write an asterisk, and then all the values will be extracted for you. And if you want to filter out, let's say there is a condition where you want to filter out all the employee details where department is equals to HR, then you will go ahead with one filter query, which is where, right? That particular where is a clause in SQL. So this can help you understand how simple SQL is. It's just a verbal language. You talk to your database and you'll get the queries. It's as simple as that, right? This is what makes SQL so exciting, so resilient, so reliable, and so relevant to the current IT standards and industry standards wherever data is related to it. So now without further delay, let's start by creating a simple table, right? So now you can see on my screen, we might have to use the database first. I have already created a database on the name interview, and this particular database will be used by us in upcoming modules, maybe 2 or 3 times for interview questions and answers and joins. And for now, we are just working on the basic terms of creating and filtering data and extracting data insights. So I'll be using this particular dataset. And if you want to create a new dataset, it's really simple. You go to File, and here you create a new model. And then you add the names to your model and all those things. Or you can also go ahead with this particular option. Create a new schema. And then you name your schema as sample schema test now. And then you can choose a default location and all those default things for yourself, and then apply. And then you create a schema if you want, apply, and finish. For now, I don't want to create this one, so I'll just close it. And once you create the schema, everything is straightforward, like we are going ahead with now. So once you create a database, you need to remember the database schema name. So now I've created this particular interview schema. So to begin with adding any of the tables or adding any of the data entries, I need to specify the database I'm using. So you can see on the left-hand side, we have a lot of data schemas. We have car dealership, credit card data, interview, sample store, right? This is the one sample schema test that we recently created, right? You can drop this schema, drop now. So we have removed it. That's the way you delete a schema if you want. Okay, let's take it as a learning step in case if in future if you wanted to delete any schema. So now I want to get the access to interview schema, or the one which I created already. So how do I get access to it? Again, SQL is really simple. You just need to write down use schema name, which is interview. Done. Semicolon. Now SQL understands, yeah, user wants me to use this particular schema on the name interview. So let me expand this so that you can see it better. I hope the code is visible clearer. So now you can select the entire query and use this particular flash logo to execute, or the best way I use is hold control and press enter. That is the best way, or a shortcut to select the database. Now comes the next step where you want to create a database. So again, let me tell you this. So we have linked this particular code document in the description box below. You can open up the code document and follow along with us so that you have a better learning experience. And I've also saved this particular code documentation on a notepad for quick access. But before going with the quick access, let us manually type the table names and enter the data or the insert commands so that we have a decent understanding. Let's go back. So the first table that we will be creating is departments. Now you can see this particular double code, right? If you have programming background, then you might have something called naming conventions or tagging or quoting, right? It will not be executed in real time, but it will act as a note or a sticky note that you leave on your code so any of your fellow developer understands what's happening here. So I'm using these double hyphens here as a quote so that my fellow developer will understand that I'm creating a data table which is named as department. So the simple command for this is create. So you want to create something, so you just write create. What do you want to create? I want to create a table, right? So you can see that whenever we write something, we are using, or I'm using, a separate naming convention, right? So here you can see I used uppercase for the keyword use. So anything which is getting highlighted as in a blue color is a keyword. A keyword has a dedicated meaning and it cannot be used for normal purposes. It can be used only for SQL purposes only, to make SQL understand what is your step or what is your intention. So use uppercase for all the keywords and use mixed case or sentence case or lowercase preferably for your names, right? For the table names, for the column names, for the row entries, or anything which is from your end. Basically anything which you are giving, the users which you are giving to SQL should be in lowercase so that you can differentiate. For now, we are just trying to write 2 or 3 lines of code, 2 or 3 lines of query. That is easily understandable. But in future, you will be writing subqueries, you will be writing joins and a lot of more complicated queries where at least you'll be writing 10 to 12 lines of code. In that particular scenario, you must be capable to understand which is a keyword and which is a user-defined word or a name or a column name, right? So a metadata basically. So that's the naming convention you should be following. So understand what's the difference between a keyword and what's actually the name that you have given to your column name or a table name, which is basically user-defined. So you can take it in programming terms, which is user-defined, which is internal implicit design, right? Implicit function. So I want to create a table. So write create table. And what's the table name? So my table name is departments. So this is my table name. So what do I have inside my table is my next question. So inside my table, I want to have a couple of columns. Let's say 2 columns, department name and department ID. So for that, I need to write down dpt ID and data type is integer. I want to provide integer data type for it. So basically, before we continue, let me tell you something. So whenever you want to add columns, you need to add column name. Okay, let me comment this. Column name along with its data type. So this is a set. So whenever you try to enter a column name, you should follow this particular approach where SQL understands this is a, it's a combination. It's an entity which is made of two things: name of the column and what's its data type, right? So this is the naming convention that you should be following. So I want department ID as the first column, and the next column is department name, right? So for this particular department name, I want to go ahead with varchar, and varchar is also another data type. And for that data type, you can allocate number of locations to save that particular department name. So for a basic request, I think I'd like to go with 50 character spaces, and that should be good enough for writing my department names. And then you can close the command and write a semicolon to end the query. So your query will run without a semicolon, but for safer programming practices, consider it as a protocol so that you or any other developer who is reading your commands will understand that it is the position where this particular query ends. So use a semicolon for that. This is pretty good, but remember, we might have to work on joins in the future modules. So joins is nothing different from the VLOOKUPs or the relationships or the data modules that you have seen on Power BI, Excel, etc. Basically, you're combining 2 or 3 different tables together. Let's say you are ordering something from your online websites, and for getting that particular product to your location, you're providing your address, phone number, and all the details, right? So in a similar way, when you want to access data from a different table, you might have to establish a connection between them. So to establish a connection between the two tables, you might want something called as a primary key and a foreign key. So primary key and a foreign key act as phone numbers or an address location, or basically something which establishes a relationship between them. So now this particular thing you need to understand. A primary table in one table is the one which connects with the same primary key in another table, but in the other table it is termed as a foreign key. In my table, department ID would be the primary key, it will be unique and it will not be null, and this particular department ID can also be another table. It can also be unique, it can also be not null, and it will not be empty, but in that particular table it will be termed as foreign key. The same primary key in a different table is termed as foreign key, but the same primary key in the dedicated table is termed as a primary key. So now I want to term my department ID as the primary key in my table. For that, you just need to write one more sentence here, not even a sentence, one more word. You just need to specify primary key, and that's done. So primary key and done. Now what happens is SQL will understand you want to create a table and the table name is departments, and you have one department ID column, 2 department name column, and the data type for department ID is integer and the data type for department name is varchar, and you have provided 50 spaces or 50 data spaces or addresses for you naming your department name, right? And out of which department ID is the primary key. So these are the details that you have given to your SQL workbench, and you should be ready to create a new table. So now let's head back to the notepad where we had created the code. This is the one. So create table, departments, ID is equals to int primary key, department name is varchar, 50 locations, and semicolon. So only difference is there are some indentations done. So what is an indentation? Just like any other programming, you also provide dedicated spaces, new lines, so that the fellow developer understands where is what. So this is the indentation we have followed here. We are creating a new table, departments, and the first column is department ID. It is an integer data type and it's considered as the primary key. The next column is department name. Its data type is varchar, which is a character data type. We have provided 50 spaces, and then end of the command. Right? Now comes the insert command. Now, again, similar to table creation, inserting data into a table is also simple and easy. So all you need to do is specify the operation that you want to do. It is insert. I want to insert data, but into which table? So I want to insert into table which is departments that we recently created. You can simply copy and paste the department's table name here. And what are the department columns you have? So I have 2 columns there. I'll take department ID and department name. And now these are the values I want to insert. What are the values? So again, comma separated values. The first is ID, so you don't have to write any quotes. But the second one is varchar, so character data types must be specified in single quotes. So this is the first entry, comma separated values. The second one is number 2, comma, single quotes. And what's the next one? Maybe engineering. And again, a comma separate. And third team could be finance, separate by comma. Fourth team can be marketing. So I don't have any further rows here. So what I can do is I can close this particular indentation. And write a semicolon to explain the end of this particular query. So now, similarly, you can just execute this and add the values. So let's head back to the notepad. So here you go. So this is a similar approach what we have mentioned here on my MySQL workbench. You can follow this indentation so that you are clearer. And you can just simply run the query. I'll use Control Enter. And these values are entered into your table. Now I want to extract what are the values that I have entered into my table, or I want to just cross verify if I have entered all the values or if the values that I have given are properly inserted or not. So for that, you want to select. So as we discussed, there are multiple ways to extract data. You can just specify the column names from which table. The table is departments. Or you can specify dedicated column names. Let's say I want to only extract the department name or department ID. You can also do that. Or another approach for the same code is this one. You don't have to specifically mention the column names. You can just write down an asterisk and it will still execute the same. So let's try all these 4 commands. You have your data here. And the same works for this one as well. Now, let's say I want to select only a dedicated column. So these are your department IDs and dedicated department names. This is your department name. And now, if we drill down further, let's say I want to extract the details for only HR team. So this is where the where clause comes into the picture. So extract or select department name where. So this is basic fundamental queries that I'm really writing right now so that you understand how it actually works in the background. So you understand the workflow of it. So where department ID is equals to, let's run this, department ID 4. So 4 is marketing. So department ID is equals to 4. So what happens is, SQL selects the department name column altogether. The entire department column is selected. First, it will go to the departments table itself. It has 2 columns. One is department ID and a department name. You can see it right here, right? So this particular entire table is selected by SQL. And then it reads what are the columns I need to select. So we are dedicatedly specifying just one column, which is department name. This particular column will be selected in the second phase. The third phase is where it applies the filter for department ID. Now, again, it goes to department ID and it checks individual department numbers. So it will go for the department ID where it matches with number 4 and then adjacent to it is marketing, right? This is what we are trying to extract. SQL has understood this and it will give us the marketing team name. So this is how the query works in the background. Now that we have a basic understanding of how the fundamental keywords in SQL, which are select, from, where, filtering things, right? Basically how to create a table, how to insert values inside a table, and how to query them. Now we will proceed and add a few more tables onto our MySQL workbench so that we can get continued with further queries like some aggregate functions like average, sum, etc. So let's not waste much time. Let's go back to the query window where we have all the table details and copy them and simply write them. So let me copy the entire 3, 4, 5 tables and paste it on the SQL workbench here. I'll minimize this a little so that we have a better view. There you go. So this is our second table, which is employees table. Now, before we create the table, let me explain you few things. So we have about 5 tables. One is departments, second is employees, third one is users, fourth one is orders, and fifth one is sales. In the terms of data analytics, in the terms of business analytics, we deem these tables as 2 parts. The first one is fact tables and the second one is dimension tables. So what are fact tables and dimension tables? We will deep dive into these in the next upcoming modules. So basically, it's nothing but relationships between the tables. So there will be one table which is related to all other tables in the database, right? So in this particular scenario, the employees table is a fact table, and employee is the one which works in your company. Let's say you have an online store and you have a list of employees, and these employees are the ones which receive orders from the users, and they fetch your inventory, pack that order and send it to the users, right? So employee table is the fact table which is related to the orders table, which is related to the users table, which is related to the inventory table, which is related to the department table, right? It connects to all the tables. And on the other hand, the dimension tables, these are related to your fact table based on one foreign key, right? You will be having employee ID, right? This particular employee ID will be the primary key of your data table, and somewhere or the other, the employee table will dedicatedly have a department value, department ID, right? It will have the order values, the order ID, it will have the sales ID, right? All these entries will be in the fact table, and all these entries will be the primary keys of all the dimension values, right? The dimension tables. These values will connect to the fact tables. So it will be a little confusing now, but when we enter into the data modeling module, there you will have a clearer understanding. For now, let's understand one thing. You just have different types of tables. One is fact table, one is dimension table. Fact table is really important because fact table acts as the mother of all the other tables, and all the other tables are connected to fact table. If you delete the fact table, then there is no way you're going to perform the analytics in future, right? It is like the root. Just understand that basic thing. Now let's continue with table creation. So now let's head back to table number 2, which is our fact table here, or let me tag it as the fact table for reference. Now the same pattern again. We want to create a table. So create command, table command, provide a name to your table, which is employee. And here we have 1, 2, 3, 4, 5, 6 columns. We have employee ID, we have employee name, we have salary, we have department ID, on which date was he or she hired, and the department ID, right? So here we are dedicatedly specifying that department ID is a foreign key which relates this particular fact table to the departments table, and we are referencing this, right? So references is the keyword which helps SQL identify that you are trying to connect this particular employee data with the department data, right? So we have about 5 columns here: employee ID, name, salary, department ID, and hire date. And if you are trying to get this connected with another dimension table, then this particular command where it says we are trying to use department ID as a foreign key, which happens to be the primary key of our dimension table, which is the table name, departments, and in that particular table name, the column name is department ID. It is named as department ID. So please go to the departments table, refer to the department ID column, and then match the entries of department ID from employees table to the department table. So this is how it works. Now let's click the flash logo, or I'll go with my shortcut Control Enter, and we have successfully created the employees table. And similar to the previous approach, you need to specify the keyword insert. I want to perform an insert operation, and I want to insert these elements into is another keyword, and you need to provide the table name, which is employee. And now what are the columns I have in my table? I have employee ID, I have employee name, I have salary, I have department ID, and hire date. So based on the column names, I need to specify the data entries as well. So you cannot mix and match. You are specifically providing the order in which the entry should be happening. So the order is: first comes the employee ID, second comes the employee name, third comes the salary, fourth comes department ID, and fifth is the hire data. In the same fashion, your entries should also be matched. So first, the employee ID is 1, the name is Alice, the salary is 90,000, department ID is 2, so she belongs to department whose ID is 2, right? If we go back to department here and execute this, so we will be having engineering in the department ID 2. So Alice belongs to engineering department, and then comes the hire date, which is this one, right? So you need to specify the data type. So here I have specifically provided the data type as date for hire date. In the same fashion, rest of the employees, employee ID 2, 3, 4, 5, 6, 7, and 8, 9, and 10 are added, right? And deliberately we're also adding some null values here. So you'll understand why we are adding null values, because in future we will be performing some join operations in the upcoming modules, where we will try to filter out the employees whose department is not yet allocated. We are considering these employees are new or fresh hires, so they are on bench period and they are not aligned or assigned to any projects as of now. So they are having their department ID as null. So we'll be performing such operations. For now, just try to, here I think I've marked it, no department, right? So for now, just try to create a table and add data. So now your fundamental job to do is you need to understand how to create a new schema, which I've explained before. Go to the schema table here, create new schema, and write a name to your schema, and then apply it to create a new schema, which happens to be a dimension table, and this will be related to the fact table, which is our employees table, right? And here I'll be having user ID, email of the user, and at what time was the account created at timestamp, right? Now Control Enter, and we have created this particular users table. And similarly, we will insert the data into users table. So we will be following the same pattern. So we will be inserting into users table, and these are my values. Let me indent it. So proper indentation will help you understand how your tables are organized. So you can follow this. It might take a little time, but in future it will definitely save a lot of your time entering or making mistakes, right? So this is a good practice or best practice. Now I have about 10 users in my database. And then this is the end of the query. So here you can see I've also tagged as duplicate email entry. So this will be another learning experience for us, where we will try to find out duplicate email entries in our database. Now hit Control Enter. I think we selected employees data table. We were supposed to select users data table. Yeah. Okay, we were supposed to create the data table first. Okay, we have successfully entered the elements into the users table. Now comes our fourth table, which is orders table. Similarly, we have order ID, customer ID, and order date. Control Enter, and we have created the orders table. Let's quickly add all the data into the orders table. You can also follow the same indentation, or if you want to have a particular specific format of indentation, you can also follow that. We have the last table, which is sales table, and similarly, let's enter all the data into sales table. Now let's check all the entries or all the tables. The process is simple, like we discussed. select star from employees. There you go. So these are the employees and their details. And similarly, you can just quickly copy and paste this command and rename this to departments and run a query, and you have all the employees or department details. Similarly, you can copy paste and then you can use the name of sales, orders and users. And I'll also have orders, and also I'll have sales. So these are the user details that we have entered, and these are the timestamps when a user account was created, and these are the order details. So these are the orders placed on what detail, on what date, and who was the customer and who was the order ID, and all the details of that. And sales data table, what was the sales ID, on what date was the sale made, and what's the amount they paid, right? So these are the details that we needed. Now let's take a step further and try to extract some details from this particular data set that we have just created. So I'd like to close it here. So far, this is the creation and insert process. Let's comment it. Now let's proceed further, and this would be the querying stage. Now let's try the filtering process. So let's consider we want to filter the details of employees who are earning let's say 90,000 or more. So how do you extract it? Let's take a moment. So far we have a basic understanding of how to insert data, how to select queries, right? And we also went through a sample where statement where we extracted the marketing ID, right? So the department name where marketing or department ID was equals to 2, right? So following the same approach, can you devise a quick query? Yes, I think you already have a rough template on your mind, but it's okay if you don't have it. So let's get started with it. So as we discussed before, SQL is really simple. All you need to do is just explain SQL in very simple terms. I want to select. Select what I want to select. I want to select employee name, or I want to select everything from employee, where from employee. Let me copy the employee name to save time. This is the table name. From employees, where salary is greater than a rough number 90,000. So before that, let's run this query and see. We have Alice, we have Bob, we have David, we have Eve, we have Heidi, and we have, yeah. So there are a few employees who are drawing salary greater than 90,000. Let's say it has greater than or equal to 90,000. So we must be getting a couple of entries here. So let's quickly run the command, control enter, and there you go. So we have about 1, 2, 3, 4, 5 employees, Bob, Alice, David, Eve, and Heidi, who are withdrawing salary which is greater than or equal to 90,000. So this is one of the good filtering examples. Now let's go with a few other queries or filtering queries. So we have HR, we have employees, we have users, we have sales, we have orders. So let's say I want to extract employees who were recruited after February of 2025. So for that, we can use the same query. We can quickly copy and paste it here from employees where join date, right? So I'll execute the select query once again. So I'll copy this particular field name and paste it here, is greater than or equal to March. We don't have a March, but we can take the September. We can copy this particular field and paste it here. There you go. So any employee who is hired after September 2025 should be highlighted. Enter, and there you go. We have about a couple of employees who were recruited after this particular date. Or you can also find out less than who are the employees who were recruited before this particular date. There you go. So only David was the one who was, maybe this can be considered as David is one of the senior most employees in this particular organization. Now, let's proceed further and try the next type of query, which is the sorting data. Now, I want to sort the employees table. Let's say now I want to identify employees in terms of salary. Who is the employee who is drawing highest salary and who is the employee who is drawing the least salary? I want to order them in decreasing order. So it's really simple. You can use the same query here. Select star from employees and order by salary DESC. So we have two keywords, DESC and ACSC. So ACSC is ascending order, BESC is descending order. So you just need to run this query and we will have salaries of the employees who have highest salary numbers. So we have Bob, David, Heidi, followed by that we have Eve, Alice, etc. And Ivan is the person, maybe he's a fresher, so he's drawing the least intern level salary or the beginner level salary, which is 50,000. And similarly, you can follow another thing here. You might be assuming, can I give two columns here? Yes, you can give two columns. Order by DEPT. So let's go with department ID. So this even works for character data types as well. Department ID ascending and salary descending. So you need to separate this by a simple comma and there you go. Enter. Now what happens is you can organize the department ID in increasing order and organize salary from descending order. So it's just executed for the reason to understand if this particular order by sorting command executes for one or more columns or not. So the reality is it works for one or more columns. So that's the basic understanding. Now we need to understand one more thing, which is filtering out with limits. Let's say I want to find out only one entry which has the highest salary. So in that particular case, what I can do is I can make use of limit command, which limits the number of rows output by one or two, number of a number, dedicated number. If I just want one entry, I'll have just one entry. In case I want to have top 3 employees, I can provide top 3 as limit 3 and you'll have top 3 rows executed right here for you. So this is where we come across the limit function. And apart from limit, you also have another function which is called as distinct. So the name speaks for itself, unique entries in the row. So for example, let's say I want to find out, let me use the same query, select star from employees and I'll replace star with distinct department IDs. Okay, field name. So what it does is, for understanding what it does, we need to copy this statement and paste it once again, semicolon. Now what's happening is, when you enter this particular query, you have multiple departments. Let's say department number 2, engineering department, is repeated multiple times. But now I don't want to extract all the employee details. I want to just know how many number of unique departments are present in this particular employees table. So in that particular scenario, I need to provide a semicolon to follow the principles or best practices. So here you see we have about, okay, I think for distinct function we might not need semi double quotes. Okay, I think I made a mistake in keyword. Yeah, there you go. We have 1, 2, 3, 4 distinct department IDs and one null. So that is from the employee to which we did not assign any team yet. So that's one thing. And now if we continue ahead, we have aggregate functions, which are basically the average, sum, count, minimum, max, and a few other basic aggregate functions that you use on a daily basis. So for basic aggregate functions, I'll just quickly copy and paste the comments here so that we save time and spend that time for understanding how the query is performing. So here we have the first function, which is counting the number of employees. So basically we'll start with the first aggregate function, which is trying to calculate the total number of count of total employees in this particular data set. So we are using the count function, and here you can provide a dedicated column name, or you can also provide the star logo, which basically calculates the entire rows here. So just enter. Then you have about 10 employees here. Now the next aggregate function is we will be trying to find out the average salary of an employee from a specific department, which is engineering. So for that, let me expand this again. So for that, first we will be calling the columns from this particular table, which is employees table. And since we are also dealing with a specific department, which is engineering, we need to perform a join operation where we will combine both employees and department tables together based on one keyword or one column, which is department ID. So department ID will be a primary key for department table, and department ID will be a foreign key for employees table. So based on this foreign key, meaning the employees table will be able to get joined or connected with the department table based on this particular department column, department ID column. Now, so our statement is simple. We are selecting average of salary, and we are aliasing it as average engineering salary from the table employees, and we are joining the employees table with the departments table on one common column, which is department ID. Departments dot department ID is equals to employees dot department ID. So departments is the name of the table and employees is the name of the table. So in this particular table, I'm referring this particular column, and I'm trying to connect to this particular column in the next table where department name is equals to engineering. Now let's execute this particular query. There you go. So on an average basis, the salary of any employee working in engineering department is 1,08,750. So this is the average salary of any employee who is working in engineering department. Could be more or could be less based on the designation. If he's an intern or a beginner, then the salary might be less. If he's a supervisor or in a senior position, the salary might be more. It's basically an average of both. Now, the next aggregate function that we will be dealing with is the maximum and minimum. So for finding out minimum number, you can use a function in SQL, which is called min. And for maximum, we can use a function called max in SQL. So it's as simple as that. Minimum of salary as minimum salary, maximum of salary as max salary from employees table. So let's quickly execute this query. There you go. So we found out the minimum salary of any employee in the entire company is 50,000, and the maximum salary in the entire company is 1,20,000. Next comes the last aggregate function in this particular domain, which is count function. So we will be selecting a department ID, and we will be counting the total number of employees per department, and we will also name it as employee count from the table employees, and we will be grouping it by department ID. Let's enter. There you go. So we have one employee who has no department assigned, maybe he's an intern, and department ID 1 has 2 employees, department ID 2 has 4 employees, department ID 3 has 1 employee, and department ID 4 has 2 employees in it. And with that, we have come to an end of this module, and we have understood the basic functionalities on how to create a table, how to insert a table, how to select or extract data entries from a table, how to filter data using where clause and having clause, and we also learned grouping, aggregate functions, basically all the fundamentals to proceed with the upcoming modules. And with that, we transition to the next module. So now we enter module number 3, which is about understanding SQL data types and operators. This particular module will help you set the stage for all the basics. In this module, we will be diving into something absolutely fundamental, something every single SQL developer, data analyst, and database engineer uses every single day: data types and operators. Now, I know what you're thinking. Data types? Operators? Isn't that basic stuff? Yes, it is basic. But it is also the reason behind almost 70% of SQL mistakes that beginners make. Wrong data type breaks queries, slows down performance, and causes corrupted results, and even sometimes crash the entire production system. I've seen senior developers accidentally storing dates as text and then wonder why the database can't sort December properly. So in today's chapter, it's not just theory, it's how not to break your job interview or your database. Let's dive into this section. The first step is understanding SQL data types. Before we even start to write a single query, SQL forces us to follow this one golden rule. Every piece of data must have a type. Why? Think of a database as a massive warehouse. Data types are the labels on the boxes. Without labels, the warehouse becomes chaos. With accurate labels, everything is fast, searchable, optimized. SQL databases rely heavily on the data types for storage, indexing, comparison, sorting, and performance tuning. Imagine a library where books have no categories. SQL without data types feels exactly like that. Now let's break them down. First one, numeric data types. We have integer, or it is also specified as int, which is used for whole numbers. Great for IDs, counts, quantities. For example, age can be stored as integer. Product ID can also be stored as integer. Quantity, the number of items ordered. Now it's a small story type. In one of my early projects, someone stored product prices as int field. So the price was $99.5 or 99.5 rupees. So the total became 99, ignoring the 50, right? Or the decimal value. Now, what happened because of it? We lost precision and the entire billing report was off by lakhs. Lessons learned: use the right data type. Now, the right data type was numeric type or a decimal one. So, this is the superstar for financial data. P is equals to precision, total of digits, and S is equals to scale, which is digits after decimal. Now, for a simple example, consider this one. Decimal 10, 2, up to 10 digits and 2 digits after decimal. The maximum value is 99 millions dot 99 decimal values, or one decimal value less than 100 million. Now, real world use case: salaries, prices, taxes, rates, weight, percentages, etc. Next comes the float or double data type. It is used when you need very large or very small numbers, but some precision may be lost. Think scientific data sensors, machine learning scores. But don't use float for money unless you want rounding problems or angry accountants calling you. Now the next data type is character data types. We have char function n for fixed length string. Always use the full allocated space. Let's consider country codes where you have some country codes for that. For India, you have IN for US, you have US, and you can also have gender, which we have M and F. For example, country code, character data type, 2 values. And the second one is varchar, and it is one of the most commonly used ones. It stores variable length data, and some of the use cases to consider as names, emails, city names, product descriptions, etc. A small story again. Once I saw a table with varchar and the limit was 5,000 for storing the first names. First names alone. Imagine allocating 5,000 characters for storing just a 3-letter word like Max or Raj. Now, what are the lessons learned here? Proper sizing matters for performance. If you store 5,000 characters for just 3 letters, your space is wasted. And this might affect your performance. Now, the next data type is text. Text is used for large bodies of text. Blogs, descriptions, comments are a few examples. But avoid text whenever a reasonable worker works in place of text. It cannot be indexed efficiently. That's the problem. Now the next one is date and time data types. SQL is amazing at working with time-based data, but only when the data is stored correctly. For example, dates are stored only in year, month, and date types. You can see on my screen we have YY, YY, MM, and DD as the format. This type of formatting is perfect for birth dates, join dates, attendance logs, and a lot more. Next is time, and time stores only time. And after that, we have date along with time function. This can be represented as date time together or also known as time stamp. This stores date along with the time. Now some of the use cases: timestamps, log entries, attendance tracking, transactions. A mistake I've seen too often is people store date time as varchar, right? A data type change completely. And then sorting goes like 2024 1 or 2023 12 1, 2024 110. Completely messed up, right? Now, this can be solved. You just have to change the data type, and also we'll go through some examples in the real-time use case where these type of issues are addressed. Moving ahead, we have the Boolean data types. So the name stands for itself. It is either true or false. Some of the examples is active, is verified, is published. Never store Booleans as workout. You might be wondering, why cannot we use workout? It is just simple yes or no. Reason: if you use worker, it wastes space and breaks the filtering logic. That's the main problem. Proceeding ahead, we have the next data type, which is binary, and miscellaneous data types, which is blob. This particular data type is used for storing images, PDFs, videos, JSON files, and they store semi-structured data. Modern SQL feature: JSON is a lifesaver when you need flexibility without completely switching to NoSQL. Now let's go to the next section where it will help us to learn the arithmetic operators and other functionalities. Operators help us calculate, compare, and manipulate data. Let's start with the easy ones. The first one is arithmetic operators. Just like math operator meaning example, addition salary plus bonus, subtraction price, discount, multiplication, quantify, and division, modulus, etc. Now let's go through a simple example query. So you can see it on my screen. Select product name, sales, quantity into rate as new sales from Excel data. Now the real-time analogy. Operators like these are calculator inside SQL. Instead of exporting data into SQL, SQL helps you compute right inside the database. Now let's also go through a real-world scenario. Imagine a store wants to compute total revenue, discounts, tax calculations, profits instead of running separate scripts. A single SQL query can handle all of these arithmetic operations. Now, let's dive into section 3, logical operators. Logical operators help SQL make decisions like, should this row be included? Does it match with condition? Is it true or false? Followed by that, we have AND operator. All conditions must be true. For example, where salary is greater than 50,000 and department is engineering. You can see that query right on my screen. Followed by AND, we have OR operator. Any of one condition should be true, where city is equals to Mumbai or city is equals to Delhi. So this selects all the entries from the cities of Mumbai and Delhi. You can see a sample query on my screen. Followed by that, we have NOT operator. This exactly reverses the condition, where not country is equals to India, and this particular query is on my screen. So you can see any other data apart from India. Logical operators like filters on YouTube, language is equals to English, duration less than 10 minutes, category is equals to technology. SQL just filters rows instead of videos. Now we land into section 4. So this particular one is based on between, in, and like operators. Sometimes we have another one as well, which is called I like, which is the opposite of like. These are the operators you will use every single day. Now another one is between operator. So this is used for ranges. For example, columns between value 1 and 2. For example, you can see it on my screen. Select everything from Excel data where row ID is between 10 to 20 or 10 and 20. Now, what this query does is it will eliminate any rows before 10 and it will eliminate any rows after 20. Only the rows between 10 and 20 are executed and shown to you. Now, a friendly tip. Between is inclusive. It includes both the boundaries, which means 10 and 20 are included. They are not excluded. Now let's dive into the next one, which is in operator. Instead of writing many or conditions, you can just write one in condition and write the set of cities. For example, you might want 3 or 4 cities. So what you can do is, where city is in and the function, inside that function, you can write the city names. For example, Mumbai, Delhi, Hyderabad, Bangalore, and many more, right? Whenever a city name matches with the elements present inside the in function, that particular row entity will be selected and displayed for you, or filtered and displayed for you. Now, followed by that, we have like operator and pattern matching. So you'll have a modulus sign or wildcard, which represents any number of characters. And the example is right on my screen, where name is equals to or name like modulus a, and ends with a where name like modulus sign an modulus sign. So contains an as a wildcard. So any name which has an included in it, and it might have anything in front of it, it might have anything in the right hand side of it or the end of it. So whichever text has an inside it, all those text values will be extracted and displayed for you. Now in the section 5, we will have a small practical story or a real world analogy. To make this chapter sticky to your memory, let's run through a few stories. The first one, date disaster. An HR system stored join date as varchar. So sorting by join date gave Jan 10, Jan 2, Jan 25, Jan 5. Why? String sorting treats 10 as smaller than 2. Solution, convert varchar to date to fix everything instantly. Moral, always pick the right data type. Let's also go through story number 2. The like operator that saved a scale, an e-commerce company needed to find all products with Pro in their name. iPhone Pro, MacBook Pro, GoPro. One more simple query where product name like modulus sign Pro modulus sign. It can have anything before Pro, it can have anything right hand side of or the end of the Pro. So basically any text which has Pro included in it will be displayed. So what's the result? Marketing team recovered thousands of lost sales because these products were mistagged. Now comes the section 6 where we will have some demos. Here are some fully explained queries for learning purposes. So we will be diving into MySQL Workbench and start executing commands. So now we are on MySQL Workbench for running all the examples that we discussed previously. So my data is in sample database. So we will be using the use database keyword. Let me expand the screen. And the name of the database is sample. So we are in a sample database right now. And we have to show the tables that we have. Again, the keyword. You can see that MySQL Workbench is showing us some recommendations, but we don't want any recommendations. We should go with what we have. Now, apart from that, we want to see what's inside this particular table. So, yeah, Superstore. So we were supposed to go into Superstore, not a problem. So this is our database name and show tables. We have checkpoint data, we have complex post view, and this is the Excel data we need to work with. So now let's type a command, select star or everything from Excel data so that we have an information on all the rows and columns that we have to deal with in this particular execution. So we have row ID, order ID, date, shipment date, customer ID, and everything that we need to know. So now we will execute some sample queries to understand the functionality. So let me write down the demos that we want to execute. So the first demo is about finding employees earning between 50,000 to 100,000. Right, this is the first query. Let's leave a little space and also write down demo 2. And what's about the demo 2? We need to search city names. So these are the examples that we discussed before on the go, right? So containing PUR. So it can be Nagpur or any city which has the letter PUR in it. So it took an auto recommendation, or instead of PUR, you can also have anything like DEL, right? So now let's go with the third demo, which is show products with price calculation. And demo 4 will be about list users from specific cities. Demo 5 will be about employees not in HR department. Or we can also make some changes to this based on the dataset that we are working with. So we can go ahead with the segment here. We have a segment in, we have which are not in segments of consumer or anything apart from consumer and home office. In specific segment, let's go with the consumer. And lastly, demo 6, which is about items with exactly matching some words, like let's say OUR, or let's say instead of exactly matching, we can consider this as text matching. So we have a template or a skeleton of what demos are we trying to execute here. Now let's start with queries. Now I want to find out any employee or any of the products. So we have number of pricing, right? So we should go with sales here. So let's identify sales which are more than 3,500. So between 3,500 to 4,000, or sales. Find sales between. So this is a requirement. So what we will write is a simple select statement. We will select everything or select a specific product name. So we will go with the product name. So what I'll do is I'll simply copy this field name. I'll paste it over here, comma. I want sales column as well from Excel data. Where sales is between 35 and 4,000. Now we have the list of products that are having this range of sales. So we have about 5 or 6 entries which have the sales in between 3,500 INR or dollars to 4,000 INR or dollars. And now let's go into the demonstration 2, where we wanted to find out city names containing PUR. So if we go back to our Excel data set, we had a column which had the address, right? So we had cities like Leeds and a few other things, Paris, Parla, and all those things. So I want to find out any city name which has some given text. For example, if you go with Munich, so we have MUNICH, right? And we have Naples here. So APL or APL. So any state or any city which has Hamburg, etc., right? So any state which has AMB, I want to extract it, right? So let's write down a query for that. Select city from Excel data where city like, since we're using a keyword, let's have like, and since this is a text related data, we need to encode in between single quotes, and we want Hamburg, right? So AMB and anything after AMB, semicolon, enter. So now we have any city which has AMB included in it displayed here. We had Cambridge, we had Hamburg, and all those city names which has AMB included in the text. Now let's go with the demo 2. We wanted to show the price calculations. So we have, let's execute this one more time. So we already have sales data, right? So if we go back here, let me scroll it. So if we go back here, we have the rate of every single product and the number of quantity. So the rate for single unit was $24.4 or rupees, and multiplied by 3 times, you have 79.2 as the final price, right? And now I want to calculate that once again. Let's say we didn't have that sales tag or sales column. If we wanted to calculate it, how would you do that? That's the problem, right? So we can do this by the following application of the formula. So what you can do is write down, select. What we want is product name. So I'll just copy paste this particular field name here instead to avoid any kind of errors. Comma. We also have sales, right? So let's keep sales, comma. We have quantity star. Let me copy that. Quantity into price. We have rate here, so we'll copy this rate name, paste it here, and we'll alias this as new sales from Excel data, semicolon, enter. So now we have all the product names and the sales and new sales. Remember the one which we discussed, decimal points? So we did not, kind of constraint to, minimize the number of decimal points. So it gave the full potential of decimal points here. So we could, include a new column with mathematical or arithmetic calculations to go ahead with. Now the next demonstration was about including all the details about a specific segment. So list users or list products. So what we can do is, again, a simple select statement, star from Excel data, where segment in. So we want the following. So we have segment as corporate, we have consumer, right? So I want, let's say, corporate and consumer, comma, consumer. So since these are text-based data, so we need to include single quotes as well. And a semicolon to close the data. And there you go. So we have also, you can choose to include only a specific segment, but overall we have filtered the data to include only corporate and consumer related data set. Now if we go into fifth, so data of the not in segment, so all you need to do is a simple change. So you can copy this and paste it over here as it is, and simply replace in with not in, and there you go. Now you'll get all the data which is not from the section of corporate and consumer. Run that, yeah, there you go. Okay, there was a small error mistake, corporate, and we could also include corporate, separate by comma. There you go. Now let's execute this command. And now we only have a home and office depot related data segment. So that's how you can filter. And the last one is nothing but text matching. So where we wanted to find out the products which have this particular, naming convention. So it's similar to this one which we executed before. Select city names which have this following text matching. So instead of AMG, you can go ahead with any of the other city names like MIL or ILA. So you'll have any of the cities which have ILA in that. This is the list of the cities. And now with that, let's close this particular section with pro tips and best practices. So let's wrap it up with some practical wisdom. First, never store dates as vocab. This is the number one beginner's mistake. Use decimal for money, not float. Float introduces rounding errors. Third one, keep vocab length realistic. Avoid vocab 5000 unless necessary. Next one is use in for clearer queries instead of many ors. Fifth one is like with leading wildcard, and it is slow. Avoid it in large tables. Sixth one is Boolean fields, make filtering faster and cleaner. Seventh one is use int for IDs fields, not vocab. Eighth one is understand indexes before using like frequently. And the final summary. In this chapter, you learned why data types matter more than most people think, how numeric, character, datetime, Boolean, and advanced types work, how arithmetic and logical operators really behave, how between in like help simplify filtering, real stories that highlight how crucial good data modeling is. Now let's also go through some professional best practices you can use immediately. With this foundation, you are now ready to write cleaner queries, avoid common mistakes, and handle real-world SQL tasks confidently. In the next chapter, we will start leveling up with constraints and advanced filtering logic, which is where SQL begins to feel powerful. Stay tuned and keep practicing. Module 4, Safe Deletion Practices and Best Practices for Data Entry in SQL. Before we talk about writing advanced queries, joins, or analytics dashboards, there's one uncomfortable truth every SQL professional must understand. The most dangerous SQL queries are not the complex ones. They're the simple queries executed without thinking. And among all SQL commands, there's one command that has probably caused more panic, data loss, and late night emergency calls than any other. And that command is delete. In this chapter, we are going to slow down and talk about something that separates beginner from a professional. It basically depends on how you delete data safely, responsibly, and confidently, and how you insert and maintain clean, reliable data from day one. Because in real world, SQL is not about writing queries that work. It's about writing queries that don't break business. So the part one, why delete statements are the most dangerous ones. So let's start with a very honest question. Why is delete such a scary command? The answer, delete is permanent. Delete does not ask for confirmation. Delete executes immediately. Delete can affect millions of rows within mere seconds. There is no undo button in SQL for delete option. Once data is deleted, reports break, dashboards go blank, finance numbers change, trust is lost. And most importantly, you are accountable. That's why companies don't fear complex joins. They fear one command, that is careless delete statements. Now, with that, we enter into part 2, the most common delete mistakes that a beginner makes. So, let me share you the most common and most dangerous mistakes beginners often make. Let's look at a sample on my screen. For your information, we are not manipulating this database as of now, because we will be using these tables for our next module, and if we run these commands and delete or truncate the data, then we might lose it and we might have to recreate again. So let's not do that. Let's have a sample query on my screen, and that should be good enough for you to understand what's the flow. So here's the query. Delete from employees. We are deleting from the employees table. That's it. No where clause, no filter, no condition. This query means delete every single record from the employees table. In a production system, this could mean all employees' records are gone. payroll reports destroyed, compliance violations, audit failures, and here's the scary part. SQL will happily execute this query. It won't warn you, it won't ask you, it will just do it. This is why experienced SQL professionals treat delete like handling a loaded weapon. And with that, we transition to the part 3, safe deletion principles. So the first one, always preview before delete. The golden rule of safe deletion is simple. If you cannot select it safely, you should never delete it. Before deleting anything, always run a select query using the exact same where condition. Step number 1, preview the data. Let's take a look at the simple query on my screen. Select star from table, that is employees table, where department is null. This should show you employees without a department. Now ask yourself, does this data look correct? Are these the records I truly want to remove? Is this count reasonable? Only when you're 100% confident, move to the delete option and delete those records. Now comes the step number 2, convert select into delete. Let's look at the sample query right on my screen. Delete from employees where department ID is equals to null or is null. Same condition, same logic, no surprises. This single habit can prevent 90% of data deletion disasters. Now with that, we transition to part number 4, safe deletion principle number 2. Use transactions. This is professional level practice. In professional environments, delete is rarely executed alone. It is wrapped inside a transaction process. A transaction allows you to preview changes, validate row count, roll back if something looks wrong. For an example, safe deletion using transaction. Let's take a look at this sample code on my screen. Start transaction, semicolon, delete from orders where order date is less than 2025, 1st of January. Now, select row count method and then roll back. What's happening here? SQL prepares the deletion. You check how many number of rows would be affected. If the number looks wrong, you can directly cancel it. When you're confident, then you can commit. This is how real companies delete data. If you mention transactions during your interviews, it instantly signals production level experience. With that, we make a transition to part number 5 of this module. Safe deletion principle number 3. Delete with primary keys when possible. So what do you mean by primary key based deletion? Never delete data using weak conditions if a primary key is already available. So what could be the dangerous part? Let's look at a sample code on my screen. The code will be delete from users where email is equals to alice@example.com, right? Now, how would this be dangerous? Let's say you have orders data and Alice is your company's employee. Alice might have made thousands of sales and she might have entered the same email ID, which is alice@example.com. When you run this query, those thousands of orders records will be vanished in a mere second. Let's say you wanted to just delete the order for a specific number, let's say order 123, and instead of order 123, thousands of all other records based on alice@example.com will be deleted. So now let's understand why this is risky. So in technical terms or SQL terms, email may not be unique. Remember the unique keys that we discussed? You might delete multiple records unintentionally. Now what's the safe process to escape this? Let's look at the sample code on my screen. Delete from users where user ID is equals to 4, right? Or order ID is equals to 4. Now this will be the safest step. It will only eliminate the records of that particular primary key. Now let's go with primary key. Primary keys are unique, they are predictable, they reduce accidental data loss. Professionals think in keys, not names. Now with that, let's make a transition to part number 6 of this module. Safe deletion principle 4. Soft delete. This is again an industry standard. In many real systems, data is never permanently deleted. Instead, companies use something called soft delete. So what is soft delete? Instead of removing the record, you mark it as inactive, you preserve history, you avoid compliance issues. Example, add a status column. Let's look at the sample on my screen. Alter table users, add column, is underscore deleted, Boolean default false. So what's happening here? You're trying to make some changes to the table users, and you're trying to add a new column, which is termed as is deleted. And you're adding a new Boolean value, which is by default false. So in case if you're trying to delete something, then you will refer to this particular default false value, and anything if you want to hide or delete or filter, you can just use that command and filter out those rows. That's what is happening here, and that's called the soft delete option. Now the soft delete query. Let's look at the sample on my screen. Update users, set is deleted is equals to true, where user ID is equals to 4. Now the next one, fetch only active records. So for that, let's look at a sample on my screen. Select star from users where is deleted is equals to false. Now, why companies love soft delete? It is audit friendly, reversible, safer, analytics friendly. If you say soft delete strategy in interviews, it shows maturity. Now let's make a transition to part number 7, delete versus truncate. It's an important distinction. Many beginners confuse delete and truncate. So let's discuss this once. Let's start with delete. Delete can use where. It can be rolled back when used with transactions. It triggers logs. It's slower but safer. While truncate, on the other hand, deletes everything. It cannot use where clause. It cannot be rolled back. It's extremely fast and extremely dangerous. So let's have this rule of thumb. If you don't fully understand truncate, don't use it. With that, let's make a transition to part number 8 of this module, which is about best practices for data entry. It's the foundation of trusted analytics. Now, let's shift gears. Safe deletion protects your data. Good data entry prevents problems before they even exist. Bad data is more dangerous than missing data. So, the best practices. Number 1. Always define data types correctly. Every column should reflect real-world meaning. Let's go for an example for bad design. Salary, worker, 50. So you know this is a character data type and it doesn't make any sense. The correct way, salary is integer or salary float. Why this matters? Sorting works correctly, aggregations are accurate, performance improves, data validation becomes automatic. SQL data types are your first line of defense. Now, the second best practice, use constraints, not trust. Never trust users, applications, or APIs to send clean data. Use constraints. So the first one, primary key. Primary key is employee ID in our case. A foreign key, department ID, which can reference department ID from the other table. And for safe side, you can also keep another constraint which says not null. So whenever a null value is being trying to insert, it will not take it. It will definitely throw an error. Next one is name, worker 50, and it can also be not null. Unique value, which is email, worker 100, and it should be unique. And another few benefits of using constraints, it prevents duplicates, maintains relationships, stops bad data early. Good SQL developers design defensively. And with that, the next best practice, that is number 3, handle null values intentionally. Null is not bad. Unplanned null is bad. Ask these questions. Is null allowed? What does null mean in business terms? Should there be a default value? For example, department ID data type is int and null, meaning employee may not belong to any department. This is acceptable only if business allows it. Clarity beats assumptions. Now with that, the next best practice, number 4, insert only verified data. Before inserting data, validate the formats, check references, confirm business logic. Let's look at a sample on my screen. Insert into employees, employee ID, name, salary, department ID, hire date. Select 11, Kevin, 80,000, 2, 25, 12, 10. Where exists, select 1 from departments where department ID is equals to 2. This is a sample query on my screen. This ensures 2 things. Department exists and referential integrity remains intact. Now the best practice number 5, standardized data formats. Inconsistent data kills analytics. Bad HR, human resources are a good example for that. Now, good version of it. Single standardized value. Solution, use lookup tables, enforce values via foreign keys. Avoid free text whenever possible. Now, clean data is equals to reliable insights. Now, with that, we have best practice number 6, log changes for critical tables. In real systems, every insert, every update, every delete is logged. Why? Because audits, debugging, compliance, accountability. This is why data engineering and SQL governance matters. Now, you might be wondering why this chapter matters. Let's look at the summary. Let's close this with something important. Anyone can write SQL query. Anyone can join tables, but only responsible SQL professionals delete data safely, protect data integrity, design clean schemas, think long term. Companies don't trust databases to beginners. They trust them to people who respect data. If you master safe deletion and data entry best practices, you are no longer just learning SQL. You are learning how real systems survive. In the next module, we will move into joins and relationships using the same database to answer real business questions. Real-world data never lives in a single table. In real companies, employee names are in one table, department names are in another, orders are stored separately, revenue lives somewhere else. If you know how to query one table at a time, you don't know SQL. You know toy SQL. The moment SQL becomes powerful is when you learn joins. Because joins are how HR teams combine employees with different teams, finance teams combine orders with revenue, product teams combine users and behavior, analysts answer business questions, not just technical ones. This chapter is where SQL stops being syntax and starts becoming decision making. Why joins exist is your next question. Let's take a step back and understand why joins even exist. When databases are designed properly, data is normalized, redundancy is avoided, each table has a single responsibility. For example, employees table. Employees table only stores employee details. Department table stores only department names and other details related to department alone. We don't repeat department names inside employees. So, why is this done is your next question again. It is done for few reasons. One is data consistency, easier updates, better performance. But this creates a challenge. If data is split across tables, how do we see the full picture? Right? That's your question now. That's where joins come into the picture. A join tells SQL, combine rows from two or more tables based on a relationship. And that relationship is usually a primary key in one table, a foreign key from another. In our database, department.department ID is the primary key from department and department ID from employees is the foreign key for employees data table. This is not accidental. This is an intentional design. What's the business analogy behind it? It's very important for learners. Think of joins like VLOOKUPs on steroids. But unlike Excel, joins scale to millions of rows. Joins preserve data integrity. Joins power dashboards, reports, and even AI systems. If select is asking a question, join is asking a smarter question. Now, let's go to MySQL Workbench to execute some of the queries on joins to understand them even more. So now we have discussed the theory part of module 5. Now we will be proceeding into the demo part. Here we are going to slow down things a little bit because joins are not about memorizing syntax. They're about understanding how rows from different tables come together and work together. Most SQL learners struggle with joins because they imagine tables merging physically, data being copied. That's not what happens. A join is a logical operation, not a physical one. So in this session, we will visualize tables row by row. We will see which row survives, which rows disappear, and why that is happening. By the end of this module, inner join will feel more obvious. Left and right join will stop being so confusing and full outer join will finally make some sense. And you will understand joins well enough to explain them to someone else. That's a real goal. Now, let's start with first query, employees with department names. Let's have a look on the query on my screen. So you can see, let me minimize this output window. So you can see we are starting with the demos of module 5 from here. To get access to the data table inside this particular database, we will be executing use interview, which is the schema name. And now we are on the first type of demonstration here, first query. So what is the first type of join are we executing? So the first join we are executing will be an inner join. But before we understand what exactly or technicality of this particular join, let's understand the problem that we are solving. So we have an employees table, we have another table which is departments table, and we already know what are the columns. We have an employee table and department table. So now what is our end output for this particular query, or what's the business question? Employees store only department ID, not the department name. So the business question here is, show me employees along with their department names. This is a classic relational problem. So let's deal with this in a step-by-step way. Step 1, understanding the join condition. So the join condition here is specifically mentioned. Department ID from employee table with department ID from the department table. This line defines how rows are matched. It tells the database, take department ID from the employees, match it with the department ID of the departments table. Only rows where this condition is true will be joined. Remember, this condition is not filtering after the join. It is defining the join itself. That distinction is critical. Now, let's go into the step number 2. What inner join really means? Inner join means only keep the rows where the match exists on both sides. So, employee with a valid department is kept and employee with null department will be removed. So, remember the employee with no department in the employees table? So, that particular employee will not be considered here. Department with no employees will also be ignored. So we might be having certain departments in the department table with no employees. So that will also be ignored. Think of it as, give me only the confirmed relationships, not any vague relationships. Row by row visualization. Imagine looping through employees. Alice is equals to department ID is equals to number 2. And engineering exists is equals to keep. Bob from department ID 2, which is engineering, exists, so keep it. Charlie from department ID number 1 is from HR, and it exists, so keep it. And lastly, Frank, the department ID is equals to null and no matches found, so that will be deleted. Frank completely disappears from the end result. That's how inner join behaves. Now let's select the entire query and execute. So as we discussed, there are 2 different ways to execute. So let's go with the shortcut Control Enter to execute the command, or you can also go with this flash logo here. So you can have the output table right here. So the department or employee ID, employee name, his salary, and department name. Second one is Ivan from employee ID 9, salary and department name, which is HR, and so on. We have about a couple of entries here. So overall, where the department is not null and employee is not null, those particular specific columns have a relationship established successfully, and those will be combined or joined together, and we have an end output here. We can also name this as, instead of specific name, ID, salary, department, you can also keep star, where all the columns of both tables will be displayed all together. Let's try that for a homework. Now, from an interviewer's perspective, interview insight, if someone asks you, why is Frank's missing? Your answer should be, because we applied inner join. Inner join only returns rows where the join condition succeeds on both the tables. That shows clarity. Now let's move to the next query. So let me scroll down my query. And here we will be implementing left join. All employees without departments. So let's have a look at the query on my screen. So this is the one which we will be executing for left join. Key mindset that you should be having in your mind is, what exactly is left join? The left join means the left table is mandatory. The right table is optional. Whatever happens, every row from the employees must appear, even if there is no matching from the department table, which happens to be the second table. What changes did you find here compared to inner join? It is only one thing. Rows without a match are not removed here. Instead, missing columns become null. Let's have a visual walkthrough. Let's focus back on Frank again, where Frank did not have any department ID. It was basically null. So no department match. But left join always says keep him anyway. That's the main core difference between the left join and inner join. So now let's see the result. So before executing the query, let's find out how it may look like. So employee ID is equals to Frank's ID, name is equals to Frank, and salary is Frank's salary, and department will be null. It is intentional, null. It's not a bad data. Now, let's execute the query and see the output. So let me select the entire query and hit enter, and there you go. So we have Alice, Bob, Charlie, David, Eve, and here you can see we already have employee ID 6, Frank, Frank's salary, and Frank's department name is null, right? So even if the matches are not accurate, right, in terms of accuracy, even if there is no actual match between both the tables, but whatever the data we have in the left table, which is employees table, everything will be present. That's the major difference between inner join and left join. Now, even if this kind of data is existing, why companies or why professionals prefer left join is your question. Left join is used often when you want to complete coverage, when you want to detect missing relationships, you want to preserve the main data set. When you have these kind of intentions in your mind while executing query, then left join is the most preferable one. So what are the kind of examples you must be thinking when you are dealing with left joins? So all users, if they are never ordered, all products, even if they are not sold, all employees, if they are not even assigned to a dedicated group like Frank here, right? So these are the scenarios where you are forced to use left join. Now a quick interview tip, a powerful phrase. Left join preserves the left table cardinality. That's senior level language. Now let's go into the next query. So the next query will be based on right join. So let me highlight my query first. And now let's understand the technicality. So this particular query is based on all departments, even if no employees. Let's take a look at the query on my screen. So conceptual identity to the left join. Right join is just the left join from an opposite direction. Previously, we focused solely on the left table. Now we will solely focus on the right table. Now departments are very mandatory. Employees are optional. In the previous one, employees were mandatory and departments were optional. Now this is the opposite side. What row survives will be your question. Departments with employees and matched rows will appear, and also departments with no employees will also appear. But anyways, employees without departments is a little bit irrelevant here, but for the concern of understanding, let's keep it that way. Now let's execute the query to understand the output. Now there you go, we have all the departments and their employees together. We have HR and the name of employee is Charlie. We have Ivan from HR, and we have Alice, Bob, and David from engineering, Heidi, Eve from finance, Grace from marketing, and Judy from marketing. Now, let's understand one more thing. Why right join is rarely used. Most developers prefer left join, reorder table instead of using right join. So, this query could be written as from departments D, left join, employees E, right? This is also a perfect logic. Same logic actually, more readable. Now, for that, let's have a small teaching insight. Right join is important to understand, but not commonly used in production code. Now, let's dive into the fourth query, which is about a simulated full outer join. So, why simulated, you ask? Because there is nothing called full outer join, but we can still have a simulation of it by including the union in our code. So, you can see I have highlighted the code and we have a union command here where we will combine both the tables together. So now, why are we doing this? Some databases do not support full outer join, or learners want to understand how it works internally. So for that, we have a query highlighted right on my screen. We'll simulate it. But before that, what full outer join means conceptually? Give me everything, right? This particular data extractions include matched rows, left only rows, and right only rows. Basically, what we are trying to do is we are combining inner join, left join, and right join, basically extracting whatever is present inside both the tables. Nothing is lost. And now you might be having a question. Why did we use union here? Left join keeps all the employees from left. Right join keeps all the employees from right. Basically, employees and departments. And what is the purpose of union is union combines both and removes any duplicates present in both the tables. So what's the result? Full coverage from both sides. Now, let's execute this query and see the output. So there you go. We have all the names of the employees and their specific departments, similar to the previous query. So we have Frank without department name and all the other employees with their dedicated department names right here. Now, what's the important learning moment? This query teaches join logic, set operations, result set thinking. This is advanced understanding, not beginner syntax. Now let's move with a few example queries. So first one, I want to identify orders with user email, and we could go with an inner join here. So let me select the entire query. Now let's understand the flow of this particular query. So take a look on my query at my screen. Business story orders store and we have customer ID, not customer email. User store, and we have email, not every other details on that, right? Now we want to join to enrich the order data. Why inner join? Because inner join makes sense here. An order must belong to a user. So orders without users is invalid. Inner join enforces data integrity logically. So before we move further, let's execute this command and see the output. So we have order ID, email ID, and order date as per our requirement. Now, what's the real world relevance? This is how dashboards, invoices, analytics queries are built. Almost every real system uses this pattern. Now, let's go with the next query where we will try to find out revenue per order date. And we will be using an aggregate function here. So let's take a look at the query on my screen. So shift in thinking. We are no longer looking at rows. We are looking at groups of data. Group by in my query changes everything. How group by works conceptually and everything else. Now, let's look at the database steps. First, we will scan all the rows. Then group by order table, plus we will also be applying an aggregate function for the group. And then we will return one row per group. So let's quickly execute this query and see the output. There you go. We have order date, total number of transactions, and total revenue all in one shot here. So why count and sum work here? Because count of number of rows per date, and sum adds revenue per date. This is basically time series analysis, and it is extremely common. Now a quick interview insight for you. Group by reduces number of rows. Join expands number of rows. Remember that contrast. Now we have query number 7, which is about employees with highest salaries. And here we will be using two things. First is a join function, and next is a filter function. Now let's take a look on the query. So here we have employees with highest salaries, and this is my query. So what we are basically trying to do is we are combining both the tables, which is employee table and departments table, and our concern is to find out any employee whose salary is more than 90,000. So that's the overall observation on this particular question or business question. So what's the execution order? Coming to execution order, one of the most important and commonly asked question in SQL interviews is the execution order of the commands. So far, we have seen through all the basic fundamentals of SQL commands, right? The keywords basically select, join, and all those things. So let's consider this as a homework. Let us know in the comment section below what is the execution order of all these keywords in SQL. Now, for a quick clue, let's see the flow of execution for this particular query. So what happens is, first, join is the one which activates. It joins both the tables. Then, where comes into the picture? It filters the rows. And then comes selects, which formats the output. And this order matters. Let's quickly execute this query and see the output. So there you go. We have Bob, David, Eve, and Heidi, who have salaries greater than 90,000, and their dedicated departments are engineering, finance. So these three employees are from engineering department, and we already discussed this, right? Engineering department is the one which is paying highest number of salaries. So we have 3 from engineering itself, and the next one is finance. Now, why where is executing after join? This is your question, right? We are filtering employees, not departments. If we filtered earlier, we might lose the relationship context. Now, let's have a quick practical takeaway. Join defines relationships, where it defines conditions. Never confuse with both of these. Now we have the query number 8, where we will find out departments with no employees at all. Now, let's take a quick look on the query on my screen. So this is my query. I want to select the department name from departments B, and I want to apply left join, and I'm joining this with employees on the category of department ID, and where employee ID is null. This is a classic interview query, and it tests deep join understanding. What's happening is, in a step-by-step way, left join keeps all the entries from the departments table, where employee ID is equals to null. And it keeps only rows where no employee is matched. So the result, let's execute this to find the result. So there you go. Departments with 0 employees. Why inner join can't solve this? Inner join removes non-matching entries. Left join plus null, check, reveals them. This is powerful logic. Now we move into the 9th query, customers with multiple orders. So let's take a quick look on the query. Now this is a multi-layer query, and it combines a lot of things. For example, join, group by, and having. This is real world SQL. Why having is used instead of where could be one question in your mind, because where filters rows and having filters groups. This you need to understand. This is one golden rule which you always need to keep in your mind. Now let's discuss the execution logic. Join users and orders. Join is used to combine users and orders. Group by to group or categorize email. Count is used to count the number of orders per user. And lastly, having keeps only the users with order numbers greater than 2. Now, let's execute this query. So we have the output here. We have Alice and Bob with total orders 4 each. That's the output. Now, what's the business meaning? This query finds out the loyal customers, high engagement users, retention targets. Exactly what analytics teams do on a daily basis. Now, this is a final wrap up for joins. If you understand this module deeply, joins are no longer scary. Nulls make sense. Aggregations feel logical. Interview questions become more predictable. You didn't just learn the syntax, you learned how databases combine data, how SQL thinks, how real systems are queried. That's professional level SQL. And with that, we make a transition to the next module. Now, repeat. Now we have reached to the module number 6, which is about grouping and aggregating data in SQL. So here we will be dealing with group by, having, aggregation functions, and filtering group results. Now, let's have a quick introduction to this. Why this chapter or this module matters the most. Up until now, everything we have done in SQL has focused on individual rows. We used to select rows, filter rows, sorted rows, and we used to join some rows. But here's the reality of how SQL is used in the real world. Businesses almost never ask that, show me every row in the table. Instead, they ask, how many employees do we have per department? What is the average salary? Which days generate the highest revenue? Who are most active customers or the most loyal customers? These are summary questions. And the moment SQL moves from showing rows to answering summary questions, you made a huge transition. We enter the world of group by and aggregation. So far, you had a basic introduction to these functions. This chapter is where SQL stops being data relevant and starts becoming data analysis. If joins helped us connect data, group by helps us understand patterns inside the data. Now let's go with the part 1. What group by actually does. Let's build the intuition first. SQL looks at each row independently, but when you use group by, SQL changes how it thinks. Instead of processing row by row, SQL tries to process in a different way. It tries to group rows that share the same value, applies calculations to each group, returns one row per group. So you are no longer working at row level. You're working at a group level. Think of group by as a machine that takes many rows, bundles them into logical buckets, and produces summarized information. This is the foundation of reports, dashboards, KPIs, analytics, and business intelligence. Now let's go to the part 2. First, group by, simple and clear. This could be our first query here. Now let's go through the sample query on my screen. So here we have a department ID and we're trying to count the number of employees per department, and we will be aliasing it as total employees. And we are selecting this data from employees and we are trying to group it by department ID. Now, what we want to know is the question. So it is basic and simple. We want to know how many employees are there per each department. Instead of listing employees one by one, we try to group them, and once we group them, we will try to count them and then execute the query. So let's execute this query and see the output. So basically we have 5 departments here. One department is not assigned, so that particular one is based on Frank that we earlier executed. So let's take a pause and understand what SQL is doing here. It is scanning the employees table, grouping rows by department ID, counts the total number of employees inside each group. Every department becomes one row in the result. Now, one important observation that you need to have here is employees with null department form a separate group altogether. This is real world behavior. Missing data doesn't disappear. Now let's make a transition to part 3, where we try to group by with join, making output business friendly. IDs are useful for databases, but people don't think in IDs. They think in names. So Let's improve this query by using a join function. So let's quickly go to Workbench and see the code on my screen. So previously we had no names to the department, right? Now to make it more sensible, we are trying to combine employees table with the departments table, because departments table has the name of the department, right? The null 1, 2, 3, 4 doesn't make sense. So it could make a lot sense when we had an actual department name. So for this, let's execute this particular query, and you already know how the left join works and on what basis did this particular employee table establish a join with employees table, right? So here we have department ID from employees table, and here we have department ID from departments table. Based on the match and the type of join that we are using is left join, what it does is it keeps all the entries from the left table, which is the department or employees table, and the matching elements from the right table, which is the departments table, right? So employees is the left and departments is the right. Now we will be grouping by department name. So let's execute this query, and there you go. We have HR, engineering, finance, and the null department, and the total number of employees working in each department. Now we join employees with departments. We grouped by department name. We made the output more readable for leadership. This is how SQL is used in HR reports, management dashboards, workforce planning, and a lot more. Now, one very important learning from this part is joins usually happen before group by. Now let's make a transition to part 4, which is slightly tricky group by, and we will be using multiple columns here. Now let's raise the difficulty slightly. Suppose the business asks you this: how many employees were hired per department per day? This means we group on more than one column. So let's execute the code right on my screen. So if I scroll down, here we have another slightly tricky query. So here we are trying to select the department ID, hire date, and we are counting the number of employees based on the column employee ID, and we are aliasing it as hire count, and we are extracting this data from employees table, and here we are grouping by multiple elements. One is department ID and another is hire date. You might be wondering, will this work? Group by was designed to take multiple entries here, so this totally works. Now let's execute this query and see the output. So we have a department ID and hire date. So based on these dates, we have the total number of recruits that we had on that particular date. Now what's happening here? SQL creates groups using both columns together. Each unique combination becomes one group. This increases the number of results per row. The key rule to emphasize clearly is any column in select that is not aggregated must appear in group by. This rule appears frequently in interviews. Now let's move to the next part of this module, which is about aggregation functions. So it's a quick deep dive. Now that group by makes sense, let's talk about aggregation functions. These are functions that operate on groups, not individual rows. Now we have a few of them. So let's get started with count function. It is basically used for measuring volume. Let's start with count. You can see a sample query on my screen. So let's go to the workbench once. So here what are we trying to do is we are trying to count the total number of employees from the employees table, right? And we will be aliasing it as the total employees. What this basically does is it counts all the rows. Now with grouping, back to my screen. So let's execute this, and we have about total employees. Now about grouping, we have the query right on my screen here. So what we're basically trying to do is we are basically trying to group the total number of employees per each department. So we are adding the department ID and counting the number of employees in there. So let's execute this query. There you go. So count of column ignores all the nulls. Count of star counts total number of rows regardless of how many entries we have. Count answers questions like how many, how frequent, how active. Now with that, we have the next aggregate function, which is a sum function measuring total value. Sum is used for totals. Let's see a code. So here we have select sum of salary as total salary from employees table. Let's execute this, and we have about 8,70,000. Now let's make it a little more meaningful. Explain the business context, budget allocation, cost control, department-wise spending, right? These will be the business level questions. If you categorize by departments, then you will have a clear answer on the budget allocated for each department. Next aggregate function is based on average, typically measuring some value such as average salary per department. So let's execute the code. So we also have another query on sum. So let's execute this as well. So once executed, you will have, this is the amount of salary or budget allocated to each department. Now let's go with the average function again as discussed. So here we want to find out the average salary allocated per employee in each department, which is similar to the previous query. So let's execute this and we will have the answer. So the average salary allocated for each department is, for HR we have 60,000, for engineering we have 1,08,750, for finance we have 95,000, and for marketing 80,000. So this is the average salary which we have allocated for each and every department. Now the next aggregate functions are minimum and maximum, and it is finding the extremes. So let's go for an example, and the business use cases are salary bands, compensation gaps, identifying anomalies, and a lot more. So here we have the department name. So minimum salary as lowest salary per department, maximum salary is the highest salary per department, and we're extracting this from employees table. And since we need the department name, we are joining this with departments table D, and based on the column department ID, and we are grouping by department name. So let's quickly execute this query, and there we have the lowest and highest salaries of each department: HR, engineering, finance, and marketing. So the lowest salary in HR is 50, highest is 70, engineering is 90, and 12 or 1,20,000, and 95,000 for finance, and 95 is the highest as well. Marketing we have 75 as the low and 85 as the highest. Now let's make a transition to the part 6 of this module, aggregations with dates, transaction data. Now let's switch tables and think like analysts, like orders per day. Now let's go through the query here. So this is one query that highlights the number of orders per day. Let's execute this. So we have about so many orders, and a few dates are where we had multiple orders, and we also have few dates where we have about a single order per day. And let's go through the next query that we had, which is revenue per day. So this particular query is based on revenue per day. Let's execute this, and we have 25,12,6 as the highest revenue which we earned, which is December 6th, 2025. So this is how daily KPIs are built. These queries sit behind dashboards. Time-based aggregation is extremely common. Now with that, let's make a transition to part 7 of this module, which is about having clause, filtering groups, and it is really critical. Now we address one of the most misunderstood concepts of SQL, where filters rows, having filters groups. You cannot use aggregation functions inside where. I guess this is the second time I'm repeating this because this is really important, and most of the times we confuse with this. This is why having exists, and basic having examples are the following: departments with more than 2 employees. And for executing this command, let's take a quick look on the screen. So here we have the query. Select department ID, count the total number of employees as department's employee count from employees table, and group by department ID, having count of employees greater than 2. So let's execute this, and we have that one particular department where we have about 4 employees. I think it is engineering department. Now let's also discuss the execution order once again, so that you have a quick understanding of how the execution order really works in SQL, and it could be helpful for your homework that we had in our previous model. Group by runs first, aggregation happens next, having filters the result, and having with join. And for this, let's go with an example. Right here we will be combining both having with join. So here we are trying to have this particular business question: which departments are highest paying? So here we have a department name, average salary, and employee, and we are trying to find out the employees with paycheck more than the average paycheck of every employee. So engineering and finance are those two teams which are paying more than the average salary. So we have our final answer. So those two departments which are having the highest salary, right? Tricky, having multiple conditions. So is our next repeat. Now moving next is another tricky question, and this particular one is based on having multiple conditions. So let's go back to the MySQL workbench and have a look at the query. So multiple conditions is right here: having count more than 2, and the average salary should be more than 80,000, right? So let's execute this query. The only difference is we are trying to have the average salary should be more than 80. So engineering team is the one which has employee count as 4, and average salary is 1,08,750. So having can use multiple aggregations. This is advanced interview level question from SQL, so you can make a note of it. Now moving further, we have part 8 of this module, filtering grouped results, where we have where along with having together. This is where learners truly level up. Now, let's have a small business requirement. Show average salaries per department for employees hired after November 2025, but only include departments where the average salary is above 85,000. So let's take a quick look on the code. So this is the code that we will be executing. So we have put the hire date, which is November 1st, 2025. We're trying to group by department, and the same query condition, which is salary should be more than 85,000. So let's quickly execute this query. So we have two departments in that way, engineering and finance, where we recruited employees after November 2025, and the salary is above 85,000. Now let's look at the execution order. From executes first, then join, followed by that we have where, then group by will be executed, followed by that we have having clause, then we will select, and lastly we will order by. This is core analytical SQL thinking. Now let's move to the part 9 of this module, which is a capstone query, and this could be real dashboard logic. Let's end this with a realistic analysis query. Back to the workbench. So here we have the query. So here what we are trying to do is we are trying to group by order date, and we should be having some amount greater than 800, and total revenue should be in descending order. We are trying to find out those particular columns, which is order date, count total sales, sum of total revenue, and average order. So let's execute this query, and we have the output over here. Now let's understand this. Multiple aggregations are done together. Filtering is done using having clause. We have sorted the results, and this query could power a business dashboard. Now let's also discuss some of the common mistakes that learners should be warned about. Now let's discuss some of the common mistakes that learners make and we should be alert about. So the first one is about forgetting group by columns using where instead of having, mixing row level and group level logic, ignoring null behavior, aggregating without the business context. Now, why this chapter was a turning point? At this stage, learners cross an important milestone. If you have understood group by, aggregation functions, having clause, where clause, filtering group data, then you're no longer just querying data, you're analyzing data. This is the skill that powers dashboards, drives decisions, gets tested in interviews, separates beginners from professionals. In the next chapter, we will build on this foundation with advanced analytics concepts, including window functions and ranking. Now we enter the module 7, which is about subqueries and nested queries in SQL. So it could be single row, multi-row, correlated subqueries, plus usage in select, from, and where. Now let's have a quick introduction to why subqueries matter so much. So far in SQL, we've been answering direct questions. Some questions like, show me the roll number of employees, show me departments, show me total revenue per day. But real business questions are rarely simple. Businesses ask questions like employees who can earn more than the company's average, departments with higher than average salaries, customers who place more orders than most of the other users, sales days that outperform the overall trend. Notice something important. These questions depend on the result of another query. And that's exactly why subqueries exist. A subquery allows one SQL query to depend upon the result of another SQL query. This chapter is where SQL becomes logical and layered, not just procedural. Now, part 1 of this particular module, what exactly is a subquery? So, let's define it. A subquery is a query inside another query. It runs first, produces a result, and that result is used by another outer query. Think of subqueries as asking a question, using the answer to ask a better question. In interviews, this is often described as SQL inside SQL. Simple visual example can be understood in this way. Inner query calculates something, and outer query uses that calculation to provide some better answer. SQL reads subqueries inside out, not top to bottom. This mental shift is really critical. Now, let's go through some examples. So this brings us to part 2, single row subqueries. What is a single row subquery, you ask? A single row subquery returns exactly one value used with operations like equals to, greater than or equals to, less than or equals to. Let's take an example on my screen. So employees earning more than the average salary. So let's find the average salary first. Let's look at the code on my screen. So here we are trying to find out the average salary of the overall employees table. So the average salary is 87,000. Now instead of hard coding this value, we will nest it, right? So here we want to find out the employee ID, name of the employee, and salary from employees table, where salary is more than the average salary. So here we are ingesting this particular subquery that we recently executed, right? So this happens to be the single line subquery that we are discussing as of now. So this particular single line subquery will be ingested inside the outer query. So this happens to be the inner query and this happens to be the outer query. Now let's run this. There you go. So we have about 1, 2, 3, 4, 5 employees who earn more than the average salary of other employees. So let's take a pause and understand what's happening here. Inner query calculates company's average salary. Outer query performs and filters employees above the average salary range. Important business interpretation to understand here. Who are our top earners compared to the organization? This is a classic interview question. Now, let's take another example. Employees earning more than the maximum salary in a specific department. Let's say HR. Now, let's take an example on my screen. So here, we have a subquery which is select maximum salary from employees where department ID is equals to 1. So the department ID 1 is none other than the HR department. So we are encapsulating this particular inner subquery onto the outer subquery, which is trying to select the name, salary from the employees table, right? And where salary is greater than a number which is the result of this particular subquery, which is the maximum salary of employees. Now, let's execute this query. Control enter, and there you go. Now, let's take a pause and understand how is this working. The inner query returns the maximum value of salary from HR department, and the outer query compares every employee against it. This shows targeted comparison logic. Now, let's make a transition to part 3 where we will have multi-row subqueries. So what is a multi-row subquery? A multi-row subquery returns more than one row. It is most commonly used with operators like in, any, all. So for this, to understand in a better way, let's take an example. And the example question is employees in departments with average salary greater than 90,000. So first, let's identify all the departments. For that, let's take a look on my screen. So let me quickly write a small query. Star from departments. So we have 1, 2, 3, 4 departments: engineering, HR, finance, and marketing. Now we need to execute this particular subquery where we are trying to find out department ID and employees and department having salary more than 90,000. Now let's execute this. So we have department IDs 2 and 3 where they have greater higher salary or the average salary. Now we need to use this particular query inside another external query. So this is the outer query, this particular section, and this was the subquery that we just executed. Now we need to encapsulate this particular subquery inside the outer query, and now let's execute this. So we have the name of the employee, their salary, and their department ID. So as discussed in the first subquery, these are the employee or department IDs and their relevant employees. Now let's understand this clearly. Inner query returns multiple department IDs and outer query filters employees belonging to those departments. Now the business question answered here is which employees work in higher paying departments. So that's what the answer we gave. Now let's take another example. So the example 2 is we want to find out customers who placed more orders than the average. Now let's execute this particular query. So there you go. These are the customer and their IDs 1 and 2, and they have placed orders 3 and 4. These are the most loyal customers. Now let's understand the working of this particular code segment. Customers who placed more orders than average. Now let's understand this carefully. Inner subquery calculates order counts per customer. Next level calculates average order count. Outer query filters high activity customers. This is advanced analytical SQL, not beginner stuff. Now let's make a transition to part 4, which is about correlated subqueries and most important concept. Now, what is a correlated subquery? A correlated subquery depends on the outer query and it executes once per row and cannot run independently. Think of it as for each row, run a subquery that depends on that particular row. This is where SQL starts to feel like programming. For that, let's take an example. So this is the particular example we are going to execute. Question here was employees earning more than their department's average. Now let's understand this particular example. Outer query processes each employee. Inner query recalculates average salary for that particular employee's department. Now the comparison happens row by row. Now the business interpretation. Who are the top performers inside each department? This is one of the most frequently asked SQL interview questions. Now, let's consider another example. Orders that occurred after customer's first order. For that, let's take a quick look on the code on my screen. So here it is. We are using two different queries, the outer query and the inner query. So the inner query is where we selected minimum orders and customer ID is equals to customer ID from orders table. And we are joining, or we are applying self join here, basically combining the orders table with itself. Now let's execute this query. There you go. Now let's understand this. For each order, we find the customer's first order. We keep only the later orders. This helps to analyze repeated behavior. Now what is used here? We use this in retention analysis, funnel tracking, behavioral analytics. Now with that, let's make a transition to part 5. Part 5 is about subqueries in where clause. So it is a basic recap plus best use. This is the most common place where subqueries are used. Let's take an example. So here the business query is sales on high revenue days. Let's understand this. Inner query identifies high revenue days. Outer query fetches detailed sale rows. This pattern is used constantly in analytics. Now let's execute this query. So there you go. We have the answer. So we have two different entries, sale ID 8 and 9, and the amount was 400, 50, and 600. Now let's make a transition to part 6 of this module. So part 6 is about subqueries in SQL clause and will have calculated columns. Subqueries can act like dynamic columns. So let's take an example. So this is our example here. Let's execute this. So we have the output. We have a name of the employee, salary, company's average salary, and difference from average. Now let's understand what did we execute here. Salary compared to company's average. The inner query runs once, adds context to every row, makes reports more meaningful. Now it's great for dashboards and exports. So here what we did is we find out the salary of the employee and company's average and what's the difference, right? The difference amount that they are earning more than the average salary. Now this drives us to part number 7 of this module, which is about subqueries in from clause, or also known as the derived tables. Subqueries from act like temporary tables. For example, department-wise salary summary. Let's take a look at the example on my screen. So this is the code that we will be executing, and here we have the output. Now let's understand what is the logic that we implemented here. The inner query creates a derived table, outer query filters it, and this improves readability for complex logic. This is a stepping stone to CTEs and window functions. Now let's move to part 8. So part 8 is about when to use subqueries versus joins. Now one important discussion. Now with that, we make a transition to module 8, which is about the difference, right? When to use subqueries and when to use joins. Use subqueries when logic is layered. Aggregation is needed first. Readability improves. And when to use joins? Joins are used when data relationships are direct, performance matters most, data volume is really large, and professionals choose clarity and performance. Now let's also go through some of the common mistakes to warn learners about. So using equals to instead of in, expecting multi-row subqueries to return one value, forgetting correlation logic, overusing subqueries where joins are better, and the last one, ignoring performance implications. Now why this chapter was a milestone? If joins taught SQL how tables relate, subqueries teach SQL how logics relate. Once you understand single row subqueries, multi-row subqueries, correlated subqueries, subqueries in SQL, from and where clauses, you can answer almost any analytical question in SQL. This chapter is a bridge from intermediate SQL to advanced SQL to interviews to real production analytics. In the next chapter, we will take this logic and supercharge it using window functions and ranking, which solve many problems more efficiently. Now we transition into module 8, which is about data modeling and relationships. So primary keys, foreign keys, relationships, ER diagrams, and normalization are the topics discussed in this particular module. Now, let's have a quick introduction. Why this module defines your SQL maturity. Before we begin this chapter, I want you to pause for a moment. Up to this point in the course, you've been learning how to talk to a database, how to select data, how to filter it, how to join tables, how to aggregate results. That's important. Okay, this chapter answers a deeper question. Why does a database look the way it does in the first place? This chapter is not about writing queries. This chapter is about thinking like a database designer. And here's a reality check that most tutorials won't tell you. In real world, SQL queries are easy to learn. Poor data modeling destroys companies. Most production bugs are data design bugs. Most analytical errors come from bad relationships. If data modeling is weak, joins become confusing. Data becomes inconsistent. Reports contradict each other, performance drops, and most importantly, trust in data disappears. This is why senior designers, architects, and analytical leaders care deeply about data modeling. This chapter will help you understand how professional systems are designed, read any database schema with confidence, answer system design interview questions, avoid beginner level modeling mistakes, build databases that scale logically, not just technically. Think of this chapter as the architecture class of SQL. Now, let's start with part 1. What is data modeling? Now, thinking before coding is nothing but data modeling. Let's start with the foundation. So, what do you mean by data modeling? Data modeling is the process of identifying entities, defining their attributes, establishing relationships, enforcing rules and constraints. In plain language, data modeling is deciding how information is structured, stored, and connected before data even exists. A good data model answers what are core subjects of this system, what information belongs to each object, how do objects relate to each other, what rules should never be broken. Now let's go through a real world analogy to understand this better. Imagine you're designing a hospital data system. You don't start by randomly creating tables. First, you think. You think about patient's data table, doctor's data table, appointments table, departments table, prescriptions table, bills table. Then you start asking questions. Can a patient have multiple doctors? Can a doctor treat multiple patients? Does an appointment exist without a patient? This type of thinking is nothing but data modeling. SQL syntax comes later in the picture. Why data modeling comes first is because of some reasons. First, many beginners jump directly into creating tables. Start inserting data, worry about queries later. Now, let's discuss this in terms of professionals. Professionals design the data model first, validate relationships next, anticipate growth in the future, and prevent any type of inconsistency. Data modeling is about future-proofing your dataset. Now, this makes our transition to the part 2 of this module, primary keys, the primary identity of any data. Let's talk about the most fundamental concept in relational databases. What is a primary key, you ask? A primary key is a combination or a column of columns that uniquely identifies each row in a table. Every record must have one identity, one unambiguous reference. In simple terms, a primary key answers one question. How do I uniquely point to this exact row? Now, why primary keys exist? This is one particular and critical insight. Imagine a table without a primary key. You have two customers with the same name, same city, and same phone number as well. Now you ask yourself, which row do I update? Which one do I delete? Which one does a specific order belong to? Now your answer. Without a primary key, data becomes unreliable. That's the answer. That's why we do have a primary key. It's like an identity for your data entry. Let's understand through a real world analogy. For example, government identity. Your name can change, your address can change, your phone number can change. But the passport number, the Aadhaar number, social security number, which will not change. This uniquely identifies you. That's exactly what a primary key does for a row. Now, let's discuss the characteristics of a strong primary key. A good primary key should be unique, no duplicates ever, it should not be null, its identity cannot be missing, Third one is it should be stable, should not change over time. And next one is it should be minimal, prefer single column keys. Now let's understand one difference between natural keys and surrogate keys is very important. Natural key comes from business data. Example, email, username, PAN number, etc. Now what are the problems here? So the problems are this can change, this can be duplicated, it can be tied to business rules. Now let's understand the surrogate key. Surrogate keys are artificially generated ones. For example, auto increment ID. What are the benefits of using surrogate? They are simple, stable, and efficient for joins. Most modern systems use surrogate keys to enforce uniqueness separately. Now, a quick interview tip. Should email be a primary key? A most mature answer is email can be unique, but emails can change. Better as a unique constraint, not as a primary key. Now, we make transition to the part 3 of this module. Foreign keys, which are connecting the data world. Now comes the concept that makes SQL relational. So what is a foreign key? Foreign key is a column in one table that references the primary key of another table. In simple terms, a foreign key relates a relationship between tables. Why foreign keys exist? Now the next question is why foreign keys exist. Instead of duplicating data, department name, customer details, product information, we store it once, reference it everywhere. This ensures consistency, reduced storage, cleaner updates. Now let's understand through a real world analogy. Booking a flight. A ticket references to passenger ID, flight ID. The ticket does not store passenger name repeatedly, aircraft details repeatedly. Foreign keys keep systems normalized and scalable. Now let's go through referential integrity, a non-negotiable rule. Foreign keys enforce you cannot reference a record that doesn't exist. You cannot delete a parent if children depend on it. This protects the database from orphan records, broken relationships, logical corruption. The next one is on delete and on update. These are business decisions. When a parent row changes, should child rows get deleted? Should they get updated? Should the action be blocked? Now to understand this, consider these examples. Deleting a customer with orders, usually it is restricted. Deleting a draft record, cascade is allowed. These are domain decisions, not just SQL syntax. Now let's make a transition to part 4 of this module, relationship types, how data connects. Understanding relationships is the heart of modeling. We have a wide variety of relationship types. Let's start with one-to-one relationship. One record in table A maps to another record in table B. For example, user data table to profile data table, employee data table to ID card data table, person data table to passport data table. Now the next question is, when should you use one-to-one relationship? It is rarely but intentionally used when sensitive data needs separation, optional data exists, performance optimization is required. Now let's consider an example. Authentication data separated from user profile. Now the next type of relationship is one to many or one to n. This kind of relationship is most common. One record in table A maps to many records in table B. Examples, customer table to orders table, department table to employees table, user table to post table. This is the default relationship in relational databases. What's the implementation rule? The foreign key always sits on the many side. This rule alone clears 70% of beginner confusion. The next one is many-to-many relationship or M is to N relationship. Many records in table A relate to many records in table B. Some of the examples are students table to courses table, products table to orders table, movies table to actors table. Now, junction table concept. Relational databases resolve M to N using a third-party table, two foreign keys, optional extra attributes. This table often stores timestamps, quantities, status, grades, etc. With that, we make a transition to part 5, which is about ER diagrams. It is basically about thinking visually. An ER diagram is a visual blueprint of a database. It shows tables, columns, primary keys, foreign keys, and relationships. Now, why ER diagrams matter in the real world? Before code, architects use or draw ER diagrams. Teams review them. Business rules are validated. ER diagrams prevent rework, confusion, costly redesigns. How interviewers use ER diagrams could be a question. So they want to see logical thinking, relationship clarity, normalization awareness. You don't need fancy symbols. Clarity matters more. With that, we make a transition to part 6 of this module. Normalization, which is about keeping the data clean. Now with that, we make a transition to part 6 of this module, which is about normalization and keeping the data clean. Now, let's talk about one of the most misunderstood topics. What is normalization? Normalization is organizing data to minimize redundancy and dependency. In simple words, avoid duplicate data, avoid inconsistent updates, protect data integrity. Now, why normalization exists? Without normalization, same data stored in multiple places, updates miss same rows, reports contradict each other, and the data trust collapses. Now we have a few different types of normalizations. So the first one is 1F, or the first normal. It is about atomic values and no repeating groups. Now, a bad format will be phone 1, phone 2, and phone 3, and a good separate phone table is the best example for this. Now we have this second normal form, which is 2NF, and the rules are in 1NF, no partial dependency, and it applies mainly to composite primary keys. Now we have the third normal form, which is also known as the 3NF, and the rules are in 2NF, no transitive dependency, meaning non-key attributes depend only on the primary key. Now let's understand the difference between normalization versus denormalization, which is a real-world trade-off. OLTP systems, highly normalized, write consistency matters, analytics systems, often denormalized, read performance matters, and professionals choose intentionally, not blindly. And with that, we make a transition to part 7 of this module, which is about real-world case study on e-commerce modeling. Let's design a simple e-commerce system verbally. So we have the following entities. We will be having users, products, orders, order items, and payments. Now let's discuss the relationships. Users are connected to orders in 1 to n, and orders are connected to order items, which is also 1 to n. And the last one is product to order items, which is also 1 to n. No direct order to product, which is m to n, resolved via order items. This is real world modeling in action. Now let's make a transition to part 8, which is about common beginner mistakes. Let's quickly cover some mistakes professionals avoid. So some of the mistakes are using names as primary keys, storing repeated values, missing foreign keys, over-normalizing early, ignoring future growth. Avoid these mistakes and you already think like a pro. Now we enter the part 9 of this module, which is about interview mindset and how to answer design questions. Interviewers want thought process, trade-off awareness, business understanding. Always explain why you choose a structure, why you rejected alternatives, how it scales. Now, a simple summary. Why this chapter changes everything. This chapter transforms how you see databases. You no longer memorize syntax, fear joins, or guess relationships. You now understand structure, design confidently, think long term. This is the difference between a SQL user and a data professional. So now we have entered module 9, which is about indexing and performance tuning. This module will help us understand why indexes matter, creating and using indexes, and query optimization tips. Now, let's have a quick introduction. Why performance is a career skill. Before we talk about indexes, let me tell you something very important. Most SQL learners stop at select, where, join, group by commands. But professionals are judged on performance. In real companies, no one praises a query that works. They praise a query that works fast. They praise a query that works at a scale. And here's the truth. Performance problems don't show up in small datasets. They show up in production. This chapter is all about why some queries are fast, why others slow down as data grows, and how databases search data internally, how indexes change the game completely. If you understand this module, you'll write scalable queries, you'll pass performance-based interviews, you'll avoid production outages, you'll sound like someone with real experience. This is not about memorization. This is about how databases link. Now the part 1 of this module. Why indexes matter, how databases find data. So let's start with a simple question. How does a database find data? Imagine a table with 10 rows. It could be fast. And if you have 10,000 rows, maybe your query is manageable. 10 million rows, already you might be thinking your query could be slower. And in case if you had a billion rows, it's a complete disaster. So without indexes, this could become a reality. Now without an index, the database performs a full table scan, meaning it checks every row, one by one until it finds what you asked for. That's like searching for a name in a phone book without an index, reading every page from start to the end. Now, a real world analogy. Book index versus page by page reading. Think of a textbook. If you want to find out a normalization topic, you don't have to read every page. You go through the index, find the page number, jump directly, and that's exactly what a database index does. Now, what is an index? An index is a separate data structure that stores column values in sorted order without pointers to the actual rows. In simple terms, an index is a shortcut for finding data quickly. Why indexes improve performance is your question, right? Indexes reduce disk input-output operations, CPU usage, query execution time. It is especially for where conditions, join conditions, order by conditions, or clauses and group by clauses. Now, important reality check indexes. They speed up reads, slow down writes. Every insert, update, delete commands must also update indexes. So indexes are not free. This is why indexing is a design decision, not a default action. Now, with that, we make a transition to the part 2 of this module, which is about how indexes work internally. Now, you don't need to be a database engineer, but you must understand the intuition. Most databases use B tree or B plus tree structures. Conceptually, data is stored in sorted blocks. Each block points to a child block. Searches are logarithmic, not linear. This means searching 1 million rows is almost equal to a few steps. Searching 1 billion rows is also still manageable. Without indexes, search time grows linearly, performance collapses at a scale. Now, let's understand the difference between clustered and non-clustered index. First, clustered index. It defines physical order of data. Table can have only one and it is often a primary key. Now, non-clustered index. It's separate structure. Multiple clustered indexes are allowed. Points back to table rows. You don't need to memorize this just now. You just understand. Some indexes control how data is stored. Others act as lookup maps. And with that, we make a transition to part 3 of this module, which is about creating and using indexes. Now, let's talk about practical usage. Basic index creation. Indexes are created on columns that are frequently searched, frequently joined, frequently filtered. Now, some of the examples are like user ID, order ID, email address, and other foreign keys. When should you create an index could be your next question. You should create indexes when table size is large, queries use where on that column, and joins happen frequently, and sorting is very common. And the next topic is about selectivity, which is a key performance concept. High selectivity. Column has many unique values. For example, email, user ID, and low selectivity are few unique values. For example, gender, status, active or inactive. Now, indexes work best on high selectivity columns. Composite indexes sometimes queries filter on multiple columns as well. For example, a department ID is equals to 2 and salary is greater than 90,000. A composite index on department ID and salary can significantly improve performance, but order matters. Department ID, salary is not equals to salary, department ID. Indexes follow left to right rules. Indexes and joins, very important part. Indexes on primary keys, foreign keys make join operations faster, more predictable. This is why foreign keys are often indexed. Now, we make a transition to part 4. Query optimization is not magic. It's about reducing work, reducing data scanned, helping the optimizer. Now, the rule 1. Avoid select stuff. Select stuff fetches unnecessary columns, increases input-output operations, slows network transfer. Always select only required columns. Rule number 2. Filter early. Use where conditions as early as possible. Filtering early reduces rows, improves joins, and improves aggregations. Now comes rule number 3. Index where and join columns. If a column appears often in where, join, order by, it's a candidate for indexing. Rule 4. Avoid functions on indexed columns. Now let's go through an example which is bad, where year of order date function is equals to 2025. Now let's also go through a good example, where order date is between 2025 1st of January and 2025 December 31st. Functions can prevent index usage. Now the rule number 5. Use explain. Most databases provide explain and explain analyze. These show query plan, index usage, and scan type. Professionals always check execution plan before optimizing blindly. Now comes the part 5 of this module, which is about common performance anti-patterns. Let's talk about mistakes that kill performance. First anti-pattern, over-indexing. Too many indexes, slow inserts, slow updates, and increases storage. Indexes should be intentional, justified, and reviewed. Second anti-pattern is indexing everything. Not every column needs an index. Indexing low selectivity columns rarely helps and often hurts. Now, third anti-pattern, ignoring data growth. A query that works today may fail at a scale or may time out later. Always ask, what happens when this table has 1,000,000 rows or 100,000,000 rows, right? Now, the fourth anti-pattern is blind optimization. Never optimize without measuring, without understanding the plan. Premature optimization is often dangerous. Now comes the part 6 of this module, which is about real world scenarios. Now the first scenario, slow dashboard query. Millions of orders filtered by date range, grouped by customer. Now the solution for this problem, index on order date, composite index if needed, and avoid select star. Now the second scenario, slow join query. Orders joined with customers, foreign key is not. Now the quick fix for this problem is index foreign key, reduce join columns, and check execution plan. Now comes the scenario number 3, which is about reporting versus transaction systems. OLTP, normalized index for writes plus reads. Analytics, denormalized index for reads, sometimes materialized views. Now comes the part 7, which is about interview perspective, how to talk about performance. Interviewers don't expect perfect tuning, deep engine internals. They expect awareness, trade-off thinking, real-world mindset. Good answers mention indexes, execution plans, data volume, and query patterns. Now, some of the bad answers that you should avoid are add indexes everywhere, use faster hardware. A little summary of this module. Why this module makes you professional. Anyone can write SQL that works, but a very few can write SQL that scales, performs, survives growth. This module moves you from beginner level SQL thinking to production ready SQL thinking. From here on, you won't fear slow queries. You will reason about performance, you will design smarter schemas, and you will earn trust in real teams. And with that, we make a transition to the next module. Now we enter module number 10, which is about views, functions, and stored procedures. Up until now, we've been writing queries directly on tables using select, join, and group by, subqueries, and even some window functions. That's great for learning SQL fundamentals. But in real-world organizations, analysts and applications do not write raw queries every time. Instead, SQL logic is abstracted, reused, and secured using database objects. This is where views, functions, and stored procedures come into the picture. Think of it like software development. Views are reusable layers, functions are calculation utilities, stored procedures are like back-end APIs running inside the database. Mastering these concepts separates someone who knows SQL from someone who works with SQL in production systems. Now, SQL views. What is a view? A SQL view is a virtual table created with a select query. It doesn't store any data by itself, but it stores the logic. Whenever you query a view, SQL runs the underlying select query. It fetches fresh data from the base tables. So remember, tables store data and views store business logic. Why views exist in real systems is the question you ask. There are 4 main reasons companies use views. First one, simplification. Analysts don't want to write complex joins every time. So the next reason is consistency. Everyone should calculate metrics in same way. The third reason, security. Views hide sensitive columns from certain users. The fourth and most important reason is maintainability. Change logic in one place and it updates everyone. And those were the 4 reasons why views really matter in real-world data analytics. Now, let's go through some examples. View example number 1, right on my screen, which is about employee details view. Right? We are creating a view on the employee details. Now let's imagine you are an HR and you want employee details along with department names without writing joins repeatedly. Now for that, let's create a view. So here we are creating a view using the word or the keyword create and the keyword view. And this is the customized name that you are providing to your view, VW employee details. And inside this view, you will have this particular query. where you are selecting employee ID, employee name, employee salary, hire date, and you're also using department, right? So here you can see the D letter. So this means you are using a different data table, which is department's data table, and from employees, and you're joining that particular department's table based on the foreign key department ID and the keyword, the primary key in department table, which is department ID, right? This is the query, and this is totally a join, and this is your view. Now let's execute this so that your view is successfully created. So I have executed this query previously. So here you can see VW employees details already exist, right? If you want to extract the details from this particular view, all you need to do is select star from view, which is this one, and you'll have view here, right? Let's have a quick understanding. So when you execute this particular query, you create a reusable virtual table. You'll have a left join here, which ensures that employees without departments are still visible. For example, contractors or new hires, the Frank, which we have in our table, he doesn't have a department here, right? In our previous section, we have discussed about that intentional missing of department for Frank. And this view hides the complexity of joins. Now, so we have already used the view to extract the details, right? Now the key point, SQL executes the join behind the scenes. The user sees clean results. This is exactly how dashboards and BI tools work. Let's go through another example in view, which is department salary summaries. And what's the business question here? The business question is, what is the average and total salary per department? Now, let's go through the query. So here we have the second view, which says department salary summary. And we are creating this particular view using create and view keywords. And here we have department name, counting the total number of employees in each department. And we are aliasing this as employee count, and average aggregate function, and we are aliasing it as average salary. Sum aggregate function as the total salary alias from department's team. Left showing the employees on department ID from department's table with a department ID from employees table and group by department name. We already created this view. Let's say if we try to execute this, we'll get an error which says view department salary summary already exists. Now, how do we use it? So you can just use the same select function. You can copy and paste it here and replace this particular view employee details with this particular view name, salary department, and enter to use this view. And there you go. So we have the department name, employee count, average salary, and the total salary, right? Now we enter a state where we should understand why views matter. So views matter when you're creating monthly reports, leadership dashboards, financial analysis. Without views, you would write the same query multiple times, risking inconsistent results and creating a maintenance headache. Now, a quick interview insight. Now, if someone asks you to explain what is a view, then you should not answer use store data. As we discussed in the beginning section, views never store any data, but they store only the logic. So the correct question would be, views store query logic. They abstract the complexity and keep the data dynamic. Now we transition to the next part, which is the SQL functions. Now let's understand what exactly is a function. A SQL function is a reusable block of logic that accepts input, returns a single value. It can be reused inside a select, where, order by condition, and you can think of it like an Excel formula that works directly on your data table. Why functions matter? Functions avoid repeating case statements in multiple queries, centralize business rules, improve readability, reduce errors. Now, let's also go through some examples. Now, the first example is salary category. Now, what is the business need here? The business need is we can classify employees as high, medium, or low salaries, right? Now, let's go through the query. So here we have the delimiter, and we are creating a function which is function salary category, which returns worker type of data 20 and deterministic begin here. So declare category, and the categories are high for employees having greater than 1 lakh salary, medium for employees having greater than or equal to 70,000 salary, and the other category is set to low. Now this function is already created. Now, how to use the function? Now, we are using the function here. Select name, salary, and the function name as salary band from employees. Now, let's quickly hit enter, and we have all the details right here. Now, we have the second example for function, which is experience calculation. Now, before that, let's see how the output works. So basically, this particular query returns worker type of output, and deterministic, which is same output, always returns the same output, and helps the optimizer if or else if function, and encodes the business rules using the function. Now, this approach keeps your queries clean, readable, and maintainable. Now, as we discussed, the second function, which is experience calculation. What this does is it basically calculates how many years of experience does each employee have. Now, where is this being used? So for that, let's go to the workbench. So we have already created this particular function, which is function experience in years. Now we have deterministic, returns int type of data type, and we will use this particular function here and execute the query. So Alice, I think this particular industry was created recently, so none of the employees have crossed 1 year of experience. So that's great, not a big deal. Now we enter the next part, which is about stored procedures. And before that, let's understand the difference between function and a view. When comparing views and functions, there are few points to note. First, their purpose. A view is designed to be reusable query. It encapsulates the logic of one or more tables so that anyone can access it without writing or rewriting joins and aggregation. A function, on the other hand, is reusable calculation. It is meant to perform specific logic or transformations on data. Second, what they return. A view returns a result set, essentially behaving like a virtual table that you can query just like a regular table. A function, on the other hand, returns a single value which can be used directly in calculations or conditions. Finally, where they are used. Views are referenced in the from clause of a query, just like any other table. Functions, on the other hand, are used in select statements, where conditions, or even order by clauses whenever a value needs to be computed. In short, think of views as query containers and functions as calculation helpers that make your SQL cleaner and more reusable. Now, a quick interview insight. A good explanation is functions encapsulate calculations while views encapsulate data relationships. Now we enter into the stored procedures. Now, what is a stored procedure? A stored procedure is a named set of SQL statements stored in the database. It can accept parameters, execute multiple queries, return result sets, enforce business workflows. Think of it as a backend logic running inside the database. Now, why stored procedures exist? They reduce application database traffic, improve performance, improve security, standardize business logic, and a lot more. Now, let's go through an example. Now, the example is about employees by department. And what's the business requirement? They return all employees for a given department. For that, let's go through a sample query on my screen. So here's a procedure that we recently created, and the procedure name is SP get employees by department. Now, it's already created and we cannot create this procedure once again. So let's simply call it. So there you go. So all the employees from engineering department are being called here. Now, why it matters? Applications call the procedure. Users never see the underlying tables. Logic is centralized. And now let's go through the next example on procedures, which is department salary summary. Now let's go through the procedure name, which is department salary summary. And since this is already created, we can just call it and execute it. So this is what we have. So we have engineering, HR, finance, marketing, and their employee count, average salary, and the total salary. Proceeding ahead, we have another example in procedures, which is in and out parameters. So here we have in and out parameters. So we are providing customer ID, and out will be the order count. Now this particular procedure is created. Now we can call this particular procedure and then select the total orders. And here we have the output, which is a total of 4 orders. Now, what was the business use case? They return total orders from a dedicated customer. Now calling it will give you the results. Now let's have a quick understanding between the stored procedures versus the function. When we compare functions and stored procedures, there are three differences to keep in mind. First, what they return. A function always returns a single value, making it perfect for calculations or deriving a specific result. A stored procedure, on the other hand, can return full result sets and even use out parameters, which makes it ideal for handling workflows or multiple operations at once. Second one, how they are being used. Functions can be called directly inside a select statement, so you can embed them in queries whenever you need a calculated value. Store procedures, on the other hand, cannot be used inside a select. They are executed independently. Finally, their primary use case differs. Functions are primarily used for calculations like categorizing salaries or computing experience. Store procedures, on the other hand, are better suited for workflows like fetching all employees for a department, updating multiple tables, or encapsulating business logic. In short, think of functions as a calculation tool and store procedures as a workflow engine inside the database. Now, a final summary. Views improve readability and consistency. Functions improve reusability of logic. Store procedures improve performance and control. Mastering these concepts prepare you for data analyst job roles, business analyst interviews, working with production level databases, and backend and business intelligence systems. Now this finishes the module 10, and with that we transition to the next module. Now we have entered module 11, which is about transactions and error handling in SQL. Before we talk about SQL transactions, error handling, or even asset properties, let's take a moment to understand why this chapter matters so much. Until now, we've been writing SQL queries that read data, filter rows, and analyze information. But in real systems, SQL is not just about reading data. SQL is also responsible for changing data, and once data changes, the consequences become serious. In production systems, a single SQL mistake can lead to incorrect salaries being paid, orders being duplicated, money being deducted twice, customer records becoming inconsistent, or the worst case, complete data corruption. This is where transactions come into play. Think of transactions as the safety net of SQL. They ensure that when multiple changes happen together, they either all succeed or nothing happens at all. This chapter will help you understand what SQL transactions really are and how databases protect data integrity, why asset properties are critical in enterprise systems, and how databases deal with errors gracefully. This is one of those chapters that separates beginners from professionals. Interviewers love this topic. Architects expect you to understand it, and production systems depend on it every single day. What is a transaction is our first question in this chapter. At a very simple level, a transaction in SQL represents a group of database operations that are treated as one single logical unit of work. Instead of executing each SQL statement independently and immediately making its changes permanent, the database deliberately groups multiple statements together and evaluates them as a whole. In practical terms, a database makes a promise. That promise is simple but powerful. It says either every change inside this group must succeed together or none of the changes should be applied at all. There is no middle ground and no partial success. To understand why this concept exists, let's step outside the world of databases for a moment and think about real-world scenarios that almost everyone can relate to. Imagine you're transferring money from one bank account to another. This process always involves at least two steps. First one, money is deducted from account A. Second, the same amount of money is added to account B. These two steps are logically connected. One step cannot exist without the other. Now pause and ask an uncomfortable but important question. What happens if the system crashes after the money is deducted from account A, but before it is added to account B? From a user's perspective, that situation is completely unacceptable. Money has vanished without reaching its destination. Trust in the system is broken. Databases face the exact same challenges. In SQL, real-world operations rarely involve a single statement. A business process might require updating one table, inserting records into another table, and deleting rows from a third table. Each of these statements may succeed individually, but from a business perspective, they are not independent. They are a part of a single operation. If one of these steps fail, allowing the others to remain would leave the database in an inconsistent and unreliable state. That is why these actions must behave like one combined operation, not three separate ones. This logical grouping of multiple SQL statements into one indivisible unit is what we call a transaction. Now, why transactions are needed is your next question. Without transactions, databases would behave like a collection of isolated commands that execute independently without awareness of each other. While this might sound simple, it quickly becomes dangerous in real systems. Imagine a database that executes every SQL statement immediately and permanently without any ability to reverse or group changes. In such system, failures would create chaos. Partial updates would become common. Data mismatches would appear across tables. Relationships defined through foreign keys would break silently. Reports and analytics would start showing numbers that do not align with reality. Let's take a very common example from an e-commerce system. An order is created in the orders table. Payment processing begins. The payment fails due to a network issue or insufficient balance. However, the inventory system has already reduced the stock count for that product. Now the database shows an order that was never paid for or inventory that no longer exists. This is not a rare edge case. It is exactly the kind of scenario that happens in real systems every day if the transactions are not used correctly. Without transactions, SQL would simply execute each statement in sequence and move on, completely unaware that something went wrong midway. The database would not automatically understand that these operations were connected logically. Transactions introduce control and intent into this process. They allow us to clearly tell the database when to start tracking changes, when to confirm and permanently save those changes, and when to cancel everything and revert back to the original state as if nothing ever happened. This level of control is not optional in modern systems. It is essential. Banking platforms rely on transactions to protect financial accuracy. E-commerce systems use them to ensure orders, payments, and inventory always remain in sync. ERP systems depend on transactions to maintain consistency across complex business workflows. Payroll systems cannot afford partial salary updates. Analytics pipelines and data warehouses rely on transactions to ensure reporting data is trustworthy and complete. In short, transactions exist because real systems fail, networks break, users make mistakes, and databases must be prepared for all of it without compromising data integrity. Now, we land into the next part, which is begin, commit, and rollback. It is the core of SQL transactions. Now that we understand what a transaction is and why transactions are necessary, it is time to focus on the three most important commands that make transactions actually work in SQL. These commands form the backbone of transactional control in every major database system used in the industry today. Those three commands are begin, commit, and rollback. You will encounter them in MySQL, PostgreSQL, SQL Server, Oracle, and almost every enterprise-grade relational database. While syntax variations may exist, the underlying concepts are universal. If you understand these three commands deeply, you understand how databases protect data from mistakes, failures, and unexpected crashes. Let's take them one by one and truly understand what each command does, not just at a syntax level, but at a conceptual level. Now, let's start with begin, or also known as a start transaction. The begin statement marks the starting point of any transaction. Conceptually, begin tells the database something very specific and very important. It tells the database, from this moment onward, do not permanently save any changes yet. Before begin is executed, every SQL statement typically operates in what is known as auto commit mode. That means each individual statement is immediately finalized and written permanently to the database. Once executed, there is no easy way to undo it. Begin changes this behavior. When you execute begin, the database switches into a controlled state. From this point forward, every insert, update, or delete statement is tracked internally by the database engine. The changes are applied in memory or in temporary structures, but they are not yet committed to the permanent storage. This distinction is extremely important. At this stage, the database remembers what has changed. The original data is preserved internally. Other users do not see the changes. The system is effectively waiting for your final decision. A very helpful way to think about Begin is, imagine opening a draft document. You start editing the document, but nothing is published yet. You can add text, remove sections, or rewrite entire paragraphs. But until you click Save or Publish, the changes are private. Begin creates the same draft-like environment for database operations. This is why Begin is often described as the moment when the database starts recording intent rather than finalizing the action. Now, visibility of changes after Begin. One subtle but critical aspect of Begin is visibility. Once a transaction has started, the changes made inside that transaction are usually not visible to other users or sessions. This means you may update a salary inside transaction. Imagine multiple analysts running reports while data is half updated. Without isolation, reports would show unpredictable results. Begin creates a protected workspace where changes can be reviewed, validated, and finalized safely. Now let's dive into commit. Once you have executed all the necessary SQL statements inside a transaction and you are confident that everything is correct, you use the commit command. Commit tells the database that everything that has happened since Begin is correct. Make it permanent. This is the point of no return. When commit is executed, the database takes all the track changes and writes them permanently into the disk. At this moment, the transaction ends. The database is updated. Other users can now see the changes. The old data is replaced by the new data. From a conceptual perspective, commit is equivalent to clicking Save or Publish. Until this moment, everything was reversible. After this moment, the changes become a part of the official database history. It is very important to understand that there is no undo after you use commit. Once the database confirms a commit, the transaction is complete. If a mistake is discovered later, it must be corrected with a new SQL statement, not by reversing the commit itself. This is why commit should only be executed when all statements have run successfully, all constraints are satisfied, the data makes logical sense, the business rule has been fully applied. Professional developers and database administrators treat commit with respect because it represents finality. Now we have durability and commit. Another important idea connected to commit is durability. When a database confirms a commit, it ensures that the changes are safely returned to persistent storage. Even if the server crashes immediately after, the committed data will still exist when the database restarts. This guarantee is one of the reasons relational databases are trusted for critical systems. Commit is not just a logical confirmation. It is a promise that the data will survive failures. Now we have rollback. While commit represents success, rollback represents recovery. Rollback tells the database something went wrong. Cancel everything that happened since Begin. This could be due to a constraint violation, a failed business rule, an unexpected error, a manual decision by the user, or even a system failure handled gracefully. When rollback is executed, the database discards all track changes from the current transaction. Every insert, update, or delete is undone, and the database returns to its exact previous stable state. It is as if the transaction never happened. This behavior is what makes transactions so powerful. Instead of leaving behind partial updates or corrupted data, the database cleans up everything and restores order automatically. This is why rollback is often called the panic button of SQL transactions. When something feels wrong, rollback ensures safety. Now we deal with rollback and data integrity. Rollback protects data integrity in situations where partial success would be dangerous. Consider again the banking example. Money deducted from one account, errors occur before adding money to another account. Rollback ensures that the deduction never truly happened. The system goes back to a consistent state where balances still make sense. Without rollback, errors would permanently damage data trust. Mental model for transactions. A very effective way to remember how these commands work together is to use a simple mental model. Think of it like this. Begin means start recording changes. Commit means accept and save changes. Rollback means forget all changes. And this mental model is powerful because it works across databases, tools, and even interview discussions. Whether you're working with MySQL, PostgreSQL, SQL Server, Oracle, or any other enterprise database, the behavior remains conceptually the same. The syntax may differ slightly, but the intention never changes. Transaction lifecycle is our next concept. Every transaction follows a clear and predictable lifecycle, even though the most users never see it happening. The lifecycle begins when a transaction starts. This may happen explicitly using begin or implicitly when auto commit is disabled. At this point, the database prepares itself to track changes rather than finalizing them. Next, SQL statements execute one by one. Insert, add rows, update, modifies values, and delete, removes records. Each change is carefully tracked internally by the database engine. During this phase, the database maintains enough information to undo everything if required. This is where transaction logs and internal buffers come into the play. Although those mechanisms usually remain hidden from the users, after all statements are executed, the transaction reaches a decision point. One of the two outcomes must occur. If everything is correct, commit is executed. The database permanently saves the changes and ends the transaction. If something goes wrong, rollback is executed. The database discards all the changes and returns to the previous stage. What is crucial here is that there is no third option. A transaction can never end in half-completed state. The database guarantees that it will either fully succeed or fully fail. This all or nothing behavior is what makes transactions more reliable. Why this lifecycle matters? Although this lifecycle is invisible to most users, it is absolutely critical behind the scenes. Every time you place an order, receive a salary, update customer information, generate financial reports, you are relying on this lifecycle to behave correctly. Understanding this flow not only helps you write safer SQL, but also helps you think like a system designer. It teaches you to anticipate failure, plan recovery, and respect data integrity. Now, with that, we make a transition to the asset property. Now, a quick introduction to asset properties and error handling in SQL. Now that we have built a strong understanding of transactions and we clearly know how begin, commit, and rollback work together, it's time we move into one of the most important theoretical foundations of SQL and database systems as a whole. This section is not just theory for the sake of theory. It explains why databases are trusted, why transactions work reliably, and why SQL systems can safely power critical business operations across the world. Every reliable transaction database follows a set of guarantees known as ACID or asset properties. Asset is not a buzzword. It is not any academic concept that exists only in textbooks. Asset is the reason why banks do not lose money, airlines do not double book seats, and enterprise can run large-scale systems with confidence. The word asset is an acronym, and each letter represents a functional fundamental property that a transaction must satisfy. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. If you truly understand these four properties, you understand why databases are considered reliable systems rather than simple storage tools. Let's explore each one of them carefully, one at a time. First one is atomicity, all or nothing. Atomicity is often the earliest asset property to understand conceptually, but it is also one of the most powerful. Atomicity means that a transaction is treated as a single indivisible unit of work. In simple terms, a transaction must either complete entirely or not happen at all. There is no such thing as partial success. When a transaction contains multiple steps, the database does not allow some of them to succeed while others fail. Either all steps are applied successfully or every single change is undone. Imagine a transaction that contains 10 SQL statements. According to atomicity, the database guarantees one of the two outcomes. Either all 10 statements succeed or none of them are applied. There is no scenario where 5 succeed and 5 fail. This guarantee becomes especially important when systems fail unexpectedly. Consider what happens if a transaction is executing and the system crashes during the ninth step. From the user's perspective, this crash is unpredictable and unavoidable. However, the database still guarantees safety. It detects that the transaction did not complete fully and automatically rolls back all the changes made by that transaction. This is atomicity in action. Atomicity prevents half-written records from entering the database. It prevents partial updates that could break reports, analytics, or business workflows. It ensures that relationships between tables remain intact and logical. Without atomicity, databases would be extremely fragile systems. Every unexpected shutdown or error could leave the data in a corrupted or unusable state. Atomicity is one of the primary reasons databases are trusted in financial systems, healthcare platforms, airline booking engines, and other mission-critical applications. When money, lives, or legal obligations are involved, almost correct is not acceptable. Atomicity ensures correctness or nothing at all. Now, the next one, C for consistency. From one valid state to another, while atomicity focuses on all or nothing, consistency focuses on correctness. Consistency means that a transaction must move the database from one valid state to another valid state. A valid state is defined by the rules of the database and the rules of the business. These rules include technical constraints such as primary keys, foreign keys, unique constraints, and not null conditions. They also include business rules such as salary limits, account balances, or workflow conditions. For example, if a table requires that every employee must have a unique employee ID, consistency ensures that a transaction cannot insert duplicate IDs. If an order must reference a valid customer, consistency ensures that orders cannot exist without customers. When a transaction violates any of these rules, the database does not allow it to succeed. Instead, the transaction fails and is rolled back. Consistency ensures that invalid data never enters the system. It guarantees that every committed transaction leaves the database in a state that makes sense according to the defined rules. It's important to understand that consistency does not mean the database automatically knows what is right for your business. Instead, it enforces the rules that you, as a designer or developer, define. Once those rules are defined, consistency becomes the database's responsibility. This is why well-designed schemas matter. The stronger your constraints and rules, the stronger the consistency guarantees your database can provide. Consistency is what allows analytical teams to trust reports, auditors trust financial records, and engineers to trust system behavior. Now we have the next one, I for isolation, protection in a multi-user world. Modern databases are multi-user systems by design. At any given moment, hundreds or even thousands of transactions may be executing at the same time. Isolation answers a very important question. What happens when multiple transactions interact with the same data simultaneously? Isolation means that transactions should not interfere with each other in a way that causes incorrect or unpredictable results. In simple terms, isolation ensures that one user's incomplete transaction does not affect another user's transaction. Imagine one transaction is updating employee salaries, but it has not yet committed. At the same time, another user is running a report that calculates average salaries. Without isolation, the report might see half updated data, leading to incorrect results. Isolation prevents such scenarios. It ensures that uncommitted changes are not visible to other transactions. Dirty reads are avoided, data remains predictable and stable. Different databases implement isolation at different levels, allowing trade-offs between performance and strictness. These are known as isolation levels. While the strictness may vary, the core principle remains unchanged. Isolation exists to ensure that concurrency does not break correctness. Without isolation, databases would become chaotic under load. Reports would fluctuate unpredictably, updates would conflict, and debugging would become nearly impossible. Isolation is the silent guardian that allows multiple users to safely share the same database. Now comes the last one, D for durability. Once committed, always committed. Durability is the final asset property and it focuses on permanence. Durability means that once a transaction is committed, it will remain committed even in the face of system failures. Once commit is executed successfully, the database guarantees that the data is safely stored. Even if the power goes out, the server crashes, or the database restarts, the committed data will not be lost. This guarantee is achieved through internal mechanisms such as transaction logs, write-ahead logging, and persistent storage strategies. Before a transaction is considered committed, the database ensures that enough information has been written to disk to recover the changes if necessary. Durability is the reason databases can recover safely after crashes. When a database restarts, it replays committed transactions and discards incomplete ones. Without durability, a database crash could result in data loss, broken trust, and catastrophic failures. Durability transforms databases from temporary data stores into reliable systems of record. Why ACID matters in real systems. At this point, it should be clear that ACID properties are not abstract ideas meant only for exams or interviews. They are the foundation upon which real systems are built. Banks rely on ACID to ensure financial accuracy. Airlines rely on ACID to manage reservations without conflicts. E-commerce platforms rely on ACID to synchronize orders, payments, and inventory. Enterprises rely on ACID to run payroll, compliance systems, and analytics pipelines. When interviewers ask about ACID properties, they are not testing memorization. They are testing whether you understand why databases can be trusted or not. A candidate who understands ACID demonstrates system-level thinking, not just SQL syntax knowledge. Now we make a transition into error handling in SQL transactions. Now, let's move on from guarantee to reality. In the real world, errors are inevitable. Networks fail, constraints are violated, input is incorrect, applications contain bugs, systems crash unexpectedly, and the key question is not whether errors will happen. The key question is how databases handle these errors without compromising data integrity. The transaction system's error handling is deeply connected to ACID properties. When an error occurs inside a transaction, the database does not panic or partially commit changes. Instead, it ensures safety. Errors typically trigger rollbacks. This means the database cancels all changes made by the transaction and returns to a stable state. Some databases automatically roll back when a fatal error occurs. Others require explicit rollback commands regardless of the implementation. The principle remains the same. Errors must never leave the database in an inconsistent state. This principle is non-negotiable in reliable systems. Now, the conceptual workflow of error handling. The conceptual workflow of error handling in transaction is simple and elegant. First, a transaction begins. Next, the SQL statements execute one by one. The database continuously monitors for errors. If an error occurs at any point, the transaction is rolled back. If all statements succeed, the transaction is committed. This flow is deeply embedded into enterprise systems, even if the developers are not consciously aware of it. It is this flow that allows databases to gracefully handle failures instead of amplifying it. This is why this chapter is career critical, and this chapter may feel theoretical, but it is one of the most practical chapters in SQL. Understanding transactions, ACID properties, and error handling improves system design thinking. It prepares you for production environments. It helps you answer senior level interview questions with confidence. It builds credibility as a data professional. Many people know how to write SQL queries. A very few truly understand how databases behave under failure, load, or concurrency. This chapter closes that gap. Now, let's summarize everything that we have covered so far. Transactions group multiple SQL operations into a single logical unit of work. Begin starts tracking changes. Commit saves changes permanently. Rollback cancels all changes. ACID properties guarantee reliability. Error handling protects data integrity. Transactions form the backbone of enterprise systems. If SQL were a building, transaction could be its foundation. Without them, everything collapses. And that brings us to the end of this chapter. And now we transition to the next one. Let's imagine you just joined a company as a data analyst or a business analyst, and your manager gives you one of these CSV file and say, we sell products across multiple regions. We run marketing campaigns. we generate traffic, leads, and orders, and I want you to find the insights that can drive revenue and reduce losses. That's exactly what this project is all about. In this module, we will build a complete SQL sales analytics project using real-world sales data. We will move step by step, just like the actual analytics rule does. By the end of this project, you will know how to analyze sales data performance using SQL, how to convert raw data into business insights, how to write interview-ready SQL queries, how to explain your analysis like a professional data analyst. Now, before we get started with data understanding and everything, let me show you a quick way to understand how to import data. So this particular data is from an Excel workbook, just as we discussed. So it can be either an Excel workbook or it can be an Excel CSV file. So this is my data. So we'll be having order ID, order date, delivery date, order status, and all those things. So if you observe closely, on each and every column ID, I have not left any spaces. You can either go with an underscore or don't leave any space, because in real world data analysis, if you're having spaces in between the column header names, then you might face issues while writing the queries. So for safe side, just understand one thing: no spaces in between the column header names. Okay. And then make sure you save this as .csv, because in SQL workbook, we import data in the form of .csv files. So that's one major thing. Now let me show you my data location. So we have data in the download section. Here we have the file. So if you save the same file in the form of .csv, this is how it's going to look like. There you go. And also you need to remember the files, the date files should be saved in the form of date, and the specific format should be year, month, and date, right? So let me go through the workbook and check if my data is according to my request. So here we have the data already. Let me also show you how to load it, not a worry. So there you go, we have the data in form of year, month, and date. So this is how you basically have the date files. So what I'm basically telling you is, before you load the data onto SQL workbook, when you have the opportunity to work on it on Excel, then why don't you use it, right? So most of the times, before you load the data, on any of the platforms, it can be a MySQL Workbench or it can be a data visualization tools like Tableau, Power BI. Make sure you clean the data and data is ready for analysis, right? So we've already gone through how to, change the data type of the column, how to change some elements, how to replace filter and all those things, right? So based on that analysis or based on that approach, you might have to work on the data cleaning first. And once you're satisfied with it, you can close and load the data. So now back to MySQL Workbench. So this is the location. And now if you come back to the MySQL Workbench, now here you can see the databases. You can select any of the schemas. So this is my schema. So here what I'll do is I'll go for an option which says data import or visit, right? From here, I have already given my location, or else if your location is in a different location, then you can just browse and go to the location and then just select the file, and here you go to the next option, and here you have the next, right? So you already have the table. So in case if you don't want to delete the table and import a new one, you can just cancel it. But in case if you want, you are exploring, don't worry, this particular data set will also be provided to you in the description box below. And if you want to just load the data, you can just proceed with it, and I'll use the existing. So I don't want to delete the data table. So this is how you basically load the data table. And in case if you want a little bit more clarity, I'll also drop a tutorial link in the description box below, which will explain you how to load data from Excel files. So that's the approach. Just right click, and here you go to the table data import wizard and just select the location where you have it and then load the data. That's basically it. And once you are loaded the data, what you can do is select the database. I'll just use interview database, and then here show tables. So these are the tables you have, and this is our data set, which is sales data, and you have an overview. And once you load this data, you might be having a few errors on the column names, sometimes, very rarely, 1 out of 100 cases. So I had an issue due to some spacing issue on the name. So I quickly changed this, but let me expand this. Yeah, I quickly expanded or selected the column name. What I did is I just copy the field name and paste it over here. So this was the initial field name, and I changed it to my requirement, which is order ID. And once you do it, the column header name from this got changed to the expected name, which is order ID. And now we start with the business analysis and questions and queries, right? So this is how you quickly load the data to the MySQL Workbench platform, and then you start with the business queries. So this was a basic understanding of how to load the data and understand what's present in our data. Now let's proceed to deep dive into the data set. So now comes the data understanding. Before writing even a single SQL query, the first thing an analyst does is understand the data. Our dataset contains the following key information. We have order level data, which includes order ID, order date, and delivery date, order status, such as it is delivered or cancelled. We also have customer information, which includes customer ID, first name, and the last name, which state or region he or she belongs to. Then comes the product and sales metrics, which includes product name, product category, product subcategory, the quantity of the product sold, cost to the company to make it, and the revenue details which we made out. And also we can have the profit column, and finally the marketing funnel metrics, which include the traffic number on the website or the store's site, and the total number of leads we had, total number of orders we received, and all those things. This tells us something very important. This is not just sales data. This is sales plus marketing plus operations data all combined together, right? So we have the sales data, which has product price, cost of the company, revenue, and all those details. And we also have marketing data, which is about leads, revenue, and traffic, and all those orders, and the product data as well. So this is a combination of all three of the data sets together. And most of the times what happens is these three different data tables will be stored in three different data modules altogether. So we also had data modeling part in this particular full course. So you can go through that once again to get a full detail on this particular aspect, right? So most of the times the data will be stored in different tables so that we maintain a schema of data sets. Most importantly, we follow the star schema, and all the other tables are related to one another through a foreign key, right? Using foreign key, we can combine different tables to the fact table. So here the fact table will be the orders data table or the sales data table, and product data, marketing data, and all those things will be the dimension tables. But now to eliminate the confusion and keep the project more simplistic, we have combined all this together in one single data table, and we have it in one table here itself. So this means we can analyze revenue, profitability, conversion funnel, regional performance, product performance, order cancellation, and all those aspects in one single go. That's exactly what companies expect from SQL analysts today. Now, the project problem statement. Let's clearly define our project goal. So the problem statement is analyze sales, performance, profitability, and marketing efficiency across different regions, products, and customers to identify revenue drivers and business bottlenecks using SQL. It is simple, clear, and business focused. Now, let's get started with the questions and their answers. So the first question. So I have already added the questions here to save time, and also the queries, and you can have this code documentation readily available for you in the description box below. So to follow up with me, make sure you copy the dataset and the queries document with you, and be ready with your SQL workbench so that I will explain you on the go what's happening here, and you can also follow along with me and run the query with me and get the output. And if you're getting anything different, or if you are facing any difficulty, please feel free to drop them in the comment section below, and we will address that as soon as possible. Now, the first question is, what is the total revenue, total cost, and total profit? Let's understand this a little bit more detail before we start with the solution approach. So now what we are doing is we are understanding total revenue, cost and profit, which is fundamental for any business. This analysis provides a snapshot of overall financial health of the company. Revenue indicates the total income generated from sales alone. Cost shows total expenses incurred while manufacturing that particular product. And profit reflects the net gain. Now, monitoring these metrics helps decision makers evaluate the business performance and identify whether operational strategies are generating the desired financial outcomes or not. Now, let's go through the approach design, right? The query aggregates the values of revenue, cost to company, and profit across all records using a sum function. Each aggregation is labeled with an alias for clarity. For example, we have total revenue, total cost, and total profit. This approach ensures we get a single summary row representing the company's overall performance. Now, let's go through the query. So, as discussed, we have the sum of revenue and we have aliased it as total revenue. And total cost to company is aliased as total cost, and total profit is aliased as total profit as here, right? And you already know what is the meaning of aliases. It's just an alternate name or the user defined name for your column names or the output, right? So this was the indentation followed. But in case if you are someone like me who likes to have all the columns in one line and the table name, and then get ahead with the indentation when you actually deep dive into queries, then this approach is fine for you. But in case if you are someone who is comfortable with naming the columns line by line, then you can follow the line by line approach. So this is the query that we will be executing now. So let's quickly execute this, and there you go. So you have all the details. So this is your total revenue, which is around 533 million, and the total cost is about 101 million, or is it 10 million? I think, yeah. And then we have total profit. So this was the total cost we invested, and this is the total revenue we generated, and this is the total profit that we made. So this is how you go ahead with the first question. And now we come across the second analysis for the day. So the second analysis or the second question of the day is, what is the monthly revenue trend? Now, let's understand this question. So this question is basically about tracking monthly revenue trends that help businesses understand seasonality, sales growth, and revenue fluctuations over time. By visualizing these trends, organizations can identify peak periods, forecast future revenue, and make informed marketing or operational decisions. So it's basically like if you're going through a Diwali festival or Dasara or Christmas or any of the Eid or any of the special days like Independence, Republic, right? So you can take out the seasonality of that special occasion and then boost up the sales so that making those offers look more lucrative and make some more sale out of it. So that's the overall business perspective of this particular query. So it helps in evaluating the effectiveness of promotions and campaigns across different months. Now let's go through the approach. So this is the query. Now let's understand or deep dive into this particular query. The query uses date format function to extract year and month from order date and then groups the data by this formatted month. The sum of revenue function calculates the total revenue per month. Ordering by month ensures that the result set follows a chronological trend, making it easier to interpret temporal changes in revenue. Now, let's quickly execute this query and see the output. So here you have the date format, which extracts the year and month as provided here. So you have the percentage Y for year and percentage M for month, and it is aliased as month. And here you have sum of revenue, and we have aliased it as monthly revenue from the table, which is sales data. So this is another approach where you write the query. So here the column headers or the column names are mentioned in line by line. So you can also follow this one, this kind of indentation or this kind of indentation. Both are good enough based on your comfort, right? And then we are grouping by date format and ordering by month. Now let's quickly execute this query, and we will be using the shortcut method, which is Control Enter, and there you go. So we have date and month wise analysis. So here we have 2021 data starting, and we are ending data with 2024. So this is the overall sales data. And here we have monthly revenue numbers. Now, let's proceed with the next question, which is about which product categories generate the highest revenue. Now, let's understand this question before getting started with the query. Now, the third question is about which product categories generate the highest revenue. Now, let's go through the explanation. Knowing which product categories contribute to the most revenue allows businesses to focus on high performing segments and optimize their product mix. It also helps in inventory planning, promotional strategies, and prioritizing resources towards categories with maximum financial impact. Now, that was the backstory behind this particular query. Now, let's go through the approach and query design. This query groups data by category, column, and calculates total revenue for each category using the sum of revenue function. The results are sorted in descending order to immediately highlight the top earning categories. This aggregation approach provides a clear ranking of categories based on their revenue contribution. Now, let's go through the query and understand what's happening here. So here, as discussed before, we have the following columns: category, sum of revenue, which is alias as total revenue from sales database. And here we have category. We are grouping them by category and we are ordering in descending order so that highest revenue numbers comes on the top and the lowest revenue numbers comes below, right? Now let's quickly execute this particular query. We've also been through the group by and order by filters. So you can go through that in the previous chapters. And now let's execute this. And there you go. So the category FMCG, furniture, home appliances, clothing and electronics are the top revenue generators. And out of all those, FMCG is the highest revenue generator, almost next to the furniture. So you can next time, so you can focus on these two categories so that you can earn maximum benefits. Now, let's go through the next question, which is about the top 10 products by profit. So the fourth question is about top 10 products by profit. Now, what's the explanation for this particular approach? So identifying the most profitable products is crucial for maximizing business margins. While revenue indicates sales, volume, profit, it provides insight to the financial efficiency of the products. Highlighting top products by profit helps prioritize marketing, production, and strategic investment decisions. Now, this was the backstory for this particular question. Now, let's understand how the query design and approach is for this particular question. The query first groups the records by product and calculates the total profit using sum of profit. Then we use order by to total profit in descending order and the products from the highest to lowest order. The limit 10, right? So we wanted to identify the highest number of products or the highest selling products, but we didn't have a limit here. So small improvement here. We want to find out the top 10 products, right? So if you want to find out the top n number of products, you can use limit clause and provide the n number. Let's say if you want top 5, then you can use limit 5. And in our case, we are using the limit 10 because we wanted to find out the top 10 products, right? So the limit 10 clause ensures only top 10 products are retrieved, giving a focused view of the most lucrative offerings. Now, let's go through the query and execute it. So here we have a product and sum of profit as total profit. And from sales data, we are grouping by product and order by total profit in descending order. And it is top 10, right? So limit 10. Enter. And there you go. So we have a washing machine, air conditioner, soap, headphones, and all the other top 10 products which are highest selling. So the next time in the marketing aspect, you can share this data with the marketing team so that they can run a couple of more ads and campaigns on washing machine, air conditioner, and soap so that by the end of the year, you'll have more profits in the upcoming sales analysis. Now, proceeding further, we have section B, which is about the customer analytics. And here, the first question or the overall fifth question that we are facing is, how many unique customers do we have? Now, let's go through the question a little bit more. So to deep dive how many unique customers we have, we are basically here trying to understand the size of customer base, and it is very vital for any business. It is vital for assessing marketing research and growth potential as well. Knowing the number of unique customers helps you segmenting audiences, target retention campaigns, and estimating lifetime value per customer. It also serves as a foundation for analyzing repeat business and customer loyalty. Now that we have a briefing on why this particular question is placed, let's go through the query approach and design. The query uses count of distinct of customer ID. So this is a part. So basically we have two aggregate functions here, the count function as well as the distinct function here to calculate the number of unique customers. This ensures that even if a customer has placed multiple orders, they are only counted once. This approach provides an accurate representation of the business actual customer base. Now, let's go through the explanation. So here, as discussed, we have distinct. First, we are filtering out the customer so that the customer ID is unique. There are multiple possibilities where one customer ID could have placed multiple orders, right? So multiple entries in rows. So what we're doing here is basically you're finding one repetition of each customer and then we are counting the total number of customers and aliasing them as total customers. And then we are selecting this from sales data. So let's quickly run this query and there you go. We have about 3,216 unique customers in our data set and these might have place multiple orders. So the overall count of rows could be a little different. Now, let's proceed with the next question in our customer related queries. So the next question is, which states contribute to the most revenue? So let's deep dive into this question a little bit more. So identifying revenue contribution by state helps businesses understand the geographical performance. It highlights high performing regions that can be targeted for growth and underperforming states that may need marketing support or operational improvements. This analysis is crucial for regional strategy, distribution planning, and resource allocation. Now that we have a brief understanding of why this question was asked, let's go through the query approach and query design. So this is our query. Let's understand this a little bit. The query groups sales records by the state column and sums the revenue of each state using the sum of revenue function. Results are ordered in descending order of revenue to immediately identify top performing states. This aggregation approach provides a clear picture of geographical revenue distribution. Now let's quickly run the query and see the output. So as discussed, we have state here and sum of revenue as total revenue alias and table name. So we are here trying to perform a group by function and we are ordering revenue in descending order. And in case if you are having that question, can we find out the top 5 performing states? Yes, we can just limit them by 5 and we will have top 5 states here: Telangana, Odisha, Delhi, Maharashtra and Kerala. And if you remove this particular limit function, you will have the entire states list right here, right? So all the states and their performance. Now with that, let's go to the next question, which is the 7th question and 3rd question in customer analytics. So here we are trying to find out average revenue per customer. Before we execute this query, let's go through a little bit more deep dive into this particular question and why this was being asked from an interview perspective. So average revenue per customer. Why this question is asked? Average revenue per customer, or in short, ARPC, measures the value each customer brings to the business. It is an essential metric for evaluating customer profitability and effectiveness of sales or marketing strategies. Higher ARPC indicates better monetization on the customer base and helps in targeting premium customers. Now that we have an understanding why this question is being asked, let's go through the approach in solving this question and the query design. The query groups data by customer ID and calculates the average revenue using average revenue function. This approach ensures that we get per customer data view of revenue and highlighting differences in spending patterns across the customer base. Now, let's go through the query and execute this. So as discussed, we have customer ID, average revenue as average revenue per customer aliases, and we are grouping by customer ID. Now, let's execute this query and see the output. So here, based on their revenue, here we have the highest spending or the average spending of each customer, right? So there are a few customers who have been registered onto the website, but so far they haven't made any sale or purchase from our website. And apart from that, we also have a few customers which have already placed some orders, and there are a few customers who are repeated, and there are a few premium customers as well with the highest number of sales from the website. Now, we enter into the next section of this particular project, which is about regional performance analysis. So, in the regional performance analysis, we have the eighth question or the first question in this particular part, which is about revenue contribution by region. So, let me scroll this a little. This is our question and the quit. Now, let's go through the question and understand a little more detail why this question is being asked. Now, revenue contribution by region is very important. Regional revenue analysis provides insight into which areas generate the most income. This helps in strategic planning for expansion, marketing campaigns, and allocation of sales resources. It also identifies strong and weak regions to improve operational efficiency. Now that we have a briefing on why this question is being asked, let's go through the approach on what basis this question can be solved and the query design. The query groups the dataset by region and sums the revenue column. This aggregation ensures each region total revenue is calculated, providing a concise overview of regional performance. Now, let's go through the query and execute this. So, as discussed, we will be having region and summation of revenue and alias as total revenue from sales data, and we are grouping by region. Now, let's execute this query, and there you go. So, we have overall country-wise East region sales revenue, West region, Central region, South, as well as North. So, region wise, these are the sales numbers. Now, let's dive into the next question, which is about profit margin by region. So, this is our question and query. Before we execute the query, let's understand what is the meaning of this question or what's the reason behind this question and understand the query approach and design. So, profit margin by region is really important. Understanding profit margins at the regional level helps businesses assess operational efficiency and pricing effectiveness. A region might have high revenue but low profit margins. This indicates cost ineffectiveness or discounts impacting profitability. Now, this was the reason behind why this question was asked. Now, let's discuss the approach to solve this question and what does the query decide. The query calculates profit margin using the formula, which is sum of total profit divided by sum of total revenue into 100, which is named as profit margin or alias as profit margin from sales data. And we will also be using a filter function here where revenue should be greater than 0, which ensures division by 0 is avoided. Now, along with that, we will be using a round function, which enhances the readability of percentages. Now, let's go through the query and execute this. So here we have it. So we are selecting the region column, and then here is the function or the mathematical calculation, and we are aliasing it as profit margin percentage from sales data. This is the filter that we were talking about. Revenue should be at least greater than 0, right? And you can have at least 1% revenue, but it shouldn't be 0. That's why we have using this filter, and we are grouping by region. Now let's execute this query and see the output. There you go. So we have East region profit percentage margin, South, North, West, Central, so on. So these are the profit margins here. Now we dive into the next section, which is marketing funnel analytics. Let me point this out. This is very strong analytical section and great for interviews. And in this, the first question we have is traffic to lead conversion. Most of the times, if you are a business analysis aspirant or a data analysis aspirant, or you're already working in business analytics or data analytics, then these are the most common figures that you will be listing or saying in your meetings. Traffic to lead conversion, lead to order conversion, right? So these are some important things that you go through in interviews or in a business analyst day-to-day life, right? So this is one such question, traffic to lead conversion rate. Now, let's understand the business aspect behind this particular question. And along with that, we'll also see why this question was being asked and what's the solution to this particular question and what's the design of the query. So traffic to lead conversion is critical. Conversion from website or store traffic to leads show how effectively marketing channels are capturing potential customers. This metric helps evaluate campaign efficiency and the quality of the visitor engagement, forming a critical part of marketing analytics. Now, let's go through the approach to solving this question and also the query design. The query sums the total leads and traffic across all records and calculates the conversion rate as leads divided by traffic into 100. And we also use a round function to format the percentage. Aggregation across the dataset provides an overall conversion insight. Now, let's go through the query and execute this. So, as discussed, we will have the function sum of leads divided by sum of traffic into 100, and we are giving a round function as well. So we are rounding up the decimal values to 2 decimal values, right? So this is the total function here, and we are aliasing it as traffics to leads conversion percentage, and we are selecting this data from sales data, right? So let's execute the query, and here we have the output. So traffic to lead conversion is 10%, which is pretty decent. Now, along with that, let's go to the second question, which is about lead to order conversion, right? So the traffic will be on your website, and if your marketing is really good, then they convert into a lead which show interest in your product, right? And we want that lead to convert into an order. That's the critical point, right? So this is the intention behind asking this question. Anyways, let's deep dive, right? And after that, we'll also go through the approach. Lead to order conversion indicates the effectiveness of sales process. It measures how potential customers, basically leads, are successfully converted into paying customers which place an actual order. This is basically done for highlighting areas for sales optimization. Now let's understand the approach to solve this question and the query design. The query sums orders and leads where leads exist and calculate them as orders divided by leads into 100. We also use a where clause as a filter where it filters down the leads having number greater than 0, and this condition avoids division by 0 errors and ensures the calculation is meaningful for relevant data points. Now, let's go through the query and see the output. So this is where we had the total orders divided by total leads into 100. And we also have the round function here where we will have the decimal values limited to 2 numbers, and we are aliasing it as lead to order conversion. And leads filter here, it should be greater than 0. Now, let's execute this query and see the output. So lead to order conversion is somewhere around 0.9%. Now, with that, let's move into the next question, which is about overall funnel conversion. So traffic to order is this particular aspect. Now, let's go through the intention behind asking this question. Traffic to order is also one of the important aspects. The overall funnel conversion rate reflects the efficiency of the entire marketing and sales process. From attracting traffic to closing orders, it's crucial for evaluating end-to-end performance and return on investment of campaigns. Now, let's go through the approach to solve this question and query design. The query aggregates total orders and traffic and calculates orders divided by traffic into 100. This approach summarizes the overall funnel efficiency, giving leadership a clear metric of conversion effectiveness. Now, let's go through the query. So here we have it. So we will be dividing total orders divided by total traffic and into 100. And here we have a round function as well to limit the decimal values to 2. And we are aliasing it as overall conversion rate from sales data. So let's quickly execute this query to see the output. So overall conversion rate is somewhere around 0.09%. So this is some serious issue. So we need to focus more on sales and marketing. Don't worry, this is not a real sales data. This is an actual data which we created for learning purposes, right? So the real business data might vary a lot, but it could be also a reality where the conversion rate is really falling and you need to focus on improving, right? In the initial stages, any business might have weak performances, but down the line, if you are someone who's really good with analytics, then you can help the company to grow, right? That's the overall perspective. Now, let's dive into the next question, which is about funnel performance by category. So why this particular question is being asked? Now let's go through that. Analyzing conversion by product category helps identify which product lines convert visitors into buyers most effectively. This insight guides marketing focus, inventory allocation, and promotional strategies. Now that we understand why this question is being asked, let's go through the approach to solving this question and the query design. The query groups data by category and calculates conversion as total orders divided by total traffic into 100. Using grouped aggregation allows comparing performance across categories and identifying high and low performing segments. Now, let's execute the query. So as discussed, we have the category and the function of total orders divided by total traffic into 100. And we are rounding this particular number as two decimal values using the round function. And we are aliasing it as conversion rate. And we're extracting this data from sales data and we're grouping by category. Now, let's quickly execute this query. So we have electronics, clothing, home appliances, FMCG, furniture. So far we have furniture and FMCG as the highest performing categories, and the conversion here is really good. Now, rest of them needs a little more attention. And with that, we enter the fifth segment of this particular analytics, which is order and operations analysis. In that, we have the 14th question as our first question, and it is about order status distribution. Now, let's deep dive what's the meaning of this question, and along with it, we'll also go through the solution approach and the query design for this question. So order status distribution is really important as well. Understanding the distribution of order statuses, which is delivered, pending, cancelled, etc., provides visibility into operation performance and customer satisfaction. It highlights bottlenecks and potential service issues. Now that we have a brief understanding of the question, let's go through the approach in solving this question and the query design. The query here basically groups by order status and counts the number of orders per status using count star function. This gives a simple frequency distribution, making operational insights easy to interpret. Now, let's go through the query and execute it. So as discussed, we have the order status and we are counting the total number of orders and we are aliasing it as total orders from sales data grouped by order status. So we might be having a delivered, cancelled, pending, something like that, right? Based on that, we will be grouping it. So we have 997 delivered, 986 cancelled, and 1013 written, and 980 pending. So these are the statuses of our products so far. Now that let's dive into the next question, which is average delivery time for delivered orders. So if you go back to the data set, you might have seen order date, delivered date, and as well as we have created another column which says time to be delivered, right? So it is basically the time difference between delivered date and ordered date. Let's say we have 5 days of difference between the ordered date and delivered date. So we are trying to, okay, before we solve this question, let's understand why this question is being asked and what's the query design, right? That is the basic approach before you start to write any query. You need to understand the question. And if only you understand the question, then only you can design a perfect query for that. So let's understand the question. So average delivery time for delivered orders is basically measuring average delivery time that helps evaluate logistics efficiency and customer satisfaction. Faster deliveries usually correlate with better customer experience and retention. Now, let's understand the solution approach and query design. The query calculates the average difference between delivery date and order date using the average date diff function. For orders marked as delivered, filtering ensures only relevant orders which are completed are included and rest are ignored. Now, let's go through that. So here we, before, the previous question, we had cancelled, return and pending, right? So here we are specifically filtering out the delivered products only, right? So once we have the data of delivered orders, and based on that, we can find out the order date and delivery date of that particular product and find the difference. And once the difference is found, we will have multiple rows of number of dates, and that particular rows will be filtered out using an average function, right? Let's consider 10 rows. One product might have taken 5 days to deliver, one might have taken 3 days, one might have taken 2 days, one might have even taken 7 days, right? So out of all those 10 entries, we will find out an average of 10 days, 7 days, 3 days, 6 days, etc. And then we will have a final number. So you can declare that as this is the average time that we are taking to deliver one product to a customer. Now let's execute this query, and there you go. So on an average, we are taking about a 5.99, or we can consider 6 days on an average to deliver any product from the inventory to the customer. So on the application or on the website, you can confidently mention within 6 days, your product will be delivered to you, right? Now that may help you in retention, right? So customer might feel happy that within 6 days, I'll be receiving this product. That's the basic approach behind this question. Now we have the question which says or speaks about cancellation rate, right? Now, why this question is being asked and how do we solve this? Let's understand that. Cancellation rate measures the proportion of orders that did not complete successfully. High cancellation rates indicate potential operational issues, product dissatisfaction, or a pricing problem. Now that we have understood the concern behind this question, let's understand the approach to solve this question and the query design. The query counts cancelled orders using a case statement inside some function and divides by total orders. Next comes the round function, which formats the result as a percentage, giving a clear view of order cancellations. Now that we have a clear understanding of how this question can be solved, let's go through the query and solve this particular question. Here, let's dive with this particular case. So we are using cases here. Now, when case order status is cancelled, then 1, else 0. So in the previous chapters, we have also been through cases. And this gets divided by count of staff into 100. And the decimal value is limited to 2 numbers. And this is aliased as cancelled rate. And now let's execute this query. There you go. So the average cancellation rate we have is 24% as of now, which can be reduced based on improving the product quality and decreasing the days to deliver and basic things that we discussed now, right? Now, let's go ahead with the next question, which is the 17th question. And a new section is also allocated here, which is about profitability analysis. Now, in this particular profitability analysis section, the first question we have is profit margin by product category. Now, let's understand the question. Profit margin by product category is basically about evaluating profit margin by product category, which helps identify high margin product versus a low margin category or product. This informs pricing strategies, product focus, and profitability optimization. Now that we have a briefing on the question, let's go through the approach to solving this question and the query design. The query groups by category and calculates the total profit divided by total revenue into 100. And we will be filtering out by revenue, which should be greater than 0, which avoids invalid calculations. And finally, we'll have a round functions, which ensures clarity in presentation. Now that we have a briefing on the approach, let's go through the query and execute this. Now we are trying to find out the profit margin by dividing the total profit by total revenue. And we have a round function to minimize the decimal values to 2. And we are aliasing it as profit margin. And here you see we are filtering out the revenue should be greater than 0 and we are grouping by category. Now let's quickly execute this query and see the output. So here we have all the categories and their profit margins as well. And you can also add another query which is order by descending. So we have FMCG on top and the rest of them in following in the next, right? We have clothing in the next section, home appliances in the next section, and so on. Now we have the next question, which is the 18th question in this section, which is about loss-making products. Now, let's go through the intention behind asking this question. So, loss-making products is nothing but identifying the products that generate a little or negative profit. This helps businesses optimize their portfolio by removing or repositioning loss-making products, and this can make significant improvement in overall profitability. Now we have understood the intention behind this question. Let's understand the approach to solving this question and the query design. The query basically groups by product and sums profit, and we are using having by clause where the total profit should be less than 10. And this filters the underperforming products. This approach directly highlights the items contributing minimally or negatively to profits. Now that we have a briefing on the approach, let's go to the query and solve the question. Now, as discussed, we have the sum of profit from sales data, and the filter having profit less than 10 is the filter or the query here. And now let's execute the question. So far, there are minimum products which are underperforming, those, or you can also change to 2 and find out if there are any products which are even now. So it's good enough. Maximum number of products that we have in our inventory are not underperforming, right? So that's a good news. Now, with that, we enter into the next section, which is advanced analytics, and it makes you a little ready for interviews. Now, inside that, we have about two questions more, and out of which the first one is top five customers by lifetime value. Now, what does this question mean? Now, let's highlight the query and understand what's the intention behind this question. So top five customers by lifetime basically means the lifetime value or LTV, which qualifies the total revenue as a customer brings over time. Identifying top customers by LTV helps prioritize retention, loyalty programs, and personalized marketing strategies. Now that we understand the intention behind this question, let's go through the approach and query design to solve this question. The query groups by customer ID, sums revenue per customer, orders the results by lifetime value in descending order, and limits the output to top five customers. This highlights the highest value customers most efficiently. Now that we have understood the approach, let's go back to the query and execute this. So here we have minimum customers. Yeah. So these are your high value customers, which gave you about so much revenue. 1,71,000, 140,000, 120,000, 117,000, and 117,000. So these are the top five customers which have your highest lifetime value. So here we have the sum of revenue as lifetime value and customer ID. And we are grouping by customer ID and we are ordering lifetime value in descending order. And we have the limit 5, right? So which reduces or filters out the top 5 performing customers. Now we have the last question in this particular project and the second and last question in this particular section of advanced analytics. So this question is about repeat customers versus one-time customers. Now, what do you mean by repeat customers versus one-time customers? So let's understand this question. So repeat customers versus one-time customers differentiates repeat and one-time customers is crucial for retention analysis. Repeat customers indicate loyalty, while one-time or high one-time orders may point to marketing but weak retention. Now, this was the intention behind the question. Now, let's go through the approach in solving this question and the query design. The query first calculates order counts per customer in a subquery. Using a case statement, it classifies customers into repeat or one-time, grouping the customer type, and counting provides a clear comparative distribution. Now, let's go through the query and execute it. As discussed, we have case statement here. So if the order count is greater than 1, then it is referred as repeated customer. Else, it is referred as one-time customer. And the case ends here, right? And now we will count the total number of repeated customer and we'll also count the total number of one-time customers. And from there, we will select the customer ID, order count, and then we group by customer ID, right? So this particular query is encapsulated inside an outer query. So this is the inside query and this is the outside query. So if you have any doubts in subqueries, you can go back to the subqueries chapter and go through that once again. Now, finally, we will group by the customer type and then we will have the total number of repeated customers and the total number of one-time customers. So let's quickly execute this query. So there you go. We have 2,574 one-time customers and 642 repeated customers. And that brings us to the end of this session on the SQL data analysis project. And now we will proceed to the next section. Now we enter module 13, which is basically about framing SQL as an analytics tool. Up until now, we have been using SQL primarily to fetch data. But in this chapter, we will shift our focus. We are going to use SQL as a powerful tool for analysis. This is the difference between someone who knows SQL syntax versus someone who can drive business decisions using SQL. So, what does data analysis in SQL really mean? It's about comparing values to identify patterns, creating categories for better insights, ranking records to spot top performers or priorities, tracking change over time to understanding trends, finding patterns directly in SQL without exporting to Excel. This chapter is essential for anyone in analytics roles, including data analysts, business analysts, product analysts, BI developers, writing analytics queries, and a lot more. Now, let's get started with what is an analytical query. An analytical query is more than just fetching data. It is designed to aggregate information, compare results across groups, identify trends and patterns, answer why something is happening, not just what is happening. For example, you might want to ask who are the top performers in my company, which customers bring the most value, how is revenue changing day by day. Now that we have understood the basic fundamentals of this particular chapter, let's get started with the analytical queries. Now, starting with the first one, salary analysis. And the business question here is, what is the average salary per department? Now, here we will understand the group by, which allows us to define the level at which we want to analyze the data. The aggregation functions like average convert raw rows into meaningful insights. Now that we have the basic understanding, let's go through the query. Now here, this was our first analytical query, which asks one question: what is the average salary per department? Let me expand this particular area. Yeah. So here, what we're trying to do is we are trying to identify the department name, and we're using the average aggregate method to identify the average salary, and we're aliasing this as average salary. And we're extracting this from the employees table E, and we are trying to join with departments table D, and we are joining the tables based on the department ID from employees table and departments table, and we are grouping by department name, right? So based on this query, we will be getting the department names in the table and their average salaries. Now let's quickly execute this query and see the output. Now based on the query, we are having HR as 60,000 average salary, engineering as 1 lakh 8,000 as average salary, finance as 95,000, and marketing as 80,000. Now, let's go into this second analytical query, which is about how many employees were hired per month. Now, let's understand the question here first. So, business question here is how many employees were hired in each month? The real world relevance. This analysis is used in HR planning and workforce forecasting. Now that we have understood why is this particular question is being asked, let's solve this. Now in the query, we have date format. Here, we are extracting percentage %y, which stands for year, and percentage %m, which stands for m. Now based on this, we are hiring employees and we are using count star, and we are aliasing this as hires, and here we are aliasing the date format as hire month. And we are grouping by hire month and order by hire month. Now, let's execute this query, and there you go. And in case you want to, uh, order by, add some more value to this, you can order by descending, and which gives you December and November were the highest hiring months, and this is our answer. And now let's proceed with the next analytical query, which is right here on my screen, customer order frequency. Before we execute this query, let's understand the key aspect, why this is a question here and how do we solve this. So customer order frequency basically gives one business question. How often do our customers place orders? Now, what's the business meaning? This query helps identify repeated customers, which is critical for designing loyalty campaigns. Now, let's go to the query. Here we have the query, and here we have the customer ID count as star as total orders from orders data table, and we are grouping by customer ID and order by total orders in descending order. So once we execute this query, here we have our output. So these are the customers and their total orders. Customer number 2 is a repeated customer and the total orders placed by him or her are 4. Next is customer ID 1 and he or she placed 3 orders and so on. Now we get into another example, which is case example salary banding. Now the business need clarify the employees into salary ranges or classify the employees into salary ranges. Let's select the query. This is our query. Now let's understand the intention behind this query. Using case statements in select. So what is a case in SQL? Think of case as a sequence version of if-else logic. It allows us to create categories, apply business rules, convert numeric values into readable labels. Now, case example, salary banding. Now, what is the business need here? We need to classify employees into salary ranges. Why analysts love case? So we have some answers for that. It eliminates the need for pre-processing. You can perform clean categorization directly inside SQL. Now let's go through the code. So here we have the case. So when salary is greater than or equals to 1 lakh, then deem it as high. And when salary is greater than or equals to 70, then deem it as medium, else consider it as low. And the case ends here. So this is our case statement. And we will alias this case as salary band. And we will be extracting name of the employee, salary details of the employee, and the case result of the employee from the employees data table. Now, let's execute this query and see the output. So we have Alice, Bob, Charlie, David, and Eve, and their salary numbers, and their salary band falls in medium, high, so on, as described in the case statement here. So Frank is having low salary, and Ivan is having low salary, or in case of low, you can also tag them as new recruits or freshers or interns, right? Now, with that, let's move into another example for case, which is department-wise salary labels, which is basically a similar approach, right? But still, let's go through the question once again. So the example 2, which we have about department-wise salary labels, which is basically none other than the same question. So let's go through the query here once again. But there are a few differences. In case of salaries, we have the department-wise details here. If department ID is equals to 2, then tech department, department 1 is equals to support department, and others, right? So this query is basically designed just so that you understand how case actually works in real time, right? Now let's execute this query and see the output. So here we have the same name of the employee, department ID. And if the department ID is 2, then we have the tech department. If it is 1, then the support department. If it is anything other than the tech and support, like marketing, software engineering, etc., we will deem it as other, right? There you go. Now let's also go through another example in case so that we have a comfortable understanding. So here the example is about customer segmentation. Now what's the business aspect of finding out this particular answer? Now let's go through that. Let's select or highlight the query first. So what's the business question, right? Which customers are high value and what's the industry usage? It is used in CRM segmentation, marketing, target, and revenue prioritization. Now let's go through the query. So here we have the case statement. So this particular one is the case statement where count is greater than 4 or greater than or equal to 4, and it is high value customer. Greater than or equal to 2, then medium value customer. If it is greater than or equal to 1 or less, then low value customer. This is aliased as customer segment, and we are counting the total orders here and the customer ID. We're extracting the customer ID from orders table and group by customer ID. Now, let's execute this query. Control Enter. And here we have the customer ID and total number of orders they have placed. So if it is greater than or equal to 4, high value, greater than equal to 2, then it is medium value. And the other one is else, low value, right? So this is how you execute the customer retention things, right? Now we have the next function, which is a row number. Now out of which one example is rank employees by salary per department. Let's highlight the query first and then understand the intention behind this function and how do we use it. So before we move into the next function, which is row number, I want to quickly deliver one interview tip for you. So if ever someone asks you to explain about case, then consider two things, right? The bad explanation of case could be this one. Case just replaces if. No. Yeah, I agree that I told if is a replacement for case in SQL, but there is a difference, right? It was given for a quick understanding of the difference. But in interviews, that's the reason why I'm giving this tip to you. In interviews, when someone asks you to explain about case in SQL, then you can go with this strong explanation where instead of just saying it as a replacement for if, you can say case enables rule-based categorization directly in SQL query. If you have gone through our codes here, you can see we have different categories, right? If there is something happening in the dataset, then deem it as or categorize it as under this particular value. And similarly, if something is happening here, category in this particular aspect, and so on, right? So it is just another categorization tool where it compares the values and based on the results, it categorizes. This is the perfect and strong explanation of case in interviews. Remember that. So in the beginning, we said it is just a replacement for if. It is just said so that you have a quick understanding. It's not the final answer. Remember this. Now we enter window functions, which is the core of data analytics. Now, what are window functions? Window functions allow you to perform calculations across related rows without collapsing the data, unlike group by. Why window functions matter is your next question. Now, without window functions, you often need complex subqueries and multiple joins, which hurt performance. With them, your queries get cleaner, faster, and more readable. So, one such window function is row number. Now, what does row number function do? It assigns a unique sequence number within a group. For example, rank employees by salary per department. Now, what's the business usage of this particular question? It identifies top performers duplicating records, picking the latest records. Now, let's go through a sample query here. So here on my screen, you can see a sample query where we are selecting the customer ID. They're counting them as total orders. Okay, this was a previous query. Yeah, here we have the row number. So this was the example, rank employees by salary per department, right? So here we have the employee ID, employee name, department ID, and their salary. And here we have the row number function over partition by department ID, order by salary descending as salary rank from employees. Now let's quickly execute this query, and there you go. So based on salary numbers, we have rank 1 and 2 and 3, 4, and so on, right? Now, we will have a quick comparison between rank function and dense rank function. And we'll also go through an example which says department salary ranking. Now, let's highlight the query and then we will try to understand the business requirement or business behind this particular functions. Department salary ranking, right? Rank skips the numbers if there's a tie. Dense rank, on the other hand, does not skip any numbers. That's the basic difference between rank and dense rank. Now, let's execute this query and see the output. So, there you go. So, there are no rank gaps like we had in the rank, right? Here in the dense rank, we don't have those gaps. Now, we have another window function, which is lag function. It assesses previous row data. And we also have a quick example for this here, day over day sales comparison. Let's highlight the query. Now, let's understand the business behind this function. Lag method assesses data from a previous row. For example, day over day sales comparison. Now, the business insight. Growth analysis trend is one business insight where you can implement the lag method. Now, let's go through the example. So, here we have the lag amount over the order by date and the previous day sales. Now, let's execute this query and see the output. Now, the daily changes are written in the last column and the previous day sales are here and the total amount is here. Now, the next function is lead, which is assesses next row data. Now, let's highlight the query. Now, what is lead method? It assesses data from the next row. What's the use case? It is used in predictive comparisons, performance tracking, and much more. Now, here we have a query for quick understanding. And let's execute this. And there we have the output. Now, the last one in this particular segment is the running total. So, running total window function, which is basically from advanced analytics. Let's highlight the query and now understand the business insight of this particular window function. So, this particular window function is used in financial dashboards, KPI tracking, investor reporting, and a lot more. Let's quickly execute this query and see the output. There you go. So, we have the outputs over here. Now, let's have a quick follow-up of all the window functions. Case statements, window functions, analytical thinking in SQL. You are no longer a beginner. This chapter prepares you for data analyst interviews, building business dashboards, solving real world analytics problems, and a lot more. With that, we have come to an end of this module, and now we transition to the next module. So, the first question is, what is the difference between SQL and DBMS? To understand this question at a professional level, learners must internalize that SQL and DBMS serve two completely different roles, yet they work together tightly. SQL, or structured query language, is a standard communication language. It is the vocabulary and grammar we use to talk to a database. We can write select star from customers. We are simply sending a request. We don't actually store data using SQL. We don't manage files using SQL. We don't enforce security using SQL. All of that is the job of DBMS. A DBMS, or database management system, is a fully fledged software that handles how data is stored internally, how it is indexed, how users access it, how security rules are applied, how concurrency is handled, how backups and recovery work. So SQL is just the language, while DBMS is the system that understands and executes that language. So, a helpful analogy: SQL is the remote control, and DBMS is the TV that responds to the button presses. Without TV, the remote accomplishes nothing. Without remote, the TV cannot receive instructions. Now, let's go through some examples to strengthen the understanding of SQL Server. SQL Server uses eSQL, Oracle uses PL/SQL, PostgreSQL uses PostgreSQL, Dialect MySQL uses its own SQL variant. So, SQL sits inside a DBMS the same way a steering wheel sits inside the car. It's necessary, but not enough to make the car move. Now, the second question: explain primary key versus unique key. This question helps interviewers assess whether you understand how relational databases maintain identity and prevent duplicate records. A primary key is the central identifier for a row. It is the official identity card of each record. Before that, a primary key must meet two conditions. The first condition is uniqueness. No two rows can share the same ID. Second one, not null or non-null. Every record must have an identity. A unique key, on the other hand, enforces uniqueness but does not define the identity. It's more of a constraint that ensures no duplicates are allowed here. So the key difference is primary key is equals to strict, no duplicates, no nulls, only one per table. On the other hand, unique key is equals to flexible, no duplicates, allows a single, multiple allowed tables analogy. On the other hand, unique key, which is equals to flexible, no duplicates allowed, a single null, multiple allowed. Now let's go through a table analogy. Imagine a table analogy. Imagine a table called employees. Primary key is employee ID, unique keys are email, phone number, and every employee must have an ID. But emails simply must be unique to avoid any conflicts. This distinction keeps data clean, consistent, and logically structured. With that, we move into the next question: what is a foreign key and why is it important? A foreign key is the glue that holds relation databases together. It connects tables exactly the way real-world relationships links entities. A foreign key in one table refers to primary key in another. This enforces referential integrity, meaning you cannot insert an order for a non-existing customer. You cannot delete a customer still referenced by others. You cannot break relationship chains accidentally. Now let's go through a real-world analogy. An order referencing a customer is a passport referencing a citizen. The relation must be valid. Without foreign keys, datasets become chaotic. Broken relationships, missing references, incorrect reports, often records. Foreign keys keep the database accurate, safe, and logically consistent. Now, the fourth question: difference between where and having. Now, this is one of the most commonly tested SQL concepts because it checks your understanding of query execution order. Let's start with where. Where clause filters rows and applies before the group by function. It cannot use any aggregate functions. For example, where salary is greater than 50,000. Having clause, on the other hand, filters groups after group by function is applied. It can go with aggregate functions. For example, having count greater than 3. Now, let's have a mental model mapping. Imagine organizing employees by department. Where clause filters individual employees before grouping. On the other hand, group by forms the groups. Next is having clause. Having filters the groups themselves. This conceptual clarity helps avoid mistakes in analytical SQL. With that, we jump into the question number 5. The question number 5 is about the difference between inner join versus the left join. Joins reveal how well someone understands relational thinking. Inner join returns rows only when both tables have matching values. Left join returns all rows from the left table and matching rows from the right table. Missing matches become null. Now, let's have a mental visualization. Let's have a Venn diagram. Inner join is equals to intersection. Left join is equals to entire left circle with intersection. Now, let's go through a practical example. For inner join, let's consider customers who made some purchase. For left join, all customers, including those with zero purchase. This distinction is essential for building BI dashboards, performing retention analysis, or generating financial summaries. Now, let's dive into the question number 6. What is normalization? Normalization is the process of structuring data to reduce redundancy and improve consistency. So, we have a few types of normalization. So, the first one is 1NF, no repeating groups. So, atomic only values are stored here. The second one is 2NF. It must be in 1NF, removes practical dependencies. The third one is 3NF, must be in 2NF and removes transitive dependencies. Why normalization matters? Normalized data avoids duplicate information, updates anomalies, inserts anomalies, deletes anomalies. So the database remains scalable, clean, and reliable. Now let's enter into the question number 7. What is denormalization? While normalization focuses on structure, denormalization focuses on performance. It intentionally introduces redundancy to reduce joins, lookups, computation time. And now comes the question where it is used. It is used in data warehouses, BI reporting, OLAP, star schemas, etc. Now let's consider a small analogy. Normalized is equals to highly organized data library. Denormalized is equals to popular books placed at the entrance for quick access. You trade structure for speed. Now we have the 8th question. What is a subquery? The answer, a subquery is simply a query inside another query. It is used to answer more complex questions. Where subqueries help is your next question. It helps in dynamic filtering, ranking, and comparisons. Apart from that, it is also used in conditional validation, nested logic, and a lot more. A few examples to consider: finding second highest salary, checking if a value exists in another table or not, filtering based on aggregated criteria. Subqueries increase the expressive power of SQL dramatically. And with that, we dive into the question number 9. What is an index and why is it used? Indexes are crucial for database performance. Let's go through an analogy. Think of an index page in a book. It helps you jump directly into the right content instead of flipping every page. What indexes do? Indexes accelerate select queries, improve filtering and joins, enable fast ordering and grouping, but they come with a cost. Slower inserts, updates, because index must be updated. Increased storage usage. Indexes are one of the first performance optimization tools. Every SQL developer must understand them. Now, with that, let's dive into the question number 10. Question number 10 is, what is ACID compliance? ACID, or simply called as atomicity, consistency, isolation, and durability for the full form. It ensures reliability and predictable transaction processing. Atomicity is the first one. All steps succeed or none do. Second one, consistency. The database remains valid after each and every transaction. Next is I for isolation. It stays concurrent transactions do not interfere. Last is D for durability. It changes, survive, crashes. These principles make transactional systems trustworthy, especially in banking, e-commerce, ticketing, and ERP systems. With that, let's dive into the 11th question, delete versus truncate versus drop. Now, these commands all do the same thing. They remove the data, but with crucial differences. Delete is row level removal, logged slower, can use where, and can be rolled back. Truncate does not use where clause and mostly it is irreversible. The third type is drop. It removes the entire table definition and data and it is completely irreversible. This distinction is extremely important for safe database operations and disaster recovery. Now let's move into the 12th question. So the 12th question is, what is a view? A view is a virtual table based on a query. Why views are used? It is used to hide complex joins, improve security, simplify repeated logic, provide abstraction layers. Views are heavily used to enterprise applications and BI too. Now with that, let's dive into the 13th question. What is a stored procedure? Stored procedure is a pre-compiled blocks of SQL that sits inside the database. Benefits: reusability, security, consistency, reduced network load, better performance, and many more. They allow complex business logic to run close with the data. Now we have the 14th question. What is the difference between char versus varchar? Character has fixed length storage. On the other hand, varchar has variable length storage. Char is ideal for country codes, gender, etc., which has mostly the fixed identifiers. Varchar is ideal for emails, names, addresses. Understanding this distinction leads to better storage optimization. Now, the last question in the theory section. What are window functions? Window functions allow you to perform calculations across rows while preserving individual records like group by, which collapses rows. Most common window functions are row number, rank, dense rank, lag, and lead, sum, over, average, over, and a lot more. Where they are used is your next question. We can use them in running totals, moving averages, trend analysis, time-based comparisons, leaderboards, cohort analysis, and a lot more. Modern SQL exams and interviews test window functions heavily because they reflect practical analytical skills. Now comes the next part of these interview questions where we will be dealing with practical query-based or scenario-based questions and answers. So now we are in the scenario-based or practical query-based interview questions and answers. So let's go through the questions and answers quickly because we will be creating a new table, entering the data. After that, run the queries. So let's go through the questions and answers quickly. So first we have the fetch the second highest salary from the employee data table, and we have the answer here. It uses a subquery to exclude the highest salary and extract the next one. Now the second question is retrieve employees who have no department assigned. So this is the answer for it. It uses left join to identify unmatched rows. So what we are currently doing is we have a list of 10 interview questions and answers. So we'll quickly run the PowerPoint presentation and have a quick analysis on what we are going to face and how are we going to answer the question. And you can see the last line, right? This particular last line gives you a small hint of the logic we are going to implement. So once we are happy with all the overview of all the questions and answers, and then we will create new data tables. And inside the new data tables, we will add new data entries and then start question by question and run our queries and extract the outputs that we are looking to. Now, the next question in the list is find duplicate email IDs in the table. And after that, we have display the top 3 highest paid employees. So here we have order plus limit, where we will limit the output to only 3 rows. And then we have count orders per customer. We will be using a count function here. Then get employees whose salary is above the department average. So first we will be calculating the average of salary, and then we will include that inside the subquery and find the employee who has salary greater than that particular value. Next, we have display employees hired in last 30 days. So this is related to our time date function. So we will use the current date and then subtract the interval of 30 days. Then we have get all customers who placed more than 5 orders. So we have to use group by and having functions here. Then retrieve the running total of all the sales, use a window function for cumulative logic. Then we have to remove the rows while keeping only the latest records. So it keeps only latest records per unique email. So we will be using unique function here. So this is the overall overview of all the 10 scenario based or demo based questions that we will be facing today. Now let's quickly jump onto the MySQL workbench and try to create the new tables, add the entries, and then run each and every single query for each and every questions that we have listed here. So now we are on the MySQL workbench. So this is the SQL training interview questions that we are facing. So let me also check the data table first real quick. So I have a doubt that I've already created a table on interview questions. So for better clarity, yeah, we have created a database, but there is no table inside this particular. Yeah, we do have tables. So let's open a new query prompt quickly and see, or we can use the same prompt. Let's check it. Use, let me expand, database interview. We are in interview and then show tables. Yeah, we do have created all the department employees order sales data. So let's quickly run the select commands star from departments. But if you are worrying about the queries to create the data sets, don't worry. So here you can see on my screen, we have the entire code documentation done for us, the SQL training documentation. So here you have the, you know, commands for creating the table, inserting the table data, and then selecting the employees and all those things. And apart from that, if you scroll a little bit down, here are the places where we start with interview questions and their answers. This is the section. So this is the first question, right? So no worry, all the tables are created for saving time. And also this particular document is listed in the description box below. You can go through that and start running the queries along with me, right? So now let's go to the table here. Select star from department. So we have about 4 departments, and the fifth one deliberately left as null because one of the questions was also listed as find the employees where a department is not assigned yet, right? Something like that. And we have a second select. Let's copy and paste quickly so that we save time. And instead of departments, we have employees. This is the employees table. And we have the employees here. Department is equals to null. So Frank is one of the employees where department is not assigned. So we will be extracting them in the runtime. And the third one was about orders. And we have the following orders along with the date time. And next table is sales. So we have the sales here, sales table. And lastly, users. Let's run. And there you go. So now we have a briefing on all the data table entries and the elements. Now let's go back to SQL file number 8. I think we do not need to create any tables so far, so I'll eliminate this particular part. And that brings us to the first question. Fetch the second highest salary from the employee table. Now, we need to understand subqueries here. So we've already been through subqueries tutorial. So I have highlighted a small part of the single query, which states select maximum salary column. So we have a salary column. Inside that, we need to find out the maximum value inside the salary column. So that becomes a subquery. And that particular subquery is encapsulated inside an outer query. So outer query is this one. So we need to select maximum of salary from employees where salary is less than the maximum salary of employees. So basically it gives you a list of all the salaries which are less than the maximum salary, but we want the second highest one only. So for that you can also add limit 1. If you don't add limit, what you will have is all the entire list of rows. But if we have limit, you'll just get one entry. Let's quickly run this. So we have this particular salary, which is second highest. You can also include employee name, right? So what was the name given for employees? So if we run the employee table here, we have name, right? So we can copy this field name, go back to file number 8, paste it here, comma. Okay. Right now, if you run this, you'll get the name of the employee. Okay. So what we need to do is employees dot name. This should resolve our problem. I think it's not working. Basically, this is how we run and we get the second highest salary. And there you go. Now, the second question is retrieve employees who have no department assigned. So here we need to perform join operations. So we are doing a join operation of left join on departments as well as employees table. And based on that, we will find a location where employee department ID is equals to null. And according to that, we will find out the employee's name. So let's run this query quickly. Left join departments D on employees department ID. So based on these IDs, we are finding or creating a join and then finding the employee. And there you go. So Frank with employee ID 6 and his salary is 60,000, but department is not entered, so it's on null. Now, proceeding ahead, we have the next question. Let me expand this. So the next question is find duplicate email IDs in a table. So here we will find a simple select query with email and count from users table, and we are grouping by email, and we are grouping by having count star is greater than 1. So what this basically does is if one email ID, right, is counted for multiple times more than one, then that particular email ID is been duplicated. So we need to execute this query here, and there you go. Alice at example.com is one particular email ID which has two entries there. It is repeated for 2 times. So we have a duplicate entry there. Now the next question is display top 3 highest paid employees. Remember the first query? It is completely similar to that one. So here what we are doing is we are ordering by salary and descending by salary, order by salary in descending order, and we are limiting to 3 entries. So we will have 3 entries. It is similar to the previous question. So quickly control enter. And we have 3 employee IDs, 2, 4, and 8. So these earn top highest salaries. Now next is count orders per customer. So we have customer ID and we are counting their order IDs as total orders from table orders, and we are grouping by customer ID. You can also do an order by thing here. So we can order by descending so that we can find out the highest orders. Let's try that. Well, let's execute this first and then try to plan out the order by query. So there you go. So we have customer ID and the total number of or total orders. Now let's get going with the next question. Get employees whose salary is above the department average. So we have already discussed this particular question. So what we are basically doing is we are encapsulating the query here. So let's format that. So here is our subquery. We are basically finding the average salary from employees where department ID is equals to this one. So we are finding the average salary and then we are comparing the salary with the average salary, and it should be greater than the average salary. Now let's execute this particular query, and there you go. So we have about 1, 2, 3, 4 employees who have salaries more than the average salary paid to overall employees. They must be in good roles. Now the next one is display employees hired in the last 30 days. So here we need to use the date and time function. Select star from employees. Interval is 30 days. I think interval is 30 is enough, or there must be a small query error here. So let's go to the next question. Get all customers. So let us consider this particular query as your homework. You can let me know the answer for this particular question. Display employees hired in the last 30 days. Go ahead with the time date function and find out the answer for this. And please do let us know in the comment section below. Now, the next question is get all customers who placed more than 5 orders. So we are selecting customer IDs from orders table. We are grouping by order ID and having. So we are going with an aggregate function here. So we cannot use the other function, but having. So having is the only function that go with the aggregation functions. So enter, and we are having the details here. So I think nobody is having more than 5 orders. Let's go with another number, 2. So we have 2 customers, customer ID 1 and 2, which have more than 2 orders placed. That's the answer. And next one is retrieve running total of sales. So for extracting running totals, we need to have aggregates over date as running total from sales. Now let's run this query. And there you go. Now we have reached the last question of this particular session. Remove duplicates rows while keeping only the latest record. So what we are doing here is select maximum creators subquery and users U2, and we need to find out the unique email. And if that particular email is repeated twice, then we need to delete that, and we need to keep only the latest entry of that particular email. So we are also using a delete command here. Enter. So I think there are no duplicate emails entered, so we already removed them so far. So that's how you remove the duplicate entry so far. And with that, we have finished the top 25 most frequently asked theory-based interview questions and answers, as well as scenario-based or query-based interview questions and answers on SQL. Now, let's proceed with the important tips for SQL certification exams. Now that we have decoded the theory questions and walked into some most commonly asked interview patterns, it's time to shift gears and boost your exam performance. Interviews sharpen your fundamentals, but certifications validate them formally. Recruiters, hiring managers, and even senior architects look at certifications not just as badges, but as proof that you understand SQL at a systems level. So, in this section, I'm going to walk you through high value strategies and by top performing candidates. These are not generic tips, these are insight sharp by real exam patterns, real failure stories, and success paths. Now, the first one. Master SQL fundamentals deeply. Every SQL exam, whether it's Oracle, Microsoft SQL Server, PostgreSQL, or any cloud-based SQL assessment, it's fundamentally built on the same backbone. SQL fundamentals. The exam creators know that if you truly understand these foundations, you can handle any advanced question with confidence. Now, when I say fundamentals, I don't mean memorizing definitions. I mean truly understanding why and when something works. For example, joins are not just about combining tables. They test how well you understand relationships between entities. Subqueries check whether you can break down data problems into layered logic steps or not. A key skill in real analytics. Transactions ensure that you know how databases maintain consistency even under failures. Indexes test whether you understand performance, not just correctness. Certification exams love focusing on those areas because they expose whether you're simply writing SQL mechanically or whether you can actually reason with SQL. You'll notice that nearly 60 to 70% of exam questions revolve around these fundamentals, sometimes directly and sometimes hidden inside complex analytical questions. So before you jump into mock tests or dumps, invest time in mastering the foundations deeply. Once you have this clarity, the rest of the exam becomes significantly easier. The second one is practice SQL on actual exam engine. One of the biggest mistakes candidates make is preparing on generic platforms like SQL Zoo, HackerRank, LeetCode, or any online based examples, but not practicing on the actual exam environment. Each certification vendor, whether Oracle, Microsoft, PostgreSQL, or even cloud vendors like Google BigQuery, it has its own flavor of SQL. That means the syntax, the built in functions, the error patterns, and the way the system responds to your mistakes can all vary slightly. For example, SQL Server uses TOP for row limiting. Oracle uses row number or fetch first. PostgreSQL uses limit. These small changes or differences can completely change the behavior of a query. The advantage of practicing on the real exam engine is that it reduces the exam time surprises. You're already familiar with the UI, the formatting rules, the syntax behavior, and how strict the evaluator is. You also get comfortable writing queries without relying on the autocorrect, autoformat, or syntax highlight. This is exactly why top scorers insist on simulating the exam environment early. The more you replicate real conditions, the more confident and stable you will be under pressure. The third one is learn vendor specific features. Now, let's talk about a very underrated area, vendor specific functionality. Every SQL database implements the SQL standard slightly differently, and certification bodies intentionally test these unique features. Let's break down some examples. Oracle SQL, row number. It is used heavily for pagination and row limiting queries. NVL, Oracle's versioning of handle null values equivalent to is null or coalesce in other engines. If you don't know these features, you will misinterpret these questions and lose marks. For example, SQL Server uses top n function, a very common row limiting clause. The other one is try convert, a safe conversion function that avoids throwing errors when conversions fail. Again, Microsoft exams love to test these. Another example is PostgreSQL's JSON-B. PostgreSQL's powerful binary JSON format is heavily tested because it's a core strength. Rich window functions like PostgreSQL is known for analytical SQL, so expect questions on ranking, partitioning, and frame clauses. When you learn vendor-specific features, you're not just memorizing functions. You're understanding the identity of each database. This gives you an edge because you can decode what the question writer is expecting. The next one is fourth one, understand execution plans. Execution plans are game changers. Modern SQL certification exams are not satisfied with candidates who can simply produce the correct output. They want you to understand how efficiently the database retrieves that output. Execution plans reveal whether an index is being used, whether a full table scan is happening, how joins are processed, which query operations are most expensive, When you understand execution plans, you understand the internal mechanics of SQL engines. This helps you answer exam questions that revolve around cost optimization, indexing strategy, and query rewriting. For example, an exam may show two queries with the same logic, but ask you which performs faster. Without knowledge of execution plans, you are guessing. With understanding, you're simply decoding the behavior systematically. This is why high scores always study execution plans. It's a direct way to align your reasoning with how the database actually operates. Now, the fifth one, learn to interpret SQL errors. SQL certifications don't always give you perfect queries. Sometimes they intentionally include incorrect code and ask you to identify the issue. If you're not comfortable reading SQL error messages, you will struggle. Common exam patterns involve foreign key violations. These test your knowledge of referential integrity. Null violations is the next one. These test check constraints, default values, and null handling logic. The next one is type mismatch errors. These enforce you to understand data types rather than relying on generic casting. Even experienced candidates get stuck because they expect perfect queries. Remember, the exam is not just testing your ability to write SQL, it is testing your ability to debug SQL. Now we have the sixth tip, master join combinations. Joins are one of the most commonly or frequently tested topics in SQL certifications. But not just simple inner joins. The real complexity is in combinations and edge cases. You need to be comfortable with cross joins, self joins, and right outer joins, full outer joins, anti joins. Not exist right now, but in exams it may be there. Exams often place these joins in the context of tricky dataset structures, missing values, duplicate records, circular relationships, and asymmetric data. The goal is to test whether you can visualize table interactions mentally. When you master joins at this level, you can handle any data retrieval question under pressure. The seventh tip is focus heavily on window functions. Now, let's talk about one of the most important areas in modern SQL exams, window functions. These include row number function, rank function, dense rank function, lead function, and lag function, sum function, over function, average function, and a lot more. Partitioning and framing clauses are also important. Why are window functions heavily tested might be your next question. Because they represent analytical SQL, the core of modern data engineering, business intelligence, and analytics workloads. Window functions allow row by row analysis without collapsing the dataset. This means you can perform ranking, running totals, and trend analysis and change direction, all with elegant syntax. In certification exams, these questions are often look complex, but if you understand partitioning and ordering deeply, you can decode them instantly. So, allocate special timing for mastering window functions. They are high marks, high value, and high impact. Now, let's go with the eighth tip. The eighth tip is about use official learning paths plus practice tests. Another strong recommendation, stick to official learning paths. These are curated by same teams that design the certification exam. That means the content is aligned with the exam blueprint terminology and difficulty level. For example, Oracle University's learning path, Microsoft Learning Modules for SQL Server, and Azure SQL, PostgreSQL official docs, and tutorial guides. These official resources also contain free practice tests. Use these to gauge your readiness. Consistent scoring above 85% is good indicator that you're ready to book the exam. Remember, random online sources like blog posts may be good for learning, but they rarely follow the exact same pattern. Trust official sources when preparing seriously. Now, the next tip. The next one is our ninth one, build at least two real-world mini projects. Certifications are not just theoretical. Practical experience massively boosts your retention and intuition. Building real-world mini projects help you develop muscle memory. Some ideas include a sales dashboard with aggregations and window functions, a user engagement analysis with session-level SQL, a logistics or inventory dataset involving joins, subqueries, and transactions. These projects strengthen your ability to handle multi-table analysis, a core exam requirement. The more you practice data challenges, the faster you'll decode certification exam questions. The 10th and the last tip, build a time management strategy. This one area many candidates underestimate. In SQL exams, the time pressure is real. Even if you know the answer, overpacing can cost you the certification. Here's a simple but extremely effective strategy. Attempt all easy questions first. Mark medium questions for revisit. Leave complex analytic questions. multi-step queries, and optimization-based problems for the last 25 to 30 minutes. This ensures that you maximize your score early and avoid getting stuck. Remember, exams do not reward you for solving hard questions first. They reward strategic thinking. And with that, we conclude this model, a complete roadmap to succeeding in your SQL interviews and certification exam. In this session, you will learn how to articulate SQL concepts with clarity, precision, and confidence. We've reviewed the most common interview question patterns, logic behind real-world SQL scenarios, and how certification bodies test both your fundamentals and your analytical mindset. The entire goal of this module was to help you think like a professional, not just write SQL queries mechanically, but develop a deeper reasoning style. And once you start thinking this way, SQL stops being just a query language. It becomes a tool for structured analysis, pattern recognition, and business decision making. With these fundamentals, you will walk into interviews and exams with not just knowledge, but confidence, speed, and strategic clarity. Now, take these insights, put them into practice, and start preparing for your next step in SQL journey. You got this. As we come to the end of the SQL full course, take a moment to pause, not just to finish a course, but to recognize how much ground you've covered. When you first started, SQL may have felt like a new language filled with unfamiliar keywords, syntax rules, and database concepts. But now, SQL should feel less like a tool you're memorizing and more like a language you understand, a language that allows you to ask meaningful questions of data and receive precise, reliable answers. This course was designed with one clear objective, not just to teach you SQL commands, but help you think in SQL. Because in this real world, successful professionals are not those who remember every syntax keyword, but those who understand how data behaves, how databases are structured, and how to extract insights logically and efficiently. Over the last few hours, you didn't just learn SQL. You built a foundation that is used daily by data analysts, backend engineers, data engineers, business analysts, and even AI professionals across industries. From startups to Fortune 500 companies, SQL remains one of the most trusted and widely used skills in data ecosystem. Now let's take a structured walkthrough of everything you have learned and even more importantly, why it matters. So recap chapter by chapter learning journey. So the first chapter, Introduction to SQL and Database Basics. You began by understanding what SQL is and why it is still dominating in 2026 and beyond. You learned that SQL is not just a programming language, it's the standard way humans communicate with relational databases. You explored how SQL powers everyday systems, banking, e-commerce, flight bookings, healthcare, telecom, and analytics platforms. This chapter grounded SQL in reality, helping you see it's not just a theoretical concept, but as an invisible engine behind the modern digital systems. You also learn the difference between relational and non-relational databases, understanding when structure matters and when flexibility matters. This comparison laid the foundation for architectural decision making later in your career. Finally, you set up your own SQL environment, an often underestimated but critical step. By installing MySQL or PostgreSQL and running your first query, you crossed an important milestone from observer to practitioner. Now comes chapter 2, Basic SQL Queries. This chapter marked your transition into hands-on SQL. You learned how to retrieve data using select statement, filter it using where, sort it using order by, and control result size using limit and distinct. These are not beginner concepts. They are most frequently used SQL commands in production systems. You also learn how aggregation functions like count, sum, average, minimum, and maximum help transform raw data into meaningful metrics. This is where SQL starts becoming analytical, where you stop looking at individual rows and start identifying patterns. By end of this chapter, you had the core skills required to answer real business questions using data. Now we dive into chapter 3, understanding data types and operators. In this chapter, you learn something many learners overlook. Data types matter. You explore numeric, string, date, and Boolean data types and how choosing the right data type impacts storage, performance, and accuracy. You also learned how arithmetic and logical operators allow SQL to perform calculations and comparisons. Operators like between, in, and like taught you how to filter data intelligently, skills that directly translate to writing clean, efficient queries in real systems. This chapter helps you move from writing queries that work to writing queries that work correctly. With that, let's make a transition to chapter number 4, inserting, updating, and deleting data. Here's where you learn SQL isn't just about reading data, it is also about responsibly modifying it. You practice insert, update, and delete operations while understanding why careless data manipulation can cause serious issue in production environments. You learn save deletion practices, conditional updates, and the importance of verifying data before making any changes. This chapter introduces you to the mindset of a professional, someone who understands that data integrity is as important as data access. Now comes chapter number 5, mastering SQL joins. This is where SQL truly starts to show its power. You learn why joins matter and how real world data is almost never stored in a single table. Through inner join, left join, right join, and full outer join, you learn how to combine data meaningfully across many tables. You practice multi-table joins and saw how business insights emerge when data relationships are used correctly. This chapter is often a turning point where learners realize SQL is not just about tables, but also it's about relationships. If you understand joins well, you already stand ahead of many beginners. Now comes chapter 6, grouping and aggregating data. This chapter focuses on summarization and insight generation. You learn how group by transforms detailed records into aggregated summaries and how having allows you to filter aggregated results. This distinction, where versus having, is subtle but very crucial. Here, SQL starts behaving like an analytical engine. You move from row level data to trend level thinking, which is exactly how data is used in dashboards, reports, and decision making systems. Now comes chapter number 7, which is about subqueries and nested queries. In this chapter, you learned how to write queries inside queries. Subqueries taught you how to break complex problems into smaller, logical steps, just like solving real world analytical problems. You explored single row, multi row, and correlated subqueries and saw how they can be used in select, from, and where clauses. This chapter sharpened your problem solving skills and introduced a more modular, logical way of thinking in SQL. And now comes chapter number 8, which is about data modeling and relationships. Here, you step back from writing queries and looked at how databases are designed. You learned the difference between primary keys and foreign keys. You explored one-to-one, one-to-many, and many-to-many relationships and understood why normalization exists. This chapter helps you communicate better with data architects, backend engineers, and system designers. It also explains why well-designed databases make SQL queries simpler and faster. And with that, we come to chapter number 9, indexing and performance tuning. In this chapter, you learn that performance is not accidental, it is designed. You explored how indexes work, when to use them, and how they speed up query execution. You also learned basic optimization principles that help queries scale with large datasets. This knowledge separates casual SQL users from professionals who work with real production systems. Now we make a transition to chapter number 10, which is about views, functions, and stored procedures. This chapter introduces you to reusability and abstraction in SQL. You learn how views simplify complex queries and functions encapsulate logic and how stored procedures allow SQL to behave more like a programming environment. These concepts are widely used in enterprise systems and play a major role in reporting, automation, and backend workflows. Now comes chapter number 11, transactions and error handling. Here, you learn how SQL ensures reliability and consistency. You explored begin, commit, and rollback and understood the importance of asset properties. This chapter showed you how databases protect data even when systems fail. This knowledge is critical for finance systems, inventory systems, and any application where data accuracy is non negotiable. Now, chapter number 12, real world SQL projects. This was where theory met practice. You applied everything you learned by building a mini e commerce database, writing sales reports, and analyzing customer behavior. These projects mirror real world workplace tasks and help bridge the gap between learning and doing. Now, the chapter 13, SQL for data analysis. Here, SQL became a true analytical tool. You learn case statements and window functions like rank, row number, lag, and leak. These are powerful features and are used in advanced reporting and analytics platforms. This chapter aligns SQL with modern data analytics rules. Now comes chapter number 14, integrating SQL with Python. You learn how SQL fits into larger ecosystems. By connecting SQL with Python and Pandas, you saw how data flows from databases into analytical and machine learning workflows. This integration is essential for data scientists and engineers. Now, with that, we come into chapter number 15, which is SQL interview and certification preparation. You will learn how SQL is evaluated in interviews and certifications. You explored common interview questions, best practice answers, and how to demonstrate SQL knowledge practically. This chapter prepares you not just to know SQL, but to prove it. Now let's go through a roadmap which explains you what to learn next. Now that you have a strong SQL foundation, here's what you can go with next. Advanced query optimization and execution plans, advanced window functions and analytical SQL, database internals and indexing strategies, SQL for big data platforms like Snowflake, BigQuery, and Redshift, SQL in real-time analytics systems, SQL for data engineering pipelines, SQL certifications from Oracle, Microsoft, and cloud platforms. Think of SQL not as a destination, but as a core skill that grows with you. SQL is one of the rare skills that ages well. Technologies change, tools evolve, but SQL remains relevant because data remains relevant. Every decision, every product, every AI model begins with data, and SQL is how we access it. If you have completed this course sincerely, you are no longer a beginner. You have the confidence to explore data, ask questions, and solve problems. The real learning begins now when you apply SQL daily, break queries, fix them, optimize them, and use them to create value. Thank you for committing your time and effort to this journey. Keep practicing, keep questioning, keep building. And remember, those who control data shape decisions, and SQL gives you that control.
Python is a high-level object-oriented programming language developed by Guido van Rossum in 1989 and was first released in 1991. Python is often called a batteries-included language due to its comprehensive standard library. A fun fact about Python is that the name Python was actually taken from the popular BBC comedy show of that time, Monty Python's Flying Circus. Now, let's look at the top features of Python. First, Python has a simple structure and a clearly defined syntax. This allows the learners to pick up the language quickly, so it is easy to learn and use. Python can run on different operating systems such as Windows, Linux, and Mac, making it a portable language. It enables programmers to develop the software for several competing platforms by writing a program only once. Third, Python is freely available at the official website. Since it is open source, this means that source code is also available to the public. Now, Python uses an object-oriented approach that encapsulates code within objects. Python provides a collection of libraries for various tasks such as machine learning, web development, and data analysis. And finally, in Python, you don't need to assign the data type of the variable. When you assign some value to the variable, it automatically allocates the memory to the variable at runtime. Now with that, let's move on to the uses of Python programming. So Python programming language is used to develop desktop applications and build web applications too. It is popularly used in the field of data science, machine learning, and artificial intelligence to analyze data, build predictive models, and make business decisions. Python is also widely used in game development. Now, let's see some of the popular Python frameworks and libraries. Python can be used for web development using frameworks like Django, Flask, Pyramid, and CherryPy. Now you can build graphical user interfaces using libraries and frameworks such as tkinter or just Kinter. You can also use PyGTK, PyQt, or PyJS or Python JavaScript. Now Python is also used to perform machine learning tasks using libraries such as TensorFlow, PyTorch, scikit-learn, Matplotlib, and SciPy. You can also perform mathematical computations using NumPy and Pandas. Now let's look at the best IDEs that you can use to write programs in Python and perform specific tasks. So we have Jupyter Notebook, which is part of the Anaconda distribution that is widely used these days. Even for our demo in this video, we'll be using Jupyter Notebook. I'll show you in a while. Then we have the Visual Code Editor from Microsoft. This is also one of the preferred IDEs by learners and companies. Then we also have the popular text editor called Sublime Text Editor. Then we also have PyCharm, followed by Python IDLE and Spider as our top IDEs. Now let's look at the top companies that are using Python in our day-to-day work. So we have Google, Quora, Facebook, even Netflix, Spotify and Instagram. Now there are other top product-based, service-based and startups that also use Python programming. So what really is Python programming language? Python is an object-oriented, high-level programming language that supports built-in data structures and dynamic semantics. It supports multiple programming paradigms such as structured, object-oriented, and functional programming. Python is often described as batteries-included language because it has a comprehensive collection of standard libraries. Python supports different modules and packages, which allows program modularity and code reuse. Python was developed by Guido van Rossum, and its implementation started in December 1989. Python 1.0 version was released in the year 1994. Python 2.0 came out in October 2000, while Python 3.0 was released in December 2008. Now that you have got an understanding of the Python programming language, let's now look at the top 10 reasons why you should learn Python. So at number 10, we have ease of use. One of the most common reasons to like Python is that it is quite easy to learn and code. It provides a simple syntax that improves readability and makes it easier to understand. So developers can create any desktop or machine-based application using this language. Python is very versatile and is instrumental in artificial intelligence and machine learning. We will talk about this later in the session. Compared to Java or C++, it has fewer lines of codes. In the example here, we are printing a Hello World program in Java. As you can see, if you have to write a program in Java, you first have to declare the class name along with its scope. Next, using curly braces, you need to pass the main method along with its arguments. And then, using system.out.println method, you can print Hello World. That's quite a tedious task, isn't it? The same task of printing Hello World can be done using just one line of code in Python, as shown here. You can write the print function and pass whatever you want to display inside the brackets, and that will print the output. It is so simple. That is why Python is considered as a high-level language and it's open source. You can just download it from the website and start using it. At 9, we have active community. You need a community to learn new technology, and friends are your best asset when it comes to learning a programming language. Python has large community support. It has an extensive and active community to assist engineers, developers, analysts, and data scientists with expert support in case of programming errors or issues with the software. You can just go ahead and put your queries in the community forum. The community members will address your queries in real quick time. Communities like Stack Overflow also brings many Python experts together to help learners. Python Enhancement Proposals, or PEP, is where the proposals and the improvements are announced. Also, there are a set of recommendations or core values called the Zen of Python, written by Tim Peters, that represents the guiding principles for Python development. Up next at 8, we have portable and extensible. Multiple cross-language operations can be performed effectively because Python is portable and extensible in nature. For example, if the users have a Python code written on Windows and they want to execute on a Mac operating system or Linux operating system or Solaris, they can easily do it without any amendment. They can also run this code on any platform flawlessly and without any interrupt. Due to its extensibility feature, you can integrate other programming languages such as Java, .NET, C and C++ codes with Python. The components of other programming languages can be used with Python, and thus it can be used to make a cross-platform suitable application too. So it is a really good feature that Python provides. The next reason to learn Python is testing frameworks. Python supports several built-in flawless testing tools and frameworks that help in debugging and speeding up workflows. Some of the tools and frameworks supported by Python are PyTest, Selenium and Splinter. This is the reason for which every tester tries to use Python-based tools and frameworks to test any application or code or to validate it in an easier manner. PyTest is the most recommended testing framework for functional, integrational and unit testing. You can run Selenium test scripts using Python programming language to automate various tasks. And Splinter is an open source tool for testing web applications using Python. It lets you automate browser actions such as visiting URLs and interacting with their items. At number 6, we have libraries and packages. Another reason why Python has become so popular in the industry these days is that it has a massive collection of libraries and packages that make your task simple and easy. It has a range of libraries, packages, frameworks and modules for data manipulation, statistical calculation, web development, machine learning and data science. Python programmers have developed tons of free and open source libraries that you can use. You can find many of them via Python Package Index, the repository of Python software. Python provides the default package called pip. Anaconda is a third-party Python ecosystem. Other examples include NumPy, SciPy, and Django. Then we have scripting and automation. Python is not just a programming language. It can also be used for writing scripts for automating tasks and workflows without human intervention. The code can be written in the form of scripts and executed later. Further, it is interpreted by the machine and checked for errors at runtime. The machine is used to read and interpret the code. Once the developer checks the code, it can further run or be used several times without any interruption. This allows you to automate a set of certain tasks within a program, or the same code can be used with other applications as well. At number 4, we have web development. Another reason to learn Python is that it makes the web development process so much easier. It provides a wide collection of frameworks that make it easier for developers to develop web applications. Some of the examples are Django, Flask, Pyramid, TurboGears, CherryPy, etc. These frameworks are written in Python, which makes the code a lot faster and stable. The task which used to take hours in PHP can be finished in minutes using Python. Python is also used for web scraping. Django offers many elements of intricate programs such as template design, management panel, signing in, signing up, signing out, URL routing, etc. Once the user establishes the framework, all these features become ready to use. Flask is a microwave framework written in Python. Of all the components that are part of this module, they are all ready to execute in the server context. Pinterest and LinkedIn use Flask. Pyramid offers more attributes than Flask. It will assist users with URL routing and authentication support. TurboGears is a highly recommended and scalable framework that supports features such as authentication, caching, identification, management of sessions, and pluggable applications. Up next at number 3, we have machine learning. The growth of machine learning has been phenomenal in the last 5 years, and it's rapidly changing the world around us. Python is one of the most preferred programming languages for machine learning because of its simple syntax and support for several machine learning libraries. Using different libraries and functions in Python, the system can learn and train itself from past data. Once the system is trained, it can then learn to adjust itself to new inputs. Finally, it can make predictions and perform human-like tasks automatically. At number 2, we have data science. Machine learning and data science go hand in hand. Python is robust, scalable, and provides extensible visualization and graphics options. Hence, it is widely used in data science. Python has libraries such as NumPy for numerical computation of data, Pandas for operations to manipulate data on numerical tables and time series. It also provides SymPy for symbolic computation and SciPy for technical and scientific computations. It has another library called PyBrain, which is sought for Python-based reinforcement learning, artificial intelligence, and neural network library. Scikit-learn is the machine learning library for creating classification, regression, and clustering algorithms. And finally, it provides PyTorch and TensorFlow for deep learning. Finally, coming to the most important and the top reason to learn Python, which is career opportunities and salary. Python language provides a variety of job opportunities and promises a high growth graph with huge salary prospects. It is being used by most of the tech giants. Industry leaders using Python are Amazon, Google, Facebook, IBM, NASA, Netflix, and YouTube. Next, you can see the Google Trends, where I have considered 3 programming languages, Python, Java, and C++. I have compared them for the past 12 months. You can see it clearly on your screens that Python has become a frontrunner in terms of popularity and web search volume. It means people are interested in Python, they want to learn it and use it in their work. You can also check for the YouTube search. There also you will find that Python programming language is the most searched language on YouTube. Now on your screens, you can see the report of PYPL, which is Popularity of Programming Language Index. It is created by analyzing how often language tutorials are searched on Google. It is a leading indicator. The raw data comes from Google Trends. The bar graph depicts that Python is the most popular and widely used programming language across the globe, followed by Java, then JavaScript, and C#. The Popularity of Programming Language Index can help you decide which language to study or which one to use in a new software project. The next graph shows the popularity of Python and Java over the years, starting from 2004 till the current period, which is 2020. Worldwide, Python is the most popular language. Python grew the most in the last 5 years by 19.4% and Java lost the most by -7.2%. Now let's talk about the different career opportunities and the job roles that you can get into if you learn Python language. First, you can become a Python developer, where you will be asked to write and test codes, debug programs, and integrate applications with third-party web services. Second, you can become a web developer. Here, you will be responsible for writing server-side web application logic. Python web developers usually develop back-end components, connect the application with third-party services, and support the front-end developers by integrating their work with the Python application. You can also become a data analyst if you know Python. As a data analyst, you have to gather data from multiple sources using scripts, analyze that data, develop and implement databases, and data collection systems. You can become a data scientist. As a data scientist, you need to understand the challenges in business and come up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Lastly, you can be a machine learning engineer, where you can develop intelligent machines that can learn from vast volumes of data and apply knowledge without human intervention. So there's a lot of scopes if you learn Python.
But before we move on, let's understand first what is Jupyter Notebook. So guys, as you can see all over here, that Jupyter Notebook is a popular open source tool that basically allows you to create and share documents which contains codes, equations, you can have visualizations also. Basically, it is used for data analysis, machine learning, and scientific research, which makes it a very essential tool for developers like data scientists and researchers alike. Now, before installing Jupyter Notebook, I request you that you have Python installed in your system. So the requirement should be Python 3.6 or greater. So now let us officially navigate to the Python's website. So guys, as you can see all over here, so on python.org, if I click on download Python, so we're going to see that all over here, download Python 3.125. So as I already told you that the requirement of Python should be greater than 3.6. So just you can click all over here and you can see the download had started. So guys, as you can see all over here that we have installed the Python. Now let us open the file. So you can see the given software is going to install on this directory. Okay. So just click all over here. So guys, as you can see all over here, the Python installation of 3.125 is in progress. Let's wait for some time till it gets installed. So as you can see guys all over here that we have successfully installed our Python. Now let us open our terminal and let us check whether Python is correctly installed. So we are going to type python/version. So as you can see all over here, we have successfully installed our Python. So guys, that was our prerequisite. Now there are two ways to install Jupyter Notebook. The first one can be pip. Okay, pip is a package manager, or using Anaconda distribution. So let us see with pip first. So guys, pip is a package manager which is used to install and manage software packages, libraries written in Python. So you can see all over here that the Python with version greater than 3.6 have default pip installed in them. Okay, so we can use pip command to install our Jupyter Notebook. So guys, as you can see all over here, we have come to the official documentation of Jupyter.org, and it is saying that installing Jupyter Lab with pip command. So what you can do guys, you can just copy all over here. You can go right all over here and click on this. Now, as you can see all over here, it has started downloading the Jupyter Lab. So guys, we are going to install our Jupyter Lab with the pip command. So this is the official documentation of Jupyter Notebook. Okay, and just all you have to do is copy this and type on your terminal. So as you can see all over here, it has started downloading the packages which is required to download the Jupyter Notebook. Let us wait for some time. Okay guys, so we have successfully completed this step. Now let us move on to our next step. So as you can see all over here, so we have installed, okay, then what we have to do, then you can type this, you can launch the Jupyter Lab with this command on the terminal. Now let us wait. So as you can see all over here guys, we have successfully installed our Jupyter Notebook. So you can go all over here and just create a new notebook, and you can also choose your kernel and you can start working on your Jupyter Notebook. Suppose I'll show you one snippet. So 3 plus 5, let us try to run this notebook. So as you can see, it is giving us the 8 as answer. So it is following the Python syntax, and in this way we have successfully installed our Jupyter Notebook using the pip command. So now, as you can also see all over here, you can also install Jupyter Notebook with this command, pip install notebook, and then you can just open it. This is also another alternative. Similarly, you can install with Viola also. Same command and just open the Viola. Now, if you are using any other operating system like macOS or Linux, then you can install by brew install Jupyter Lab. So Homebrew will be the package manager for macOS and Linux. So I hope so you are pretty clear with how to install Jupyter Notebook with the pip command. Now, I have downloaded Anacondas from this official website. So as you can see all over here, this is the official website of Anaconda. Okay. Now just type your email and you can just download it. So similarly, as you can see, after installing, I'm going to launch my installer, and let us click next. Okay, let us click agree. Okay, and let us install this on the given directory. Let us wait for some time till the installation gets complete. So guys, as you can see all over here, we have completed our installation of Anaconda. So just click on finish, and you can say we have successfully installed our Anaconda. Now let us open our Anaconda navigator. So just click on So as you can see all over here, just right click on this and our Anaconda navigator will be opened. So as you can see all over here, this is our Anaconda navigator and it is loading the packages. And for us to install the Jupyter notebook, so as you can see all over here, just click on launch. So guys, if you click on launch, it is going to open our Jupyter notebook. So as you can see all over here, it is saying launching the Jupyter notebook and it is hosted on localhost 8889. So this is our hosted Jupyter notebook. And similarly, you can create a new notebook all over here. And in this way, you can start working.
Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that question is that typically when you're working on Python, one of the most basic things that you can do is create a Python script and execute a script. A script is essentially a sequence of commands and instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy and it's not very useful for a beginner. Another way is using a text editor such as the one I have opened right now, which is the Notepad++ text editor. Now it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most common, one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. All right. Now, it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose, this folder seems fine. So now I give the file name over here as, say, I want to keep it as test. I need to prefix this with .py, and this tells any sort of interpreter, or anytime we need to read the script to know that it's a Python script, we need to add a .py. Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, you go, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is Python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since my file is already in the folder that I am in my command line, I would just have to enter this command right now. So if I execute this, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print this these two words, and of course the command line is now waiting for the next command for me. So this is one of the most simple ways or the most rudimentary ways of executing a Python script. Now another question would be, well, this isn't the most visually appealing or not the easy to read or easy to use way of executing scripts, and I would agree. And that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or in any programming language stands for Integrated Development Environment. It's essentially a software that not only allows us to run scripts, but it allows us to create the scripts, it allows us to debug, it allows us to see outputs, it allows us to see intermediary outputs, it allows us to do a wide variety of tools and tasks. And it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda Navigator, as you can see, the Anaconda Navigator shows me a bunch of technologies and options, and I'm looking for something called the Spider IDE, which is over here, as you can see here. It's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. So this is the Spider IDE in particular, and this is how it looks. Don't worry about the exact details. Just know that on this left-hand pane is our current script that is open out here, and out here we will get the results in this. This is what we call a console essentially. So now that we have already created our script in Notepad++, and I want to open that script and I want to see the result of that script would look in an IDE. So let's just open it. So we can browse for our file, and as I had named it test, this is the file over here. I open this, and as you can see out here in the left hand pane, my script has opened, and the command that I had given or had written is out over here. Now if I want to run this application, I press this green button, and as you can see, the result of my execution essentially is over here. It's in slightly small font, but as you can see over here, it says hello world, and the next line is essentially it's waiting for me to do another execution of the script, and then it will give me new results. So let's actually give the system new results. So now that I have printed something called hello world, let's change what's written over here. Let's say I will perform basic maths. All right. And then let's actually perform the basic maths. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called a. Let's store a number 3. Let's create a variable b, store a number 5. All right. Let's create another variable c, which will store the result of what's in a and b, in the addition of a and b. All right. And let's print the result, or print what's in this variable c, or what's the result of a plus b. I will print a statement saying the result of the addition of 3 and 5 is, all right, and I will put my result over here. As you can see, I should get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I performed 2 print statements, and I've performed a basic expression, some variable assignments. All of these things we will be doing later. This is what I'm essentially trying to show you is that IDEs are a very convenient way of not only creating the scripts but actually seeing the results and then making adjustments as well. We can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the IDLE IDE. It stands for Indicated Development and Learning Environment. So the IDLE IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or Integrated Development and Learning Environment. But of course, since we are using Python, and that is what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I open, or when I launch the Jupyter notebook, this is what I get. Now, a very important feature, or a feature of notebooks, is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. You don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new, and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function, this is a separate addition, another separate print function, and for longer programs or larger programs, you'll have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now, I want to do what is 5 plus 3. It should give me the result over here, 8. Now, the next, another part of your program might be storing 5 and 3 into variables. So I can do this and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables. And I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks, and I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts of different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects, 5 and 10, are being added, and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything, it's simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b, and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors, or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like 4num is equal to something, say the same string hello, this would be an illegal variable name, and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num_4 and I said random, some random string, this is perfectly fine. However, if I changed num_4 to num-4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words in Python. Now Python has a bunch of reserved words. These words essentially are performed, or they are used to perform certain special functions and are used as identifiers for certain special functions in Python that have a special purpose. Like that particular word has a special purpose within the Python programming language, and we cannot use them to name our variables. So a list of them, as you can see over here, some of them are like false, def, if, del, raise, and there are around 33 of them. And sometimes some of these words are taken out. Sometimes there are more words added as Python gets updated. Now let's move on to a concept where we try to really understand what do we mean by storing data inside a variable. Now when I say that we are storing something inside a variable, you get an image or you get an idea in your head that this variable is like a container where we store or we put a particular object inside it. So does this mean that variables have a place in the memory? Are they also an object that is placed in the memory where we can put other objects inside of? Well, I'll show you an example where this idea is kind of disproven, or where I'll show you that the idea of variable is kind of different than what we understand by storing something inside a variable. Now, let's say I'm storing the same object. I will take this object as some random number, let's say 100, and I'm going to store it into two different variables. So I take x is equal to 100 over here, and in the next line I will store 100 in y as well. Now, if variables were objects that we placed in our system, then x and y should have two different IDs. But let's see what happens when I check the ID of x and the ID of y. They should be different in case variables were their own objects. However, as you can see, the ID of x and the ID of y are exactly the same. So, well, obviously we know that two different objects in Python cannot have the same ID. So what does this mean when it comes to the nature of a variable? Well, the fact is that variables are not actually objects in Python. In fact, variables are more like pointers or references to the actual object. So when I said x is equal to 100 and y is equal to 100, what I'm actually telling the system is that there is this variable name called x that I want to refer or point towards the actual object that is in my memory called 100. And I do the same thing with another variable y. So I am not exactly creating a different space in my system for these variables. These variables are more like placeholders or references that point to a particular place in the memory where this object is located. And that is what happens when I do ID of x and ID of y. It's not giving me the ID of something called x or the ID of something called y. It's giving me the ID of 100 each time because 100 is stored in x and y. So as you can see, this is something like a visual representation of what I'm trying to say. And similarly, if I were to, so in this example on the left, as you can see, I've used the value of 50 to explain my point. So as you can see, initially x and y are pointing towards this value 50 because I have stored 50 and 50 in both x and y. Now what if I changed the object that is stored in x? Well, that means x is now pointing towards this new object, and I have stored this new object called hello, this string called hello, as you can see here. So now x is pointing to a new object in the system, and it's called hello. And I haven't changed anything with respect to y, so y will point towards the same thing. And I can also make the pointer of y different, or what I'm trying to say is I can store something else in y. See, I stored this list in y, 50, 60, and 100. And when I do that, now y is pointing towards a different object in Python. And X is also pointing towards something else. So what happens to this object 50? Well, now that there's no variable referring to this object 50, it becomes what we call an orphaned object. And we can actually see that when we do the ID of X, now let's go back to my example on the right where I stored X is equal to 100. So as you can see, it gives me some ID represented by this number. Now let's say I stored something different in X, say 200. Now if I do the ID of X, it should give me a different ID because as you can see, the values are different. And this is because this object 200 is what is stored in X, and when I do the ID of X, I'm actually getting the ID of this new object now, 200. So as you can see, variables are, they should be, and they are treated more like references or pointers instead of containers for a particular object. In this video, you will be introduced to the concept of objects in Python. Now, what are objects in Python? Well, all the data that we manipulate or use in our operations in our code are represented as objects or relations between objects. So if you want an example, two numbers that you add in your code, well, both of them are objects, and they're usually numeric type objects. Similarly, if you want to store someone's name or an address of your hometown in your code, you usually store it in a form of text, and that text is also an object, usually a string. Similarly, you might want to create a container of different smaller objects inside them, and that big container is also a type of an object, and one of those containers are called lists. And similarly, we have many different types of objects which we will be covering during the duration of this course. The following pictorial representation gives us a broad classification of different Python data types and objects. As we can see, there are 5 broad classifications: numeric, which contains integers, complex numbers, and floats. We have the dictionary data type. We have the Boolean, which essentially consists of objects that have only 2 valid values, true or false. Then we have sets, and we have sequence data types, such as strings, lists, and tuples. Every object in Python has 3 important properties that kind of define that particular object. They are its identity, its type, and its value. The identity of an object is, it can be considered as a place in the memory or its address in the memory where an object is stored. An object's identity does not change once it has been created. So for example, if I took an example of, say, a string called hello, I can use the ID function, this is how you use the ID function to find out the ID of this object. And it should be, the answer should be in the form of a particular long integer. So as you can see, the ID of hello is this integer 2326476623024. Similarly, all objects in Python have an identity. We have another operation with regarding the identity of an object is the is operator, and the is operator compares the identity of 2 objects. So if 2 objects have the same identity, it should give the answer true, otherwise false. Now the next property of objects is the type. The type of an object is essentially what defines what kind of values and operations that object can have. So for example, a numeric data type in Python, such as an integer, would allow us to do arithmetic operations. And similarly, string object type in Python will allow us to do concatenation operations. Much like its identity, the type of an object cannot be changed as well. Now let's see what's the type of that particular object that I had shown you above. As you can see, it should be string. str stands for string. Similarly, if I did a type for a number, say 50, it should give me int, as you can see. Now the third property of an object in Python is its value. Now the value is the actual data that is contained in the object. It's the thing that we use, that we display, that we can manipulate, and that we can perform operations on. So for example, if I were to talk about this string is hello. So the value of the string is the word or the sequence of letters that spell out hello. And similarly, this particular object is a numeric object with the value 50. Let's see, in this pictorial representation, I have shown you that you can assume this dashed blue area as the memory of the system. Now within this memory, we have objects created called 50 and hello, and this list containing smaller objects called cat, pen, and 40. Now, what I'm trying to show you here is each of these objects have a type, an ID, and a value. And let's see what they are. So if I wanted to see, as we had already seen the type of 50, now let's find the ID of 50. As you can see, we get this unique ID for the object 50, which is obviously not the same as the ID of the object hello above. And the value of this object is the value of 50 itself. So that was a brief introduction into objects in Python. In this video, we will cover the topics of numeric object types and type conversions in Python. So let's get started. Numeric object types in Python are a broad classification of objects. Plenty of common real-life applications that we associate with numerals, such as arithmetic operations and calculus, are done in Python using numeric object data types. There are three main types of numerals or numeric data types in Python. They are integers, float, and complex. Integers, as the name suggests, represent all integer values in Python. These can be such as 100, -3, to 305, and so on. Floats are used to represent numerals that contain decimal points, such as 100.3, 3.9, 4.8, -6.8, and so on. Then there is the complex object type, which is used to represent complex numbers in Python. And this is an example of a complex number, 3 plus 7j. This is a complex number 3 plus 7j, where the real component is 3 and the imaginary component is 7. All complex numbers have a real and an imaginary component, and this is how we denote them. Now it's important to note that this j is a very common symbol in maths and engineering used to denote the imaginary portion of a complex number. And it's the same in Python as well. So moving on, let's talk about type conversion in Python. Type conversion refers to the conversion of an object from one data type to another, for example from string to an integer. And there are different types of conversions, and let's go through some of them. First of all, let's consider the conversion of something to an integer, and more specifically, let's consider the example where we convert a string to an integer. So let's consider my example string to be something called 145, and I'm storing this within a string for a reason, because I want to convert a string to an integer. So as you can see, I have stored this 145 within a variable x, and if I were to confirm that it is actually an integer, I can use the type function and see that it is actually an integer, str. Now let's convert this into an integer using the int function. So how would we use it is simply passing the int, by passing the variable that we want to convert into the int function. And as you can see, this is what I've done over here, but before this I will also store it into another variable. Alright, now let's see what's in y. Well, y gives us 145, but are we sure that it's an int? We can just check it by using the type function. And as you can see, the type gives us the answer int. That means that we've converted the string to an int. Interestingly, we can convert something and also specify what base we have to treat the number as. By default, when we pass something in the int function, the program or Python will treat whatever we have passed within the string as something in base of decimal. But what if we were to pass something that is, well, not in a decimal? Well, we could do it like this. Now let's store y, and in y let's do this, and I will show you what this means. X, and I will give a comma and 8. What this tells Python is, well, I want to convert the string in x into an integer, but I want to treat whatever is in x as a number of base 8. So 145 is actually 145 in the base 8. Now when we see what's in y, we get 101, which is different to 145, because, well, 101 is actually the decimal equivalent of 145 in the base 8. Similarly, if we were to give it in the base 2, we would just replace 8 with 2 over here. Now next, let's talk about converting something to a float. Now as we know, float is just simply something that has a decimal point. So let's convert an integer into a float. How would we do that? Simply by using the float function. So if I gave 120 and I pass this integer through the float function, I should get 120.0. These two are not the same, though they may mean the same things to us, but for Python, 120 is an integer and 120.0 is a different object, which is a float. And this is how we convert something to a float. Now, what if we wanted to convert an integer to a string? Well, we can use the str function. We can also use the hex and the oct function if we want to convert a particular number to a hexadecimal or an octal string, respectively. Let's look at all three examples. Say I have a number 688 and I want to convert this into a string. I just use the str function around this. So as we know, just to confirm, let's see what the type of 688 is. This should be an int, as we can see. But let's say we convert it into a string, 688, and let's store it into some variable. Let's call it a. Alright, now let's see what's in a. It gives us 688 in the form of a string, but we can confirm by checking the type of a. It is an str, so it is a string. Similarly, we can use hex if we wanted to convert an integer into its hexadecimal equivalent as an output of a string. As you can see, this sort of complicated thing is actually telling us that we have converted 688 in terms of hexadecimals. Now, how do we read this output? This 0 should not be treated as anything. It's more like an identifier, which says that the letter after this first 0 is the base of this whole number. So it's saying that X stands for hexadecimal. So it's saying that 2B0 is to be treated as a hexadecimal number. And if you did basic maths, you would find that the decimal equivalent of 2B0 is 688. Similarly, if I use the oct function for 688, it will give me the result, something like this. So again, how to read this? The first 0 is to be treated as an identifier and not part of the number. What it's saying is the letter after the first or after this 0 is the base of the number following these two characters. So as you can see, what's this saying is that this whole number is an oct represented by this letter O, and the number itself that we are dealing with is 1260. And 1260 in octal system is the equivalent of 688 in the decimal system. So this is how we've converted an integer into a hexadecimal or an octal string. Now, what if we wanted to convert two numeric objects into a complex data object? Well, for that we can use the complex function, as you can see here. If I passed complex 5 and say something like 3.1, let's see what this gives us. As you can see, it gives us a complex object where our real part is 5 and our imaginary part is 3.1. So what this does is essentially you pass two numbers. The first one is the real component and the second is the imaginary component. It combines to give you a complex number, as you can see here. Now let's look at some other type conversions. The next type we will be talking about is converting something to a tuple or a set or a list. So what if I wanted to convert a string into a tuple? I will use the tuple function, and as you can see over here. So let's say I have a string called random. Let's call it random. Alright. Now if I want to convert this to a tuple, I will use the tuple function, as you can see over here. The output will give me tuples where each individual component of this tuple are the individual components or the individual characters of my string random. Similarly, if I wanted to convert the string to a list, I would use the list function. And this will give me a list of the individual characters of the word or the string random. And I could do the same thing with the set function to create a set of individual characters of the string random, as you can see here. So yeah, these were some of the basic Python type conversions that I have shown you. As we learn about more complex data types and different object types in Python, we will learn different type conversions and functions associated with them. In this video, you will be introduced to the concept of strings. Strings are an object type in Python used to store textual data. This textual data could be something like, for example, someone's name. It could be an address of a place, or it could be something like a word or a sentence. Now, strings in Python are an object type that is actually a subtype of a broader classification of objects called sequences. Sequences are objects in Python which contain components placed one after the other, where each component is given what we call an index, a numeric index. This numeric index identifies the component in the sequence and its position within the sequence. Now, since Python is a zero-index based language, the first object of any sequence is always index 0. The second is index 1, the third is index 2, and so on. Now let's move on to defining strings. How do we define them? Well, strings are defined using what we call delimiters, and delimiters occur in pairs, an opening and a closing delimiter. In Python, these delimiters are pairs of single or double quotes. So for example, if I were to use single quotes to define a string, I would do it like this. This is a string. As you can see, this is a string is printed over here. This is delimited using single quotes. Similarly, if I were to define a string using double quotes, it's as simple as doing this. This is also a, as you can see. Now a valid question arises. What if I wanted to include a single quote within my string? Well, if I tried to, let's see what happens if I try to print a statement with a single quote naturally inside it. So say I'm saying it's my birthday. Alright, let's see what happens if I try to print this statement. It says invalid syntax, and this is because, as I had mentioned, in Python, single quotes and double quotes are delimiters, so they have a special function in Python, and we cannot simply just use them within a string because Python will treat them specially for a special purpose. So what Python will do is it will pair this and this delimiters or single quotes and say, okay, this looks like a string to me, and it's not going to understand the rest of this, and then it will find a random single quote and it won't find its pair, and it will basically throw us an error because of this. So one way or one workaround to introduce single quotes into a string is simply to delimit our string itself using the other type of delimiter or double quotes. So if I want to include a single quote, I will close my string using double quotes. So if I did this instead of what I had done earlier, this is a perfectly valid and legal way of defining my string. And I would do the opposite if I had to introduce, say, double quotes within my string. I would use single quotes to close it. So if I were to write a speech statement, she said, I am hungry. Alright, I want these two double quotes to essentially show that this is a speech, and I'm going to close the string using single quotes, and this is a valid way of doing it. As you can see, my string has these two double quotes. Now, I had mentioned that strings are sequences. Well, let's describe how are they sequences. So first of all sequences in Python are essentially a sequence of smaller objects that form the sequence, right? So let's try to understand like how are strings to be treated as sequences. Some sequences that we will learn later are like lists or tuples. And in all sequences, we can retrieve any particular object or component in that sequence using its index. And how do we use indexes in Python? Well, we enclose a numeric index within square brackets. Now let's see what I'm trying to talk about by this example. Now say I'm storing a particular string called, say, random within, now my variable name here is test, and I'm storing the string random within it. Alright, and this is a way of retrieving a particular index from test. I write the variable name and then next to it I put the square brackets. Now I'm supposed to put a numeral within the square brackets to tell Python like what particular index I'm looking for. So let's try 0. Now, as I said, Python is zero index based language. So the 0 index essentially means the first part of or the first component of a sequence. So let's see what happens when I ask Python to retrieve the first part of what is stored in test. It gives me the string R. In fact, it's just one character R and it's a string. So as you can see, it has given me the first character of the string random, which is R. So what this shows is that this string random is essentially a collection or a sequence of one character strings. So random is essentially a collection of the string R, the string A, the string N, and so on together combined to form the whole string that we call random. Similarly, if I wanted the character at the third position of this thing, I would use, well, since it's the third position and since we're working in Python, I would use the index 2. And it should give me the letter n. As you can see, it's given me the letter n. So this is how we can show that strings are also sequences in Python. Well, now let's move on to certain string operations and functions that we can perform. Well, as you have seen already, that we can retrieve any particular character within a string using numeric indexes. Well, what if we wanted to know what index is a particular character at? And we can do it like this. We use the index function. So let's say my test, and I want to know where or what position the character D is in my string random. So this is how I would use the index function. Index, and within the index, say I'm looking for the character D, and now it should give me the answer 0, 1, 2. It should give me the answer 3. So if I execute this, it gives me the index 3. So this is the index function that we can use for our strings. Now, what if we want to say slice a string into a smaller part? We want to slice it and we want to retrieve only that particular slice. Well, here is an example. Say I'm going to use the same string called random, and it's stored in test, right? So the way of doing this is like this. Now let's just see what this does first. As you can see, it's given me A and D, and if I went to my string random, A and D is this particular slice. Now let's try to understand what I have done by entering 1:4. Well, what this has done is it's retrieved a slice from the first position, the first index, which is the character A, up until the fourth position, which is the character O, but it has not included O. So it's very important when I index like this, every time I put something to the right of this colon, I am not including this itself. Alright, so it's essentially when I say 1:4, what I'm telling Python is give me the first, the second and the third character, but not the fourth one. So it's given me A, N and D, and this is how we do a slicing operation in Python. Similarly, if I were to say slice from the first, if I wanted only the first and the second character, this is what I would do. If I wanted the first and the second character, I would do 1, 2, 3. So this way it tells Python that I want the first, I want the second, but not the third of. So as you can see, I get A and N. Now, so this is a basic slicing. What if I wanted the portion of a string from a particular point all the way to the right or all the way to the left? Well, let's consider the example of where I want the portion of the string random from the, say, fourth character until the left. Well, the way I would do this is test. Now, since I want it all the way to the left, I don't enter any index to the left of my colon sign. And since I want everything to the left of the fourth character, I enter 4 here. So as you can see, it gives me A, R, A and D, which is everything from the fourth character of my string random to the left. Similarly, if I wanted something to the right of it, I would just do it like this. I would enter some index here and I would leave the portion to the right of the colon blank. So this will give me everything, including the third character, since this is how we treat the indexing in Python, everything including the third character all the way to the right. So this is DOM, as you can see. Now another perfectly valid slicing is, say I want to slice or take out different characters from the string, but I want to skip certain characters. Like I want this one, then I want to skip one, and I want to take the next one, and then I want to skip one. Well, in that case, we have to introduce a step. So one way of doing this is, now how do we read this? So as you can see, I've written 0:6:2. So what this is telling Python is, I want every character from my string test, starting from the 0th character up until the 6th, but not including the 6th, after skipping or taking 2 at a time. Taking 2 at a time can also be assumed as skipping 1 at each step, or skipping 1 character at each step. So what this will do is, it will go to random, it will take the 0th one, it will take R, and then it will skip the next one. So it will not consider A, and then it will pick N, and then it will not consider D, and then it will consider O, up until the 6th character, whichever that may be. And if you see the output, it gives us R, N, O, which is exactly what we wanted. We wanted R, we wanted N, we wanted O, where we skipped A and D, or we skipped every second character essentially. So this is a way of slicing strings while also skipping certain characters, or skipping characters in steps. Now Python is also there's another interesting technique that we can use in Python to where we can start retrieving characters from the rightmost side of a sequence or a string. We can use negative indexes. So if I were to, for example, show you, let's see what this gives me. Test what is a -1th index. It gives me the character M. Now remember, a string is random, so -1 gave us the last character of the string random, which was M. So this is a way of using negative indexes. And similarly, if I used test -2, it would give me the second last character, which should be the character O, as you can see here. Now there are some other important functions that you may use in Python. So for that, let's create another string. Let's call it upper, lower. All right. Now I'm storing it again in the same variable test. Let's see what happens when I use the upper function and what happens when I use the lower function. Now I'm going to use the lower function for this. So these two functions will respectively give us the result, or give us our string in uppercase and lowercase respectively. So as you can see, the upper function created the first string in full uppercase, and the second one created this string in full lowercase. Now another important, and probably one of the most important methods that we use for strings, especially when it comes to data science, is the split function. So let's see what I mean by the split function. Let me create another string. Let's call it hello world. All right. And I'm going to use a split function, and I'm going to see what happens when I use this function essentially. So what I'm doing in these 3 lines is I'm creating the string hello world. I am storing it in test, and then I am using the split function on the test, and whatever result I get, I'm storing another variable called sliced, and then I'm just going to show you what is in sliced. As you can see, what's happened to the string hello world is that I have broken it into its components, or its component words, if that makes any sense, into hello and world, and I've stored both of these into what we call a list. Now you might ask, well, how does Python know that it has to separate at a blank space? Well, the split function by default will break up a string at its blank spaces. But if we wanted, we could break it up using or at every comma. So for example, if I wrote hello world using comma, and if I put a comma inside over here, and now if I try to execute this, like for example, I'm going to look for commas in the string, and then I'm going to try to split it. As you can see, there's no splitting happening. I have one list with my original string itself because it's not found a comma. What if I introduced a comma over here? Now let's see what happens. As you can see, the splitting has happened. It's found this comma and it's caused a split between hello and world. Similarly, in my string, if I put a comma again and I put something else, it should give me the split over there again. So we can define our split using whatever we put in between these circle brackets after the split function. It's just important to note that by default, if in case we do not enter anything over here, it will use blank spaces to do the splitting. Another very important operation and very common operation in strings is what we call concatenation. So if I have 2 strings first and say another string second, and I want to join these together, well, the operator I would use to do this is called the plus symbol. This is the concatenating operator when it comes to strings. So what is the result of this? Let's see. Let's print this out. Let's print this whole thing, and let's see what is the result. As you can see, what this has done is it has combined the string first and the string second into one string called first second. So this is the concatenation operator. Now finally, the last topic in this lesson is the topic of escape sequences. Now escape sequences are special commands that tell Python to either suppress special meaning of some character or symbol in a string, or give some special meaning to an otherwise ordinary character in a string. So let's look at the first example. Now remember earlier in this video where I was telling you like what is the way of writing, or how do we introduce single quotes or double quotes into a string? And I had told you the trick. If I want to use a single quote in my string, I just close it using double quotes, or if I want to use a double quote, I close it using single. Well, another way of doing this is using what we call an escape sequence. And an escape sequence in Python is the backslash character. Alright, so let's see what happens when I use the backslash character where I want to introduce my single quote. So if I use my previous example where I wanted to introduce a single quote and say I'm going to close it using single quotes as well. So I'm going to go back to my error example, so as to speak. Now this would throw me an error, right? As you can see, it has thrown me an error. So what if I used the escape sequence that I mentioned? The escape sequence is just backslash character. Now this is the point of the string where I want my single quote. So I introduce a backslash. Now I have my single quote and I continue writing the rest of my statement. Let's close the string. Now will this work? As you can see, this has worked. So what this has done is this backslash character has told Python to not treat this special character or the single quote, to not treat it specially and let it be as a part of the string. So as you can see, that's what's happened here. Now the next case, or the other use case of escape sequences, is when we want to give a particular character that is otherwise just ordinary some special meaning. So let's take the example of the character T and the character N. We use the character T to introduce tab space, and we use the character N to introduce what we call line break. Well, let's see by an example. So normally the character T has no special function. So the character T within a string will just be outputted as the character T itself. However, as you can see here, I'm going to introduce a backslash before this character T. Let's see what it does. It introduces this thing that we call a tab space, which is a larger than normal space. Similarly, if I were to use the backslash n combination, this would introduce what we call a line break. And if you were to see the output of this, you can see at the point of the string where I have this combination of backslash n, a line break has occurred. So there are plenty of other escape sequences that you may choose to learn, and these are just two of the probably the most common ones that I used. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered, arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? Lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains 3 objects, 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if 2 lists contain the exact same elements, if the elements are placed in a different order, the 2 lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3, the same elements but in different order, I will use the is function to check whether these 2 lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have 2 lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are making or as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say increase we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists are they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list, and I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I wanted to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is, I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider 2 every second element essentially. So what it will do is it will go here, and then it will skip 1, and then go here, and then skip 1. And that's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. Alright. So let's see what happens when I take every second element. It should give me, it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say A minus 1, it's essentially looking at the last element of the list. So it gives me the 6th or the last element, which is the object 6. If I did A minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax: double colon, and we give a minus 1. What this tells the system is, I want the list A, but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be 2 similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this, and I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication or a replication function where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's 3 strings, eggs, apples, and carrots, and I have 5 int objects, 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with say mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first 3 elements. I want to replace mango, I want to replace apple and carrot. So what I will do is, I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with 3 different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my 3 elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, 3 elements with only 1 or 2 elements, that is also possible. So now if I want to replace the first 3 elements, kiwi, orange, and sponge, with just 1 element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, 3 elements have been replaced with 1 wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with 3 different elements, an obvious way would be just consider that element's index and then put whatever objects you want. Say I want to add, instead of wine, I want to add beer, I want to add ball, and say club. Yeah, well, let's see what happens. Now if I say B, check what's inside my, you can see my elements have been added, but they seem to have been added as is. I had entered a list over here, and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace one, if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine, and I had 1, 2, 3, 4, and 5. Now if I do this, B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace. It will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have the, I've removed wine, and in place of it I've put beer, ball, and club, but these 3 are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2, and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append 3 different objects, I want to append 5, 6, and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list. And this is not what I wanted. I wanted 5, 6, and 7 to be individually placed. And we do have a way of doing that. And the way to do that is the extend function. That is what I'll show you next. Now, if I want to extend, say, the original list by 3 different elements, 8, 9, 10, when I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now, the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parenthesis, you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, all right, this number, if I want 8 itself removed, what I will do is put the value 8 here and it will remove it from my list. So if I check my list A, as you can see, the value 8 has, it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list. But unlike remove, the pop function actually outputs a value and that value is what we have popped out of the list. So by default, it will pop out the rightmost value of a list or rightmost element of a list. And in this case, that element is 10. So it should give me 10. But of course, if we want to pop out any particular object, in this case, we do not give that particular object, we give its index. So now say if I want to remove this list object from my bigger list, as I can see, it's in index 0, 1, 2, 3, 4th. It's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in 2 key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2, and 3. And the next very important property that is different or that differentiates tuples from lists is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So you use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I will be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3 and 4 tuple into t, let's unpack it into another tuple. Let's call this, let's put these elements into this tuple, and I put this into t. Alright, now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in b, it gives me the value 2. If I see what's in 3, it gives me value 3, and d gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into t, and then put that tuple t into this tuple a, b, and c, d. So what has happened essentially is the element a has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto a, 2 has been unpacked onto b, 3 has been unpacked onto c, 4 has been unpacked onto d. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to a, 2 to b, 3 to c, 4 to d. I have matched these two tuples together like this, and this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements of this tuple and the elements of this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright? In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did x, comma y, comma z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in x, it is actually 5. If I see what's the value in y, it is 6. If I see what is the value of x and z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. In this video, we will cover concepts surrounding dictionaries. Dictionaries are another type of composite data type in Python that are also a collection of objects, much like tuples and lists. And like lists, they are also mutable, dynamic, and can be nested. However, a key difference and property of dictionaries is that they are unordered. Items in dictionaries are paired using keys, unlike in lists and tuples where the objects are assigned numerical indexes. To define a dictionary, we use curly braces. Each key value pair in a dictionary is separated using commas, and the key and values themselves in a pair are separated using a colon. Let's look at an example. This is a dictionary where I have 3 key value pairs. As you can see, they have been separated by colons, and each pair themselves are separated by commas, and these are enclosed in curly braces to define the whole dictionary. In this example, these are the keys: banana, apple, and grape, and their respective values are yellow, red, and green. So this is very important, that in this particular data type, we have what we call a key, and that key is assigned a value, and we can have multiple such pairings, and we have 3 such pairs in this particular example. Another example, or another type of way to define a dictionary is using the dict function. This is how we use it. As you can see, I have inputted 2 value or 2 object tuples. This is a tuple, this is a tuple, and this is a tuple. And when I use it in a dict function, when I place it within a list, what Python will do is it will consider the first element of each tuple as a key and the second element of each tuple as its respective value. Now if I check what's in D, as you can see, the key banana has a value yellow, the key apple has a value red, the key grape has a value green. So this is another way of defining dictionaries. An important note over here is that the objects that we use for keys have to be of an immutable data type. So we cannot use, for example, lists as an example of keys, but we can use, say, integers or strings for our dictionary keys. Also, keys have to be unique when it comes to a dictionary. You cannot have two different keys with, or should I say, the same key having two different values. You can have only one key, and that one key will have a unique value assigned to it. Duplicate keys are not allowed. However, when we speak about values, we have no such restrictions. You can have a mutable or an immutable data type as a value in a dictionary, and you can have duplicates as well. So if I created a dictionary with a key, say, banana, and if I associated with it a value green, I cannot create another key banana and associate a value yellow. Let's see what happens when I actually do this. If you actually see, what has happened here is Python has considered the second case. So it first looks at the first pair, it goes, okay, so my dictionary has a key banana with a value green. But right after it, it sees another key banana with a value yellow. So it overwrites my first key banana with the second key, and it overwrites the first value green with the second value. And we essentially get one key banana with the second value yellow. So obviously this is Python does this to avoid duplicacies. However, if I created a dictionary with a key banana again, if I gave it a value yellow or say green, if I created another key, and if I gave this also a value green, this is perfectly fine, and this will nothing special will happen in this case because values do not have to follow such rules. Let's see certain dictionary operations and functions now. So let's bring back our original dictionary, which we had created earlier with the 3 pairs. Alright. So what if I wanted to, we can use keys to essentially do these operations and functions. Let's see what happens when we, so much like how we use indexes in example of sequences, we use keys when it comes to dictionary. So let's see what happens when we use a key over here. So as we know, banana is a key in this dictionary. Let's see what happens when we give this command. It actually gives the value associated with that key, which is yellow. What if we wanted to change a particular value associated to a particular key? I would do this. I would give the key and assign it the value that I want to change it with. Alright. Now if I check my dictionary, you can see the key banana no more has yellow value, but the value gold. What if I wanted to add a new pair? A new key with a new value completely. I would do it pretty much the same way as I did in the previous step. I would essentially write my new key, whatever I wanted. Say if I wanted a new key called watermelon, I would assign it a value red. And now if I check my dictionary, at the end of the dictionary, you will see that my new key value pair has been added, watermelon red, as you can see over here. Now what if I wanted to remove a key value pair from my dictionary? I can use the delete function, which is called by using the del function. Now how do I do it? Say if I want to remove the key value apple and red. So all I have to do is do del, d, and within square brackets, I have to only mention the key. I don't even need to mention the value, just the key. So you can probably draw parallels in how we use indexes when it comes to lists and tuples and even strings, and how we use keys when it comes to dictionaries. They are quite similar. So if I did this, and if I, I think red is actually not a key. As you can see, red is a value. My key is apple actually. It's not red, it's apple, as you can see. Now if I see my dictionary, the key apple and its value red has been removed. So these are some of the operations that we can do for dictionaries using keys. What if we wanted to use certain inbuilt functions that are associated with dictionaries? Well, some of the examples are as follows. There is a get function. When we use the get function, all we have to do is enter a key inside the parenthesis, and it will get the value associated with that key. So if I gave the key grape, let's see what value is associated with it. As you can see, it's green. there is also a function called items that returns the key and value pairs in our dictionary as a list of two object tuples, where the first object is the key and the second object is a tuple. So let's see what it does. As you can see, it gave me a list, and in this list the objects inside the list are two object tuples, where the first object is always the key and the second is the value, and it's the same for each of the tuples. So this is what items function does. Let's see what the next function is keys. Let's see what the keys function does. As you can see, it returns a list of all the unique keys within our list, within our dictionary. Similarly, there is a function for values as well, and as you can see, it returns all of the different values that are present in our dictionary in the form of a list. Also, it's important to note that if we have a particular value that has occurred multiple times in a dictionary, it will appear as many times it has occurred in the dictionary or appeared in the dictionary in our list over here when we use the value function. So if, say, a particular value, say I had another key where its value was green again, so I would have the value green appear in this list once more, essentially. Our next function is pop item. What this does is, much like the pop function in lists, it gives us the last entered key value pair that is present in our dictionary. So the last entered pair was watermelon, key watermelon with the value red, and that's what has popped out when we give this function. Another important function associated with dictionaries is the update function. And the update function is a very neat function that is used to merge two dictionaries together. So say if I had a dictionary, let's say I'm creating a dictionary using the dict function where I have, say, some key called kiwi. So as I had mentioned, I will use two object tuples in this case, and let's say I give this also a value green. All right, and another pair would be, say, mango, and let's give it a value yellow. All right, so this is another dictionary that we have created. As you can see over here, we have created a dictionary with a key called kiwi with value green and another key mango with the value yellow, and I already have a dictionary D with these values. All right, now if I want to merge these two dictionaries, I can use the update function. What I do is, say if I want to merge D with X or X with D, only the ordering will change, and that doesn't really matter when it comes to dictionaries. So if I want to merge D with X, I use D update, and then inside it I put my target dictionary. Now when I check what's in D, I have the dictionary X and its key value pairs merged inside my original dictionary D. As you can see, I have my original ones here and I have the merged ones over here. So this was the update function. In this brief video, I will explain what we call the type hierarchy or the standard type hierarchy in Python. It's also known as the data model in Python, and it probably has other names. So essentially what we do or what we speak about in this is how the different types that we use in Python are categorized and classified and what are their subtypes. So it's important to note before we continue further that in future versions of Python, there might be new types that are introduced or the existing ones may be modified. But it's safe to say that what I will speak about in this video will still form the core of what we call Python standard type hierarchy. So let's begin. So the first type is the none type. It's accessed through the built-in name none. Its truth value is false. It's essentially used to denote functions, or it's returned as the value for functions that don't really return anything. So if you have an expression or a function that returns no particular value, you actually get a data type called none. That is how Python interprets it. Then there is the ellipses. Ellipses is something that you might encounter later. It is accessed through the built-in name ellipses. It is used to indicate the presence of this particular syntax, this particular symbol or expression or syntax in a slice. Its truth value is true. Again, don't worry too much about ellipses right now. Next is numbers. And numbers is something that we are very familiar with. We've seen, we've worked with numbers a lot. They are an immutable type. They are created through numeric literals, and they are the outputs of arithmetic expressions and built-in arithmetic functions. Its subtypes are integers, floating point numbers, and complex numbers. Within integers, you have plain integers that represent numbers in the range this number and this number. So this number is basically the largest positive value that you can represent using 32-bit notation in 2's complement, and this is the equivalent for the negative side. Long integers, on the other hand, are used to represent numbers in an unlimited range that is only subject to the available memory of your system. So these are two types of integers, and as we know, floating point numbers represent machine level double precision floating point numbers, or numbers with a decimal point and a component after that. Complex numbers are numbers that contain a floating point number that represents a real part and a floating point number that represents an imaginary part. So these are the types of numbers. Then we have sequences. Sequences are finite ordered sets indexed by natural numbers. So each element in a sequence has an index, and that index is a natural number. The different types of sequences are based on the mutability, whether the objects can be changed or not, is essentially what we mean by mutability, right? Once we create an object, whether we can modify it or not. That is how we differentiate different types of sequences. So there are mutable and there are immutable types. The different types of immutable ones are strings. We know what strings are. They are sequences that contain characters. Unicode is the other immutable sequence, and then there are tuples. Tuples are a collection of arbitrary Python objects, and unicodes are sequences that contain Unicode characters. Then we have mutable sequences, and there is only one. Currently, there is only one built-in mutable sequence in Python, and that is lists. Lists are also, again, collection of arbitrary Python objects. Finally, we have, well, not finally, but next we have mappings, and mappings are, again, sets of objects, but these objects are now indexed using arbitrary index sets. You know, the difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings, they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python, there is only one built-in standard mapping type, that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So these, so what I have mentioned until now are probably the most common data types that we encounter, or that we have encountered now. So next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that we that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime we, and as we will during the course of this tutorial, during the course of this this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division, or the single and the double backslash, is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power of something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. I am creating, so as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true, false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. So if I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did X is say equal to 2 and now Y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false. As you can see, since X is 2 and Y is 3. As you can see, X and Y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if X and Y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because X is not equal to Y in this case. The next one is greater than. So if I did X greater than Y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did X lesser than Y, I should get true over here, as you can see. There's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say X is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright, so now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11, as you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b or 6 by 2 and it will assign that back to a. So my value in a should be 3. As you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see if I did a is equal to 7 now, and then b is equal to 3. Now, if I did a double backslash equal to b, now it will do the same division, but it will do a floor function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say a is equal to say 5 now, b is equal to 2. Now if I do a percentage symbol equal to 2, I mean b, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in a. As you can see, it did a divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide a by b and then give me the remainder and then put that remainder back in a. And as you can see that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have a is equal to say 5, b is equal to 2, and I want to raise a by, if I want to raise the value of a by the value of b and then store that back in a, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If A is equal to 1001 and B is equal to 1000 plus 1, alright? If I did A is equal to 2, this is an equality check. Are they the same values? True. Now if I say A is B, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of A. The ID of A gives us some value like this, and the ID of B gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. The is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2 and 3. Basically simple list with 3 integer objects, 1, 2 and 3. I will check whether, now say 2 in A. So is 2 in A? If it is, it will give me true, as you can see. Is 5 in A? It should give me false because 5 is not in A. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmetic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3, it can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with a radius 3, all I would have to do is use the formula 2 pi r. And to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant in from the math module, it will also return you a float number, and to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, so let's see what happens when we call the math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of INF or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus INF. as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical concept. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, how to call it, this is how you actually do it: math.nan, and it will give you a data type called NaN. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation. There's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this: math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass math.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil, as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the largest, it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12, the smallest integer that is greater than minus 12.3, and this should give you 12, as you can minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component, so only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It should give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this mathematically, what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in to Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if you say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, which is this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, Moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function. And let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is, the details are not important. So this will, I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element. And in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this, math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2. And this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is, again, I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the math? The square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of certain angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details don't have to be, you don't have to know the details. You just should know that if we wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be cos a cos h. In this video, we will learn about conditional statements. And we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if followed by an expression. As you can see from this pictorial, there's an if statement, there is a expression, there is this block of code which, if you can actually see, is slightly indented to the rest of the code, and then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if the statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. Let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this, the result, which is, this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consist of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this if this condition is met? Well, this is where indentation comes into play. And as you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now, it's very important to understand that this is how indentation is used in Python. In other languages, we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for. But it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally I have one small topic that I would like to share with you is the conditional expressions or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now X, now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement. And then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable X. And this, what value I'm assigning to X depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to X. And as you can see, if I execute this and check what is in X, you can see adult is indeed in X. So this is a very neat, a very readable, and a very it's probably a better looking way to perform simple else, simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python? Well, let's just keep it a hold for now, and I might put something into this block later in the future. Well, I would use the pass statement. So if I had this, say this some condition again, so I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's like a way to create a placeholder where maybe in the future I might write some sort of a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything. to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false. And if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process, and it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop, and then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n, and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times, and each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0, and I print the statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, or like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now this while statement, now it might look confusing. Now it says while A. Now what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally, we have another statement within this block called the pop statement, where we're popping the elements of A. Now, as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. And again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1. And as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list, and that is why while A returned me a false, and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements, and we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them, and it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5, and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B, and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops, and this is completely executed, and only then do I go back to this first one, and then I come back and do all of this again. then I go back to this one, and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration, and then I do the second while loop. Then I have the second iteration, and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now, break and continue statements are ways to abruptly end iterations in a particular loop. Now, you can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements and I have a break command over here and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was, I was printing the value of n. So it was printing as value of n is 0, and then 1, and then 2, and then 3, 4, and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, so when I've executed this, I don't get the whole value of n is 0, and then 1, and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay. So let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed, and that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement between, that is the difference of the continue statement with the break statement. This video will be an extension to that topic, where we will be looking at 3 examples where we are using while loops along with other stuff like, say, if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC, which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0. And if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC, where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line, where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again, where we are going to multiply FAC. This time FAC stores the value 8, and we multiply it times the new number, which is 7 now. So we do 8 into 7. And then again we decrement this. Also once we do 8 into 7, we store it back into FAC. And we keep doing this, where we keep multiplying 8 times 7, and then we decrement the number variable by 1. And then we check this condition again. So what ends up happening is, we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself, where it will show you 8 times 7, or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate. And then the user would be asked to give an input, which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first two numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now, in that case, we move on to this block. In this statement block, we initialize the fib variable with the first two Fibonacci numbers 1 and 1, and we store in this array. Now, we are going to do a while loop within this, and in this while loop, we are going to keep executing this statement block as long as this condition is met, or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we are going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1, and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we are going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I, j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the 3rd row and the 5th column, or say the 3rd row and the 3rd column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the 2nd row and the 4th column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input 2 numbers, 2 integers, to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5, 5, that will be stored as an int in this particular string or this variable. What we want is we want 5, say we entered 5, 5, we want 5 as a separate integer and the other 5 as another separate integer, and that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we're going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multi-list, which is basically what our final array is going to look like, and we're going to store into multi-list. And in this example, we will be using for loops to do this or to create this particular array. So as you can see here, our first, we have initialized our multi-list saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multi-list will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3, 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as, so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So this is my final array that I get. So what you can see here is this is the 0th position, and or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the 4th row, for example. 4th row times the 0, 1, 2, 3, third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are two types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. All right. So in Python, we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So, think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, it is actually a list iterator at some random memory location, which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator. And in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now, what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other. And that is kind of how, or that is the basis for which we do, we create loops. Let's see what we exactly mean using this, using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter_a. Now with this iter_a, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth, now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned two things. What is an iterator, and how do we create an iterator out of different collections of objects like a list or a tuple. And we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. As you can see, some for loop with the objects again 1, 2, 3, 4, and 5. Alright, this is a list. Now I'm going to do for x in A, print x. And let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4, and 5. So first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in A, print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2, then 3, 4, 5. And then finally, on its own, this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright, so think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration. Alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally, the third step is the termination step, is when after we do the final next, where we get this error, as you can see, the stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so Now I'm going to speak about, in specific, I'm going to speak about this something called the range function. That is quite, you could say it's used, definitely it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4, and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in X. Okay. Now let's do a type just to see what happens when we do type X. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in X print I. Okay. Let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is, when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3, and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator of 5 objects from 0 to 4, 0, 1, 2, 3, and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len A. Let's see what's going on here. First I do length of A. That gives me 5. Then I do range of 5. That creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, there are you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely, and we will move on to the next piece of code. Whereas the continue statement will break that particular iteration, and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, create this dictionary. Again, we'll store it in A. Okay. So I created this dictionary A. Alright. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type, of a specific dict key iterator type. Alright. So now let's do something on this. So as you can see in this dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has the value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore a print I. Let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore a. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is how to, this is basically two different ways of iterating through a dictionary, one through keys and one through values. In this video, we will be doing a small exercise on if statements. Now in the previous video, you might have already seen some of the basic concepts surrounding if statements. However, in this video, just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is, it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if-else statements are if-else statements within if-else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0, stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block. Else, we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true. And finally, I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are two sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int. data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if else statement block. Now, what this block is checking is whether the entered number is an even number or not. Now, as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number, and that means when we divide by 2, we should get the remainder 1, as you can see here, and we get printed your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered, and the code is telling me that my number is indeed odd. Let's look at some other. What if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20, and my number is even, and the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is this condition itself is not met, and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1, and we execute this block, which says our number is odd, as you can see here. In this video, we're going to learn about the topic called file handling. Now, file handling is basically needed because most of the times when we're handling large and different types of data in Python, or in general, we cannot store everything into a variable, and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now, all binary files are encoded in a particular format and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding, and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are 4 main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file, and the syntax is as you can see here, where we use the open command and we give a file name and we give a mode, and we store that in a particular variable. Now, a mode is basically telling Python how to handle this opening. So we can have a read-only mode, which is done by this letter R, a write-only mode, which is done by letter W, and there are a bunch of other modes, such as read or write mode, which is done by R+. And we are going to see them as we encounter them. Now, it's important to note that what I just mentioned is for text files. If we are going to do, for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. and that's how you do it here. Now let's look at different ways in which we can read from a file. And there are 3 commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I have done first, I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is going to, each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file, I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file. And what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted you to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these 2 variables are equal. So when I do this, I get my result, which is machine learning, which is the 5th line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in 2 variables. So it's basically 2 strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future or in future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store two particular file locations in two variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here, very similar to a normal text file opening. Now once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image, and if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image, and my second image is another JPEG, slightly bigger image, and again RGB. Now we can also of course display these images, and to do that we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that again you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of IM1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function, and it copies an image onto another variable that you have assigned. And when I use the IMShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I'm done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user-defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. repr is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user-defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also, the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods. This basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now instance, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of is called the string name myClass with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class myClass in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like @class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called myInstance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method. which is declared using the addStatic method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. In this video, we will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use this print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3. And I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print is instance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that well, this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is a simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1 we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have 2 methods again. One method is called set marks, which has the option of putting in 2 attributes, m1 and m2, both representative of the 2 marks, and we store them in self.mark1, self.mark2. The second method is put marks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called a result, which derives from 2 classes, marks and student, as you can see here. In my parentheses, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have 2 methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I've created an instance of this derived class called result, and I'm storing it in R, Then I'm going to access method 1, which is obviously a method from the first superclass called student. And I'm going to store, okay, so this is name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called set stud and put stud, or you can call it set student and put student. In my first method, I have the options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called set marks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do basically, we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2, and finally we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier, but the only difference is in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1 where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1. And I'm going to say, after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y. And since I've done this twice from 2 different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much. That is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the 3rd class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, 2 attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called setMarks, where we can pass 2 attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a putMarks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has 2 methods, getPractical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for putPractical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a putTotal method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have setMarks, which is again the second level parent, which is the student class, where we set the marks. Finally, we access this getPractical. Now, if you notice, getPractical is part of the practical superclass. So in this, we store the 3rd subject of the practical marks 100. Then we calculate the total and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. In this video, we will continue our discussion on object-oriented programming with the topic of polymorphism. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example where we're able to use the plus operator for different operations is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now for example, what I'm going to show you here is an example where I have a method called sum. Now by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8 and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8 and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C have a default value of 0, I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define. The initializer is two attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also wanted to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator or the special method to provide functionality for the plus operator in Python is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffix with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point, and I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator, where I'm going to basically allow the this asterisk operator to multiply two objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default, it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object1.name, and it will say earns more than object2.name if in case object1 is indeed greater than object2. So when I execute this, you can see here, my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. In this video, we will be taking a brief introduction into what is a function. So a function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. All right. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in triple double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. All right. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. All right. Let's done here, and let's call this. So of course, now once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a doc string. So what this doc string is basically something that we include in triple quotes over here just after the def keyword. And this is like a brief. We can use this to give a brief brief information into what our function is doing. So we can say this function performs addition, this performs subtraction, or whatever, like some basic information as to what our function does. So we can use a doc string for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. All right. But for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay. So now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you've noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said if I included some a and b over here? So what this means is, whenever I call this function, I need to pass two parameters, a and b. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add a and b. So instead of this print statement, let's do this. I create a variable c, and in that I'm storing a plus b. All right. And then I return c. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called c, which is the addition of a and b. Now, how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of A and 3 will take the place of B. Alright. What will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the doc string of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is the doc string, and this is how I do it. So let's do print. Let's print what is the doc string over here. This is a doc string. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. Alright. Now this will say this does addition when I execute this line. So this is the way to check what is a doc string. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. Alright. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called my var, and it prints the value as 10. And the moment my function has been executed, it destroys this variable, and the variable which contained the value 10 is of course now destroyed, and all we have is the my var that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The my var that is present inside this function is different to the my var that we create outside. So the scope of the my var within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function I've stored my var. Let's say I define a function, define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in my var. Okay, so let's do print value of variable is value stored in variable is. Okay, that's my var. So let's see what happens when we do this. Let's call this function fun underscore name. See what happens here. So as you can see, the value, I stored a value 100 in my var and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable. So I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable, now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted, and that is because I've defined my variable to be a global variable within this function. So I can, in fact, make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions. The three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions. That is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function where fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default a is 2 and b is 3. But this is not fixed and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a default value. Then that's because well, there is no default value and it needs an a and b. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now, the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers. It doesn't really matter what this is, but this is the key, the asterisk here, and this tells us that whatever we pass here is now, if we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just, since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing, I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of, like, it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep, I can just keep like, so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable, argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings. And what I'm going to do in this function is I'm going to join them together. And I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, like, if I had to add something else, like Python is say, cool, and say, I just wanted to say hello and say one more string. I can add it just like this. I don't have to like define a fixed number of arguments. I can pass any number of arguments I want. And this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. Like this, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. In this video, we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process, and it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now, if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so, that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception, where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay. So let's use the assert keyword. All right. Now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error. The error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we are going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block, where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right. It's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you could look at it like this: if when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. All right, so now I have a try block over here in which I am going to try this function, Linux_interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens? So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block, where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error? And we can do that explicitly like this. So now what I'm doing is I'm going to try Alright, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It'll basically print this statement: function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using the try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that, and I'm going to print that error over here in the except block. Alright, so as you can see, file not found, and whatever error I have, I printed over here. Alright, so this is another a file not found error that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have multiple errors in a try block. So as you can see, in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get two exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux underscore interaction function. Function can only run on Linux systems. The Linux function was not executed. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not to use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception happens, is raised, or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This is I'm doing the try block. Now, if I catch an error, that I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. Alright. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Well, that was it for an introduction into exceptions in Python. I hope you learned something from this. And of course, this is just the beginning. Exceptions are something that you would probably encounter a lot, especially when you're beginning. And it's something that you will learn to extensively work with. And that will also help you improve in your programming. In this video, we will be covering the topic of iterators. Now, an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two key value pairs. Key X, which contains the value 1, and key Y, which corresponds to the value 2. Now, when I'm going to do a for loop through this, by default, I will be traversing through the keys X and Y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. In this video, we will be covering the topic of modules in Python. Now, a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing the statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module, as you can see here. All of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCWD function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now, a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these 4 functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I have to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from mycalc, we can do from mycalc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way of importing something from a module. Now, to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import mycalc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code, and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have 2 variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, then the subtraction, multiplication, and the division of these 2 numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these 2 arguments or these 2 variables to say that I want to add these 2. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now, to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement, and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import os, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. In this video, we will be covering the topic of packages. Now, what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules. What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever you needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg, and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this, so you don't need to bother about seeing me doing it right now, because I've already created these files. And what I've done is within mod111.py, I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import start. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples, such as methods when we were working with classes and objects. In this video, we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here, I have defined a generator called myGenerator, where I'm doing like there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. Then I'm printing second item yielding 20. Then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know myGenerator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see, when we do next and we use gen, what happens? So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next. Let's do it once more, since there is one more task. There's one more iterable inside. You can see this. Now, a valid question is what will happen if we do next gen again, since there is nothing after this. Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global. And the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright. And let's put a return over here after this particular, the second yield. Okay. Let's do the same thing. We say gen is equal to my generator, and let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is again is going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration, and that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop or for a for loop. So let's take this, what I have over here, and I have defined a function called getSequence up to x, and what this will do is basically it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say, sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0, and now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error, because that we have reached the end of our iteration. So this is a way of using generator functions for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. In this video, we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples, we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to So I'm creating a list over here, as you can see. Now within this list, you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if, now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. All right. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will you just basically need one line. In this case, it will just be like this. Now this is my string. Now let's see, when I check what's in h letters, let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this would this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is x is going to take the value of 1, 2, 3, 4, and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this, what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number. And if this condition is met, that means we store the x into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each, okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are the even or odd. The first, let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between, like say the first 10 natural numbers, as I said. And let's check if it is divisible by 2. Well, if it is divisible by 2, of course it's going to be even, right? Else, we say that it is odd. And then we check for I in, say, the first, let's say the first 20. Okay. So now when we do this and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double x, this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking. What we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list let's call it y. So now let's see what's in y when we check. It should be 0, 1, 4, 9 and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check. So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set, and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course, now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key, which is going to be like 0, 1, 2, 3. And the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2, 4, and then 3, 9, 4, 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user friendly. And also it's important to note that every list comprehension can be written in the form of a loop. but every loop cannot be written in the form of a list comprehension, and that is probably a very key point to remember. In this video, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now, the regex pattern or the regular expression module in Python can be imported using this statement, import re. Now, once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module re, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this this command, we should get a perfect match. So we should basically it should say that search is successful if I execute this, and this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we are looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this $ symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B, and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B, and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B, and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4, and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B, or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B, and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma, whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. Even though you might be wondering, like, I can see an A over here, I can see a C over here. re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my larger string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now, if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string, and it will return us the first instance where it finds a match. Now let's see, this is a test string now, and we're searching again for we're searching for A, B and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again, but this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us, that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now what if we wanted to find out all the instances wherever A, B and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found two A's successively. So this is actually how findAll works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.findAll methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now a period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have two characters, like sets of two characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have two characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is one character. If we checked it with AC, it is a match because A and C are two characters. A, C and D will also give us only one match because it will find A, C and then it will leave D as a single character. But when we check A, C, D and E, or this string in particular, it will find two matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using re.search for each of these different examples. So if you see when I use findAll on A, C, D, E, and when I'm searching for a two character match, you will see that it will return me A, C and D, E, as you can see here. And similarly for something like this, it will return me again whatever like two character patterns it finds successively. So the next symbol, the next meta character is the caret symbol that you've seen earlier. And the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is one is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not. So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we have already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N? And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately, or the N is preceded by an I immediately. And this is a no match because the strict condition in the search is that N must precede an A if the A exists. Again, in woman it will match because N follows an A over here. We're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need M and A, at least one occurrence followed by an N. All of these conditions have to be met. So again, if we took the first example, M and N, this time it will be a no match because there is no occurrence of an A over here for preceding the N. So it's a no match. M, A and N is a match because, well, this is perfectly fine. M triple A and N is also perfectly fine. But if you look at M, A, I and N, much like earlier, the N is preceded by an I and not an A. So there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1. Only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases. Only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, M and N is a match because there is 0 occurrence of A and 1 occurrence of M preceding N. So this is fine. This is also fine because there is 1 occurrence of A and M, and then it's followed by an N. This will not be fine because now we have 3 occurrences of A, which is followed by an N. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character A in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one A, and even this part of the string only contains one A. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 A's for two repetitions of A's consecutively. But this in the third example, you can see both the strings actually contain matches. So we get 2 matches because, as you can see here, there's 2 A's here followed by 3 A's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of A, but now we have 4 occurrences of A. But what the search engine is going to recognize is these first 3 A's, and it's going to see, okay, so there are 3 occurrences of A and I already have a match. It's not going to consider this 4th A in the search. It will just look at the first 3 and it say, okay, there are 3 A's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different meta characters and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we are going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it'll find one match. This particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not because these are characters. But if you look at this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3 as you can see here. But now if you look at this test string, it's going to return me 12. It's going to return me 3, 4, 5 and 6. It's going to return me 3, 4, 1 and 2, but not 7 because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7 followed by 8 and 8 as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by x and z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have 2 matches in this case. First an A followed by x and z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an x and z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an x and z. And we can get that over here. We get B followed by an x and z. So you'll get 2 matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves 2 purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these 2 examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that there should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis.
Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is Exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically there are two different types of data analysis: initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts. What exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliners, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now, let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that, we will project the future, that how they will, improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color. Color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can give the border radius as 20 pixels. And padding to be 16 pixels. Text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python exploratory data analysis, and we will break here for student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have our title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that, we might have to install these libraries. So we will be using pip install here, pip install CatBoost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that, we will also install LightBGM. sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, Matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output, and after that we will tell the Jupyter notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import numpy as np. Let's quickly copy this and proceed, enter. And now we will be needing pandas as pd, enter. And now we will be needing Seaborn SNS, and we will also use matplotlib.pyplot as plt, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import re from sklearn.impute import simple imputer from sklearn.model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries lit-gbm as lgb from lit-gbm library, import lgbm regressor from catboost, import catboost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read csv, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case, it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df dot shape, so that you can understand what's happening with this data, right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns, couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here, and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here, and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure. Figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. Now 9 would be a little bigger. Now enter. Now we'll use cbound library here, sns dot count plot x is equals to data frame cleaned target. Okay, before cleaned target we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right, null entries, and we also found some. So here we have 299 rows which have missing values, so we will have to remove that. For that, we might have to create a new column which has to be named as not assigned, right? df data frame not assigned, which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null. So we don't have null values, but we have some illegal entries, maybe some. There you go. Now let's quickly run this query. So there you go. So the new data is about 678,20. So there is some, okay, we did some mistake here. So we are supposed to add it as null, null. Now quickly run this. So we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new data set. df na dot describe. So these are the new columns and the rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, but by mistake if they added another one, right? Triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular data set. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned data set. So we can make use of the same code here and paste it right here, and instead of describe, let's write head, so that we have the header of this particular data set. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous course. And after that, we will also make use of other columns in this particular data set, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data, okay? We will categorize the data in terms of, let's say, first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category, If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular data set so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it. And now next we will check the data type, column separated and everything, and we will create data type category variables. Right, and now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns. Hours studied, attendance and previous scores. For num call and for cat call, we are considering the other columns apart from the first 3, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations. And before that, let's try to add some data from in HTML. Let's try to create a, okay, what we can do is simply copy this particular HTML file here. We can take this and add it here so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data. And we will keep the colors same, dark blue background, and the color for data visualization will be light blue and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with 3 other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15,6. Big size is equals to 15,6. The same one that we considered before. And we will be using cbon SNS dot count plot, open bracket, is the function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line, if you need you can add the full stop, if not you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to, so I want lines to be hyphen hyphen, in this way I want the lines, and comma, line width, let's say 0.5 or 0.7, let's go with 0.7, line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done. And we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65. And there is a good number of students which are also scoring above 65 as well, right? So 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create three different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name. Length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score. Let's also add single quotes here. Who are scoring in between or less than. Let's start with less than or equal to 64. We'll not consider 65, we'll consider 64 divided by len of df cleaned target variable exam score, single quotes, into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, R under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70. Lastly, in between, the ones in between 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate if possible this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML. Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non-na values. We're trying to eliminate na values. In place of those values you can write true, and after that we will try to eliminate the null. So if it is null, dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance, and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course, and we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure axis equals to ELT dot subplots. So we will be having three different plots here since we're considering three different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot rebel for idx comma call in enumerate call, and we will try to import the cbound library here. We will try to create histoplots here, histograms here, histoplot, so line style we will be selecting this one, and comma line width will be 0.7. There you go. Next will be access idx dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the three ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height and show the plot. There you go. Let's try quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these three parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page. And if we run this, it will give you the result. The breaks or gaps in the hour studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is our target variable. Now, let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now, we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here. But before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically, a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation, it is the df.corr, which is a data frame, and it is created by selecting only these columns for df cleaned data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the corr, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df.corr. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level and extracurricular activities, and we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it.
Web scraping is a powerful technique that allows you to automatically extract data from website, turning the vast amount of information available online into something you can easily analyze and use. Whether you are gathering data for research, building a dataset for machine learning project, or just curious about how websites work behind the scenes, web scraping is an essential skill to have in your toolkit. On the other hand, Python is one of the most popular programming languages for web scraping, thanks to its simplicity and the wealth of libraries available. In this video, we will explore how to use Python to scrape data from websites, and we will dive into practical examples using Python libraries like request and Beautiful Soup to fetch and parse web content. But it's not just about the code. Web scraping comes with its own set of challenges and ethical consideration. We will talk about how to scrape responsibly, respecting the rules set by websites, and ensuring that your scraping activity don't negatively impact the sites you are collecting data from. So by the end of this video, you will have a solid understanding of how to start scraping data from the web using Python. Whether you are new to programming or looking to add web scraping to your skill set, this video will give you the knowledge and tools you need to get started. So let's jump in and see how Python can help you unlock the full potential of the web.
So here I am using this Google Colab for the web scraping. Okay, you can use your own like Jupyter Notebook, Visual Code Studio, anything. Okay, so here I will write web scraping using Python. Okay, then here first you have to install some libraries like request, and you have to install Beautiful Soup, and you have to install that Pandas, because we will create one data frame and we will save it, then we will check our data. Okay, and you can install some basic Python libraries like NumPy and all that. Okay, so here first I will import request. Okay, then I will write from PS4 import Beautiful Soup. Okay, soup. Then I will write import Pandas as Bill. Fine. Then now what I will do, okay, let's see what is this request and all this. So request is an HTTP client library for the Python programming language. So request is one of the most downloaded Python libraries. Okay, it's like more like over 2000, not exactly 2000, sorry, 200 or 300 million monthly download. Okay, so what it does, it maps the HTTP protocol onto Python's object-oriented semantics. And here Beautiful Soup. So Beautiful Soup is a Python package for parsing the HTML and XML documents, including those with malformed markup. It creates a parse tree for documents that can be used to extract data HTML from HTML, which is useful for web scraping. Let me run it. Here our second step will be define the URL and the headers. Okay, URL and the headers. So URL, okay, from where you want to extract your data. So I will write here Simplilearn, then this. Okay, let's open this PMP certification. Okay, let's got it. Yeah. So here I will write this, and headers equals to. So these are the headers. Okay. So like in which device or you are working on, which browser you are working on. So these are for the headers. So now what I will do, I will send a GET request to the Simplilearn page, okay, to this URL. For that, right, let me write this, sending GET request. Okay, here write response equals to requests dot get, then URL comma headers equals to headers. Okay, let me run it. Okay, working fine. So now let's check if the request is successful or not. For that, if response dot status code equals to 200, then so equals to equals to, okay, then response dot content comma HTML dot parser. Okay, here, so here I will write codes titles. Why? Because here I'm initializing the list to store our titles or whatever the things are. Okay, basically the data. Okay, why I'm writing course here? Because this is again course page, that's why, nothing else. Okay, here I will give the empty list. So now we will find all course titles based on the actual HTML structure. What is HTML structure? You have to go to the page, right click, then inspect. Okay, according to this HTML structure means what is the class name, what is the this PMP certification is which heading, H1 heading, H2 heading, which heading it is. Okay, so let's see which heading it is. Okay, this PMP certification training H1 heading. Okay, just remember H1 heading. So here I will write for course in so dot find for H1. Okay, then title equals to course text dot strip. Okay, then here I will write course titles dot append title. Okay, now what I will do, I will check if any data was extracted before it not. Okay, I will write if course titles. Here I will create a data frame, df equals to pd dot data frame. In this I will write course title. It will be our that column name. So for I will write it course data. Okay, then course titles. Okay, then here I will write df dot to CSV, then just create Simplilearn.csv. Okay, so our data will be saved in this Simplilearn.csv. Okay, CSV. Fine. Here, what I will do, I will write index equals to false. Print data. Print data is saved in CSV. Simplilearn.csv. Fine. So here I will write else print web page. Okay, write field to retrieve the web page. Okay, that's it. Let me run it. Okay, if response or status group. Response object has no attribute. Status code. Okay. Okay, title. It is text. Some minor spelling mistakes are there. Okay, dear field. Sorry, my bad. Again. Okay, sorry. D will be capital, F will be capital. Yeah, so now you can see data is saved in Simplilearn.csv. So what I will do, I will write data equals to, everyone know how to read CSV in Python. Read underscore CSV. What was our file name? Simplilearn.csv. Okay, let me copy paste, run it, and then find data. Okay, PMP certification training data is fetched. Okay, here you can see H1 we gave, and that's why PMP certification training came. Let's take what's in H2. Okay, in H2 there is leading premier PMI partner, something is there. Okay, I will change here H1 to H2, then I will run it. Okay, fine. See, leading premier PMI. Okay, let me make it big. Yeah, so now you can see course data we mentioned. So if you will see, this H1 didn't come. Why? Because we have mentioned H2. That's why. So these all are the H2. Okay, so what is this? I don't know. Okay, this is a time series graph. This is Google collecting. Okay, so this is how you can literally retrieve your data from any website. Okay, just remember that some websites don't give you access to their, for their scraping, just like Amazon don't give. So you have to use at that time API, and this is not ethical also to use someone's data, okay, without asking or whatever you guys. So as you can see, I'm using Jupyter Notebook for the Python. Okay, so here what I will do, I will go to new and the Python 3. Okay, so here first I will rename it to Pandas for data analysis. Okay, then rename it. Okay, so already everyone know Pandas is a Python library that provides extensive means for data analysis, right? Data scientists often work with data sorted in the table formats like .csv, .tsv or XLX. Okay, so Pandas makes it very convenient to load, process and analyze such tabular data using SQL-like queries. Okay, so in conjunction with Matplotlib and Seaborn, Pandas provide a wide range of opportunities for the visual analysis. Okay, you can make charts and all, right? So the main data structure in Pandas are implemented with series and data frame classes.
So now let me import numpy first, okay, as np. Then I will write import pandas as pd. Why I'm writing as np and as pd? Because I don't want to write pandas and numpy again and again and again. So I gave the short form, you can say. Okay. So here I will write just pd dot set underscore option display dot precision. Okay, then I will write comma 2. Okay, where are it? Okay, fine. So we have imported pandas and this numpy library. So now what I will do, I will demonstrate the main method in action by analyzing a data set on the churn rate of telecom operator. I have like one data set named telecom churn, okay, operator clients data set. So now let's first import it. Okay, so I will write here df equals to, df means data frame, you can give any name. Okay, df pd, as you can see here, pd means pandas dot read underscore csv, then telecom churn dot csv. So you can find this data set from the description box, okay, in the description box below, right? Then I will write here df dot head. What does this do, df dot head? It will show you, the first 5 lines using the head method of the data set. It will show you first 5 lines of the data set head. And if you will use tail instead of head, you can see the last 5 rows of data set. Okay, if I will write here df dot tail, you can see the last 5 rows of the data set. Fine. Yeah, so on our data set we have state, account length, area code, international plan, voicemail, this. Okay, and the churn rate is false. Fine. So now what I will do, I will recall that each row correspond to one client, an instance, and the columns are the features of the instance. So now let's have a look at the data dimensionally, features, names, and the feature types. Okay, so how many columns and rows we have? Fine. So I will write here print df dot shape. Okay, so now we have 3333 rows and 20 columns in our table, in our data set. Okay, so now let's try printing on the column names using columns. Okay, so for that, what I will do, I will write here print. So these are all the functions used in pandas. Okay, then df dot columns. Okay, so now you can see here we have 20 columns right here, 20 columns. Okay, so here state is one column, account and 3 4, these are the all columns name, these columns name. Fine. So now let's use another function called info, which will give you some, it will give you some general information about the data frame. Okay, so here I will write print df dot info. Okay, so yes, so now you can see class is pandas core frame data frame, then this much entries. Okay, 0 to this 3332. Okay, column name and the non-null values, non-null count is okay 0, and the data types you can see, this is object, this is int 64 object, floating type. Okay, so there are 4-5 type of data sets here. Okay, bool is there, float is there, okay, int is there, and the memory usage you can see 498.1 plus KB. Okay, and then bool is 1, float 64 type is 8 columns, then int 64 8 columns, and object is 3, right? So here these bool, int 64, float 64, and object are the data types of features. Already I told you. So we can see that one feature is logical. Okay, that bool one is logical. Where is the bool? Yes, this one. Churn rate is logical. Okay, logical means true, false. Okay, and the 3 features are of the object type. You can see this is state. These are the object, and the 16 features are numeric. Okay, float is also numeric plus variable, right? So with this same method, we can easily see if there are the missing values. So here are, none, because each columns contain 3333 observation. See, every column is same, and you can see null count is non-null. Okay, so here you can see we don't need any cleaning and that type of thing. Okay, so we can change the column type with the as type method. There is one more method. So let's apply this method to the churn feature to convert into int64. Got it? So for that, what I will do, I will write df, then I will write churn. Please note that no spelling mistake while writing the column names. Okay, equals to df churn. Okay, C is capital dot as type in 64. Fine. So now we have convert this bool to int 64 now. Okay, so now what I will do, I will use one more method. Okay, let me run it first. Okay, it's no issues. Now what I will do, I will write here df dot describe. Yeah, so now, so the describe method shows basic statistical characteristics of each numeric feature, int 64 and float 64. Okay, count is there for the particular column, the mean, standard deviation, minimum value 25%, 50%, this is the max value. Okay, now you can see the churn 0 and 1 dual. Okay, so, and the number of non-missing values, mean, standard deviation, range, medium, everything is here. Using describe, you can just find it. Okay, for every column it will give you. Okay, count, how much count, and mean of this particular account length and the area code, like this. So now, so in order to see the stat of non-numeric feature, so one has to explicitly indicate data types of interest in the include parameter. Okay, I will use the include parameter. So at first I will write df dot describe include equals to object comma bool. Okay, so now you can see the count is 333 and unique values are the 51, and the top is this and the frequency is this. Okay, so I am here seeing the stat of non-numeric features. Okay, like state, international plan, and the voice plan, like this. Fine. So for categorical data like type, object, and the boolean type bool feature, we can use the value counts method. So now let's have a look for that also. So I will write df churn dot value counts. Okay, so this is some data, right? So now what I will do, so there are, okay, fine. So now what I will do here, I will normalize it. Churn dot value counts normalize equals to true. Okay, so we have 2850 users out of 3033 are loyal. Their churn value is 0. Okay, and to calculate fractions pass normalize is equals to true, I did that to the value count function. Okay, so here you can see 0 and the 1 value counts, right? So now let's go for the sorting data. So what is sorting? So a data frame can be sorted by the values of one of the variables like columns. So for example, we can sort this table by total day charges using ascending or in descending, right? So now I will do here df. Okay, first let me write here sorting. Okay, df dot sort values by equals to total day charge ascending equals to false dot head. Dot head means I want to see the top 5 rows. Okay, so now what I did, total day charge. Okay, total day charge I've sorted in this. Ascending equals to false means I've sorted into the descending order. Okay, and the top 5 rows are this. Okay, 59 is the maximum, 59.64. Fine. So now, like, we can also sort by multiple tables, so in one go. Okay, so let me do it. df dot sort, same thing I have to write, values by equals to churn. Okay, this. Yeah, churn, comma, then again total day charge, comma, ascending equals to true, comma, false. Then I want to see, okay, let me write the same dot head. Okay, first I will show you this 11111. Okay, then let me change it. See, it's sorted now. Fine. So these are the top 5 as per these two columns, churn and the total data charge column. Okay, so now we will perform some indexing and retrieving data. So a data frame can be indexed in a few different ways. Like, to get a single column, you can use data frame name. Okay, and so now let's use this to answer a question about the column alone. So let's take one question, like, what is the proportion of churned users in our data frame? Okay, proportion. Okay, df dot, we will do simply, we have to find the mean. I will write churn dot mean. That's it. Okay, so 14.5% is actually a quite bad for a company, such as a churn rate can make the company go bankrupt, right? So Boolean indexing with one column is also very convenient. So the syntax is, I will write here df, then again df churn equals to 1, then dot mean. Okay, so here what I am finding is what are the average values of numerical features for churn user. Okay, see, account length just ignore this warning. Okay, so account length is 102.66, area code is this, right? So now what I will do, I will find one more thing. So like we will find how much time, like in average, do churn users spend on the phone during daytime. Okay, df then churn equals to 1, then total day in minutes. We have this column, right? I hope so. We have this column, total day minutes. Okay, fine. Yeah, dot mean. Okay, so how much time an average churn user spend on the phone during daytime is 206. Okay, almost 207. Okay, so now let's take one more question, like what is the maximum length of international calls among loyal users? Okay, loyal user means where churn is 0, like who do not have the international plan. So here for that I will write df and df churn equals to 0. Here I will write and df, okay, I will, okay, international plan equals to no, because there is, see, you can see the international plan, no, yes, no, yes, no. Okay, no, then total international minutes. Okay, this, okay, for the confirmation let me copy it and paste. Okay, no issues. Dot maximum value. Yeah, so 18.9. Okay, so 18.9 is the maximum length of international calls among loyal user, whereas churn is 0, who do not have the international plan. Okay, so indexing, data frame can be indexed by column name, I told you already, or the row name, or by the serial number, you can say, of a row. So there is one method loc. Okay, method is used for the indexing by name, while iloc is another method for indexing by the number. Okay, first I will show you df dot, here I will write indexing, df dot loc comma state, then area code. Okay, so in this first case, we can say I gave the values of the rows with the index from 0 to 5, like inclusive, and the column labeled from the state to area code inclusive. Okay, so this is how you can perform indexing, okay, using by name. Okay, if you want indexing by the numbers, you have to use iloc instead of this loc. Iloc means location. Okay, don't get confused. 5 comma 0 to 3. Okay, see, you got the same almost, right? Yeah, this is 0 to 5, okay, and this is 0 to 3. 0 to 5 means 1 2 3 4 5, and 0 to 3 1 2 3. Fine, So what if we need the first or the last line of the data frame? So we can also do that. So here simply you have to write simple thing, df -1. Okay, that's it. See, this is the last line, -1, last line. Fine. So if you want to, apply something to all the columns, so there is one more function which is apply. So how to do is df dot apply np dot max. Okay, right? It gave me all the maximum values of the particular table. Sorry, particular column, not table. Okay. So this is how you can do this. So this apply method can also be used to apply a function to each row. I already told you. So to do this, you have to just specify the axis or the lambda function are the very convenient in such scenarios. Like for example, let me give you one example. df, then df state. Let's use the state. Okay. Then dot apply lambda state and state 0 equals to w, which is starting from w. Okay, then dot, I need only 5 rows, dot it. Okay, so the state is starting from w, here it is. Okay, top 5, right? So yes, so there is one more function, map method, which is used to replace the values in a column by passing a dictionary or the form, right? So map function d equals to no okay, it is false, then yes is true, right? Then df international plan equals to df international plan dot map d. Okay, df dot head. Fine. Okay, there is some international plan. Okay, p is small, that is why I was saying please write it carefully. Yeah. Okay, so this is the map function. Okay, so wherever there is no or yes, okay, so I have mapped it to the true false, right? Okay, see here you can see international plan, yes no yes no yes no. I have marked yes to false. And okay, why different? Because the series is different. Okay, here I have performed different thing. The numbers, just check the number. Okay, 0 1 2 3 4, right? df dot head. Let me write this. So now let's compare. Okay, why it's coming? Because I have already performed that thing. So we'll go to here, see no 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 yes yes. Now you can see here false 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 true true. So for no I gave false, and for the true, for the yes I gave true. Fine, this is the mapping. This is how you can do the mapping. Okay, so now let's do df equals to, same thing can be done using replace as well. There is one more function. Okay, let me give you the name, stack replace. Dot replace then voicemail plan. Oh, sorry, my bad. Plan D. Okay. Fine now. Yes. Then df dot. Okay. So what I took, voicemail plan. Right? Same. See, true, true, false, false. Because here, if you will see, I have write D. D equals to this. Again, you have to write no to false and yes to true. The same I used here, D. No need to write again and again. Fine. So now let's see how to do grouping. Okay. So first, the group by method divides the grouping columns by their values. Okay. First, let me write this grouping. Okay. So here I will write columns to show equals to total day minutes, right, comma total if minutes, comma total night minutes. Okay, then df dot group by, then here I will write churn, then here I will write columns to show dot describe, percentile. Fine. Where is it's empty? Fine. There is error. Df dot group by churn by can different describe got an unexpected keyword argument percentile. Okay. Fine. It will be percentiles. Yeah. So this is how you can do the group by with a churn. Okay. So what I did. So let me explain the steps. So first, the group by method divides the grouping columns by their value. Okay. Then they become a new index in the resulting data frame. Then column of interest are selected, column to show, this column to show. Okay, so if column to show is not included, all the non-group by classes will be included. Finally, one or several functions are applied to obtain the groups per selected column. So here what I did, we group the data according to their values of the churn variable and displays that of 3 columns in each group. Right, these 3 columns in each group. Same. Count means standard deviation minimum 50% max. Count means this. Okay. So this is how you can do grouping. Fine. So if you want to summarize the table, okay, suppose we want to see how observation in our sample are distributed in the context or 2 variables, churn and international plan. So to do so, we can build the contingency tables using the cross tab method. I will show you. Okay. So here I will write summary table. ed dot cross tab. Then I will write here data frame df churn comma df international plan. Okay. So this is the true false. The summary. Okay, we have this much true, false, 0 from the international plan, and the 41 are this much. Okay, for one, there are 346 and 137 true. Right. So this is how you can perform the summary table. right? You can do for the more also. So now let's create the pivot table. Okay, so let's make the tables. Stack pivot tables. Okay, pivot tables. Fine. So I will add df dot pivot table. Okay, then I will write here. Sorry. Yes. So here I will write total day calls, comma, I will take 3 column total eve calls, comma, then total night calls, comma, then area code. Okay, comma, then aggregate function equals to mean. Okay, I'm using mean. Fine. So this is pivot, you got the area code and the mean of particular this thing. Right. So data frame transformation. So let me explain you first this pivot table. Okay, before moving forward. So so now we can see the most of the users are loyal and do not additional services. Okay, international plan or the voicemail. So this will resemble pivot table to those familiar with Excel and non, of course. Okay, so here the values are the list of variables to calculate stat for, and the index. Okay, a list of variables to group data by. Okay, area code. Okay, and the aggregate function is what stat we need to calculate for the groups. Like we can use sum, mean, minimum, maximum. Okay, something else. Okay, so here I have used the mean, right? So now let's predict the telecom churn. Okay, so now let's see how the churn rate is related to the international plan feature. So we will do this using cross tab contingency already saw, and also through visual analysis with Seaborn. I've already told you with Matplotlib and the Seaborn, Pandas is crazy. Okay, so here I will write predicting telecom churn. Okay, so here I will write pd dot cross tab df churn. Okay, C is capital, churn, comma, df international plan, comma, margin equals to true. Okay, sorry, my bad, it's margins. Yeah, okay, we got the pivot table here using cost tab. So I will import here, import matplotlib for the charts. Matplotlib dot pyplot as plt. Then I will import Seaborn. Just remember to install all these libraries. Okay, you can use pip install Seaborn and pip install numpy, pip install pandas before using it. Seaborn as SNS. Then for the graphic retina I will use config inline backend dot figure format equals to retina. Okay. Then here I will write SNS dot count plot, where x equals to x-axis I'm giving. Okay. International plan, comma, let's set the hue equals to churn, then comma data will be df. Okay. See, we have the counting of using international plan, and the hue is churn. Okay, 0 and 1. Fine. So we can see that the international plan, the churn rate is much higher, which is an interesting observation. Perhaps the large and the poorly controlled expenses with international calls are very conflict. Okay, so now let's take a look to another important feature, which is customer service call. Let's also use to to make the summary table first. So for that I will do here pd dot cross tab df churn comma df customer service calls comma margins equals to true. Okay. Yes. So again, I have made the summary table for the customer service calls. So now what I will create SNS dot count plot x equals to customer service calls, where hue is churn, then data equals to df churn. Yes. Okay, so this is how you can create the charts using pandas and the Seaborn. Fine. So therefore, predicting that the customer is not loyal, churn equals to 1 in the case of when the number of calls to the service center is greater than 3 and the international plan is added. Okay, so this is how you can do data analysis using pandas. Okay,
Imagine you're building a powerful backend system that can seamlessly handle requests, process data, and serve responses, all while staying organized, scalable, and easy to maintain. Sounds exciting, right? That's exactly what we'll be doing in this tutorial. Now, in this tutorial, you won't just know how to build a REST API with Flask, but you'll also master structuring it the right way. So guys, watch this video till the end if you want to learn more about it. Now guys, before moving ahead, let us try to understand about REST API. So REST stands for Representation State Transfer Protocol. It is a kind of a web service that basically allows clients like web apps and mobile apps to interact with the server using HTTP methods. Now, you would be dealing with methods like get, post, put, delete. Now, if I talk about get method, guys, so get is all about retrieving a data, okay? And if you want to use post HTTP method, it means like we'll be creating any new data. Similarly, if you talk about put, then this given method updates the existing data. Suppose, for example, you have this data along with you, which you just recently entered using the form, and in which you entered your name, ID, and your given designation. Now, suppose I want to send a HTTP request where I want to change this data, the current designation, to something else. So, for the same purpose, you'll be using put as a given request. So, in this way, you could also do it, and definitely you will have one more option to delete it. So, delete is also one of the HTTP verbs, okay, basically HTTP method, which is going to delete the data from the given database. So guys, basically REST APIs are commonly used in web development, backend systems, and microservices. Now, we will outline our project. We'll be using a layered structure to create our given projects for this API tutorial. And we'll be using Python's backend framework, Flask, to do the same. So as you can see all over here, I have created this folder Python REST. under which you could see that I have these subfolders: controllers, models, repository, services, init.py and app.py. Now, let's try to understand the role of each of the given folders. So, as you can see all over here, that in this given folder, we have app.py, which is basically the main entry point. So this will be the entering point of our application. So this given file is going to initialize our Flask app. It is going to register the controllers, okay, whenever our server starts. Then we have the controller file, okay. So basically in this file, we are going to define our API endpoints with the help of those methods that we discussed, like get, post, put, and delete. And this given layer will be responsible for handling all the user requests, and it is going to send the appropriate response based on that. Then this given controller layer is going to call our business logic layer, okay, which is basically the service layer to process that given data. Think of this as a front desk of your API. It receives requests and directs them to the right department. If I talk about service file, then in this, we are going to implement the core logic of our application, which is going to call the repository layer, okay, to interact with the databases. And it is also going to validate and process data before sending it to the controller. This is where the actual decision making happens. It ensures that data flows correctly between controller and repository. Now, I hope you have got a brief idea about these files. So we have one left file, init.py. Now, this is a given file which is going to make each directory like controller, services, repositories, model act as like a Python package. So it is basically required for importing modules properly. Now, you could see this is a given folder structure, and I would recommend you to use this folder structure for basically, creating organized code, easier maintenance, scalability. And each component has a specific role. You can maintain it will be very kind of easier maintenance. You can modify one part without breaking, everything. And the scalability is also there. Easily you could add new features without cluttering the code. Now let us try to understand what is there in our models folder. So here we have file name item.py. This file is going to define how our items are structured in our application. So you can see all over here, we have created a class item. This defines a class item that represents an item. And then you could see we have written def init self, item ID, name, description, and we have binded all these variables all over here. Just like that we do create a constructor in Java, and similarly we use this dot given field name to bind it, so that the particular thing could be what kind of behavior could be occupied in that object. So similarly, we could see that init is a constructor in Python, which basically initializes the item within it. So here we have item ID, which is a unique identifier. Then you have a name. For example, you could put name as laptop. Then you have description, where there is the description of the item. And finally, you have def to dict self. And then you are returning the ID, name, self.name, description, and self-description. So basically, this converts the object into dictionary or a JSON format. So it can be returned as an API response. So you would have got a brief idea of what we are exactly doing in our model class. Okay. So we are defining all the parameters that our given API will be returning, or what given data that will be adding to the post request. Now, after you have created your model, it's always a good activity to go to your services class. Okay. Now, before moving to the services, let us go all over here and try to understand. So you could see that we are using an instance of repository all over here. Now, what happens, guys? So basically, after creating your model, it's always a good practice that you should go to your repository, write a code in the repository. So let us try to understand our repository first, okay? And then after that, you create your business logic. So basically, all over here, you could see we are importing our models.item, importing the item all over here. Then we are creating a class called item repository. Okay, then you could see we are doing self.items, which is basically storing items in a memory like a dictionary. So dictionary is acting as a database. Then we have put self.counter equals to 1, which is basically going to generate unique items IDs. Okay, and then you could see we have created def create self name description, and then we are using item string self.counter name description. So basically, this given piece of code creates a new item object with auto incremented ID. and it adds to the dictionary with self.items. Okay. Now there's another method called def get all self, which basically returns all the items as a list of dictionaries. Okay, so that's one thing you should remember. Then what we have all over here in this piece of code, def get by id, self item id, item equals to self.items.get the given id, and then you are returning in the form of dictionary. If item is there, then return, otherwise do nothing. So basically it retrieves an item by its ID and it returns none if the item doesn't exist. So you have got a brief idea regarding the get by ID. Okay. Now similarly, for updating the given data, there is a def update function. Okay. So you could see it's written that def update self item ID name description. If item ID is present in the items, then what you have to do, you have to assign the given item with the proper ID. Okay, you have to access this item, then you have to access its name and description and return in a form of dictionary. If present, then do it, otherwise return none. Similarly, there's a delete function that we have created and it returns self item.pop item ID none if it's not none. So basically it is popping up, or it is deleting the item ID present. Okay, if that item ID matches the given item ID present in the item, then it will be popped out. Now we have successfully created our item repository, and this given layer will be responsible for interacting with the database and do a bit of manipulation. Now let's move to our service layer, which will basically be using the instance of repository for all the business logic that needs to be implemented in our REST API will be done by services. So you could see we have this file name item services.py. Just right click on this. So guys, as you can see all over here, that when the request is coming from controller, it is directed to the services layer. Okay. Then the services layer is using the item repository instance to interact with the database and do all the manipulation. So all your business logic, imagine like services file is acting as a middle layer between the controller and the repository. It is somewhere here in the hierarchy of communication. Now, if you could see our code, we are importing the repository from item repository. Then what we are doing is we are creating an instance of item repository so we can call all the database functions. Now, you could see in this line that we are doing the same thing. Now, in the next, we are creating a method def get all items, and we are using the instance of the repository and calling the method get all, okay, which we have created in the repository. Similarly, by get by ID method, the same thing that we have done. For updating the item ID, we have done the same thing, and for deleting the item ID, we have also done the same thing. Now, the logic for these methods are built in the repository section. So whenever the controller, for example, let's go to our request ID. Suppose if the request goes to get the given item by ID, okay, as you can see in the controller layer, so /item ID, okay. So now it is going to go all over here, and the service method that's all over here. So it is present that get item by given ID. So it will be calling the service instance. Now, if you go in the service class, guys, so in the service class, you have this method def get item by ID. Now, this method is going to call this given method, which is present in our repository section. So def get by ID, and here is your logic written, which is basically interacting with the DB. If you connect it to MySQL or MongoDB or anyone else. So all manipulation you could do is. So there are a lot of things you could do with the REST API. Now, let us try to understand our controller layer once. Okay. So you could see all over here that in this given file, we will be creating all the important HTTP request methods that are get, post, put, and delete. So basically this given layer will be handling all the given request which is coming to the endpoint. So our base endpoint is /item. Okay, so this is a given URL that is mentioned. So when your application is running on a given port, so you can use HTTP localhost /items/item/item ID. If you want to get that particular ID, you could post it or update it using the put request, and also you could delete the given item. Now let us try to understand the code present all over there in this file. So you could see initially what we are doing is we are importing our Flask module. Okay, so as you can see, so in Flask we are importing blueprint, request, and JSON file. Now blueprint allows for modular routing. You could use it for that purposes. Request basically reads the incoming data from the request. Now you have JSON file, which basically converts Python objects into JSON responses. So you can see all over here, we are importing item service to access the business logic. Now you can see item controller, blueprint, item controller, name, service equals to item service. Now what it is doing, guys, it basically creates a Flask blueprint, which is basically item controller, to handle all the requests which is coming to /item route. Okay, this creates an instance of item service to interact with the stored data. Now you could see all over here, we have the post request first, like creating the item. Okay, so you could see we have used this annotation item controller dot route. So route here we have to give the given route which is going, and you could mention the method, what kind of HTTP method you are using. So suppose here we are using the post method. Now basically you are creating the item, so you are requesting a data from the request.json. So we are using this given package from the Flask library. Then what you are doing is that this data, it is going to read the JSON file. Okay, then you could see it calls service.createItem to create an item. Okay, and then it returns a new item with the status code 201. Okay, now similarly, if you go and see all over here in get/items, okay, so in the get all items request, what we are basically doing is we are trying to use the method get request. Okay, so which is going to return the resource. Suppose you added any data, like suppose let's say for example you added a product with name, ID. Okay, so when you are going to go at this URL get/items, so that given data will be returned. So basically it is going to call service.getAllItems to fetch all the items that you have added in your database. It is going to return the list of all the given items. Now every item added will have the particular item ID. Now if you want to access the individual items, then this given method will be called. So basically you are using the instance of service to call this method getItem by ID. Then you are returning the JSON file item, okay, in that format, the JSON format. Now you can see all over here, we have the update method all over here. So you can see we have the method mentioned name as put, and the given way to actually update the data is, you have to access the given data by that ID. So in this case, we are basically accessing the user's data by the given user ID. So that's why we have used item/item ID. Similarly, for the controller, we have the same thing mentioned for deleted the given item with its item ID. Now, similarly, you could see we have put the method as delete, okay, and then it deletes the item if it exists. So you could see it is stored in the variable success, and this is calling the method from the service class, okay, which is present delete item by given ID. And finally, it is going to return a JSON data with message name as item deleted. If the given item is present, means if the operation is success, you return it. Otherwise, else return a error response. So basically with the message as, item not found. Basically 404 status code. So this is how our controller is designed in this project. You would have got a brief idea what, packages we are using from the Flask library. Okay. And how our given layers are actually working and interacting with each other. So there is a lot of dependency management going on in this REST API. Okay, so that's it, guys. So we have created all those things. So guys, you can leave init.py is empty right now because we are not doing the package level imports in this. So this code looks pretty much fine. This project structure looks good. Now, if you go to the app.py, our server will run on this given port, and this is our local host. Okay, so go to your terminal after this, guys. So click on terminal. So you could see we are in our required directory. Now type the name of your given file, okay, and try to run it up. So type Python, okay, and then type app.py, and let's see what is happening. So you could see our server is running on this port. Now I'll be using terminal, guys, to check how our, whether our get request or post request is working or not. So what you could do, guys, you can open PowerShell. Okay. Now, guys, as you can see all over here, we have put a post request in our terminal. and we're using PowerShell for the same. So you could see I have put the header as content type and the file is application.json. And this is a body which I'm sending right now. Name, laptop, description, MacBook Pro. Okay. Now you could also see I also telling it to convert it into JSON with depth of 10. And then I'm invoking this URI to the REST API. So guys, now let us do the post request. Now guys, as you can see all over here, let's say we are giving the body something like this. Hash headers @ the content type is application.json. And here you could see the body is mentioned with the name, description. Okay. So this is a Dell Pro laptop. And finally, I'm invoking it to the given URI, which is the method is post. And I'm attaching the headers and the body section that I've sent all over here to this given URL. Now just click onto it and you could see our item with the ID 3 Dell Pro 16 laptop is created. So it means that our server is running great and everything is all good. Now guys, let us try to use a GET request and see whether our given items are added or not. So as you can see all over here, we have updated it to MacBook Pro 14 with M3 chip. And this is how you could do it. Now let me also show you how could you do the delete request. Suppose we want to delete this given ID. Now the same command that you have to invoke REST method with the given URI, you have to add the URI with the given item ID set with the ID 1, and I'm using the method delete. Now click on it and you could see message item deleted. Now let us try to use a get method. Okay, and we could see we don't have any items with the ID 1. So guys, this was a short tutorial on REST API using Flask and Python, where we were using the layered architecture of controller, model, repository, and a service.
Today we are talking about must-have Python AI projects and how to build them so that can really help you sharpen your skills and stand out in the growing field of artificial intelligence. So let's quickly see what is Python. Python is one of the most popular programming languages for AI because its simplicity and the powerful libraries it offers, like TensorFlow, Keras, and PyTorch. Building projects using Python is a great way to get started if you want to break into the AI industry. Whereas artificial intelligence is transforming industries like healthcare, finance, and even entertainment. Companies are now looking for experts who know how to apply AI to real-world problems. In this video, we will explore beginner level to advanced level projects. So these projects are designed to give you hands-on experience in building intelligent systems, analyzing data, and even automating tasks. So without any further ado, let's get started. So let's start with beginner level projects. So number one, we have fake news detection using machine learning. So in today's world, fake news is a major concern, causing misinformation to spread rapidly across social media and news platforms. Detecting fake news is crucial to maintaining the integrity of the information we consume. So these projects aim to build a machine learning model that can identify fake news articles by analyzing their textual content, by learning from existing datasets of real and fake news. The model will be able to classify articles into these two categories, thus assisting media outlets and social media platforms in reducing the spread of misinformation. This project is perfect introduction to natural language processing, NLP, as it involves text data manipulation, feature extraction, and supervised learning. It can also be adapted for real-time use on website or social media platforms to flag suspicious articles and provide more reliable information to users. So now let's see how to build this. In this, first step is data collection. Use dataset like LIAR or fake news net that can contain label, real, and fake news articles. You can find dataset from the Kaggle. The second step is pre-processing. Clean the text by removing stop words, punctuation, and special characters. Tokenize and stem words using NLTK or spacing. The third step is feature extraction. Use TF-IDF or bag of words to convert the text into numerical data for machine learning models. The fourth step is model training. Train a classifier like logistic regression, naive Bayes, or random forest on the dataset. The fifth step is evaluation. Evaluate the model using accuracy, precision, recall, and F1 score metrics to determine how well it classifies fake and real news. Tools you can use is NLTK, Scikit-learn, and Pandas. Skills you will gain from this are text preprocessing, NLP, classification models. And if you want to make us video on this project, please comment down below. In number 2, we have image recognition using CNN. Image recognition is one of the core applications of deep learning and computer vision, used in a variety of industries ranging from healthcare to autonomous vehicles. This project will guide you through building an image classifier using CNNs, a deep learning architecture designed specifically for image recognition tasks. The goal is to create a model that can accurately classify images, such as differentiating between cats and dogs. By working on this project, you will gain a solid understanding of the fundamental concepts of CNS, such as convolutional layers, pooling, and activation functions. This project not only introduces you to the basics of CNS, but also teaches essential skills like image pre-processing, dataset handling, and model evaluation, which can be applied to more advanced computer vision projects in the future. So now let's see how to build this project. In this project, first you have to import dataset. So use a dataset like CIFAR10 or Kaggle cats versus dogs with labeled images. The second step is pre-processing. Resize, normalize, and augmented images using libraries like OpenCV or PIL to prepare the dataset. The third step is model architecture. Design a basic CNN model with convolutional, pooling, and fully connected layers using Keras or TensorFlow. The fourth step is training. Split the dataset into training and validation sets and train the CNN model to classify images. The fifth step is model evaluation. Use accuracy, precision, and confusion metrics to evaluate how well the model predicts the correct class label. Tools you will use in this project are Keras, TensorFlow, OpenCV, Pandas. Skills you will gain after doing these projects are image pre-processing, CNN architecture, model evaluation. And if you want to make us video on image recognition using CNN, please comment down below. Second, we have intermediate level projects. In this first, we have AI-based recipe recommendation system. Recommendation systems have become an integral part of modern digital platforms. From e-commerce website suggesting product to users to streamlined services recommending shows and movies. So in this project, you will build a recipe recommendation system that suggests dishes based on the ingredients a user has on hand. This project demonstrates how recommendation algorithms such as content-based filtering and collaborative filtering can be used to provide personalized suggestions. You will also learn how to pre-process data and clean textual data, such as ingredient lists, and implement a machine learning algorithm to match user inputs with recipe databases. This is an excellent project for understanding how recommendation systems work and how they can be applied in various industries, from food tech to personalized content recommendations. So now let's see how to build this. In this project's first step is data collection. Use web scraping tools like Beautiful Soup to scrape recipes from websites, or use datasets like Recipe1M. The second step is pre-processing. Normalize and clean ingredient data by standardizing ingredient names and handling missing values. The third step is recommendation algorithms. Implement content-based filtering and collaborative filtering to recommend recipes. Content-based filtering matches ingredient list, while collaborative filtering uses user preferences model. Fourth step is model training. Use cosine similarity to match user-provided ingredients with recipe ingredient in the dataset. And the next step is interface and tools. So create a simple web interface using Flask where users can input ingredients and receive recipe recommendation. Tools you will use: Beautiful Soup, Pandas, Scikit-learn, and Flask. So you will gain skills like web scraping, data cleaning, recommendation systems using this project, by doing this project. And if you want to make us video on this project, please comment down below. Number 4, we have chatbot with sentiment analysis. Chatbots have transformed how businesses and services interact with users, providing 24/7 support and personalized responses. In this project, you will build a conversational chatbot that can analyze the sentiment behind user inputs and respond accordingly. By incorporating sentiment analysis, the chatbot will not only understand the content of the user's messages, but also the emotional tone, such as whether the user is happy, frustrated, or neutral. This allows the chatbot to adjust its tone and responses to improve user satisfaction. For example, a chatbot could offer a more empathetic response if it detects a negative sentiment. This project will give you hands-on experience in building a conversational AI system while learning how to integrate machine learning techniques like sentiment analysis. The skills you develop in this project can be applied to customer service, healthcare, education, and more. So now let's see how to build this project. In this project, the first step is chatbot framework. Use tools like Dialogflow or Rasa to build a conversational chatbot capable of handling various user intents. The second step is sentiment analysis. Integrate a sentiment analysis model using pre-trained models like Veda or BERT. The third step is conversational flow. Adjust the chatbot's responses based on the sentiment, positive, negative, or neutral, detected in the user's input. The fourth step is integration and deployment. So build an interface, website, or messaging platform where users can interact with the chatbot in real time, and deploy the chatbot on a website or app, allowing user to engage with it and receive sentiment-aware responses. So you will use tools in this are Dialogflow, Rasa, Vader, Transformers, Flask. And you will gain skills like sentiment analysis, chatbot deployment, conversational AI. And if you want to make us video on this project, please comment down below. So now let's see some advanced level projects. In this, we have AI-powered image colorization. Image colorization is a fascinating application of deep learning that transforms black and white images into color by predicting and applying realistic colors to grayscale images. This project explores how CNN and GANs can be used to learn mapping between grayscale and colored images. You will gather data set of colored images, convert them into grayscale, and train the model generate color versions. This project is especially useful in areas such as film restoration, photography, and artistic creation, where colorization can breathe new life into old black and white images. Moreover, it highlights the power of deep learning in understanding and generating complex visual data, giving you insight into how these models work for tasks like image generation, video prediction, and beyond. The skills you learn in this project will also be useful for other creative AI applications like style transfer and image synthesis. So now let's see how to build this project. So in this project, first step is data collection. Use dataset of colored image, convert them into grayscale, and use the grayscale images as inputs while training the model to output colorized version. The second step is pre-processing. Normalize images pixel values and resize them for training. The third step is model architecture. Implement a UNet model or generative adversarial network (GANs), which are well suited for image generation tasks like colorization. Fourth step is training and evaluation. Train the model on grayscale images as input and colored images as output using mean squared error method for guidance. Evaluate with visual inspection and peak signal to noise ratio. The last step is deployment. So create a web interface where user can upload black and white images and get them colorized. So you will use tools like TensorFlow, Keras, OpenCV, and Flask. So we'll gain skills like deep learning, CNNs, JNs, and image preprocessing. And if you want to make a video on AI-powered image colorization project, so please comment down below. And the last we have object detection using YOLO. You only look once. Object detection is one of the most popular computer vision applications, allowing machine to recognize and locate multiple objects within an image or video stream in real time. YOLO is a state-of-the-art object detection algorithm known for its speed and accuracy. This project involves building a real-time object detection system capable of identifying multiple objects in images or videos feeds by drawing bounding boxes around them. Object detection has widespread use in fields such as security surveillance, autonomous driving, and augmented reality, where systems need to understand and interact with their surroundings in real time. By working on this project, you will learn how to pre-process image data, format bounding box labels, and train a YOLO model using a dataset like Coco or Pascal. You will also gain a valuable experience in deploying object detection systems that process video streams, giving you the skills to build application in dynamic environment, from traffic monitoring to industrial robotics. So now let's see how to build this project. So in this project, we will first import dataset. So use a dataset like Coco or Pascal VOC, which contains label objects in images with bounding boxes. The second step is pre-processing. Resize image and normalize pixel values, ensuring bounding box labels are appropriately formatted. The third step is model architecture. Use the YOLO, you only look once architecture, which splits images into a grid and predicts bounding boxes and class probabilities for each object. The fourth step is training and evaluation. Train the YOLO model on labeled data using a framework like Darknet. Evaluate the model using metrics like intersection over union and mean average precision. The last step is deployment. Develop a system that can process video streams in real time, detecting objects and drawing bounding boxes around them. Tool you will use OpenCV, TensorFlow, and Darknet. You will gain skills like object detection, YOLO architecture, real-time video processing. And if you want to make videos on this project, please comment down below. So in conclusion, these Python AI projects not only help you build hands-on skills, but also provide a solid foundation for advancing your career in artificial intelligence. Whether you are working on fake news detection, image recognition, or developing advanced tools like chatbots and object detection systems, these projects offer real-world applications that companies are looking for. Start small, keep learning, and as you complete each project, you will get better prepared to take on the challenges in the growing AI field.
So now let's get started with Excel. So here you can see some rows and some columns. Let's understand from the basics of the rows and columns, and then we can understand the basic fundamentals on Excel, which we will be using on a day-to-day basis if you are proceeding with data analytics. Some of the basics are data validation, conditional formatting, data cleaning, pivot tables, lookups, aggregate functions, and also Before we dive into analytics, we have an inbuilt analyze function in Excel. If you can see something on the right hand top corner of the home tab, you will find something called as analyze data. Don't look into this add-in. So this is one of the co-files that we have added in. But before that, you'll just have analyze data. So this is something from Microsoft which can be considered as an AI analyzing tool. Once you provide this data tool with the data set that you have on your Excel worksheet, it will consider it as its input and it will just build some quick pivot tables for you, and it will be more like an interactive session where you can just ask some basic simple analytical questions to this analyze data tool and it will give you instant results. So now let's get started. So in Excel, if you are entering data, then this is the row and this is the column, and every column will have its own column header. So based on the column header, you will be writing some queries, pivot tables in the future. Now let's understand that fundamental. So now apart from that, you will be having home option. Here you'll be having all the font. Here you'll be having all that font settings, and here you'll be having alignment. And this section where you have the number group, this is really important. So here you will get to decide the data type of the data that you're having in. So most of the columns in your data set might be having date data type, it might be having salary data type, it might be having employee ID data type, right? So all these three or multiple will have a different dedicated data sets. Let's say if you go into employee number, then you might be having a combination of alphanumeric, or you can have just number, right? So if it is alphanumeric, then you can go with character data type. If it is just number, then you'll have to go with a whole number. And if it comes to phone number, then it's definitely and purely a whole number, right? So you need to focus on that. You cannot just keep that phone number in text format, do you, right? And apart from that, if you come into the date section, you might be having join date, you might be having the last working day, or etc. It can be anything, right? If it is related to date, then make sure that you are choosing the date format, right? And you might also have some other information. So the basic foundation on data types is make sure that you have the right data type for the right data. If you mess up, then it is going to be really having a tough. If you mess up, then trust me, in the analysis phase, you're going to have a tough time. So that's the reason you need to focus on data types first. Don't worry, we will go through that one step at a time. And when we cancel and close this section, you will have conditional formatting here, which we will be exploring down the line. So conditional formatting is something similar to data formatting. So let's say you have some student data set and you wanted to highlight, let's say if you have 10 students, it's really easy for you to identify which student has the passing marks and which student is flunked out, right? But in case if you have about 100 students or let's say 1,000 students, in that scenario, you might have a tough time to identify or point out the students with failed marks or the passing marks, or, categorization into first class, second class, and, something like failed candidate. So in such scenarios, conditional formatting, which you can see in the home tab in style section, this particular option comes really handy. And apart from that, you have a basic foundation steps where you can insert a row, delete a row, or format. So you can do this on the go, and here you can see some aggregate functions, right? So you have some average count, mean, max. So we will be having this aggregate function in this particular tab. You already have some data set here, so we will be explaining that here. And apart from that, coming back to the data sheet. So here you have some insert options where you can insert the pivot table. So here we have a basic explanation for pivot table as well. So this is just the foundation step. So we will have this for a couple of minutes of discussion. Once we are good with this, we will dive into a sales data set, which has about 10 to 12,000 rows of data. And we will also understand Power Query, where we will combine the year-on-year data together into one consolidated spreadsheet and then continue with it. So there's a lot to learn in this. So stay tuned. Now, coming back to the insert option, here we have pivot table, recommended pivot tables. And if you are going with something like data visualization, then you also have charts here if you go through this. So we have line graph, we have bar graphs, maps, pivot charts, a lot of them. And here you have spark lines. And apart from that, here you have timeline filters and slicers. So we will be going through this timeline filters and slicers. In the last phase, there we will have the dashboard of the sales data that we have created. So what we will do is just analyze the sales data, create some pivot tables, then pivot charts, then consolidate all the pivot charts in one single dashboard, and we will have slices into it, and then we will filter. Let's say we wanted sales for a specific product or a specific brand, then we will know what kind of leads are generated, what kind of conversions we have, how many number of orders we did get, and how many number of orders did we get, and how many number of customers we have, a lot of those things. So apart from that, if you go into draw, this is basic foundation. So here you will have some options to draw, or if you wanted to highlight something in your presentation when you're presenting your data or dashboard to your clients. And if you wanted to highlight something, then you can use these pen options to just write something on the screen, something like that. And here you have page layout if you wanted to print your data set, or if you wanted to print your dashboard, then you'll go with page layout here. And you have the basic formulas that we already went through, which is aggregate functions. And rest we have the data. This tab is also really important for us. Here you have the option of getting data onto your Excel dashboard or Excel workbook. Now, why get data is really important. Do I really need to use Excel to get data? Yes, because Excel happens to be that one Swiss knife still existing in every data analyst pocket, because this is one such friendly tool, or one tool which helps you with all the requirements. You can start cleaning your data. You can make some important changes on your data. It's like a quick, handy tool for you. So Excel is still one of that very important tools that you need to have in your arsenal if you're going with the fight with data analytics. So here you can get data from a wide range of resources coming from Excel workbook. It can be a text CSV, it can be Excel, JSON, PDF, or a folder as well. And if you're having your data on some database, then you can also go with database as well. And don't worry, speaking of databases, we will also export our final sales data onto SQL and specifically MySQL Workbench, and we will also perform some data analytics using the MySQL platform as well. And if you're working with cloud storage like Azure, you can also connect that from Azure to your Excel platform and Power Platforms as well. And apart from that, you have other resources like ODBC, web, etc. You can also do some web scraping and load the data from your websites to your platform as well. Now, you can also directly launch your Power Query from here. And apart from that, if you are having multiple sources of data, then you can just click on the refresh all button, and automatically your dashboard and your data sources will update everything in one single click. And apart from that, if you are focusing into filters, then let's say you wanted to identify the sales happening in one single state. Let's say we have all the states of a country, and you wanted to find out the sales related to one single country. Then you can use the filter option to filter all the states except one that you want, and then remove all of those. So that is what something you can deal with filters. So here we have it. And if you swipe down, you have data tools group. Here you have data validation, and you have data. So here you can remove the duplicates data. Data duplication is one common thing. And if you wanted to remove all the duplicates in one single go, then remove duplicates option that you have will be really handy. And here we have text to columns option. So text to columns comes handy when you wanted to, kind of split the data into different parts. Let's say you have customer first name and customer last name, and you wanted to separate them as two different columns from one single column. Then you can go with text to columns, and you can also provide the delimiter, whether if it is a space delimiter, hyphen delimiter. Based on that delimiter, it will split the data. And in the next group, you have the forecast step. If you have data for this current month or this current week or this current year, and you wanted to see how the data could be performing or the future results, then you can go with what if analysis and provide some steps to it, and you can get the projected data, right? Not just that, if you wanted to, let's say, know the marks of a student, what could happen if, let's say you have 5 subjects in total to learn, and you have got the scores for 4 subjects, and you have reached that limit point right? To either pass or fail. Now, to identify what number of marks you need to get in that one subject, you can do a what-if analysis and it will give you. Let's say you will pass if you get 65 marks in that final subject, and if you get below that, you'll flunk the exam. If you get above that, you'll pass the exam. So you have that logic in your mind, right? And if you're having a different use case and a bigger digit, not just two number digits, then you can go with what if analysis and use it in real business use case, and you'll identify what would be the target for me to, achieve that target. Let's say like 6,000 traffic you need to get onto your website to reach that target. You can do that with what if analysis. And you have the data analysis shortcut here. So you can use that. And since we already went through it, you can use that logo to generate some automated power pivot tables for you and get the analysis, right? That's what you can do with data. This is another shortcut here. And apart from that, here you have review, which we rarely use, and view and automate. If you're going with automations, then Excel VBA, this is the perfect place for you. And developer, which is also related to Visual Basics and VBA. And this is the Power Pivot, where we will use some Power Pivot options and create some data models and etc. So these are the basics you need to know before you get started with Excel. Now that we have a comfortable understanding on how rows and columns are used in Excel, how you insert data, how you create some formulas in aggregation, and apart from that, how you create some data analysis charts, etc. And apart from that, you have some data validation foundations, condition formatting, etc. Right? Now we will get started with hands-on. So here we have data validation. Let's understand how that really works. So here, let's say we have a small data table, and here we are manually adding the data. So let's say, imagine this is your sales data set, and here you need to add the sales related data, right? Now I receive a new order, which is 1005, and the product I'm selling could be one of the three options, which is tablet, phone, or laptop. Let's say I make a sale of tablet. So I have to manually write tablet, and then how many number of tablets did I sold? I think I'll be selling about 2. And then what's the price? So I think I'll be getting around $800 for this, and I sold it in the central region. This is okay for, I think I have 18 rows here, excluding the row headers. So this is the row header. So excluding the row header, I'll be having about 18 entries. Now what if I have 18,000 entries? That's a little confusing and scary, right? And this could be a little tough as well. Now, for such instance, you can use some automation and you can use some built-in functions of Excel. So let's start with the order ID. Now, let me select these two, and here you can see a small logo has been highlighted. If I expand my screen, you can see a small logo, right? This is called flash fill. If I just click on it, let me go back. So it's like I'm training this particular tool that I have a series entry. If I click on it, it will load the rest of the data entries to an automatic number, right? In the increasing order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, right? And in a similar way, I can't do this with these entries. Now for that, I can go with data validation. So I'm basically selling 3 different types of items in my store. So I'll have this around here. And I have 5 regions. So I'll have them around here: north, south, east, west, south, and central. So what are you doing? Why are we getting this, type of thing here? And what's the importance of this? So let me explain that. Now, I'm just trying to create a drop-down option where I can just select the item that I'm selling. So for that, I'll go to data option, and here I have the data validation option. So what I want to do is, I have a lot of options here. You can go with any value, you can go with any value, a whole number, decimal, list. Coming to list, I want to proceed with list because I already have a list of elements I want to work with. Now I want to provide the source. So where's the source for this? So I can select these cells as my source, and you can also have an input message. So you can provide an option which says select from the drop down. Yeah, this could be my message, and this could be my products, and the error alert as well. So we have our repeat. So here we have our drop down, right? So based on the drop down, you can select the items. Similarly, we will drag and drop this to this particular whole length. What we can do is we can drag now and select everything, and we have an empty drop down here. And we'll just copy this and drag and drop to the end. So we have the data validation applied for all our sales. Now, whenever I make a sale, I just simply select the item that I've sold, add the pricing. So what's the price for a phone? Could be $200. Let's have made about $400 here by selecting phones to the central or west region. So we'll also go through that region as well. Now here we have another list. Let's say I sold a tablet, and $400 would be the price of one single tablet. So I'll sell one tablet here and the $400 price tag here. Now, can we do the same for the region as well? Yes, we can do that. So it's a simple process. Again, go through the data validation, and here we have the data validation option. And here we go through the settings, and since any value will be our list, so where's the source? This is the source for my region, and you can have the title. So you can have the title as zone, and please select from the drop down. There you go. And error alert. From the drop down. Now we are good to go. Now you can also drag and drop this to all the cells we have here. And from the simple drop down, you can see there's a highlight here, and this particular cell is related to zone. Please select from the drop down alone, and can be anything north, south, east, west. And if I write something else, let's say I want to write it as some random name, I'll drop it as Excel and hit enter. I'll have an error. Now you can retry, and you can go to cancel, and then we will go through the region, right? Now what this does is this has wonderful benefits. You're dealing with a small data set for sample on my screen right now. But if you're dealing with a bigger data set, let's say thousands together, 10,000 or even lakhs of entries, and you have a collection of colleagues or employees or your reportees, let's say 5 to 10 or even more, and they're supposed to enter the data for you on your database, then this really comes handy. This avoids that data corruption or inconsistencies in the data, right? You just get them an option, they just make a sale and select something from the option which is right. And then you will have this data ready for analytics. It kind of minimizes the effort on data cleaning aspect, right? Now, we will go into the next stage, which is about conditional formatting. Remember the example that we discussed about students' dataset? We have something similar here. We have about 30 students and their scores in their subjects, which is math, physics, chemistry, biology, English, and sports. So a lot of them have cleared their exams and they have passed in their exams. There are a couple of students which did not. Something like we have an example here. Karan Mehta, who might have scored 29 marks in math and 35 in physics, 33 in chemistry, and so on. So there are a couple of more students who might have passed, who might have flunked, right? So you can just eyeball it and mark them. So I want to eyeball this particular section and mark it as red color, indicating that this particular candidate has failed in the exam, right? I want to do that to all these students since I have just 30. If I had about 300, what if I had 3,000 students? Will I manually check and add them? No. Even if I work with only just 30 students, manually eyeballing each and every single student could be painstaking and time consuming, right? And from a business perspective, let's say you have a wide variety of products, a wide arsenal of products that are performing sales and everything, right? And there you get a moment where you have to present your sales insights to your client. And if you are manually eyeballing every single sales performance and highlighting it And let's imagine that your client identified something which you missed. Could be really problematic in real time, right? So to avoid that, do you have any tool in Excel which can, automatically look at each and every single cell for you and does the thing what you're trying to do in just moments or even seconds? Yes, we do have. So that is nothing but conditional formatting. So before that, let's go through this small shortcut, which is Alt HOI, which will automatically adjust the cell width and height. So we have everything in order. And now we can go with conditional formatting. For that, you just need to highlight all the cell elements and go through conditional formatting. I want to highlight the cells in some color which is less than a dedicated number, which is 35. And I can also get to choose the color, red border, red fill. So I'll go with the first one, which is red fill. Enter, and there you go. Now, all the cells where the score is less than 35 is automatically highlighted for you, right? Everything in repeat. So everything is in order. Now, this will be really helpful in real time. And conditional formatting is not just about identifying a number which is greater than or less than and highlighting it with a color. It's a lot more than that. You can also include some logical conditions. You can also use some mathematical conditions. You can also use some complex formulations and then let conditional formatting decide the right decision for you. For now, we'll just, go through the fundamentals, basic examples of understanding how conditional formatting works in real life. That was a brief example for it. But in case if you wanted to explore a lot about conditional formatting, we have a dedicated tutorial on conditional formatting where we have explored each and every possible permutation and combination through conditional formatting, and it will be a great learning experience for you. So we will link it in the description box below, and you can also search that on channel. Now going to the next phase in this particular tutorial, which is about data cleaning. Now data cleaning could be a little too early for you, or even it can be the spot on position for you right now to learn about it. So what's the need for data cleaning could be the question, right? We had a good foundational experience on data cleaning in the section where we discussed about data validation, where you will have your employees or team members adding data for you, right? In real time, one data analyst might have a different perspective of vision for data cleaning or data positioning aspect, and another might have a different perspective, right? If I expand this table here, you can see, if I expand again, some of the entries are a little too different from each other. If I consider date joint column, someone has entered DD, MM, and YY. So the first one, DD 12, second one MM01, last one YYY and Y, which is 2023. In terms of Excel or in terms of data analytics, you mention the month as M, you mention the date as D, and you mention Y as here, right? So here, if you see the first cell entry is proper according to us, maybe. And the second cell entry is, having a delimiter separated by slash, right? And the third one is having YY and YY format with MM or could be DD as well. We don't know. 2 can be the month of February, or 2 can be a date, and 10 can be a date or the month of October, right? There's a lot of confusion. Now, the fourth one looks a little more pleasing. So it has 10th date and month is February and 23. Again, if you deep dive, 23 can be a date. It should be a date. So, yeah, we don't have a 23rd month. But yeah, in case if it were 3, then it could have been confusing. Would that be the month of March, or 10? Would that be month of October and the date is 3, right? So these kind of inconsistencies can happen in real time. So before we proceed with any kind of analytics, data cleaning or making the data ready enough to proceed with analytics happens to be the most important stage. And here you have amount paid column. So some of them are already mentioned with a currency. So here you can see euro, and some of them are, having some space which can be considered as an inconsistency, right? And apart from that, here you have the first name and last name. There are most of the scenarios, let's say ticket booking, if you're booking an airplane, repeat. Let's say ticket booking, let's say you're going with airline ticket booking, then always the second name comes first and the first name comes after. So let's say, let's go with Rahul Verma or Rahul Kumar, right? And in the airline booking system, Kumar comes first, then comes Rahul, or maybe the vice versa. Basically, the thing is, you want a name to be split into first name and second, right? So here, someone has chosen comma as a delimiter. Someone has chosen hyphen as a delimiter. Someone has chosen space as a delimiter, right? There is some inconsistency. Same with the phone numbers. So there are places where they have written hyphen. There are places where they have written brackets, and a lot of problematic thing here as well. Now, city and country. So here we have city and country combined in one place, but I want them to be separate. City as a separate column and country as a separate column, right? So these are the foundational basic examples for data cleaning. So let's get started to understand how it works in real time. But don't worry, in our sales dashboard, we will have a little more complex data cleaning operations where we will change the data type, happen to include some mathematical calculations, create new columns, split the data, and you also have some data related operations where we will be formatting the date, and then we will change the format from MMDDYY to YYDDMM, making it completely ready for SQL data analysis. And we will also have some pivot table analysis, a lot more. But now let's understand the basics of it to basically get the gist of it or wrap head around it, right? Now I will remove this comma and make it as space, and I will remove this hyphen and have the space there. Now I can't do this for every line, right? Let's say I want to eliminate the bracket here, so I can replace it. Find and replace. One has been made, and here another bracket is there, so I'll do that as well. Replace all, and I want to remove hyphen and replace all, and there you go. And you can also manually get into this particular one and remove the space. Now you have numerical values, and if you go through this data and if you go through this data column and into the data type, it is general. But we want more formats, and I want to select text because in case I want to run some text matching operations, find me the details of the customer whose phone number is, then it is basically a text matching operation, right? So in that scenario, I want this data type to be in the text format. So I'll keep it that way, right? And here I want to insert a new column so that I can go with text split operation. So here I'll go with data and here text to columns and go to next, and my delimiter would be hyphen and then next, and here I can see a quick preview. So this would be my city, this could be my country, and then finish. Do you want to replace it? Yes. So here I have cities and here I have countries. Good to go. And here I have numerical values. So I want to eliminate this space and I want to provide a dedicated currency format to all the numbers. Since one of them is already having a euro, I want to add euro for rest of the ones as well. So I would like to go with currency, and here I have the symbols. I'll go with the euro. Might take a little while. So B, C, D, and E. There you go. So I have euro here. Okay. And I have all the currency formats. Rest is date. This might take a little confusion. So first, we will do this in two stages. Since we have dot, slash, and everything, we will do it in two stages. We will go through data and text to columns. Here we will go with delimiter, and here we will unselect everything. We'll have nothing here. And next is here we have to select month, day, or DM by, whichever suits you best, and finish. Let's do that once again. I think I missed something. Yeah, I was supposed to go with month, date, and year and finish, right? Now, what we will do is replace this with good data format. Here I choose year, month, and date. This is so far done almost. I'll replace the dots with hyphen and we are good to go. So here we have cleaned data ready for analysis. We can save it. And now here we are at, let me delete this unwanted sheet. And now we are ready with data cleaning. And now we come to the next part of data analysis basics, which happens to be the pivot tables, right? Now, pivot tables, as the name says, pivot, right? They make a pivotal point in data analysis. So we already went through the data validation part here where we had some product and sales related information, right? Now, let's say I have this data table here, which is also related to sales. We have some salespersons, region like North, South, East, West, and product details, units. So all those details. Now I want to find out what is the number of sales we did in a specific region. Or let's say I want to find out the sale figures for the employees. We have Rahul, Mohit, Priya, and everyone. I want to find out what's the number of sale or what's the revenue that they generated to my organization. And let's say I wanted to deal with product related data. How many number of products that we sold in the laptop segment, or what's the total revenue we generated via laptop product, right? All those details, you cannot just manually check all those on the worksheet and get the details, right? So we have one such tool to help us with, which is pivot table. So it's really simple. You go to the insert option. We discussed this before, how to get to the pivot tables, right? So we just need to go to insert and here we select the pivot table option. So here we have two more other options where you can insert the pivot table in the same worksheet, or you can choose to create a new worksheet altogether. I'll go with the new worksheet and create. Yes. So we have a skeleton here for pivot table. So to get the results, it's really simple. It's just a drag and drop operation. Let's say I want to get the region-wise sales. So I'll drag and drop regions into the rows. And now I want to find out the unit price, right? So I want to drag and drop unit price to aggregation. So automatically the aggregation function is set to sum, and Excel is intelligent enough that I'm looking for some operation. So I want to find out the total sales, right? So it gave me the total sales. Now, instead of region, let's say I want to find out salesperson. I simply drag and drop salesperson into the rows. And if I don't want that, so we have the details here. Each and every one of them have equally performed. So they made $1,900 sale. And I don't want salesperson. Now I'll just drag and remove the salesperson out of this box. And I want to find out the product level. So I'll drag and drop product into the rows. Now we have the product level sales. So laptop gave us $3,600. Phone gave us $2,400. Tablets gave us $1,600, right? So this could come really handy in terms of real world analytics. And you can also create some, pivot charts as well. You have the pivot chart here and you can choose any kind. I'll go with the pie chart and press OK. And you have a pie chart here. You can name it as product sales. And you can also choose, a dedicated option, and you'll have all of those in one go. So this is really important when we are dealing with dashboards. So we'll have a similar approach. We'll create different pivot tables and then their respective pivot charts, right? So this could be handy. So this is the basic understanding of it. Now we can name it as pivot chart. Now comes lookup, right? So let me have this table positioned somewhere here. Now, what is lookup, or why is lookup really important for us? So most of the times, just like we had the data here, let me close this. So most of the times, data will not be positioned in such a way that all the details are in one place. So we have a different reason for that. That is called data modeling. So in that, you can understand much about data modeling when we land into SQL, Power BI, and Tableau. So in real times, let me go back to the same position. So in real times, we have separate positions or separate places where we store the data. For example, in my sheet, you have employees data table in one place. You have employee name, department code. This acts as a foreign key here. So we'll have a briefing on foreign keys and primary keys in SQL. So we have department code, we have product code, and the unit code. Similarly, we have a different table for departments. We have department code and department name, and another table for products where we have product code, product name, product pricing, right? So the data will be scattered. So each and every data table will be interconnected with each other via data connections or data relations. So these are done via schemas. One of the popular one is star schema. We have a lot other varieties as well. And we will have one-to-one, one-to-many, many-to-one, many-to-many relationships as well. We will go through them in SQL. So basically, we will try to store data in different locations or different tables, and then pull some strings and establish a connection with each and every other table, right? And then we will segregate all of them to one place via relations and perform data analytics. Now let's take a use case. I have a third table where I want to find out the employee related information. Right now, if I go through employee data table, I find out the department code and the product code, right? Not the actual literal name of the department or the actual literal name of product that we sold. And what's the sale he made, right? I don't have that. Let's take that as a use case and find out what's the department name and product name. So we can do that via VLOOKUP, XLOOKUP, HLOOKUP, right? A lot of options there, but we will go with XLOOKUP alone because vertical lookup and HLOOKUP are a little too obsolete right now, not completely obsolete, but XLOOKUP is a step ahead or advanced. It's a combination of both, right? And let's also discuss some quick limitations. VLOOKUP looks from left to right. Let's say the lookup value is in the left position and your result is in the right position, then it looks from left to right. But if it's the other way around, if your lookup is in the left and the result is in the right, VLOOKUP will never work. Similar with HLOOKUP, top and down approach. But if it is XLOOKUP, you just have to give the lookup value and the result value. It will give you the result regardless of the positions of the lookup array and the result array. So to save time and have a stronger dominating approach in data analysis, let's go with XLOOKUP alone. But in case if you want to really explore the lookup functions, we have a dedicated tutorial where we will discuss VLOOKUP, HLOOKUP and XLOOKUP all together, and we will have hands-on experience where we will definitely understand how it works in all the scenarios. Now, without much ado, let's go with XLOOKUP. So here, I want to find out department name. So I'll write a simple XLOOKUP formula here, and I want to provide the lookup array, right? So this is my lookup value, and where is my lookup array? So this is my lookup array. So yeah. We were also supposed to have this in my table. So let's have it. Yeah. Now it makes sense. So I want to find out the department name, right? Also, I wanted to have product details. So I'll have this as well to find out them. I need this. There you go. Now, to find out the department name, I want a lookup value. This is my lookup value. And this is my lookup array. And this is my result array. There you go. Now you can simply expand this to all the sections and you will have all the department names. So Rahul Sharma belongs to sales and he also sold a product, right? Now we want the product details. So similarly, XLOOKUP, and I want to look for this particular product, and this product details are here. So this is the lookup column or lookup array, and this is my result array. Hit enter, and this is the item. Now similarly, if I want to find out the pricing details, I'll go with XLOOKUP, and this is my lookup array, and this is my, that was my lookup value, this is my lookup array, and this is my result array. Enter. There you go. Now we have a perfectly analysis ready data table. So we have Rahul Sharma. He belongs to a certain department, and he belongs to or he sold a particular product, and this is the revenue he generated, right? So this is how you use XLOOKUP in real time. And apart from that, we can now deep dive into aggregate. So basically, lookups help you segregate all the data from different tables together in one place, or you can also fetch for some missing data. Basically, they act like search and get the data. And apart from this, we can now deep dive into aggregates. So aggregates help you with some basic mathematical functions like sum, divide, total, average, etc. And apart from that, you can also find mean, median, mode, max, minimum, right? So here we have some examples. So for average, let me remove this. So let's say I want to find out the average pricing. So I'll just write down average of unit price, and there you go. And let's say I want to find out total revenue that I generated. So in that case, I'll use sum function and give this particular array as the input. And I'll also try to find out maximum pricing of a certain product, where I'll use max function. And now I'll give this particular array and find out which is the maximum product. So a laptop has been the maximum product so far. And if I want to go with the minimum, then I'll give it as minimum of this particular array, and I'll get the minimum pricing, and so on, right? And so on. So these are the basic aggregate functions that you can use on daily basis. And now with that, we will make a transition to the next function in our list for today, which is analyze. So analyze acts as that one automation tool which is inbuilt in your Excel, which gives you the pivot tables, which it will create by itself, and you can just have a. So analyze does this thing where it automatically creates pivot tables for you and calculates the things for you and gives you results in a conversation like style. So select the entire data set, go to analyze, and you will have all the pivot tables readily created for you. So there you go. You have sales amount by region, discount sales amount, and you have a beautiful line and bar graph together. Here you have a bar graph which shows you region-wise sales and time-based analysis as well. Apart from this, if you want to have a conversation with your what analysis or analyze data in Excel, let's say I want to find out what's the total amount of sale done by Rahul. So I'll just write down Rahul total sales. He gave me all the sales which Rahul performed. So he performed sales in the North region. I think he's handling North region. Apart from that, if I expand this particular table to an extent, then I will have a few more details. So we sold about electronics items category. He sold about one laptop, one phone, and one tablet. And yeah, I think he sold 2 units of laptops, 4 phones, and 5 tablets, and units price, and also the revenue that he generated. So that's all about the basic functionalities of Microsoft Excel so far. So with that, you have understood what are the main day-to-day applications that you do along with data analytics when you are on Excel. So you'll be performing some data validation, conditional formatting, data cleaning, creating pivot tables, pivot charts, right? And you'll also use some lookup functions like VLOOKUP, HLOOKUP, and XLOOKUP. I would recommend you to focus more on XLOOKUP than other two. So because XLOOKUP is totally advanced and it is a combination of both V and H together, and it'll save you a lot of time, and the limitations are very less compared to the other two. And apart from that, you'll also have some aggregate functions and mathematical functions where you will apply some basic fundamental mathematics, subtract, multiply, add, right, divide, etc. And aggregate functions like maximum amount, minimum amount, and total revenue to generate average revenue by zone, etc. So far so good. We have a comfortable understanding of Excel fundamentals that you will be using on a daily basis. Now we will make a huge transition to the next part where we will have some real-time sales data from the year 2021 to all the way up to 2026. And we will have separate Excel files for that, year-based, and then we will try to, add them all to one place and do some performance analysis, etc. So let's go with it. Now with that, we will close this sheet, and this particular sheet will be saved for you. This particular sheet will be saved for you just in case if you want to follow along or if you want to have a deep down on this, and I will provide this sheet for you. So that will be saved. Now let's go through the data sets. So here we have sales data from 2021 to all the way up to 2026. Let's have a quick briefing of the data set. So we will be having, okay, let's use that quick shortcut Alt-HOI to adjust the column width. So we have order ID, we have order date, delivery date, order status. So consider this as a social media marketing analytics. So we have a wide variety of platforms. We have Instagram, Facebook, Snapchat, we will have YouTube and Facebook. So we will be running some campaigns on all those platforms. And based on those campaign platforms, we will have generated some traffic here. So we have about so much traffic in the year 2021. Then out of so much traffic, we extracted about so many leads. And if you see on my screen, we have so many converted orders, and those orders have turned into given us some revenue and given us some profits, right? And this particular section will be about the funnel data, and this could be our orders data, and this could be our customers data, where we have customers ID and name of the customer, first name, second name, email of the customer, the location, state, region, pin code, door number, and also phone number, right? So these are the basic things we will be having. Don't worry, we will be also performing some data cleaning operations here. This particular phone number, if you observe, we have +1, which is a country code. Along with that, we will also have some hyphens, so we will be cleaning that all. And in case if you're wondering, can we make that into a country code? Yes, we can convert that into a country code based on the country code provided here. Since you're dealing with only the US-based data, I think the country code is not specifically required here, but in case if you want to go ahead with some logical operations, you can also include the logical operations and identify which country code it belongs to and add the relevant country code as well. Now, this is the quick walkthrough of our dataset. Now, let's proceed with the next section, where we will have a new sheet created. And remember about the data importing operations that we discussed about. We will be importing the data from a folder now. So we have saved all this data in the new DA file. So here we have it. We will make use of the Power Query in Excel and segregate all the data together, apply some data cleaning operations and steps, and then once the data is ready, we will proceed with analytics. Now, let's go to data, and here we will get data from a folder and navigate to the folder. So our folder is in downloads, so new DA, and Power Query is up. So we want to perform some data manipulation here. So we will go with data transformation. So here is our Power Query. Now you can click on this particular expand button, where we will combine and expand the folders altogether, or the files altogether, the workbooks we had dealt with. It will take a little time. And now this is your preview. So you will have order ID, order date. So you can already see the order date has been transformed to a different data type. So we will have to do that. And we will also have the customer details, where we will have customer ID, first name, last name combined together. We will have it split. And then if you scroll further, we have the phone numbers, and next we have the traffic detail or the funnel detail, where the revenue and profit are not formatted to currency. We will format them to currency. So few changes that we will be doing. So let's click on OK, and we will have the Power Query window opened for us shortly. So there you go. So it has already applied some steps for us, filtered hidden files, invoke custom function, and all those things. In case if you don't want any of these changes to be approved, you can just click on into, and that particular change will be taken off from the list. But I'll continue with what we have so far. I want to perform something from my own. So firstly, I don't want this file name here. I'll remove that. And we have order dates here. So what I'll do is quickly change the type to date. And we will have the DD by format. And apart from that, here we have customer details. So I'll quickly split this. So it's a little more fast in Power Query. So here I'll provide the delimiter and click OK. And I'll name this as customer ID and this as customer first name and this as customer last name. And now we have the phone number. Before you change the data type of phone number, I'd like to make some changes to this. So what I'll do is I'll replace the values. So since I have +1 here, I don't want +1. So I'll just replace this with anything and everything or nothing, right? And now again, I'll replace the values and here we have hyphen left out, nothing again. So now we have proper phone numbers. Then we will deep dive into the last section where we have quantity, traffic, orders. Yeah, this is the one. Now I want to select these two and change the data type to currency. And this is now in dollars format. And I also want to add a new column here, which will tell me about the cost price. So I'll name this as cost price. And I will add revenue into the column and profit into the column. So subtraction of revenue and profit should give me cost to company. So this is the one. I'll also change this type to currency and all good to go. Now let's have a quick briefing. So we have order ID, we have the order date, delivery date, order status, platform, customer ID, customer name, last name, email, state, region, PIN code, door number, phone number, and subcategory, category, product, quantity, traffic, leads, orders, revenue, profit, and cost price. So far, so good. Now, what I will do is go back to home, close, and load the data. So the data will be now loaded. And here you have the quick query connections and everything that you wanted in one place. And here you have the table design. I'd like to go with the basic design, what we always used to have. And I'll remove the filter. We'll go to filter and sort and clear the filter. And if you come back here, you have this in the form of date. And I don't want that to be in this format. I'll go to year, month, and date format, which is SQL friendly for us in future. And everything is in order. Now you can also do some formatting if you want, but I'm good to go with this. And I'll save this as, before saving, let's go back and remove any other sheets. So this sheet was the original one, which you don't want. This is the one which we care about. So we will save this as downloads, and in here we have created a new file, new TA. We will save it as book 2, and also we will save it in the form of a CSV file because we need CSV SQL. There you go. Now it's all good to go. Now what we will do is we will open this particular spreadsheet once again, and okay, I think I opened the CSV file. We're supposed to open the Excel workbook. Now we can continue with some pivot table analysis. There you go. We can select all the data and now go with the insert pivot option. So I'll create a new pivot table. So here I want platform wise analysis. So I'll have platform here and the total number of orders that I have received. Or the revenue that I have received, and it will be here. So it will give me a platform wise analysis. And then we will create some pivot table chart, which can be this one, and leave it here and call it as platform based revenue, right? And now we'll go back to this particular one. We'll insert a new pivot table. We will insert a couple of pivot tables so that we have what we need. So we will have region in the rows and revenue in the values. So for this, we will have another pivot chart, which can be a pie chart. And based on this, we will have region-wise sales here. And go back to this particular one. Insert a new pivot table. So here we will have state-wise revenue, and we will use it as map. Or a tree map should be good. Bar graph should be good enough. Now we will create another pivot chart, and here we will have category wise analytics. And we can also insert another pivot table here and call it as subcategory level analytics. So we will have the brand based analytics as well. So far, so good. Insert another one. And here we will check the order date. And revenue as the values. Now we will go to the pivot chart and add the line graph. There you go. Now we have year-on-year analysis of sales and revenue. So we had a spike during 2022 and 23, and then we have a drop. We can see the sales growing in 2026 and so far. Now we have a couple of pivot charts. Now we are good to go with the dashboard. So let's have this copied and pasted in this particular sheet. Click anywhere and paste it. And let's go to sheet number 2. This one, sheet 7. You can select anywhere. We have this. Let me close this particular window. Copy, paste. So we can also have a pie chart for this one. brand distribution. And lastly, the month on month or year analysis, or I can just name it as YOY revenue. Then just copy this and share it to this particular place. And there you go. Now here we can insert slices. So I want slices for region, we want slicer for state, we want slicer for a subcategory, and I think that should be good enough. And press OK. So now, before we do anything, let's place them in order. And this would be the last one. There you go. Now we need to report connections. So we need to connect every other slicer with every other slicer. Similarly, the report connection to this one as well. So if you don't report the connections, the problem is the slicer will work with the only connected papers or the reports that you have got them connected to. But now if you report all the connections, you will have the specific brand alone. If I select Jordan, then I'll have the brand distribution of Jordan alone. Similarly, if I select the central region, you'll have the sales report only for the central region alone. So each and every chart is now interactive. So similarly, if you select any single state, you will have the results based on that single state alone. So this is how you create a completely interactive dashboard in Excel. So far we had a beautiful understanding of the basic functions. Repeat. So far we had a comfortable understanding of what are the basic functionalities that you will be handling when you're working on data analytics using Excel. And also we have created some Power Query operations, imported data from Excel workbooks, and then we have created a lot of pivot tables and pivot charts. And at the end, we have created a completely interactive and functional dashboard of the sales report. Now with that, we will make a transition to SQL, and we will be using the same Excel workbook there as well, or the Excel CSV file, to create a quick SQL data analytics report using some queries. And we'll also have, before we do that, we'll also have a quick understanding of the basic functionalities of SQL and then dive into the report generation in SQL. So now we have finished Excel, and that particular workbook was completely saved, and it will be attached in the description box below for you to practice. Don't worry. And now we have landed onto MySQL Workbench, and here we will start with SQL queries. Don't worry, we'll not hurry. We will start off from fundamentals, how to create a small table, and I'll not take much time in just fundamentals here. So we'll create some simple tables here, and then we will try to extract some basic queries just like we did back in Excel, so that you have a comfortable understanding of how SQL works in real time. Once these small sections of SQL fundamentals is done, we can directly, you can see on my screen, we can directly drive ourselves into the analytics part, where we will use the same previous sales data set that we created and filtered and query for analysis, and run some queries and extract the data that we are looking for. Now, without further ado, let's get started. So first, we will create the table, which is departments table. So you need to use the create and table keywords and the table name, which is departments. The department ID will be integer, and this will be primary key. So we need to dedicatedly provide the naming convention here that makes SQL understand this is the primary key. Next is department name, which is work_, and you have provided the character limit of 50. So Control Enter will be the shortcut that we will be using. So before that, I think we need to select the database. So we are in interview database now, and then we will create this particular table. The table has been created. And now entering the data is also similar and simple. It is straightforward. Insert into the table, which is department, and the table column, the department ID and name. And here are the values that we will be inserting. So these particular tables are inserted successfully. Now, if you want to check or extract what you have in departments, it's really simple. Select staff from the table name, and you can just write down the table name here, semicolon to end the command, and there you go. So you have the following entries in your table. Next will be the employees data table, and here we have employee ID, name, salary, department, and hire date. And here we will be having one foreign key, which is department ID. Control enter, and we have successfully created the employee table. Similarly, we will enter the details into employees table. Don't worry if it is getting a little faster. We will have this query document shared with you along with the analytics queries that we will be performing upfront, right? Now you can use those queries and follow along with us, right? Now we will enter these elements into the employees table. Same like before, we will select star from employees table and paste it here, semicolon, enter. So these are the employees we are dealing with. And we'll also have users data table, control enter. We have the following users to be entered into this particular users data table. Yeah. Does not exist. I think, yeah, this is the one. We need to create this. Yeah, we have created the table. Now we need to enter these particular elements into the data table. Control enter. Just like before, you can quickly select star from everything or select everything from users. Place users here, semicolon, enter. So these are the users you will be having. The fourth table is orders data table. Here we'll be having order ID, customer ID, and order date. So if you recall the Excel tutorial, I said you about something, data modeling. So anywhere we will not have all the data elements present in one single table. You can see it here, right? So we are creating 5 different tables. We created a users table, we created an employees table, we created an departments table, and we are creating an orders table. And apart from that, I think we also created a product table as well, right? Departments, we created a department table, we created employees, users, orders, and the other one was sales, right? So we are creating 5 different tables. And if you go along with me here, we have also mentioned dedicated locations which say as foreign. Now, foreign key is something which is used to reference another table. And based on that, remember the lookups, right? We created a 2-column entry, 2 new column entry in a data table, and referencing to one particular element in the present table to the referencing table, we extracted an output, right? In the same way, if you want to put some value to your table using another table, so in that particular instance, you might have to make use of the primary keys and foreign keys, and you might have to reference that particular table and extract the details. So this is about mostly subqueries and joins. We'll also go through that. Now, if you want detailed tutorial on that, we will have a SQL full course included in the description box below. You can go through that. But now we are just skimming through the surface of basics of SQL so that we can deep dive into analytics, right? So we have entered these particular elements and we have extracted them from elements of the table named employee. And the fourth table is orders table. I think we have successfully created orders as well. Or for safer side, did we create it? Yeah, it's already created. Now we need to enter or select star from orders table, semicolon, enter. So we have not entered anything. So we need to enter these elements. Control enter. And now we will have some elements in the orders table. Now let's proceed with the last table, which is about the sales table. We have successfully created it. And these will be the entries into the sales table. Now select everything from sales And here's the output. There you go. So far, so good. Now, let's go ahead with the basic fundamental statements. So to retrieve everything, we have so far used this select star everything and only names. If you are looking for dedicated columns only, then you can provide the column names in specific here and we will get them. And if you want to filter out something, let's say I want employee details of only engineering department, then you can do that with the where filters as well or the where clause as well. So I want everything from employees where department is specifically mentioned as engineering. So here we have the engineering department details. At engineering limit 0. Unknown EPT. So I think we need to go to the departments table. Okay, so department ID, we were supposed to go ahead with department ID. Since we want the department name as well, I think we need to create a join here. That would take just a moment. Join departments. So where is departments table? Yeah, departments. Join departments on employees dot department ID. Did we create a departments table? I think we have created employees table. Yeah, we have created departments. So department ID, department and name. We need to copy these both and place it somewhere here. Department ID is equals to employees dot department ID where department name is equals to engineering. So far so good. Now let's run the query and we have the details. So we have unexpectedly ran into joins a little bit early, but no worries. So basically that's how we join two different tables and extract the insights. So in the employees table, when we created the employees table, we did not specifically mention the department name. I think we mentioned department ID there. So based on the ID, we just roll back to departments table and extract the department name using the employee table via the foreign key department ID. So that's how basically it works. Now we go into another section where we kind of filter the data based on a number. Let's say I want to extract the employee details where salary numbers are greater than 90,000. So we are using a salary clause here with where clause. So greater than 90,000. So these are the employees. And similarly, we have employees in marketing team located in Chicago. So we have and condition here. So where clause along with an and condition, and similarly employees hired. So this is a date and time function. So here we are using the higher date should be greater than this particular year and date. So remember we created year, month, and date, or YYYYMMDD format because that is SQL friendly. That's the reason we have converted the date format in such way, and here we are using the date and time functions here, right? Now we are going into the sorting and order by function and having by clauses in the future. Now we are selecting everything from employees table, order by salary ascending. So what is happening here is ASC is a keyword which orders in ascending order, smallest to largest, right? Now let's enter. There you go. So these are the employees with least salaries and these are the employees with highest salaries, and higher date descending similarly with date function. And the last one is department and salary. Now we have the limit and distinct function. So let's say you wanted to find out that top 3 employees with highest salaries, then limit function will be helpful for you. What it does basically is it limits down the top 3 rows and rest will be omitted. Now let's go through that. And here we have select distinct from employees. So some of the times you might have used that delete duplicates function in Excel, right? In the same way, here you're not deleting anything, but what you're doing is basically filtering out the distinct entries in a table. So we'll be using distinct keywords for that. Now we have entered into the last segment, like before in Excel, we'll be using the aggregate functions, right? In the same way, if you wanted to find out the total count of employees, you can go to the count function. Total salary expenditure on all the employees, go with the sum function. And if you wanted to filter out the average salaries in a dedicated department, you can do with that as well. Department name is equals to engineering. I think we were supposed to use the join clause here as well, just like before. Or we can just quickly use the same query that we used before. Yeah, this one. Copy. Go back to aggregate functions. So here we have used a keyword called as, right? So it's used for aliasing. Now we'll place it here, join departments. This should probably work. There you go. So we have 90,000 as the average salary, minimum and maximum in just one query. So this is the minimum salary and this is the maximum salary. And now count the employees per department. This is where we come across group by. Group by is like creating a pivot table and looking into the numbers based on a specific department. So just quickly enter and there you go. Department, I think it was department name. Select. There is some error here, but not to worry much about it. Let's quickly try to resolve it. There you go. So we have 9 people in engineering. Okay, so far so good. Now we can just quickly dive into, without much ado, we can quickly dive into analytics section. So this is our analytics, right? We will frame some questions and based on the questions, we will derive some answers in the query format. So consider this particular question as a quick homework for you and you can tell me the answer in the comment section. This is your homework. You need to count the total number of employees per department. Now we have entered the analytics section. So we will be having some analytical based questions here. So I'll explain you what the question is about and why is this question asked. And then we will write a query, right? Now let's start with the first question. We will be having this data in data basics database. Now this is a different database. Now the first question is year-wise revenue trend. So this analysis focused on calculating the total revenue generated in each year to understand overall business performance. By comparing revenue across years, we can clearly identify growth patterns, shutdowns, or revenue instability. This helps stakeholders evaluate whether the business is scaling consistently over time or not. The outcome supports high-level decisions related to forecasting, budgeting, and long-term strategy. Now let's quickly look at the query. So let's go through the database first. So this is the same data that we created. We have order date, order ID, delivery date, status, platform, first name, last name of the customer, customer email, state, location, etc. And we also here have the revenue, profit, and cost price that we recently created. Now what we are basically doing is we are selecting the year section of the overall order date. So you can extract month, date, or year based on the time functions over here. And we are aliasing it as year. And we are using an aggregate function, which is sum, to calculate the total revenue as revenue. from the database, which is DBA, and we are grouping by order date and order by year. Now, let's quickly run this query to get the output. So here we have so much revenue generated in 2021, which is about 1 million. And down the line in 2026, we came down to 1.19 million. So we have a consistent kind of revenue generated. So our peak was in 2023, which was compared to the 1.2 million in the previous year. Now we have the next question, which asks about platform performance analysis. Since we discussed, we have a wide variety of platforms, which is YouTube, Facebook, Meta, Meta or Facebook, Snapchat, Instagram, and everything, right? Now I want to deep down a little bit and understand which platform is really working for us. So that gives us the second question. This analysis evaluates how different sales platforms contribute to overall business revenue. The goal is to identify which platforms are performing strongly, which ones are not, and which are the ones we need to focus on. Understanding platform level performance helps businesses allocate marketing budgets or operational efforts more effectively. The insights support data-driven decisions on platform optimization and future investments. Now, let's go through the query and answer the question. So here we will be selecting platform, and here we will also be using an aggregate function, which is sum of revenue, and we will be aliasing it as sum of revenue or total revenue, and we will be extracting this from the data table, which is DBA, and we will be grouping by platform and order by descending, right? So we will be having platforms which are performing top on the top position and the least ones in the last position. That's the meaning of descending order, right? Now we have Instagram performing on the top, next is YouTube, next is Snapchat, and so on. So WhatsApp is a little too low here, maybe due to some privacy concerns or spam reports, right? So we need to make our ads a little bit more realistic so that they reach to our customer in the best place possible, so that we can position our products in the best way possible, right? Now that brings us to the third question, which says about order fulfillment status distribution. So you might be having a question, what is order fulfillment status? So order fulfillment status distribution. This analysis examines how orders are distributed across different fulfillment statuses, such as delivered, pending, or cancelled. The objective is to assess operational efficiency and identify potential bottlenecks in the order lifecycle. A high proportion of non-delivered orders may indicate logistics or process issues. These insights help improve fulfillment performance and customer satisfaction. Now, let's go through the query and extract the answer for this. So I will be selecting the order status. So basically the order status is about delivered, cancelled, in transit, right? So that status will be in this particular column, and we are counting the total number of orders and we are aliasing it as total orders, and we are using multiple aggregate functions here. So the first external function is round. That particular round function is basically used to kind of give a round figure. So let's say if I have 4.7 marks, then it will be rounded as 5, and if I have about 4.1, then it will be rounded as 4. So based on the closest number, it will roundify the outcome. So then we have count aggregate function, which counts total number of orders, and it will be divided by a total number of over, and then it will be giving us a percentage, right? And it will be extracted from the DBA status database, and we'll have the group by clause here by status, right? Now the status delivered, total orders were 8,370, and the percentage of success satisfaction is 69%. In trans, so this can be either converted into delivered or cancelled. So both are possible. So let's eliminate the 20%, and the rest is cancelled is 10%. So quite good. We are doing really great. So we have about at least, if we take an average, we have about 75% of success rate in our delivery, right? Now that brings us to the question number 4, which deals with average delivery time analysis. Now, what is time analysis? This analysis measures the average time taken to deliver orders from placement to completion. The intent is to evaluate logistics efficiency and identify delays in the delivery process. Longer delivery times can directly impact customer experience and repeat purchases. The result helps businesses optimize supply chain operations and improve service reliability. Now let's go through the query and answer this. So similar to the previous one, we will be using round function, average function, and we'll also be using date difference function. So why is date difference here? It will basically subtract the delivery date with the order date, right? Now that gives us a number of days taken to deliver the days. So we'll alias it as average days of delivery. And we will be extracting this from data table DBA where order status is delivered. So we'll be filtering out the status table where only delivered products are calculated. Let's quickly enter. And there you go. So we have about 6 average days to deliver the product from the order date to the delivery date. Now, that takes us to the fifth question, state-wise revenue distribution, where we might have to analyze which state is giving us highest revenue. So state-wise revenue collection or contribution, this analysis breaks down total revenue by state to understand regional performance. The goal is to identify high revenue and low revenue regions across the business. These insights help stakeholders focus marketing, logistics, and expansion strategies on high potential states. It also supports region-specific planning and resource allocation. Now, let's quickly go through the query and understand it and execute it. So we will be selecting state column and we'll also be selecting the revenue column. We'll be using an aggregate function, which is total sum of revenue, and we'll be aliasing it as total revenue from the database DBA. We will group by state and order by total revenue in the descending order so that we have the top performing states in the first place. So we have, and in case if somebody asks you, give me the top one state, then you can limit it by 1, or top 3, you can limit it by 3. So here you have top 3 performance, right? And that brings us to the next question, which is about product category profitability. So product category profitability. This analysis evaluates profitability across different product categories to understand which segments generates the most value. The intent is to identify high margin categories versus low performing ones. These insights help businesses optimize product mix and pricing strategies. It also supports decisions on where to invest, scale, or discontinue offering. Now, let's go through the query and understand the output. So here we are selecting category column. We are also using a sum aggregate function from the profit column, the one which we created using some mathematical calculations, right? Now order by descending. There you go. So we have training equipment on the highest profitability product category. Then we have team sports, running, outdoor, etc. Now that brings us to the 7th question, which talks about top 5 best selling products by revenue. So this analysis identifies the top 5 products based on total revenue generated. The objective is to understand which products contribute most significantly to overall sales performance. These insights help prioritize inventory planning and marketing focus. Highlighting top sellers also supports strategic decisions around promotions and product scaling. Now let's go through the query and understand it. So we will be selecting the product column. We will be using an aggregate function of sum on the revenue column. We'll be selecting this from the DBA data table. We will be grouping by product and we'll be ordering the revenue in descending order, and we'll be selecting the top 5. So we'll be using limit 5. Jerseys, sweatshirts, helmets, pants, and shorts are the highest selling products. Now that brings us to the question number 8, which is about funnel analysis or conversion funnel analysis. So conversion funnel analysis. This analysis examines how orders move through different stages of sales funnel, from placement to final delivery. The intent is to identify where customers drop off or where processes slow down. Understanding these gaps helps improve conversion efficiency and reduce order losses. The insights directly support funnel optimization and revenue growth. Now, let's go through the query and understand how to execute. So we will be using some aggregate function and we'll be using some mathematical operations here. Sum of orders multiplied by 100 and divided by total traffic, which gives us conversion rate percentage from the table DBA. Now let's quickly execute this query. So here we have about 0.52, which is also known as 52% conversion rate, which is really good. Now that brings us to question number 9, which is about customer repeat purchase analysis. So this analysis looks at how frequently customers make repeat purchases over time. The goal is to evaluate customer loyalty and identify patterns in repeat buying behavior. Insights from this analysis help design retention strategies, personalized marketing, and loyalty programs. Ultimately, it supports efforts to increase customer lifetime value and sustained revenue growth. Now, let's look at the query and understand how it is going through. So we will be using count function, and we will be using a subquery as well. So here the subquery is, so we will be selecting customer ID from DBA, and we will be grouping by customer ID, and we'll be using a having clause and order ID or total orders. So basically we can choose any of the columns. So we'll be going with order ID. So if the count of order ID is greater than 1, then automatically it is considered as a repeated customer. Now let's execute this query and see the output. So we have about 717 repeated customers in all in total. Now that brings us to the question number 10. So the question number 10 is about profit margin analysis. This analysis evaluates profit margins across products, categories, or overall business operations. The goal is to identify where the company earns the most and least profit relative to the revenue. These insights help in pricing strategies, cost management, and resource allocation. Understanding profit margins supports sustainable growth and informed financial decisions. Now, let's take a look at the query and execute that. So we have selected the profit and sum division, and we'll be rounding off it as a profit percentage from DBA. This is just a simple mathematical calculation. And we have about 24% profit margin. That's really good. And now that brings us to question number 11, which is about platform-wise conversion efficiency. This is a little deep down. This analysis measures how effectively each sales platform converts visitors into paying customers. The goal is to identify which platforms are most efficient and which need improvement. Insights from these analysis help optimize marketing efforts and platform-specific strategies. Improving conversion efficiency ultimately drives higher revenue and better return on investment. Now let's go through the query. So here is our query. So we will be selecting platform, and we will also be selecting the orders and leads. So we will be dividing orders by leads, total orders by total leads, and we will be rounding off to 2 positions in the decimal value. And we will be aliasing it as lead to order conversion ratio and from DBA platform or the database. And we will be grouping the platform and order by lead conversion in descending order. So highest lead conversion platform is YouTube with 3.40 conversion. Next is WhatsApp, Instagram. So in the first question, we have seen YouTube to be in the second position in terms of leads, but WhatsApp is in the last position in terms of leads. Now the lead to conversion ratio speaks a different language. WhatsApp is in the top second, right? So based on this, you can strategize which platforms to focus more, pay more on marketing, right? So you can run some paid promotions on these platforms and expect good conversion ratios. And with that, we come to the last question in this particular analysis, which is about monthly sales trend. It could be a little advanced, but simple in execution. Don't worry about that. But let's understand the intent behind it. Monthly sales trend. This analysis tracks sales on a month-by-month basis to uncover seasonal patterns and short-term fluctuations. The goal is to identify peak periods, slow months, and emerging trends within the year. These insights help with inventory planning, marketing campaigns, and sales forecasting. Monitoring monthly trends ensures the business can respond proactively to demand changes. Now, let's go through the query and execute it and understand what's the output. So we are selecting the order date and we are splitting it from the date, and we're expecting only the month and year. And we'll also be using revenue column, and we'll be using the sum aggregate function as total revenue from the database DBA. Now let's execute the query. So here we have year on year until 2026. So month on month evaluations. So in the year, so we have total number of so and so numbers of total revenue generated every month of every year. And that brings us to the end of this section on SQL for data analytics. Next, we will be looking into the Power BI and Tableau for analytics.
My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. Is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then averages the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. With the next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket. It doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible on Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program, and what you come up with is you have, in this case it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your Pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice Pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from Dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the Pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and then you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example: there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example: there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, it returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP ordered by market price ascending. So what we do is we take the top 4 of the market price ascending and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those 2 currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here, you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import numpy as np, number equals our np array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your numpy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are two arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created two different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a Pandas data frame? Suppose there's an IMP data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in cells rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total cell. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product.id from production product as pp inner join, cells.sales.order.detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare a variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your 2 different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python or other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np, random arrangement equals np.random.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into Pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the in-unique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where in unique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sign graph using NumPy and Matplot library in Python. And the way we did this is we went ahead and generate an x. We know our y equals np.sign of x. If you print out x, you'll see a whole value here. Our Matplot library PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a Pandas using the below Pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
And with that, we have reached the end of this session on Data Analytics Full Course for Beginners. Should you need any assistance or any other resources used in these sessions like PPTs, datasets, workbooks, dashboards, and others, then please let us know in the comment section below. And our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.